everyone and welcome to the Data Analytics full course, your step-by-step guide to mastering the art of turning raw data into meaningful insights. In this course, you will start with the fundamentals of data analytics, statistics and probability, and then explore popular tools and libraries like Excel, SQL, Numpy, Pandas, Matplotlib and Power BI. You will learn data cleaning, visualization and time series analysis while working on real-world projects. We will also cover top visualization tools, must-have skills to become a data analyst and career insights, along with interview preparation to make you industry ready. And by the end of this course, you will have both the technical and analytical skills needed to excel as a data analyst in any domain. So before we begin, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's Data Analyst course designed by industry experts that offers a comprehensive understanding of analytics concept. You will gain practical expertise in Python, statistical, along with advanced techniques like data visualization using Tableau and Microsoft Power BI. This well-structured curriculum equips you with the in-demand skills needed to excel as a data analyst and grow your career in the dynamic field of data analytics. So enroll today and unlock the power of data. So check out the course link given in the description box below. Now, let's get started with our first topic, that is, what is data analytics?
Let me tell you what exactly is data analytics. So as the word data analytics suggests, data analytics refers to the techniques to analyze the data to enhance the productivity and business gain. Data is extracted from various sources and is categorized to analyze different behavioral patterns. Now, the techniques and the tools used to perform data analytics vary from organization to organization, or you can say individual to individual, right? So if I have to define data analytics for you, then data analytics is the process of inspecting, cleaning, transforming and modeling the data with the goal of discovering useful information, suggesting conclusions and supporting decision making. So in short, if you have an understanding of your business administration and also have the capability to perform exploratory data analysis to gather the required information, then you're good to start the career in the data analytics field. So talking about career in data analytics, once you understand and you have the capability of performing business administration with exploratory data analysis, you would become a data analyst. So now let me just quickly tell you who exactly is a data analyst. So a data analyst is a professional who collects the data from various sources and analyzes the data on various aspects and then finally generates the reports. Now, these reports are distributed to the respective teams to use the analyzed data and provide improvement in the business. So if you have to become a data analyst, then you need a set of skills as you can see on the screen. So the basic skills the data analyst should possess are the ability to perform statistics, data cleaning, and also have the capability to perform exploratory data analysis and data visualization. Apart from these skills, if a data analyst also has a knowledge of machine learning, then that would obviously add a bonus point to his or her skill set, as he or she would be able to build a model and then test the model also, right? So don't worry guys, I'll be talking about each of the skills one by one. Starting with statistics. Statistics is a mathematical science pertaining to data collection, analysis, interpretation and presentation. It is used to process complex problems in real world so that the analyst can look for meaningful trends and changes. Analysts review the data so that they can reach conclusions, and several statistic functions, principles and algorithms are implemented to analyze the raw data, build a statistical model and infer or predict the result. So if you just have to understand statistics in a single sentence, then statistics is a branch of mathematics dealing with the data collection and organization and then performing analysis, interpretation and presentation, right? So statistical analysis has basically two categories, the descriptive statistics and the inferential statistics. So let's get started by understanding each one of them one by one. So starting with descriptive statistics uses the data to provide descriptions of population either through numerical calculations or graphs or tables. So now descriptive statistics helps organize data and focuses on characteristics of data, providing the parameters. So as you can see the example on the screen, suppose you want to distinguish the objects based on the color, then you can see that this type of statistics, that is basically the descriptive statistics, divides the data into two sections based on the colors. So that's black and red over here. Now, If I have to make it more generalized for you, then suppose you want to study the average height of students in a classroom. In descriptive statistics, what you would do is you would record the heights of all the students in the class, and then you would find out the maximum, minimum, and the average height of the class, right? Now, this was just a simple example, guys. If you look into the enterprise level, then you may have a large data set, with various number of columns, right? Now, you can just pick up one column and then you can find the minimum, maximum, and the average of that particular column, right? Also, in descriptive statistics, we try to represent the data in the form of graphs like histogram, line plots, scatter plots, and so on. But yes, the data is represented based on some kind of central tendency. Now, when I say central tendency, I mean that a particular graph represents the distribution of mean or the measure of spread, or depends on what kind of a graph you're using or what's on your graph, right? So for that, you have to understand few measures in statistics. So those are basically the measures of center and the measures of spread. So talking about the measures of center, there are mainly three terms that you need to understand, which are the mean, median, and the mode. So starting with the mean is basically the measure of average of all the values in the sample. So suppose, if you consider the example in the screen, then if you want to calculate the mean of the sample that is present on the screen, you just have to add all the numbers and divide it by the number of numbers, right? So since we want to find the mean of 8 values, we're going to divide the complete sum by 8. And that's how you can calculate the mean of the sample. Alright, moving on to the next term, that is median. Median is basically the measure of central value of the sample set. So if you consider the example on the screen, then you can see that there are 8 values, right? Now to calculate the median, you have to consider the fourth value and the fifth value and then divide it by 2. So since our fourth value over here is 22.8 and the fifth value is 23, I'm just going to add both these values and divide it by 2. So the value that you get, that is 22.9, is the median of the sample, right? Now moving on to the next term, that is mode. Mode is nothing but the value most recurrent in the sample set. So if you consider the example on the screen, then out of all the numbers that you see on your left hand side, you would see that 25 occurs the maximum number of times, right? So 25 would be the mode for this particular sample set. So as and when the sample set changes, the mean, median, mode values also change, right? So those were the measure of center, guys. Now moving on to the next measure, that is the measure of spread. The measure of spread again has basically four terms that you need to understand, that is the range, interquartile range, variance, and the standard deviation. Starting with the range is basically the given measure of how spread apart the values are in a data set, right? So suppose you have 10 values, then if you want to calculate the range of these 10 values, you just have to subtract the minimum value from the maximum value, right? So that's what the formula is, guys, that is maximum minus minimum. Now moving on to the next term, that is the interquartile range. Interquartile range is basically the measure of variability based on dividing the data sets into quartiles. Now to understand quartiles, let me just consider a sample set of 8 values, right? So let me just quickly open my notepad and show you how you can calculate the interquartile range. So let's say, we have 8 values, 1, 2, 3, 4, 5, 6, 7, 8. Now to calculate the interquartile range, what you simply have to do is first you have to calculate the quartiles, right? Now to calculate the quartiles, you have to find the average between two numbers. So when I say two numbers, you have to calculate the average between 2 and 3. Then you have to calculate the average between 4 and 5. And then you have to calculate the average between 6 and 7, right? So let me just quickly calculate the average. So what I'll do is I'll just add these two terms and then I'll divide it by 2. Right? So this would be equal to 2.5. So that's 2 plus 3 by 2. That's 5 by 2 is 2.5. Similarly, I would calculate 4 plus 5. That is 9. 9 by 2 is 4.5. So I'm just going to put 4.5 over here. So let me just write that. And then finally, let's just add 6 plus 7. That is 13 by 2. That is again 6.5. Right? So basically, you have three values. That is 2.5, 4.5, and 6.5. So basically these values would define your quartiles. So the first quartile would be after 2, the second quartile would be after 4, and the third quartile would be after 6, right? So what will happen is your sample set would be divided like this, right? So as you can see on the screen, we have 4 quartiles. Now the difference between the first quartile and the third quartile would be your interquartile range. So if you just want to calculate interquartile range, what you simply have to do is you have to first calculate the quartiles for your sample set, and then the difference between two quartiles would be your interquartile range, right? So I hope I'm clear with this part. Now moving on to the next term, that is variance. Variance basically describes how much a random value differs from its expected value, right? So basically whenever you want to calculate how much any random value differs from its expected value, then you're basically calculating variance. It basically entails the computing squares of deviations. Now with that, let's move on to the final term, that is the standard deviation. So standard deviation is basically the measure of dispersion of set of data from its mean, right? So whenever you calculate the mean, and then whenever you want to calculate how far is the dispersion of set of data from its mean, you would basically calculate standard deviation. So folks, I'm not going to go into depth of how you have to calculate each of these terms. If you want to learn more about statistics, I'll leave a video's link in the description box, and you can refer to that video, that is basically statistics for data science, where you'll understand all these terms based on statistics, and you'll understand how you can calculate the values, right? So guys, that was all about various measures that you need to go through in descriptive statistics. Now moving on to the inferential statistics, that is the second category in the statistics. This is basically used to build a model and then give a probable solution. So inferential statistics basically generalizes a large data set and applies a probability to draw a conclusion. It allows us to infer data parameters based on statistical model using a simple data set. So again, let's just take the same example of, we have to segregate few objects based on the color. Now, when you implement inferential statistics on these same objects, what would happen is a statistical model will be built, and based on that, a conclusion would be given, right? So that's how, inferential statistics is. If you have to understand, if I have to generalize this for you, then you can again take the example of calculating average height of students in a classroom. Over here, what would happen is we would take a sample set of the class, and then if you want to apply inferential statistics, what we would do is we would group the students into tall, average, and short heights, and then based on this, we would build a statistical model and expand it for the entire population, right? So guys, that was all about descriptive statistics and the inferential statistics. Now, inferential statistics has one more term, that is hypothesis testing, that you need to understand. So hypothesis testing is an inferential technique to determine whether there is enough evidence in a data sample to infer whether a certain condition holds true for an entire population or not. So what basically happens is, under the characteristics of general population, we take a random sample and analyze the properties of the sample. We test whether or not the identified conclusion represents the population accurately, and finally we interpret their results, right? So whether or not to accept the hypothesis completely depends on the percentage value we get from the hypothesis. So hypothesis testing is basically conducted in the following manner that you can see on the screen. It starts with the state of hypothesis, and this stage basically involves stating the null and the alternative hypothesis. Then we basically formulate an analysis plan, where the stage involves the construction of the analysis plan, and then we move on to analyzing the sample data. So in this stage, it basically involves the calculation and interpretation of the test statistics as described in the analysis plan that we formulated before. And then we finally interpret the results, where this involves basically the application of decision rule described in the analysis plan, right? So guys, that's how you conduct the hypothesis testing. So guys, that was all about inferential statistics. So now let me just quickly brush you over the differences between descriptive statistics and inferential statistics. So descriptive statistics is basically concerned with the properties of population, whereas inferential makes inferences from the sample. Descriptive presents the data in a meaningful manner, whereas inferential compares and predicts the future outcomes. Descriptive statistics outcomes are shown in the form of charts, tables, and graphs, and inferential statistics outcomes are basically shown in the form of probability scores. In descriptive statistics, it basically describes the known data, but in inferential statistics, it tries to make the conclusions beyond the data as available. And finally, coming to the last difference, descriptive statistics has the measures of central tendency and spread of data, whereas inferential has hypothesis testing and analysis of variance, which is basically the ANOVA model, right? So I hope guys, the differences between the descriptive and the inferential statistics are clear to you guys. So now let me just quickly move on to the next skill that is important for a data analyst, that is basically data cleaning and data manipulation. Now, once you get your data, the first step would be to remove all the unwanted data. So the process of detecting and correcting corrupt or inaccurate records from a database is basically said to be data cleaning or data cleansing or data wrangling. So you need to make sure that all the null values, the corrupted values, or a column from the data are removed before you start analyzing the data. And once you remove such values from the data, the next step to perform is basically data manipulation, which is nothing but exploratory data analysis. So if I have to just define data manipulation for you, then it's the process of changing data to make it more organized and easier to read. And this is nothing but data manipulation. So whenever you make your data in a more organized manner, you make all the tuples clear, and then you have all the column values in a clear manner, and it's easy to read and analyze. It's basically known as data manipulation. It's not required that if you have 5,000 tuples, you view all the 5,000 tuples together. You can use some functions to just view the top 10 tuples or the bottom 10 tuples, so that you understand what are the various parameters or what are the columns that are present in the data set, right? So in this particular step, what you can do is you can completely reorganize the data into various forms based on whatever column names that you wish, or you can just add few columns or delete few columns, you can remove few tuples, or you can just merge few columns, and so on. So don't worry folks, I'll be showing you a demo where you will be performing data manipulation. Now moving on to the next skill for a data analyst, that is basically data visualization. So data visualization is nothing but the representation of data in forms of charts, diagrams, etc. Right? So you can represent your data either in the form of bar graphs, scatter plots, pie charts, box plots, line graphs, and so on. Not only this, but you can also visualize the data in form of complex plots like histograms, and use 2 to 3 different plots together. Like you can have a scatter plot which has a line graph, or you can have 2 different plots of histograms, and then you can have a line graph over it, and so on, right? So it's completely based on your understanding of what kind of a plot that you want, or it's completely based on how you want to see your data or how you want to visualize your data, right? So guys, these were the basic skills that a data analyst must have. We started with statistics, and then I told you the various categories of statistics and how you can calculate the various measures in both of them. After that, I told you about data cleaning and data manipulation, which is nothing but the exploratory data analysis, where you clean your data, remove all the null values or the corrupted values, and then you can reorganize your data, reorganize your columns. And finally, we moved on to data visualization, where the columns between which you want to visualize the data, right? So these were some basic skills that every data analyst should have. But yes, if you have an understanding of machine learning, then that would be obviously a plus point to your skills, right? So now let me just quickly tell you what machine learning is in short, so that you understand what machine learning is, and then we'll quickly shift to the demo part. So machine learning is basically a concept which allows the machine to learn from examples and experience, and that too without being explicitly programmed. So what basically happens is, whatever data that you pass to the machine learning algorithm, the algorithm learns from the data, and then it predicts the output for you. So as you can see on the screen, we have a training data, and then the data is passed on to the machine learning algorithm. After that, the model is created. Now over here, even if we add a new input data, then that would pass to the machine learning algorithm which was created, and a prediction would be given as an output. Now, once the prediction is given, you can just check, whether it's a successful model or not based on the requirement that you have, right? So that's about ML, guys. If you want to learn in depth about ML, I'll leave a video in the description box, and you can understand from there what exactly ML is and where is it used, how is it used, what companies are using it, and so on. So guys, these were all the skills for a data analyst. As I'm talking so much about data analyst, let me just quickly tell you the roles and responsibilities of a data analyst. He or she should be able to determine organization goals. He or she should have the capability to mine the data, that is basically performing data mining, and also perform data cleaning. Once data is being cleaned, he or she should be able to analyze the data properly and pinpoint the trends and patterns, or you can say the behavioral patterns, and finally create reports with visualizations, right? So basically, if you become a data analyst, these are the various roles and responsibilities that you would be responsible for. You should be able to determine the organization goals. You should be able to mine data. You should be able to perform data cleaning or wrangling. You should be also able to analyze data and pinpoint the trends and patterns in the particular data. And finally, create the reports with visualization, right? So I hope that the roles and responsibilities are also clear to you. Now, looking at so much of roles and responsibilities, you might be wondering, right, what could be the salary of a data analyst? Well, the average salary for a data analyst in US is around $83,000, and in India is around 4 lakhs, right? So guys, these are the starting salaries. But as and when you have a good expertise of data analysis and you're able to perform machine learning algorithms, you would be great in the market and you would have a great market value, right? This was all about the skills, roles, responsibilities about a data analyst. Now let me just quickly move on to the need of R, because the hands-on that I'm going to show you is based on R. So basically R is again a programming language that is basically used for data analytics. So R is basically open source and is freely available. It is cross-platform compatible. So you can have R with Power BI. So as you know, Power BI is a visualization tool. You can create reports using both of these tools together. R is also a powerful scripting language. It is highly flexible and is evolved. And let me tell you, it's really simple to code in R because you just have to install few packages, and then you just have to understand how these packages have various functions to take care of your needs, right? So guys, this was all about the theory part of the session. I hope that you've understood what exactly data analytics is. Now let me just quickly move on to the demo part. So what I've done is I've basically chosen a data set which has various columns like the person weight, the person height, body mass index, pulse rate, and so on. So let me just quickly open the data set and show you what exactly the data set is about. So as you can see on the screen, this is basically the data set that I've chosen. I have a person ID, the gender, the person age, race, education, marital status, the relationship status, and then insurance, salary, poverty, number of house owned, if it's rented, the rooms, the person body index, pulse rate, and then various other health parameters, right? So we're going to basically perform analysis on this particular data. What we're going to do is we're going to first import the data set into R, and then we'll perform descriptive statistics on it that I was talking about in the theory part. After that, we're going to deal with the missing data, and then we'll perform data visualization. So we'll basically form data visualization between two columns so that you understand how the values in the two columns vary with each other. And then we'll move on to inferential statistics, so where I'll perform t-test for you guys. After that, I'm going to just apply a machine learning algorithm that is perform linear regression so that you understand how that's a plus point for a data analyst, right? So I hope that the process is really clear to you guys. So let me just open my R Studio and quickly show you the code. All right. So as you can see on the screen, this is the code that I've previously written. So I'm just going to show you guys by running each of these commands one by one. So the first step that I mentioned is to import the data set, right? Now before that, let me tell you that we're going to use the deployer package for this complete code. So the deployer package basically offers various functions by which we're going to perform various functions on our data set. So you can just install this package if you don't have it installed on your R Studio. But yes, if you do have it installed, you just have to use the library, right? So I've already installed in my R Studio, so I'm not going to do that again. Now what I'll do is I'll just import the dataset directly. So to import the dataset, you have to mention the read.csv file. That's because my sample dataset is in the form of a CSV file. Or if you had any other types of file, then you have to mention accordingly. Okay. So if you just type in read, you can see various options for various kinds of files. So since I have a CSV file, I'm just going to type in CSV, right? And then what I've done is I've mentioned the directory of the file, right? So since my file is present on desktop, I've just mentioned the directory, and then I can just execute this particular command. But yes, let me tell you, once the file is read, what I've done is I've just assigned it to a variable example over here. That will basically make it easy for me to use this variable again and again to perform various steps in the analyzing part. I've just assigned this complete file to an example variable. Now let me just run this particular command. So what I'm going to do is I'm going to just press on Control Enter. So that's basically a keyboard shortcut to run this particular line. If you just want to run the complete R script that you've written, then you can just press on Control Shift Enter, right? So I'm just going to press on Control Enter, and you can see that this particular command has got executed. Now if you just want to view the dataset, what you can simply do is you can just use the command view example, and then you can click on run, and you can see that your complete dataset, that is basically your sample dataset which was present over here, has got imported into the R Studio, where you can perform various analysis functions, right? So you can see all the columns and all the values have come over here, right? Now if you observe this particular data set, you have 5,000 entries, right? Now it cannot happen that you observe 5,000 entries in your console, right? So to just observe the top 10 entries, what you can simply do is you can use this function tbl-df, that is basically creating a data frame for your data set. So what I'll do is I'll just type in tbl-df, I'll mention this variable name, that is basically example over here, and then I'll again assign it back to example, right? So if I just run this particular command, you can see that this gets executed. And then if I just type in example, you will see that only 10 rows get printed. So let me just drag this up for you. You can see that we have 10 rows printed to check all the values, and we also have a table that is basically 5,000 into 32, which says that we have 32 columns and 5,000 entries, right? So that's how guys you can use this particular function to see the top 10 rows. Now what we're going to do is we're going to just use simple commands like head, tail, dimension, names, and glimpse to just look into the data set more clearly. So what the head function does is that it basically shows the first few rows. The tail, as the name suggests, shows the last few rows. The dimension shows the number of rows into number of columns. So just in case if you just want to look into the names of the columns, then you can just use names, and glimpse basically shows the structure of the data set. So I'm going to first run head so that you see few rows. So as you can see, it has printed 6 rows, and it has printed around 1, 2, 3, 4, 5, 6, 7, 8 columns, right? So it has printed 6 rows and 8 columns, and it has also mentioned that there are total around 32 columns. Now similarly, if I run tail, then you can see that the last few rows are printed. So these are few last rows of the data set that we have chosen. Now moving on to the next command, that is dimension. So as I mentioned, dimension will basically give you the number of rows into number of columns. So that is basically 5000 into 32. Now names would be basically giving us the column name. So I'll just run in names, and you can see the 32 column names that we have. This will basically help you understand what are the different column names and what are the different column names that you can use to find the relations between the values. So we have an ID, sex, age, race, education level, status, relationship status, insurance, and so on, right? So these are few steps, guys, that are not really important, but yes, these will help you understand the data set more if you're new to data analytics, because you have to start understanding if there are any null values, or what are the number of rows or what are the columns. If you have larger number of rows, like if you have around 50,000 tuples, then you cannot use 50,000 tuples to run each function, right? So that would require a lot of memory. So for that, you can just use a sample data set, like you can just use 5,000 rows, and then you can use the built model for the 50,000 one, right? Now moving on to glimpse. Glimpse again just shows the structure of the data set, as I mentioned before. So let me just run that command and show you. So as you can see, it is printing out all the column names, and then it is printing out all the values. So you can see that person ID is an integer, sex is in factor and it has male female values, age is again an integer, race is again in factor, poverty is again in decimal points, and so on, right? So you'll know the data type, you know what kind of values are present over there, and then you can also know and what are the columns which have different kind of values, right? If you observe over here, there are a lot of NA values, right? So we're going to deal with them soon, so don't worry. Now let me just minimize it again. All right. So now that you know the basic commands in R, you know how you can start for analyzing the data. Let's start with the second step, that is the descriptive statistics. So if you remember in the descriptive statistics part, I told you that there's measure of center which has mean, median, mode, and there is measure of spread which has interquartile range, quartile range, and so on, right? So what I'm going to basically do is first I'm going to display all the race values, and then I'm going to display the unique values of race and the length, right? So to display all the race values, if you see over here in the column, we have different race. We have Asian, we have black, we have white, we have Mexican, and so on, right? Now to display all these race values, what you simply have to do is you have to use the variable for the dataset, that is example, and use the $sign with the name of the column, right? So over here it's example $race. I'll just run this particular command, and you can see the output that we have got all the race values. Now if you want to find out the unique values, what I'll simply do is I'll use the unique function, and then I'll mention example $race. Similarly, if we want to find out the unique values for any other particular column, we just have to mention that particular column's name. Over here I'll mention unique example race, and then I'll run, and you can see that we have Asian, black, white, Mexican, Hispanic, other, as various races present in the column, right? Now if you want to find out the length of all these unique values, you just have to use the length function outside the unique function, and then you have to run this particular query, and you can see that the length is basically 6. So basically what's happening is, instead of counting Asian, black, white, Mexican, Hispanic, and other on fingers, what you can simply do is you just have to use the length function to find out how many unique values are present in the race column, right? So that's how you can use the length function, guys. Now moving on to the next part, if you just want to calculate the mean, median, and range of any particular column, let's say age over here, what you simply have to do is you have to use the inbuilt functions in R, that is the mean, median, range, and then you have to mention the variable name, dollar, and the column name, right? So if you have to calculate the mean, what you'll simply do is you'll type in mean, and then you'll mention the variable name, that is example for the data set, mention dollar, that is to specifically access this particular column, that is to specifically access the column age, right? So I'll just run this particular command, and then you can see that 36 is basically the mean age. Similarly, you can calculate the median. Median is also 36, and the range is basically from 0 to 80. So that's how, guys, you can use descriptive statistics in R to find out the mean, median, and range. Now, if you just want to get a summary statistics on each variable in the data, you can just use the function summary, and then you have to mention the variable name, right? So I've mentioned summary example, and then if I run this particular command, you can clearly see that we've got summary of all the 32 columns that we have in our data set. So when I run this particular command, you can see that for all the columns with the data type int, you get the minimum value, the first quadrant, the median, the mean, the third quadrant, and the maximum value. For the columns which have the data type factor, like for example sex, we have number of females to be 2495 and number of males to be 2505. And similarly, when we see for race, we can see that the Asians are at 288, the blacks are at 589, and so on, right? So that's how you can have an idea about different values present for your data set. So you can get the number of values, the minimum, the medium, what are the various kind of values that are present in the column, and so on with this particular function, that is summary, right? So this is also one particular important feature that you need to analyze in any data set that you get to handle to. You have to understand what are the various factors, or what are the various types of values that are present in your columns, and what is the number of those values, right? So if I look into the employment status, you can clearly see that the looking is 166, the not working is 1413, the working is at highest, that is 2263, and not applicable, that means it's null values, it is at 1158, right? So these are various features that you need to understand. Now that you've implemented descriptive statistics, let's move on to the third step, that is basically dealing with the missing data. So to deal with the missing data, first let me just calculate the mean of the salary, and then I'll explain you why we have to deal with the missing data. So when I calculate the mean of the salary, you'll see NA. Now if I just open my data set and if I show you the salary column, you'll see that you have various columns which are not NA, right? But yes, you've got the output as NA, that means it's definitely wrong. You need to get the mean of the income. Now since we have a lot of columns that could be NA in this particular column, that is the reason that we're getting the output as NA, right? So what we can simply do is we can just find out whether there are missing values or not. Here I had showed you because the missing value occurred at the 29th tuple itself, right? But just imagine you have 5000 tuples and you don't know where is the NA value coming. You need a way to find out that, right? So that's by using the na.rm parameter. So na.rm basically indicates if whether there are missing values present or not. By default, this parameter is assigned to false. But yes, I'm mentioning it over to be true so that whether if we have any missing values, then this would return an output for us. So with this particular command, you can see that if the example dataset salary has any null values, that is basically true over here, then obviously we can calculate the number of null values present. So what you can do is if you just run this particular command, you can see that the mean value is basically 57,000. Now apart from this, you can also use a is.na function, which basically tells you if your value is missing or not again. So what I'll simply do is I'll just mention this is.na function, and inside that I'll mention the data set $, the column name. Since I want to find it for salaries column, I'll just mention that particular column and I'll run this particular command. So this would basically return all the tuple values with either false or true. False means that there's no NA value over there, and true means that there's an NA value over there. So that's how you can find out if there is null value present in which row or which tuple, that you have to understand. Now if you want to just add all the number of null values to calculate how many null values are present in total, you can just use the sum function, that is basically the aggregate function in front of that is.na function, to calculate the number of null values. So that's basically, it would count the number of true values and then it would print for you. So you can see that we have 377 values which have null values in the column of salary, right? So now what I'm going to do is I'm going to just remove all these null values and then I'm going to replace them with the 0, right? So for that, what you simply have to do is you just have to use this function of is.na, mention the dataset name, and then assign a 0 to it and then assign it back to the dataset, right? So I've put a 0 and I've said if is.na example, that means if there's a true value in the example dataset, just replace it with a 0 and then assign it back to the same dataset, that is example, right? So I'll just run this particular command, and now let's just view the dataset again. So I'll just view the example again. Now you must have observed one thing over here, that is all the column with NA values did not get replaced with 0. Only the values, which had the data type of int and they had NA values got replaced with 0. Right? For the other factors like, your education level, marital status, relationship status, you can handle the null values based on various parameters. Like, you can just remove the tuples completely. You can just compare two factors and then mention the value. Suppose, if I just compare educational level and marital status, so I can see that, all the females belonging to the Mexican race can go to educational level of high school and our marital status are married, right? So I can just replace these values, any values like that. So it's completely based on you, how you want to deal with the missing data set. Initially, I've just shown you how you can just remove the values and then how you can replace null values with something, right? So I just leave that part to you so that you explore how you can do that. Now moving on to the next part, that is basically the exploratory data analysis. Since we have analyzed the data and we have understood what are the various columns that can be analyzed, and what are the various columns that have null values and how some values got replaced with 0, what I'm simply going to do is I'm going to perform the next step, that is basically the data visualization, where I'm going to plot histograms for different column values, right? So what I'm going to do initially is I'm going to use this ggplot2 library. Just in case, if you do not have it installed in your RStudio, you can again just install this particular package by just using the command install.packages and then just mention the package name. And then you just have to load the library. Since I've already installed the package in my RStudio, I'm just going to run this particular command to just load the library. And then I'm going to perform data visualization, right? So if I just have to plot a histogram for you, what you can simply do is you can just use ggplot and then you have to mention the dataset name, that is basically example as variable, and then you have to mention the parameter based on which you want to plot the data. So initially I want to plot the data for body mass index and then I'll mention the bins to be 30, right? So I'll just run this particular command and then you can see the plot. So if I just zoom in this particular plot, you can see that body mass index at the count around from 20 to 40, like let's say around 30 or less than 30 is at the maximum, right? So with this we can get the count of what is the least value of body mass index, what is the maximum value of body mass index. That is basically the least count and the maximum count, right? Similarly, I can plot a histogram for a person weight. So I'll again just use the ggplot function. I'll mention the dataset variable and then I'll mention person weight, that is basically for which I want to visualize the histogram for. So let me just run this particular command and let me just zoom in this plot. So you can see that the person weight ranging from 50 to 100. Let's say this is around 75, that is less, but more than 75 to 100 is at the maximum value. So most people weigh around from 75 to 100 and very less people lay around from 50 to 200, and you can say none of them almost weigh around 200, right? Very few people weigh. So with such kind of visualizations you can have a clear idea of how many people weigh more than, let's say, 100, or how many people weigh less than 100, or what is the maximum weight around the sample data set that is given to you, or what is the minimum count of a weight of the sample set that is given to you, and so on, right? So now what I've done is this person weight histogram was basically plotted on based on kgs, right? Now if I have to just convert into lbs, what I've just done is I've just multiplied it with 2.2 and then I've given a lot number of bins so that we get a clear visualization. So I've again used the ggplot function and then I've mentioned the example data set, and after that in the A's column, I've mentioned person weight into 2.2 so that we want to convert the kgs to lbs, and then we've mentioned the number of bins. So I'll just run this particular command and then what we'll do is we'll zoom in. So you can see that the weight around 150 to 200 lbs has the maximum number of count. If you just continuously keep zooming in and you keep increasing the bins, you'll see the outputs more clearly, right? So that was about this plot, guys. Now similarly what I've done is I've again plotted a histogram for age to know whether there are kids present in the age distribution or not. So what I'll do is I'll just run this particular command again where I've mentioned ggplot, that is basically the ggplot function, the again dataset name, the person age, that is basically the age column, and then I mentioned the bins. So when I zoom in, you can see that there are a lot of number of children that are present in the sample dataset whose age is less than 18. So this is one category that you can again use to visualize or to analyze the dataset. You can just divide your dataset into children's dataset and then adults dataset and perform various actions. So that's how you can use this particular visualization for your benefit. Now, not only histogram, guys, so as I mentioned in the visualization part in the theory section, there are various number of plots like bar plot, scatter plot, line plot, box plot, and so on, right? So it's completely based on your understanding and your need, which kind of plot that you want to plot. Now, suppose I want to, compare the person's height with the person's weight, and then I also want the parameter of gender to be present. What I can do is I can just simply plot a scatter plot where I'll compare person's height to person's weight and then just color the scatter plot with the help of gender, right? So for that, you can again use the ggplot. You can mention example, that is basically the data set, and then I'll mention person height, person weight, and then color by sex, that is basically a gender, right? So when I run this particular command, you can see the output that, we've got a plot, of person's weight, person's height. So person's weight is compared with person's height, that is on the right hand side, that you can see that, the pinkish red color represents female and the blue color represents the male. If person's height was around 100, then that would be maximum of, male people present in this particular section. Let's say, the person's height is around 150 and the weight is also around, 100. We can see that, there's a lot of female section present, right? So guys, that's how you can use data visualization to perform and understand various relationships between data. These were just few columns that I compared them, and these were just few columns or examples that I showed you. Well, you can play around with data as much as you want. So this is just one more trick, that whenever you create a visualization, just make a note of it. What are you getting out of it, right? So out of the visualization that you can see on the screen, what I'm basically getting is the person's weight to person's height comparison and how many female and male population is present in that particular scenario. So as you can see, the maximum population is present in this particular range, where the person's height ranges around 150 to 200 and the person's weight ranges around, again, let's say 125 to 50, right? So that's how you can analyze data and gain some hidden insights. Now moving on to the next part, that is basically the inferential statistics. What I'm going to do is I'm going to perform t-test. So when I say t-tests are a type of hypothesis testing by which, you can compare means. So each test that you perform on your sample data basically brings down your sample data to a single value, that is the t value. So as you can see on the screen, this is basically the formula of t value. So now what I'm going to do is I'm basically, going to filter the data set first. So to filter the data set, what I've just used is I've used the filter function. I've used the dataset name, that is basically example. And then you have to mention the parameter based on which you want to filter the data set. Now what I'm going to do is I'm going to just consider the adults. So I've just mentioned person's age to be greater than or equal to 18. After that, the complete data would be assigned to a different variable, that is example A, right? So that's how you can filter the data set. So now if you have any question that, why have I filtered this data set? Well, this is just like a precaution measure to, to make us prevent from making any mistakes downstream when we keep analyzing the data, right? So now what I'll do is I'll just run this particular command and then I'll view the data set. So when I say view example A, you can see that, a person's age is obviously greater than or equal to 18. So there's no child present in this particular data set. Now what I'm going to do is I'm going to perform t-test. So as I mentioned before, t-test is basically used to compare the means. So what I'm going to do is I'm going to use this predefined function in R to perform t-test, that is t.test, and then I'm going to perform the t-test between person age and sex, right? So the person's age is basically the response and the sex is basically the group. So this is basically a formula method to perform t-test in R, and data is basically your data frame, that is example A over here. So when I run this particular command, you can see an output that, we have data to be person age by sex and t is 1.9122. That is basically the t value that is calculated, and the p value is 0.055593. So when I say t-test is basically used to calculate the p value, that is basically the confidence value. So this value basically tells us that, if the p value is less than 5%, that is 0.05, then the t-test between these two values, or you can say the alternative hypothesis between these two values, is getting rejected. But yes, if it is more than that, then you can consider that, it is around 95% correct or apt to the sample estimates, right? So basically, with the t-test that I perform for person's age and sex, what I'm basically trying to find, is there any difference for the age of males versus females in this particular data set? So since the p-value is greater than 5%, you can see that, the mean in group of female is around 47 and mean in group of male is around 45. So yes, you can see that, there is a difference in age of males versus females in this particular data set. Now moving on to the next t-test, that is basically the t-test between body mass index and the diabetes status. Well, I'm performing this t-test to identify whether the body mass index differs between diabetics and the non-diabetics patients. So again, what I'm going to do is I'm going to choose this function t.t-test, and then I'm going to mention body mass index over diabetes status, and then I've mentioned the data frame, right? So I'll just run this particular command. Here you can see that the p-value is less than 5%. That means that obviously your hypothesis is going wrong, and then obviously the answer to this question is no. That means the body mass index does not differ between diabetics and non-diabetics patients. Moving on to the third t-test that I want to perform, that is liquor year versus relationship status. So basically this t-test is trying to answer, do single or married people drink more alcohol or not. So again, I've just mentioned t.t-test, I've mentioned liquor year, relationship status, and the data frame name. And then I'll run this particular command, and you can see that p-value is again less than 5%. That means obviously there is no connection between both these values. So that's how, folks, you can understand how various columns differ over each other, or how various columns can be related with each other. Well, so that was all about t-test, guys. Now these were the various kind of skills, as I mentioned before, a data analyst should possess. Now moving on to the last skill, that is basically the machine learning. So as I said before, knowing machine learning is a bonus point. Now obviously, how would you perform machine learning? That is basically you have to understand the algorithms and you have to build a model for it. So what I've done over here is I am going to just use the linear regression over here. So as you know, the linear models are basically the mathematical representations of the process that we think give rise to our data, right? The model basically seeks to explain the relationship between a variable of interest, that is basically our y variable, which is also the outcome response or the dependent variable, and one or more x predictors or the independent variables. So if we have y equal to b0 plus b1 x, then x is basically the independent variable and y is the dependent variable, and b0 is the intercept and b1 is basically the coefficient that describes what one unit change in the x would do the outcome variable y, right? So that was a basic about linear regression, guys. Now building a linear model basically means that we propose a linear model and then estimate the coefficients and the variance of the error term. So as you can see, if you want to build a linear model in R, then you can just simply use the inbuilt function for linear regression, that is LM function, and then you have to mention the columns between which you want to calculate these values, right? So basically I've decided to find the linear regression model for about person's weight upon person's height, and then over here in the data I've mentioned my data frame, right? Now after that I'll just assign it to fit. So let me just run this particular command. Now after that we'll just find the summary of fit, right? So when we find the summary of fit, you can clearly see that the p-value is less than 2.2 into 10 power minus 16. So that means the intercept term is not very useful most of the time. So this basically shows us what the value of weight would be when the height would be 0, right? So the value of weight would be around minus 19, which is impossible. So that could never happen. But if we observe the height coefficient, we can see that it's really meaningful, because each 1 unit increase in the height results in around 0.6 increase in the corresponding unit of the weight, right? Now if you just want to visualize this particular model, what you can simply do is you just have to use the ggplot function, and then you have to mention the data set, that is example A over here, mention person height, person weight, gm point, and gm sport method to be lm, right? So if I just run this particular command, you can see that we get a plot. So by default, you can see that this is only going to show the prediction over the range of the data, which is very, very important to know. So for example, if you clearly see, the linear model tells us that the weight would be around minus 19.8 kgs when the height is 0. Now let me also tell you that you can extend the predicted model's regression line past the lowest value of the data down to height 0. And also the bands of the confidence intervals basically tell us that the model is apparently confident within the ranges that is defined by the gray boundary. But if you just think about one thing over here, we would never see a height of 0, right? So basically predicting past the range of the available training data is not a great idea, I would say, because there's no point in predicting the past range of data, as the height would never go 0, right? So guys, that was about linear regression. So what we did in this particular demo was we started by importing a data set, and then we learned how to view the data set. After that, we went through a few simple commands, that is the head, tail, dimension, names, and glimpse, and then we understood how to perform descriptive statistics on a data set. So we understood how to use the unique function, the length function, the mean, median, and the range function. After that, I also told you how you can deal with the missing data, that is basic, by using the na.rm parameter and also the is.na function. And finally, you can replace all the na values with the 0, but only for those columns with the data type int. And then we performed exploratory data analysis, where we performed visualizations between various columns and we understood the relations between them. And then we finally perform t-test to understand and answer few questions and perform linear regression, that is basically a machine learning model, right? So I hope that you've understood this particular part of the session. So folks, that was all about data analytics. Now, if you wish to master data analytics, then you can enroll yourself into Data Analyst Master Program provided by Edureka. The stack will start by letting you learn the statistical essentials such as probability, Bayesian interference, regression making, and statistics. Once you get through statistics, you will learn data manipulation, visualization, EDA, mining, sentiment analysis with R. And after that, you will get a proper SAS training where you will be taught advanced statistical techniques like proc SQL, SAS, ODS, advanced SAS procedures, and so on. After that, once you get through all these, you will learn a visualization tool, Tableau, to generate proper reports and perform integration with R. Apart from the learning path, we also offer various electives such as ClickView, Advanced MS Excel 2010, Basics of R, Analytics of Retail Banking, Decision Tree Modeling using R, Machine Learning with Mahout, and Advanced Predictive Modeling in R.
Let's understand why become a data analyst. So data analysts play an important role in today's data-driven world. As businesses increasingly rely on data to drive their strategies, the need for skilled data analysts grows. Here are some important reasons why become a data analyst in an excellent career choice. First, due to its high demand. Organizations in various industries including marketing, e-commerce, healthcare, and finance require data specialists to derive actionable insights. And the second reason is good pay packages. Data analysts typically earn competitive salaries, and with experience, they can progress to higher paying roles like data scientist or business analyst. Next, various career paths. You can work in various fields such as social media, business intelligence, and sports analytics. Next is the flexible career path. If you can analyze data, you can switch to positions like project manager, consultant, or data scientist. Next, constant learning. The industry provides continuous changes to pick up new skills, programming languages, and tools, which keeps the work interesting and dynamic. Now that we know why should we become a data analyst, so let's discover what data analysis is. Well, data analysis is the process of reviewing, cleaning, and organizing data to identify patterns and trends. This knowledge can help you make better decisions in many industries, including marketing, technology, healthcare, and finance. And this is how it works. First, cleaning up the data. The analyst begins by correcting any errors or discrepancies in the data, and this ensures the accuracy of the results. Next, shaping the data. They then convert the unprocessed data into a more easily analyzed format such as tables or graphs. Next is the modeling the data. Finally, models and formulas are used to generate predictions and identify patterns in the data. Now we will learn the necessary skills to become a data analyst. First, a solid understanding of mathematics and statistics is essential for data analysis because these principles serve as the foundation for accurately analyzing and interpreting data. Mathematics aids in understanding patterns, trends, and relationships in data, whereas statistics provides tools for making sense of variability and uncertainty in data. And some of the mathematical concepts to learn to become a data analyst include mean, median, and mode. This central tendency measures summarizes data by determining the average, middle, or most frequent value. Next, standard deviation and variance describes how much data points deviate from the mean, providing insights into data dispersions. Next, the probability is necessary for predicting outcomes, understanding likelihood, and using probabilistic models in decision making. And then the hypothesis testing. This method aids in drawing data-driven conclusions by testing assumptions and calculating statistical significance. And mastering these concepts is critical for extracting insights, drawing conclusions, and facilitating decision-making through data analysis. The next critical step is to build strong Excel skills. Excel, a popular data analysis tool, is still used in many businesses. Concentrate on mastering core features like functions, pivot tables, and charts, which are essential for effectively organizing, analyzing, and visualizing data. And some important contributors will be create and manage worksheets, then learn important formulas like count, min or max, and average, then use advanced functions like concatenate, sumif, countif, sum product, VLOOKUP, and so on. And then use pivot tables and conditional formatting to summarize and analyze data. Followed by various types of charts will be used to demonstrate your findings. Next, use sensitivity analysis to learn how different variables affect your data. Then, building Gantt charts or financial statement. After mastering Excel, the next step is to learn SQL, which stands for Structured Query Language, a powerful yet easy to learn language for mastering and querying databases, enabling efficient access, organize, and analysis of data. So begin by learning the basics such as writing queries with select, insert, update, and delete statements. Then progress to more advanced concepts like joins, group by, and subqueries to handle complex data operations. Then start by learning the fundamentals of Python, a versatile and widely used language for data analysis. Its simplicity and extensive library support make it ideal for both newcomers and seasoned professionals. So focus on essential libraries such as Pandas for data manipulations and Numpy for numerical computations. While you may come across R, another popular data analysis language, it is recommended that you start with Python because of its versatility and broader use cases. Once you have mastered Python, you can discover how R excels in statistical computing and visualizations with powerful packages designed specifically for statistical modeling and graphical displays. It's frequently used in academic and research settings. Next, Git is useful in data analysis because it manages and tracks changes to scripts, notebooks, and data workflows. It promotes collaborations by allowing multiple analysts to work on the same project without conflict, ensures analysis reproducibility by keeping track of changes, and integrates with data pipelines. Git also facilitates collaborations among data engineers and scientists by providing version control for code and processes. Next, data collection and preparation. Collection and preparation involves gathering raw data from a variety of sources and cleaning it before analysis. This includes removing duplicates, managing missing values, and ensuring data consistency. Using Python libraries such as Pandas, you can manipulate and transform data into analysis-ready format. Mastering data cleaning and transformation is critical for achieving accurate and consistent results. Next is the data visualization. Data visualization is critical for identifying patterns, trends, and insights and effectively communicating results. And to create statistic visualizations, you should master Python libraries such as Matplotlib and Seaborn. Then, familiarize yourself with business intelligence tools such as Tableau and Power BI, which enable the creation of interactive, shareable dashboards. Power BI stands out due to its growing popularity and seamless integration with other Microsoft tools. Next, machine learning. A solid understanding of machine learning is advantageous for any data analyst. Machine learning trains computers to make data-driven predictions. So if you want to learn, start with the fundamentals, which include Python libraries like TensorFlow and scikit-learn. And as you progress, you will be able to explore more advanced methods and tools. Then, moving on to big data. So when working with large data sets, big data tools become indispensable. Big data involves efficiently processing and managing massive amounts of data. Hadoop and Spark are essential tools for dealing with large amounts of data. Following this roadmap will help you develop the skills needed to apply for a data analyst position. And as you have understood how to become a data analyst, let us look at the data analyst career opportunities with salary. So first, let us talk about the entry-level data analyst. To apply for this role, you need a bachelor's degree in mathematics, statistics, economics, finance, computer science, or a related field. Required skills include data extraction, manipulation, analysis, visualization tools, dimensional modeling, data warehousing, advanced Excel for reporting, and mid-level SQL proficiency. Along with this, you need to have strong communication skills are essential, and knowledge of industries like healthcare, finance, or pharmaceuticals is a plus. And mentoring experience is preferred. As you can see, I have added a screenshot from LinkedIn of who is hiring for this position, and I have already explained to you all the skills that I've mentioned here. Let us discuss the salary for an entry-level data analyst. In India, entry-level data analysts earn an average of 8 lakhs per year, whereas in the United States, they earn around $85,662 per year. Alright, next, moving on to mid-level data analyst. The position requires knowledge of Oracle analytics tools such as Oracle Analytical Cloud, OBIEE, and Fusion Analytics, and strong BI ETL design skills, proficient in Power BI or Tableau, and experience with ETL tools such as ODI or Informatica are preferred. And then, delivering tailored POCs, workshops, and data solutions, engaging stakeholders, and fostering effective communications and relationships are all part of the job. And as you can see, I have added a screenshot from LinkedIn of who is hiring for this position. And I have already explained to you all the skills that are mentioned here. Now, let us discuss the salary for a mid-level data analyst. In India, a mid-level data analyst earn an average of 12 lakhs per year, whereas in the United States, they earn an average of $116,452 annually. Next, moving on to the senior level data analyst. The data analytics specialist will develop and manage dashboards using Spotfire and Tableau, analyze data for insights, write and optimize SQL or PL/SQL queries, collaborate with teams for tailored analytics solutions, ensure data integrity, and resolve issues in analytics tools and pipelines while staying current with industry trends. And as you can see, I have added a screenshot from LinkedIn of who is hiring for this position, and I have already explained to you all the skills that are mentioned here. Now let us discuss the salary for a senior level data analyst. In India, a senior level data analyst earn an average of 20 lakhs per year, whereas in the United States, they earn an average of $119,000 annually. And as the demand grows, it's crucial to understand the future scope of data analysis. So, the IDC study highlights key trends in data and analytics, such as the convergence of data intelligence and AI, the adoption of data as a product architectures, and the emergence of generative AI. This requires data analysts to work with complex dynamic data environments and use advanced AI tools to extract insights from unstructured data. As the role of chief data and analytics officers evolves, data analysts will play an increasingly important role in data governance, security, and assisting organizations in adapting AI-driven solutions.
So let us move forward and understand what exactly is Numpy. So what is Numpy? Numpy is basically a module, or you can say a library, that is available in Python for scientific computing. Now it contains a lot of things. It contains a powerful n-dimensional array object, then tools for integrating with C, C++. It is also very useful in linear algebra, Fourier transform, and random number capabilities. Now let me tell you guys, Numpy can also be used as an efficient multi-dimensional container for data, for generic data. Now let me tell you what exactly is multi-dimensional array. Now over here, this picture actually depicts multi-dimensional array. So we have various elements that are stored in their respective memory locations. So we have 1, 2, 3 in their own memory locations. Now why is it two-dimensional? It is two-dimensional because it has rows as well as columns. So you can see we have 3 columns and we have 4 rows available. So that is the reason why it becomes a two-dimensional array. So if I would have had only one row, then I would have said that it is a one-dimensional array. But since it contains rows as well as columns, that is, it is represented in a matrix form. That is why we call this as a two-dimensional array. So let me open my PyCharm and I'll tell you practically how to actually create a NumPy array. So this is my PyCharm, guys. Over here, the first thing that you need to do is first install the numpy module. And how you're going to do that, click on File, go to Settings tab, and you'll see the Project Interpreter option. And on the right hand side, you'll see a plus symbol. Just go on and type the module that you want to install. So I'm going to install numpy. Just go there, click on it, and install package. I've already done that, so I'm not going to repeat it. So this is my PyCharm. So first thing that I need to do is import numpy as np. Now after that, I need to create a numpy array. So for that, I'm going to define a variable, let it be a, and I'm going to type in here np.array and certain elements inside it. So I'm going to put in 1, 2, 3 and print it. That's all. So this will actually print a single dimensional array. So 1, 2, 3 has appeared. Now if I want to convert this to a 2D array, so for that I'll keep this in parenthesis. And after a comma, I'll add one more element and I'm going to give certain values inside that. So I can give, say, 4, 5, and 6. Now go ahead and print this. So as you can see that it is now a two-dimensional array. So this is how you actually create arrays using Numpy module. Alright, so many of you might be thinking, why are we using Numpy when we have list? So basically we use Numpy because of three main reasons. The first thing is it occupies less memory when compared to list. Then it is actually pretty fast when you compare it with list, and at the same time it is very convenient to work with Numpy. So these are the three major advantages that Numpy has over list, and that is the reason why we use Numpy instead of list. Now don't worry, I'm actually going to prove it to you practically by opening my PyCharm. So guys, this is my PyCharm again. So first thing that I need to do is import numpy as np, and now what I'm going to do is I'm going to import a couple of more modules. I'm going to import time and I'm going to import sys. So our first step is to actually define a list, and the name that I'm going to give to my list is, say, s, and I'll type in here range 1000. So what this will actually do, it'll actually take all the integer values between 0 to 1000 and it will give it to a variable s. So this list will contain the integer values between 0 to 1000, but it won't include 1000. It will be only there till 999, that is 999. And now I'm going to print the space occupied by this particular list. So for that, what I need to do is I need to type in print sys dot get size of any one element. Okay, so you can give 3, 4, 5, anything. I'm going to give it as 5, any one element, and multiply that with the length of my list. That's all. So this will actually give me the space that has been occupied by the list, because sys.getSizeOf will actually give me the memory occupied by one element, and when I multiply that with length of my list, I get the entire memory that has been occupied by my list. Now the same I'm going to do with my numpy array as well. Let me give a name to that. I'm going to type in d np.arange, and the range will be 1000. Now arange function is pretty much similar to the range which is there. So the same thing will happen here. The integer values between 0 to 1000, but it won't include 1000, will be present in my variable d. So we have created a numpy array. Now let us print the space occupied by it. So the first thing is I'm going to type in here d dot size. So this will actually give me the space occupied by one single element, and when I multiply that with the length of my numpy array, I get the entire memory that is occupied by the numpy array. So I'm going to type in here d dot item size. That's all. Now go ahead and print this. So this actually shows the memory that has been occupied by my list, and this shows the memory that has been occupied by my numpy array. So as you can see, there is quite a lot of difference between both of them. So we have proved our first point that it actually occupies less memory. Now when I talk about numpy array is faster and more convenient than a list. So the next step is I'm going to prove it to you that numpy array is actually faster and more convenient than list. So I'll remove all of this, and so now I'm going to show you that numpy arrays are faster than list. And at the same time, it is easier and more convenient in order to work with numpy arrays when compared to list. Let me show you practically. So first what I'm going to do is I'm going to define a variable, say size, which is equal to, say, 1000, and then I'm going to define two lists. Now what I'm going to do is I'm going to add those two lists, as well as I'm going to add two numpy arrays, which I'm going to define now. And then I'm going to compare the time taken in order to find the sum for list and the sum for numpy arrays. So first let me define two lists and two arrays. So my first list will be equal to range size. Same goes for my second list as well. Just change the name to L2. And now I'm going to define two numpy arrays, a1 equal to np.arange size. Go ahead and do the same for the second numpy array as well, and change the name as a2. So we have two lists and two arrays, and we need to compute the sum of both of these lists as well as arrays. Now before that, I'm going to define a variable, say start, which is equals to time.time, And now I'm going to calculate the sum. So I'm going to save that in result. And first I'm going to calculate the sum of list, that is L1 and L2. So for that, what I need to do is I need to run a for loop, because if I directly write L1 plus L2, it is going to give me a result which is nothing but the concatenation of both the lists. So in order to calculate the sum, I need to use for loop. Let me show you how to do that. First, I'm going to type in x comma y, and we have already studied loops in detail. For x comma y in zip, and the name of the two lists, that is L1 comma L2. That's all. So what will happen here, it'll first take the first element of list L1, and then it'll take the first element of list L2. It'll calculate the sum and it'll store in result, and it'll keep on repeating until the range has been exceeded. Now this is how you calculate sum in lists. But when you talk about arrays, what you need to do is you need to just write in A1 plus A2. That's all. That's why I'm saying that it is more convenient in order to work with Numpy arrays when compared to lists. Now our next step is to define the same variable start and initialize it with time.time. And now I'm going to find the sum of my two numpy arrays, which is nothing but A1 plus A2. That's all. And now print the time taken. So print time.time minus start, and then multiply it with 1000. Because by default it'll take it in seconds and I need to convert it into milliseconds. Now I forgot to actually print the same thing for my list, so I'm going to do it over here. So this will actually give me the time taken by my list in order to compute the sum, and this statement will give me the time taken by my numpy array in order to compute the sum. So let us go ahead and execute this and we'll see what happens. So it gives me 0 milliseconds because the size is small. Let me just add a couple more zeros. Let's make it 1,000,000. Now go ahead and execute this. Now you can notice the difference, that there is a significant change. Lists took 208 milliseconds, whereas numpy array took almost 67 milliseconds. So there's a huge difference between the compute time of a list as well as numpy array. That's why I say that numpy array are faster, convenient, and at the same time they occupy less space when compared to list. So that is the reason why we choose numpy arrays over list. If you have any questions or doubts, you can ask me. So let us go ahead and move forward towards the next topic, that is numpy operations. So let me go back to my slides. So now is the time to see various operations that you can perform with the numpy arrays. So you can find the dimension of your array, whether it is a two-dimensional or a single-dimensional array. Then you can even calculate the byte size of each element. It is pretty easy. I'm going to tell you that practically. You don't need to worry about that. And you can even find the data types of the elements that are stored in your array. So if you want to know what is the data type of the elements, you can do that as well. So let me show you these three operations first, and then we'll move forward to the other operations. I'm going to open my PyCharm once more, guys. Let me remove all of this. So we have imported the numpy module. Now what I'm going to do is I'm going to define a numpy array. I'm going to name it as A, and I'll write here np.array 1, 2, 3. Put that in parentheses. Now add one more element, say 2, 3, 4. Alright, so it's a two-dimensional array. Now if I want to know whether it's a two-dimensional or a single-dimensional array, so I'm just going to type in print a.endim, and it'll give me the dimension. So let me show you that, and I'm going to run this. So it says 2, that means it is a two-dimensional array. So what if I move this part and make it as a single dimensional array? It should give us the result as 1. Let's see if it does that or not, and yep, it gives us 1 as a result. So this is how you actually calculate the dimension of your array. Now if you want to find the byte size of each of the elements, so what you need to do is, instead of endim, you can call a function called item size. Go ahead, execute this, and you'll get, so each element occupies 4 bytes. After that, if you want to know the data type that is stored in the array, so you can just type in here dtype. Go ahead, execute this. It should give us integers 32-bit. Alright, so this is how you can actually perform these three functions that I've told you in my slides. So let us proceed with the presentation. Now let us move forward and see what are the other operations that you can perform with numpy module. So by using numpy array, you can actually find the size of your array. How you can do that, I'll show you practically. You don't need to worry about that. So when I say size of the array, that means the total number of elements that are present in the array. So if this is an array, so the total number of elements become 4. 1, 2, 3, and 4. Now you can even find the shape of your array. Now what do you mean by shape? So basically the total number of columns and rows. Now over here we have 3 columns and 4 rows. So our shape is actually 3 columns and 4 rows. Now let me show you practically how you can do that. Again, I'm going to open my PyCharm and show you. Let me remove this print statement from here. Now if I want to find the size of my numpy array, I just need to type in print a.size. That's all you have to do, and it'll give the size of your array. So there are 3 elements. So if I go on and add some more elements, say 4, 5, 6, 7, then if I execute this, you'll see that 7 elements have appeared. That means the total number of elements in my array is 7. Then comes the shape part that I was talking about. So in order to find the shape, what you can do is you can just type in here a.shape and it'll give you the shape. So let us see what happens. So it has 7 columns, but there are no rows. So it has given 7 comma blank. So what I can do is I can close this in parentheses and I can define one more element, say 8, 9, 10, 11, 12, 13, 14. Go ahead and execute this and you can see 2 comma 7 because we have 2 rows and 7 columns available with us. So this is how you can actually find the size of your array as well as you can find the shape of your array. Now let us move forward and see what are the other operations that you can perform with numpy module. So we saw how to find the size and the shape of an array. So we can perform reshape as well as slicing operation using numpy array. Now when I talk about reshape, what do you actually mean by reshape? When you change the number of rows and columns, that is called reshaping. Now over here there is an example. So we have 3 columns and 2 rows, which we have converted to 2 columns and 3 rows. Now let me show you that practically how you can do it. In a variable, and I'm going to start a numpy array and I'll have 2 elements in that. My first element will be 1, 2, 3, 4, and my other element will be say 3, 4, 5, 6. So I have a 2-dimensional array that contains 2 rows and 4 columns. Now I can convert that to 4 rows and 2 columns. Let me show you how to do that. You're just going to type in a is equal to a.reshape, and I want to convert it to say 4 rows and 2 columns. Go ahead and print this. So it has converted that to 4 rows and 2 columns as you can see it in front of your screen. Now let me show you that earlier this is not the case. I'm going to type in a print statement here as well in order to show you that how it has reshaped. So earlier we had 4 columns as well as 2 rows, but now we have 2 columns and 4 rows. So this is how you can perform the reshape operation. Now let us talk about slicing. So slicing is basically extracting a particular set of elements from your array. And the slicing operation that happens here is pretty much similar to the one which is there in list as well. So suppose if I want only this particular element, that is 3. So for that what I need to print, I'll show you, print a and the index value of 3 which is present at 0, comma, and the index is 2. Let me tell you how indexing happened. So this element will be 0, this element will be 1. Now if I want 3 from here, from the 0th element, I want the index 2. Indexing starts from 0, 1 and 2. So that's why I've written 0, 2 and it should print 3 for me. Let us see if it does that or not. And yep, it prints 3. Now say if I want to print 4 and 6. Now for that what I need to do is I need to remove this 2 here and I'm going to put a colon that says all the rows including 0, and in that row I want only index 3. So we have only 2 rows, so if I would have written 0, 1 then it wouldn't have included this particular row. So if I have one more element here, so I can actually write here 2, so that won't actually include the element which is present at the second index. So when I say 0, this actually means all the rows that includes 0 as well. So we have only 2 rows, it will include both the rows, and at the same time it'll actually going to print the third index from both of these rows. So let me show you if that happens or not, and yep, it happens. We have 4 and 6 available with us. Now just to remove confusion, what I'm going to do is I'm going to add one more element and I'm going to give values to it, say 7, 8, 9 and 10. So now if I want 4 and 6, I can't just write 0 colon, because if I do that, it'll print 10 as well. Let me show you that. Yep, it has printed 10. Now, in order to avoid that, what I can do is I can write in here 2. So as I've told you, this is the 0th element, first element, and the second element. So when I write 0 colon 2, it won't include the second element. It'll only include 0th as well as the first element. Now, inside that, we have index 3 from both of these rows. That is why we'll actually get 4 and 6. Let us see if that happens or not. And you can see 4 and 6 is now available. So this is how you can perform slicing when we in numpy arrays. Now what I'm going to do is I'm going to type in a equal to np dot line space, and now over here first I'll write 1 comma say 3, and I want say 5 values between 1 comma 3. What this will do is it'll actually print the 5 values which are equally spaced between 1 to 3. So let me print this first. I'm going to type in print a and go ahead, execute this, and you can see that we have 1, then we have 1.5, then we have 2, 2.5 as well as 3. So if I would have written here 10, it will actually give me 10 values between 1 to 3. And yep, you can see we have the 10 values between 1 to 3. So this is how you can perform line spacing as well. So any questions or any doubts till now, guys, you can ask me. So there are no questions. Let me open my slides and we'll see what are the other operations that you can perform with numpy. So we saw how to perform reshaping and slicing. Now let us see what are the other operations. So we are now going to find out the minimum, maximum, as well as the sum of our numpy arrays. So let us go ahead and execute that practically. Let me remove all of this, and now I'm going to define one more numpy array, np.array, and I want elements in it, say 1, 2, 3. Now if I want to find the element which has the maximum value, so what I can do is I can just type in here print a dot max. That's all, and it'll give me the maximum value in my a numpy array, which is 3 obviously. If I want to find minimum value, so I'm just going to type in here min, and it'll print the same for me, which is 1. Now if I want to calculate sum, it is pretty easy. Just go on and type sum and it'll give you the sum. That's all, guys. It's that simple. So let us move forward with our slides. So now comes the axis concept here, guys. It is pretty similar. We have a numpy array which looks like this, and the rows are called axis 1 and columns are called axis 0. Now you must be thinking, what is the use of this axis? Suppose if you want to calculate the sum of all the rows, then you can actually use these axes and you can do that. Now let me show you practically how it happens. I'm going to open my PyCharm again and I'm going to show it to you. Let me remove this and let me add one more element here, 3, 4, 5. So if I want to find the sum of axis 0, it's very easy. Just go on and type print a dot sum and type in axis equal to 0. Go ahead and print this, and you can see 4, 6, and 8. 1 plus 3 is 4. 2 plus 4 is 6. Similarly, 3 plus 5 is 8. If I make this as axis 1 and print this, so it gives me 6 and 12, because 3 plus 2 plus 1 is 6. Similarly, 4 plus 5 plus 3 is 12. So this is pretty easy, I know. Now let us go back to our slides and see what are the other operations. So there are many mathematical functions that you can perform with numpy. That is to find the square root of each element. You can even find the standard deviation. The standard deviation basically means that whatever the elements that are there in your NPY array, you find the mean of that and you actually find out how much each element deviates from that mean. So that exactly is standard deviation. So yeah, these two operations can be performed with the help of numpy. You can find the square root, you can find the standard deviation. Now let me show you that how you can do it. This is my PyCharm again. So now I'm going to remove this print statement here, and I want to print the square root of each of the elements that are there in my numpy array, which is actually assigned to a variable a. So I'm going to type in here print np dot sqrt, that is square root of my numpy array a. Go ahead and execute this, and it is actually printed the square root of each of the elements. So the square root of 1 is 1, for 2 it is 1.414, for 3 it is 1.73, again for 3 it is 1.73, then for 4 it is 2, then for 5 it is 2.23. This is how you can find the square root of each of the element. Now when I talk about standard deviation, so you can find that by typing here So now if I want to find the standard deviation, what I need to do is instead of sqrt, I'll just type in here std and it'll give me the standard deviation, that is how much each element varies from the mean value of my numpy array. And this is the standard deviation, guys. It's that simple. So this is how you find standard deviation. Now let us go back to our slides and see what are the other operations that are still left. Now these are the basic mathematical functions that you can perform with numpy arrays, like addition, multiplication, subtraction and division, and that will actually happen element wise. So basically you are performing matrix addition, matrix multiplication, matrix division, as well as matrix subtraction. Let me go ahead and show it to you practically. It is very, very simple, guys. So similarly, I'm going to define one more array and let me name it as B. Let me remove this print statement. Now if I want to calculate the sum, so what I need to do is I need to type in print A plus B. That's all you need to do. But when I talk about list, again I'm telling you that when I talk about list, if I do that, it will concatenate both the lists. So if I want to print list, that is the addition of two lists, I need to use for loop. So that is where numpy array stands apart, and it is pretty convenient. Go ahead and execute this and you'll see that element-wise addition has happened. 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6. Similarly, 3 plus 3 is 6, then 4 plus 4 is 8, 5 plus 5 is 10. Alright, so this is how you can perform addition. You can perform subtraction by using the subtraction operator. Go ahead, execute this, and you'll find all zeros because 1 minus 1, 2 minus 2, 3 minus 3, 3 minus 3, 4 minus 4, 5 minus 5 will be 0 only, right? No rocket science. Now go ahead and multiply it as well and see what happens. So you have 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, again 3 into 3 is 9, 4 into 4 is 16, 5 into 5 is 25. If I go ahead and divide this, it'll give me all ones, and yep, it does. So this is how you can actually perform addition, subtraction, multiplication and division using a numpy arrays. Now let me go back to my slides and see what are the other operations present. So now guys, let me tell you one more thing. If I actually want to concatenate two arrays, I don't just want to add those two arrays. You can say that if my one array is a box, then I want another array on top of it. So let me show you how you can do that. Actually, there are two ways to do that. One is called vertical stacking and another is called horizontal stacking. Let me show it to you one by one. First, I'm going to show you vertical stacking. For that, what I need to do is print np.vstack and a comma b. Let us see what happens when I run this. So we have 1, 2, 3. 3, 4, 5. Then again we have 1, 2, 3 and 3, 4, 5. So this is called vertical stacking. If I want that horizontally, I'll just write in here hstack and I'm going to run this now. And you can see that we have 1, 2, 3. Then again 1, 2, 3. That means these two are present added horizontally. And we have 3, 4, 5. Again we have 3, 4, 5. So this is how you can perform stacking as well. Now there's one more thing that I want to show you. If I actually want to convert this particular numpy array, that is A, to say a single column. So how I can do that? Just type in here print a dot revel. That's all you have to do. Go ahead and execute this. So you'll have 1, 2, 3, 3, 4, 5. So you have 1, 2, 3, 3, 4, 5. Let me go back to my slides and see what are the other topics that we are going to cover. Now come certain numpy special functions. Now I'm going to talk about sine function and cosine function first. So what I'm going to do is I'm going to use this cosine and sine function and I'm going to plot sine and a cosine graph. So for that I'm going to import a module called Matplotlib. For now what we are going to do, we are just going to use sine and cosine function in order to print their graph. So for that I'll open my PyCharm and let me remove this and import Matplotlib dot pyplot as plt. Now we are going to define two coordinates, that is x and y. First, x is equal to np dot arange 0, 3 into np dot pi, 0.1. Now I'm going to define y. So for that I'll type y np dot sine x. Now I'm going to use plt in order to plot the graph x comma y. Now finally show the plot. For that I'll type plot.show. You must plot.show to make a graphics appear. So plot.show and here we go. Go ahead and execute this and you might be able to see a graph, and yep, it is here. Similarly, what if I change the sign to cos and should give me the cosine graph? Go ahead and run this and you can see we have a cosine graph as well. Similarly, if I write in here tan, that is any other trigonometric function, and I print this, so I get the graph for tan as well. Now NumPy comes with two very good functionalities, I would say, that is called exponential function and logarithmic functions. Now exponential, this e value is somewhere equal to 2.7 and we all know log. So when I talk about log, it is actually log base 10, and when I'm talking about natural log, that is log base e, I will write it as ln. So instead of that, I've written log, that means log base 10. So you can perform these operations with the help of NumPy. Let me show you how you can do that. So I'll open my PyCharm. Let me remove this. And I'm going to define a NumPy array. Let it be AR equal to np.array 1, 2, 3. Now I want to calculate the exponential value. I'm going to throw in a print statement and I'm going to write in here np.exp AR, and this will calculate the exponential value for me, and let us see if it does that or not. So yep, as I've told you earlier as well, value of e is 2.71. So e to the power of 1 is actually equal to e, so it has returned the e value, but e to the power of 2 will be somewhere equal to 7.38. E to the power of 3 will be somewhere equal to 20.0855. Now in order to calculate log, what you can do is you can just type in here log. Now this will give you natural log. So when I talk about natural log, it is nothing but ln, or you can say log base e. But if I want to calculate log base 10, so I need to type in here 10. First let me show you how you can find the natural log. Just go ahead and execute this. Alright, so when I talk about 1, so e to the power of 0 will be equal to 1, right? So log or ln AR equals to 0. Similarly, the other values as well. Now if I want log base 10 instead of ln, or you can say natural log, I can just write in 10 and go ahead and execute this and you'll find log base 10 values. So obviously when answer is 1, that means anything to the power of 0 is equal to 1. So the answer will be 0 here, and similarly we have other answers as well. If you're unsure about it, you can open your calculators and do that.
So let us go ahead and take a look at what exactly is Pandas. So Pandas is a Python library which is used for data manipulation, analysis and cleaning. And Python Pandas is well suited for different kinds of data, such as we can work on tabular data with heterogeneously typed columns. We can work on ordered and unordered time series data, arbitrary matrix data with rows and column labels. We can work on unlabeled data, and we can also work on any other form of observational or statistical data sets. Now I'm going to tell you how you can install Pandas on your systems, guys. It's very easy to install Python Pandas. You just go to your command line or terminal and just type pip install Pandas, or if you're working on an IDE such as PyCharm, you can just simply type in pip install Pandas in your terminal over there, or you can just open the project interpreter and add the library over there. Since we are going to work on Jupyter Notebook, I'm going to tell you how you can install Python Pandas on Anaconda. So you just have to do one thing. So I'll just show you guys how you install Python Pandas on your system. You open the Anaconda prompt. We'll wait for the prompt to set up. So you type conda install. It's already there in my system because I've already installed Pandas, since I've already worked on various data analysis projects, and it's a very integral part of it. Because to work on a data set, to read a data set, you require Pandas, and it's just that you cannot work without Pandas if you're working with any data related project. So this is how important Python Pandas actually is. I'm going to tell you a few applications of Pandas as well. So first of all, you can just say that Python Pandas is an integral part of data, whichever project you're working on. So you can work on economics. You can use Python Pandas for stock prediction. You can use it for recommendation systems. Then you can use it on neuroscience and statistics also. You can use it for, and then there is advertising, so many data coming from different platforms. You can just analyze the data using Pandas, clean the data for irrelevant, inconsistencies in your data. You can do that using Pandas, and then you can use it for analytics as well. That's the very basic use of Python Pandas that I can think of. So right now that we know how pandas actually is in Python programming and what it is used for, let's go ahead and take a look at the very integral part of pandas, that is data frames and series. We'll wait for this to install, guys. Meanwhile, I'll just tell you what are data frames and series, guys. So data frame is a two-dimensional and the size of the data frame is mutable, potentially heterogeneous data, or we can call it heterogeneous tabular data. So the data structure, which is data frame, also contain labeled axes, which is rows and columns, and arithmetic operations align on both rows and column labels. It can be thought as a dictionary-like container for series objects. Now, what exactly is a series, guys? So a series or a pandas series is a one-dimensional labeled array capable of holding data of any type, which is integer, can be string, float, Python objects, etc. And the axis labels are collectively called index, and pandas series is nothing but a column in an Excel sheet. So let's just take a look at a few examples and then you'll be able to understand this better, what I'm talking about, like pandas and series, what exactly they are. We'll be working on an example now. So I'll just take it to Jupyter Notebook, guys. So we have already created a Jupyter Notebook. If you are not familiar with Jupyter Notebook, guys, we have a full tutorial on how to use Jupyter Notebook, all the cheat sheet and everything. So you can just refer to those in our Edureka YouTube channel. And make sure you subscribe to Edureka for more exciting tutorials because we have a lot of content on Python, guys. So if you want to learn Python inside out or any other technology for that matter, we have a lot of content on YouTube you can refer. Also, if you are at it, be sure to check out our courses on edureka.co, and we have a full Python programming certification program that you should also check out. So since I have already installed Python pandas, I'm just going to import pandas as PD. Run this. I'm not going to face any problem running this command because I have already installed pandas. Okay. So what this command will do over here, it's going to install the package, the latest release of pandas for me. I think that's why it's not running. Okay, we have our first statement over here and we have successfully imported pandas as PD. So I'm using the alias as PD. I hope you guys know what alias is. So let's just say I'm importing this library. So alias is going to be this one, that is PD. So for importing, I'll tell you why I'm using this. Now if I want to create a data frame, I'll just use df as my variable name for data frame. So I'm going to use the alias. Now when I type tab over here, okay, so this is how I can use my alias to create a data frame. So this is just to tell you how you use an alias. Now I'm going to show you how you can create a series and a data frame. So first I'm going to, I'll have to import Numpy as well because I'm going to use it to create a null value. All right. So df is equal to, I'm going to make a series. So I'll just write it as S. All right. Series, and I'm going to pass a list of values. Let's say 1, 2, 3, 4, 5, 6. And I'm going to use my Numpy now to create a null value like 8, 9, and one more value, let's say 10. So it's going to create a series. Now when I print S, so we have a series which has indexes which are already there and all these values that I passed inside a list. So this is how you create a series in Python, guys, using pandas. After this, I'm going to tell you how you create a data frame. So for that also, I'm going to tell you how you create a data frame using a dictionary object and how you can create a data frame using series as well. So now what we are going to do is we are going to create a data frame by passing a NumPy array with a datetime index and label columns. So I'll take one variable, let's say date or dates. I'll just type it as D, and I'm going to take pd dot. So we're going to take the date range. And after this, I'm going to pass a few values, let's say 2020, and I'm going to pass values like we're in the month of March, so I'll just write it as March. And after this, I'm going to take periods, which is equal to, let's say 10. So this is my date range, guys. Okay, I have an invalid syntax, right? Should work fine now. So when I print D over here, so I have all these values in a date range format. After this, what I'm going to do is I am going to take one data frame, which I am going to take as df for obvious reasons. to make it clearer, and I'm going to take data frame, and inside this I'm going to pass a few values. So first of all, I'm going to take a few random values. So I'm going to use np.random number, and inside this I'm going to pass 10, let's say 4. Now I'm going to get the index values as d, and I'm going to have to pass a few more values, which is columns. So I'll pass the columns as a list, and I'm going to take, let's say, 4 columns. So I'm just going to take, okay, wait a minute, A, B, C, D. All right, do we have any errors? No. So now I'm going to print my data frame. So I have a data frame, guys, which I've created using, passing a numpy array, and I have a datetime index with labeled columns, which are A, B, C, and D. This is my index, guys, and I have all these random values using np array. So this is how you create a data frame, guys. Just a simple example, and I'm going to show you how you can create a data frame by passing a dictionary of objects that can be converted into a series also. So I'll take, let's say, again, df is equal to pd dot data frame, and I'm going to pass a dictionary over here now. So I'm going to take a few values first of all. So first value is, let's say, A. Now after this I have to pass something, right? Okay, I'm gonna write, let's say, a list of 1, 2, 3, and 4. After this, my next value is going to be, let's say, B, and I'm going to pass a timestamp, let's say. And for timestamp, I'm going to use the same I have used over here, 2020 0301. I have to use the right, and after this I'm going to pass one more value, let's say C, and I'm going to use a series now, a series object, and inside this I'm going to pass 1, and the index is going to be, let's say, a range. All right, index is equal to a list with a range of 4, because we have only 4 values over here. We don't want any null values. And after this I have to type in the data type as well, the data type of the series, guys. So for that I use dtype is equal to, let's say, float 32. All right, after this I provide my next value, which is D. Now for D I'm going to use an numpy array, and for this I'm going to pass a value, let's say not 3, let's say 5 multiplied by 4, and let's take the D type is equal to integer 32. Yes. All right, now I take my final value, which is going to be E, and inside this I'm going to pass a data frame, or we're going to use the categorical object, guys. We're going to talk about this later on in the session, so don't worry. I'm just showing you how you can create a data frame using all these objects that we have at our disposal, guys. Now, instead of test and train, we can just call it as true or false. It doesn't matter. We are taking categorical object, so it has to be either true or false, or it can be 0 or 1, but it has to be decisive in a way that there are only 2 values. So I take another value, and for this, let's just say I give the value Edureka. All right, so our dictionary is done over here. So we have created our data frame, guys. There's no error. Now when I print this, so we have our data frame, guys. So A, B, C, D, E, and F. So we have all these values using different data types, or we can call it objects as well. So for that also we can check the data frame, and we just write D types, and it's going to give us all the data types that we have. So we have date timestamps over here, integer, float, integer, category, and an object, because I have used a string over here. That's why it is giving us an object. But in the new release, that is Python 1.0.0, it's not going to be an object. It's going to show you it is a string. So don't worry, guys. And we have already made a video on Python Pandas 1.0.0 with all the features that have come with the new release, the new stable release released last month. You can check that out as well to check for the new features that we have come across. So now that we have done this, let us take a look at the next topic that we have, which is how to view data. So viewing data is basically, how you actually look at the data, or how you're going to look at the data using Pandas library. So we'll just jump right to Jupyter Notebook, guys, and I'll tell you what kind of functions or all those things you have at our bay that we can use to view our data. So we'll do one thing. First of all, we have data frames already that we have over here. So I'll do one thing. I'll just change it to df1 so that we have different data types, or I'm sorry, different data frames, guys. I'll run this and this as well. When I check for df.d types, it should be different, guys, because we have already made a data frame using that. All right, it's not. So I'll run all the wait. So I'll do one thing. I'll restart and run all the cells so that we have two different data frames. So first of all, the first very basic thing that you can do for your data frame is to use, I'll just tell you guys, you write df.head. So what this function is going to do is give you the first 5 values inside your data frame, or the first 5 rows. And similarly, for the last rows, you can use the tail method. So this is how you get the first and last values inside your data frame. So it's going to display all the 5 values that you have at your beginning and the end of your data set. After this, we have df.index. So what this will do is it will give you all the values from your index. And similarly, we have df.columns, which is going to give you all the columns from your data frame. So this is how you view your data, guys. And then we have dataframe.toNumpy, which is going to give you a NumPy representation of the data. So I'll just tell you how you can do that. So I'll just write df.toNumpy. Wait a second, guys. Yes. So I'm going to create a NumPy array using this. I actually created a NumPy array. And for df, our data frame of all floating point values, dataframe.toNumpy is actually fast and does not require copying the data. So it is a very best deal for we have. And then, okay, I'll just remove this. I don't want this. And then we have dataframe.describe, which is going to give you somewhat like this, which is going to give you the count, the mean, the standard deviation, minimum, 25%, 50%, 70%, and maximum. So these are all values using the describe you can have, which is going to give you an idea or a perspective of how your data actually is and what kind of calculations are already there that you can think of. Then we have sorting by an axis. We can sort our data using an axis. So for that, you have to just write, okay, I'll just show you guys. You just have to write df.sort by index, and inside this you have to give the value of the axis. I'll just give 1, and then let's say ascending, you want it to be ascending. No, I'll just write it as false. So it has given me the data frame by sorting the index. Similarly, I can sort it by the columns as well, or I'm sorry, sort it by values. So I'll write it as values, and I want to give the value as, say, values, and I'm going to give the value as, let's say, by, I want to sort it by C. It has sorted the values depending on C. So this is how you sort your data frame, guys. And now that we know how we can actually look at our data, I'm going to tell you how you select particular values inside your data, guys. I'm going to show you how you select a single column from your data frame. So we'll write df. It's very simple, guys. To get a value from your data frame using only a single column, you can write A, or let's say C. So it's going to give all the values from C over here. It has actually given you frequency. It has given you name, data type as well. So this is how you actually get a single column from your data frame. Now let me show you how you can slice the rows as well. So for that, we're going to use the slicing. If you have actually worked on list comprehension, so we have slicing the data over here. We are going to follow the same principle here as well. So I'll just write df. Now I want my first, starting from my first value to third value. So it has given me only 3 rows, starting from the 0th row and it has given me third row, and it does not actually include the third row because it starts from 0. So I'm giving 3 values. If I write 6 over here, I'm going to get the 6th value, but it's not going to be at the 6th row because the first row over here is going to be 0th row. I hope you understand this, guys. So I have shown you how you can slice your data, to get particular number of rows. Now let me tell you how you can select the data using the labels, guys. So for that you have to use df dot, there has to be location, LOC, and inside this you're gonna pass the values by labels, guys. All right, so let's pass D, that is, and 0. So let's see what the output is, guys. All right, so we have got all the values using the label, that is D over here, which we have passed over there in our previous section where we have declared the data frame. And I'm sure this is visible to you guys. Now the next thing is selecting data on a multi-axis by label. So what we'll do is we'll write df.loc, and after this we write hyphen, and we're gonna create, let's say, A, and we're gonna pass C, right? So it's gonna give me the values accordingly which I passed over here. So instead of A I can write B, or I can write D. So this is how you can select multi-axis using labels, guys. And I have written this over here, so I can just write, let's say, 0 to 3. Let's see what happens. Oh, we have an error, guys. You cannot do this. So we'll now move on to the next topic that we have, is showing label slicing. Both endpoints are actually included. So how do we do that? So instead of this, we can just, let's say, copy this, paste it over here, and copy this, paste it over here, remove this. So this is just to show you guys how you can work with it. I'm very certain that the data that you work on is not going to be like this. It's going to be very complicated. So this is just to give you a perspective as a beginner how you can work with pandas. Now I'm gonna tell you how you can reduce the dimensions of the returned object as well. So for that, you just type one thing, guys. You remove all this, get just one value, and this is gonna give you the column number at over there. And this is how you get the values inside a data frame. So moving on, let's say we want to get a scalar value. So for that, we just write, okay, let's say D0. Right, let's see if it works. We're getting the same values, guys, only from the 0th row. For getting the fast access to a scalar, you can just write as df, instead of loc we can just write at. Okay, we have an error, guys. I'll just remove this and let's see if it works. Yes, so I'm getting the exact value at the 0th row at the column number C. Now I'm going to tell you how you select a value from using the position inside your data frame. So for that, we use df.iloc. All right, so let's say 3. Okay, so I'm getting all the values from third column. And similarly, we can slice the data. You can just get it like 3 to 5. All right, we can add more values to this, like 0 to 2. So this is how you select the values from your data frame, guys. Now we have Boolean indexing as well inside our data frames. So I'll just tell you quickly what it is. So for that, you just write df. Now I'm going to check if df column number A, let's say, this is interesting, guys. So it has given me all the values inside A where A is greater than 0. If I write it, let's say 2, I have no values because none of the values are greater than 2. So this is how you can get the Boolean indexing. This is actually important when you're applying functions to your data frame, guys. So moving on, let's take a look at another method, which is in method. I'll just tell you how it works, guys. So it's basically is to check if the particular value inside your data frame is in there or not. Now there's one more thing. We can set new values inside our data frame. we can set a new column which automatically aligns the data by the indexes. So for that, we can make the series, and we can set the values by label, we can set the values by position, and we can set the assigning with a numpy array as well. And the result of the settings will actually align with the data frame, where a new operation with the setting can be followed, where you can simply align the data frame with the existing data frame. Now let's go ahead and take a look at the next topic that we have, which is handling the missing data inside your data frame. So let's jump right to it, guys. We'll go to Jupyter Notebook and we'll work with our missing values now. So pandas primarily use the value np.nan to represent missing data. It is by default not included in the competitions, and we're going to see the missing value right now. So first of all, you have to reindex. You have to do reindexing, which is going to allow you to change, add, delete the index on a specified axis, so which is going to return a copy of the data as well. All right, I'll just take df2 is equal to df.reindex. So this is how I'm going to do the reindexing, guys. So index is equal to, let's say, d0 to 4. Yes, I'm going to get the columns after the reindexing, which is going to be equal to list of df.columns, and I'm going to add one more column, which is going to be, let's say, e. All right, now what I'm going to do is I'll do loc. I'm going to check a few values. So instead of dates, I've taken d, guys. So d of 0 and d of 1 at e is equal to 1. Now let's check what is df2, guys. We have two null values over here. So this is how I'm going to show you how to handle missing values inside your data frame. So we have done reindexing. So first of all, I'm going to check for null values. So we have true over here, and we can get the count as well, is null, and we count these null values. All right, right now we are going to drop a few columns. So we are going to drop the NA, that is the NA values. So as you can see from our data frame, all the values that had null values are dropped. Actually, the whole column has been dropped. Or we can do one thing, fill in the missing data, guys. Just do one thing. Okay, check df2 we have. So we can do one thing, we can fill the missing values, and we are going to provide some value. Let's say value is equal to 2, right? So we have actually filled the value with some other value. Wherever there is a missing value, we have given a value that is going to fill over there. So this is how you get, or check for all these missing values inside your data frame. After this, you can now actually get a boolean mask where values are nan, which is null. So for that, you do pd dot is na df2. So this is going to get you a boolean mask, which I've already told you how you can check using df dot is null. Same thing, but different processes to run this. Now let us move ahead and to the next topic that we have, which is pandas operations, guys. Pandas operations are nothing but a few operations that you can apply on the data frame or any other pandas object. So we have descriptive statistics that we can apply. We can apply functions, histogramming is there, and string methods is also there. So I'll tell you what histogramming is when we are talking about it. So let's take it up to Jupyter Notebook again, guys. I'll tell you how you can actually work with pandas operations. So first of all, I'm going to tell you a basic operation, which is that is a descriptive statistics. So it's going to give us all the mean values. Similarly, we can get one value like df dot mean, provide one value over there. So this is how you get it, guys, or we can write it as 2, right? All right, so this is how operating with objects that have different dimensionality and need alignment. In addition, pandas automatically broadcast along the specified dimension. So for that, let's make a series. I'll tell you just how it works. pd dot series, give it a few values, let's say 1 2 3, np dot nan 5, or I'm sorry, 4, 5, and then give the index value. The index is going to be dates, and let's just shift all this 2 places. Right, we have made an error, guys. Length of pass value is 6 and index implies 10. So we have to actually put more values. So write 6, 7, 8, 9. Yes. Now when I print S over here, we have all these values. Now we can do one more thing. So we write it as df dot sub, and we pass the S over here, which is our series, and we make an axis, write it as index. So we have operated with objects that have different dimensionality and needed alignment. So in addition, Pandas actually helped us automatically broadcast the specified dimension. So now I'm going to talk about applying functions to the data. So we already have data frame. Let's see what we have. So we have this data frame, guys. So what I'm going to do is I'm going to apply a few functions. So first of all, I'm going to use the apply method over here, and let's see what all do I have. Let's just check. We have absolute import, all close, a max, a minimum, angle, any append, all these functions that I can apply on this. So let's say we have CumSum. Let's see what this does, guys. All right. So this is how it works. Now let's apply a few more functions, guys. So I'll write lambda x. So we are talking about lambda functions here. I'm sure most of you must be aware of the lambda functions that we have in Python. If you don't have any prior knowledge on lambda function, guys, there is a full tutorial on how lambda function works in Python, guys. So this is how we applied lambda function to get the subtraction between the x max and x minimum. All right, for all the columns we have the subtraction between all these values. So this is how we apply functions to our data, guys. Now I'm going to talk about histogramming. So histogram is a representation of the distribution of data. So this function we have, which is matplotlib.pyplot.hist, on each series in the data frame, resulting in one histogram per column. So what we'll do is we'll make a series, and it's going to give us value counts for histogramming. How do we do that actually? So we can just write as dot value counts, right? Let's see if it works. Right, we have one value for each. So this is how we get or do the histogramming with our data, guys. Now I'm going to talk about the string methods. So series actually is equipped with string processing methods in the string attribute that actually makes it easy to operate on each element of the array. So let's just move ahead with the example. So I'll make a series, guys, pd dot, let's say series, and inside this I'm going to pass a few string values. So I'm going to start with Edureka, write Python next. Let's write Jupiter, give it a few null values as well to make it a little or slightly different from perfect. All right, so give it a few values, let's say football. And looking at the current scenario, let's write world. So we have a series over here, guys. Now what we'll do, we'll take or use the string methods. So I'm gonna make it all to lower, which are already lower. So I'll make it to upper, guys, upper letter words. So everything we have changed using the string methods inside our Pandas series. These are all the operations that you can perform on Pandas, guys. So let's move ahead to the next topic that we have, which is merging. So in merging, we are basically going to merge two data frames together. So we have two functions, which is concat and join. So concat Pandas objects along a particular axis with optional set logic along the other axis. It can also add a layer of hierarchical indexing on the concatenation axis, which may be useful if the labels are the same or overlapping on the past axis number. So let's take a look at the example for this. So we have our data frame. I'm going to use pd dot data frame. Give it a few values, let's say np dot random number from, let's say, 10 and 4. All right, so we have all these values. Now what I'll do is I'll break it into the pieces. So how to do that? So let's say I write it as df2 is equal to df from first to third row. The next one is df from third to, let's say, seventh row, and then we have df from seventh to the end of the data. So this is how I am going to break it into the pieces. Now when I write it as df2, we have 3 data sets. Now I'm going to use the concatenation function using concat. All right, I'm gonna concatenate df2. So this is how I've concatenated the missing pieces, not the missing pieces, the several other pieces together using the pandas concat function. Now let's talk about the join function that we have. So for this, basically I'm going to tell you how you can do the left and right join. So for the left join, I'll write left is equal to pd dot data frame, and let's see, first value, let's say a, give it a few values, let's say 1 2, and then say b, we have 3 4. All right, we make the for the right as well. So I'm just gonna copy all this, paste it over here. Okay, I'm just going to write it as d, this is going to be, let's say, c, and change a few values. So we have left and right, and I'm going to just type left, and then we get the output for right. So I'm going to join all these two using the join function. So for that, I'm going to use the merge function, and inside this, let's say left, we have right, and on is equal to, I'm going to join it at let's say a. Let's see how it works. Okay, it doesn't. So we have a key error, which is a. So I'll change it to a, guys. So we actually joined using the merge function over here. And another example that I can think of is, let's say we have left and right. We can change the values differently, and we can just group them together. Now what I'm going to talk about is grouping, guys. So how you do the grouping of different data inside your data frame using pandas. First of all, for that, you have to split the data into groups based on some criteria that you have, and then after that you apply some functions on them, and then later on you can combine the results into a data structure. So first of all, you have to get a data frame, guys. So let's see, we have a data frame over here. So we can actually group it by, let's say, right, I'll just write group by, say, a, and I'm just gonna sum. Right, we have an error, guys. So we have a key error, that is a, because we don't have over there. So I'll write it as, let's say, 2. All right, we don't have 2 as well. We have a key error, we don't have 2 over there because it's not a string value, it's an integer value. So we have our values right over here. So we have grouped the data using the column that is number 2. Now we can actually group the data by multiple columns and form a hierarchical index. So for that, I'll just copy this, guys, or over here only I'll just do one thing, 2 and let's say 3. So this is how you actually combine multiple columns to form a hierarchical index. But here again, we don't have actually categorical values for these columns. If we had, we'd be able to do that. If we had, like, let's say true and false, it is going to have created a hierarchical index which will have different values for true columns and for false columns. So that's how you do the grouping, or that's where you actually need grouping using pandas. Now let's move ahead and take a look at the next topic that we have. Okay, we have already talked about operations, then I have talked about merge, where we have talked about concat and join, and then I've talked about splitting the data, how you apply the functions, and then combining the results together. Merging, we have talked about grouping. Now I'm going to talk about stack and pivot table. So what exactly is a stack, guys, in pandas? I'm sure most of you must have heard about some of the definitions of stack. So I'm going to tell you about this with perspective of pandas library here. So the stack function is used to stack the prescribed levels from columns to index, and it returns a reshaped data frame or a series having a multi-level index with one or more new innermost levels compared to the current data frame. So you're going to understand this with an example. So I'm just going to take let's say my tuple is equal to, I'm just going to take a list, and inside this, let's see, we have values, and we provide, or we get two lists over here, a list inside a list, guys. So let's take a few values, take 1 2 3 4 5, and then again let's say 6 7 8 9 and 10, or we'll add a few more values, guys. Let's say 11 12 and 13. Over here I will add a few more values, let's say 17 18 and 19. So we have our tuple. I'm going to create one more variable index, so we'll have multi-index. So from tuples, inside this I'm going to pass my tuple, pass the names as well. So the names are going to be, let's say, first and second. So we have our index. Now I'm going to create the data frame, guys. So for this we write pd dot data frame, and inside this I'm going to pass a few values, np dot, let's say, random dot random number. So we have 8 values and 2 columns. All right, so, and the index is going to be index, and columns is equal to A and B. All right, we have an attribute error, guys. I made a mistake. So there's no error now, and I'm going to make one more data frame. So inside this I'm going to pass this value. Now I check my data frame. So I have reshaped my data frame with this, the first and the second, and all these values. Now we're going to talk about the stack method, guys, so which compresses a level in the data frame's columns. So we're going to do one thing. We're just going to do df2 dot stack. Right, this an attribute error. So this is how we stack or compress a level in the data frame's column, guys. And with a stack data frame or series having a multi-index as the index, inverse operation of stack is unstack, by which default it's gonna unstack whatever you have done with using stack. So we'll do df2 dot stack, and this is how you unstack. Now we'll talk about the pivot tables, guys. Oh wait, let's put it inside a variable, let's say A. Alright, so this is how you unstack, guys. We're getting different values there. Now we're going to talk about the pivot tables that we have in Pandas. So it is nothing but the levels in the pivot table will be stored in multi-index objects. On the index are columns of the result data frame. So we'll take a look at one example, guys, which is going to be pretty clear. So we'll take df again, pd dot data frame, and inside this we're going to take a few values, or we're going to take a list inside a dictionary. So let's go with a few values. Let's say 1, or let's say a. All right, so we write a, b, c, d, we'll remove a few values over here, multiply it to 3. Now we take another value, which is going to be b, and for this we're going to take a list again. So let's say multiply it to 4, take another value, let's say c now, and inside this we're going to pass a few values again. So we're going to pass 6 values. So let's write p, p, and p, q, q, and q. Multiply it to 2 because we want the number to be 12. And now d is going to be np dot random number, and the number we want is 12. And we take one more value e, and we take the same values for this as well, random number 12. No errors, I guess. So we have an invalid syntax, guys. So we forgot to add a comma over here and here and here. Right, so I think it should work fine now without any errors. So we have printed the data frame over here, guys. So this is how it looks. Now we can produce pivot tables from this data very easily, guys. The very reason of creating this data frame was to get the pivot tables. Now what I'll do is I'll just write pd dot pivot table, and I'm going to pass df over here. All right, df, and the values is going to be, let's say, b, and index is equal to a and b, and columns, let's say, is equal to c. So this is how you create a pivot table, guys. Now that we're done with pivot tables, let me talk about the next topic that we have, which is time series and categoricals. So we have done reshaping, merging, grouping as well. Now we're going to talk about the time series and categoricals. So Pandas has simple, powerful, and efficient functionality for performing resampling operations during frequency conversion, which is, for example, converting secondly data into 5-minutely data. And this is extremely common in, but not limited to, financial applications. So we're going to take a look at a few examples. And for categorical data that you collect can be either categorical or numerical. So numbers often don't make sense unless you assign meaning to those numbers. So for categorical data is when numbers are collected in groups or categories. And categorical data is also the data that is collected in an either or yes or no situation. For example, we have 0 or 1, we have true or false. So that's going to be the category over there. So let's take a look at a few examples to understand this, guys, the time series and categoricals. So we'll take a look at a few examples for time series. So first of all, what I'm going to do is I am going to make a time series, guys. So first of all, what we'll do is we'll convert the data into 5-minutely data. So it's very common, guys. So I'll just take the range first of all. So we'll take the dates. All right, I made a mistake. I'll just cut this. So I'll just run this again. We'll get one more column. And now what I'll do is I'll make one variable using the pd.date range. Yes, and I'm going to provide the range as, let's say, 2020 01 or 03 01. We want the periods is equal to 100, and let's say frequency is equal to S. All right, let's print dates. Okay, so we have dates over here. I'll just remove this for now. So now we take one more variable, let's say ts is equal to pd dot, I'm going to take a time series, and inside this I'm going to use np dot random and random integer, which is going to be 0 to 500, and the length is of dates, and then we have index is equal to dates. So we have, okay, we have numpy attribute, no random randint. All right, so we have an unsupported date time, so I'm going to have to change this over here. So we'll write it as, let's say 3 1, or we're going to write 3 3 2020. Right, so let's see if it works now. It doesn't. So we are getting the unsupported d type. Okay, so we just mention a few more stuff over here. So we'll write it as 0000. So I think I figured out the problem over here. So I've changed this to this format, and now I'm going to add one more parenthesis here and remove this one, and now I'm not getting any errors, guys. So I'll run it again. Right, so now what I have to do is I will have to make a few changes to that ts, which is time series I've made. So I'll write it as ts dot resample, and I want to make it to 5 minutes, right? And I have to sum this, so no errors there, guys. So now I'm going to do the time zone representation. So for that I'm gonna get one more. Okay, I'll just copy this, guys, this little change to this only. So I'll just copy this, paste it over here, and here I have to make a few changes. That is 00, the rest everything is going to be fine, and we'll change this to 5. All right, so now we make another timestamp, and we just use pd dot series, and inside this I'm going to use np dot random dot random number, and the random number is going to be the length of dates, and dates over here. All right, so now when I print timestamp, I'm getting the output as something like this. So this is how you get the time zone representation, guys. So you're getting the date, the time, and everything, and the data type is float 64, and then you can also get the UTC as well. So for that I'll just write ts UTC, and we just write timestamp dot tz localize, and we get UTC, right? It's UTC. Now I'm gonna print this, so we get the UTC as well. So this is how you create the time zone representation. And now after this I want to show you how we can convert to another time zone. So for that we don't have to do anything. We just write ts dot, all right, ts UTC dot tz, which is time zone convert, and we write US Eastern. So we have converted into the US time zone. And converting between time span representations also we can do that. Let's just say that's your exercise. So you have to convert between the time spans representations so that you'll be able to understand this better. For that you don't have to do anything. You just have to take the date range the period, so it's going to be 5, and then you write the frequency instead of S, you write it as M. The rest all is going to be the same, guys. Okay, I'll just do it here as well. Just copy this, paste it over here. Instead of S, it's going to be M. We'll have to remove this. All right, now I make the timestamp, which is going to be the same, guys. Now print the timestamp. This is how we convert. Or after this, we take one more variable, let's say PS, and I'm going to do period. All right, now when I print PS over here, this is the output I get. So the frequency is M. I've changed the frequency, and now I can just convert it to timestamp, guys. Let's see where it is. This is how you create it into a timestamp. Now converting between period and timestamp enables some convenient arithmetic functions to be used. So for that we have period, range, and all those things that you can add. Now moving on to the next topic, that is categoricals. So for that, let me just take one more data frame, guys. So I'll write it as df is equal to pd dot data frame. Now I'm going to take a few values inside this dictionary. The first is going to be, let's say, id. And now I'm going to pass a list with a few values, precisely 6. So I'm going to use 6 values over here. Now my next topic is, or the next key is, let's say raw grade, or just grade we'll write. So we're going to write A, B, C. Let's say again the guy is getting B and this one's getting A. So we have 5 and one more. Let's say one guy has failed. So we have our data frame. Let's print this. Okay, so we have our data frame. What I'm going to do is I am going to get the grade, right? So we'll get the grade is equal to df grade. Now this is going to be the category I'm going to make. All right, now we print df grade. So we have grades like A, B, C, B, A, E. Now I'm going to rename the categories to more meaningful names. So what I'll do is I'll make the change over here only. So I'll write cat dot categories, and I'm going to write the categories as, let's say, good. Instead of pass fail, I'm just going to write very good, and then there is excellent. All right, so we have very good, very bad, and excellent. All right, we have an error, guys. There's something we have done. So we have new categories needs to have the same number of items as the old categories. So how many categories do we have over there? Let's just copy this. So we have categories 4. So we're gonna have to make 4 categories, guys. So I'm just going to add good as well. There shouldn't be any errors. Now what I'll do is I'll just set the categories. So I'm going to set the categories now. Let's say here I'm going to have to give 6 values, guys. So right, very good. Let's say bad, very bad, medium good, very good. Any sort of categories I have to give over here. So I'll just write very bad, good, and let's say medium. Alright, so after this I have set the categories as well. Now I'll just write df grade. Okay, so we have good, very bad, then we have very good, very bad, and good, and then we have NaN because we have not given any other category for that. And we have the 5 objects, so we are getting very good, bad, very bad, good, medium. So that's how you use the categoricals in pandas, guys. Now I'm going to talk about plotting using pandas. So that's going to be very simple, guys. For that I'm going to have to import one more library, that is matplotlib dot pyplot. I'm going to use it as plt. All right, same thing goes with this as well. All right, this is going to be pyplot. All right, so there should not be any errors now. Okay, so I will close all. Now I'm going to make one series, guys, and inside the series I'm going to provide a few random values like np dot random number until, let's say, 1000, or let's say 500, or yes, 500, and the index is equal to pd dot date range. I'm going to take the date range as 1/3/2020, and let's take the periods is equal to 1000. Wait, we have to take it as 500 because we have 500 values over there. I hope no errors. Yes. Now I'm going to take the timestamp and we're going to get the sum. All right, now ts dot plot. So we have a plot over here using pandas, guys. This is how we have created one series using the random numbers from Numpy library, and using the pyplot we have plotted a graph for random values which we have taken from 0 to 500 and the random range as well. So this is how you take or get a plot using pandas, guys. Now last but not the least, we have another topic, which is reading and writing to files. So inside this I'm going to show you how you can read from a file and how you can actually create a file over there. So we have our data frame, guys, or we have our ts. This is our ts, guys. So I can just convert it to a csv file, guys. Make it or give it a file name as, let's say, ts.csv, and it's gonna save the ts.csv file somewhere in my directory. And similarly I can read from a csv file. So for that I can just write pd.read csv, and I'm gonna have to give the file location for that. So I'll just copy one file location from one of my data sets. So this is one data set that I have. So I'm going to check for the properties, or wait, I'm going to copy this, paste it over here. Okay, we have an Unicode error, so I'll just write R over here, and I'm able to read from the CSV file, guys. Look at this. Instead of CSV I can write Excel, and it's going to create a Excel file or a CSV file it's going to read from. So that's how we actually read and write from files, like a CSV file, which is a comma separated file basically, or we read from a file.
What is data visualization? Now, data visualization is basically the graphical representation of information and data. There can be many visual elements like charts, graphs, and maps. Here, data visualization tools really provide an accessible way to see and understand different trends that can occur in this data, or outliers and patterns. Anything that could be in this data could be visualized and found using data visualization tools. Now, in the world of big data, data visualization tools and technologies are very essential to analyze really massive amounts of information and then make some data-driven business decisions to help their organization. Also, with the technological revolution that's occurring, data really went from being expensive, difficult to find, and collect to abundant, cheap, but incomprehensible. It is audacious to store, understand, and analyze increasingly large volumes of data with traditional softwares and tools. However, as individuals or even as an organization, all of this data is only as good as what we can make out of it. And this is where big data comes really into the picture. It is used for predictive analysis, analyzing user behavior, or any other data analytics processes to bring value to the data that is present. Yet the raw details about this can remain uncertain due to lack of knowledge and lack of skills. Data visualization really helps to tackle this particular issue that we are facing. It is basically the process of transforming data into visualizations like charts, images, graphs, and even videos that really explain the numbers and allow us to gain some insights from it. So in short, you can say that it makes information more coherent and really adds value to it, discovers new patterns, spot trends, etc. Now, let me explain this with a really simple example. How do you explain the various rows and columns of data in an Excel spreadsheet to your boss or customers? You obviously will create a chart like, a line graph or scatter plot and even a bar chart of the same data. So what it really does is it gives meaning and purpose to the original raw data that was present initially, so that you have a visual representation of it and you can start analyzing it and integrating it with colors and giving more meaning to your data. This has really empowered many businesses and organizations by providing a much more clear and actionable insight to programs, as it can keep you ahead of the game. So I hope data visualization is clear. Let's move on and understand what is Power BI. So Power BI is basically a collection of software services, applications, and connectors that really work together to turn your unrelated sources of data into immense visualizations and interactive insights. So here your data may be in the form of Excel spreadsheet, or it can be a collection of cloud-based and on-premises hybrid data warehouses. It can be a CSV file. It can really be anything, your data, okay? So what Power BI really does is it lets you connect your data sources, visualize it, and discover what's really important so that you can share with anyone and everyone that you'd like to. So Power BI consists of several elements that all work together. So you can see these three different elements that work together on the screen. One is the Power BI desktop, then you have the Power BI service, and then you have Power BI mobile. So a Windows desktop application is called the Power BI desktop, and online software as a service is called the Power BI service, whereas the Power BI mobile applications is for Windows, iOS, and Android devices. I think that's very obvious. So in short, you'll really just have to know what Power BI is and what are the different services to start off with. Now let's go ahead and learn how to install Power BI desktop into our local machine. So right now I'm on my Google search engine and I'm just going to look for Power BI desktop. So you can see that there's an link that says download Microsoft Power BI desktop from the official website. I'm just going to click that and this will redirect me to the official website of Microsoft where I can download my Power BI desktop. So this will allow me to download my Microsoft Power BI desktop. I'm just going to click on download. So I'm just going to select the option Power BI desktop setup x64.exe file. So I'm just going to click next once I select that. and it'll redirect me to a page where it'll directly download the .exe file for me. So once the exe file has been downloaded, you can just click on it. Just select the language that you'd like to work on in Power BI. I'm going to select English, and then I'm going to click Next. You can just click Next, and then you can accept the terms. You can just click Next. You can select the folder that you'd like to install Microsoft Power BI Desktop. You can then click Next. You can then begin the installation and click Install. And you can also create a desktop shortcut. Since I already have Power BI Desktop, I'm not going to install it. And if you haven't installed Power BI, you can just click Install and then finish the entire process once it's installed. Let's move ahead and check out the Power BI interface. So now, as soon as I open Power BI, you can see there's a window that's been prompted that says Power BI Desktop. So you can see that from the welcome screen, you can get data, you can see recent resources, you can open other reports, or even select other links. You can just select the close icon to close the welcome screen. Then you can just see the entire Power BI setup, okay? So with Power BI Desktop, you can do certain things. Firstly, you can connect to data, including multiple data sources. You can also shape the data with queries that really build insightful compiling data models. You can also use the data models to create various visualizations and reports. And finally, you can share your report files for others to leverage, build upon, and share. Okay. So these are some of the advantages of using Power BI Desktop. That's why we'll be working on Power BI Desktop today. So we'll quickly go through the entire user interface. You can see on the left-hand side of the Power BI Desktop, there are three icons that are present. The first one is reports, and the second one is data, and the third one is model from top to bottom. So the current view is indicated by the yellow bar. You can see there's a yellow bar here along the left, and you can change views by selecting any of these icons. Now, if you're using keyboard navigation, just press Ctrl plus F6 to move focus to that selection of buttons in the window. So these are pretty important. You can see that you can add in your data here, and then you can also create models, okay? So we're just going to be working currently on the report part. So report view is basically the default view, okay? And Power BI Desktop also includes the Power Query Editor, which opens in a separate window. So in the Power Query Editor, you can build queries and really transform data, then load the refined data model into Power BI Desktop to create reports. Now that we have Power BI already installed, you're really ready to connect to the world of data. Now, to see the many types of data sources that are available, you can just click Get Data, and you can click More. And in the Get Data window, you can scroll through the list of all the data sources that are available. And you can also connect to a couple of different web data sources. Okay, you can connect to different databases, you can connect to Azure, you can also connect to other online services, you can also connect to Power Platform, and you can just check out all of them in the All option. Okay, once that is done, I'm just going to click Cancel. So now, for example, imagine you're a data analyst and you're working for a sunglass retailer. You would want to help your client target sunglass sales where the sun shines most frequently. So then you download data where there'd be more sun, right? So, and then you could just export this data through Get Data option. The next thing that you can really do is you can also shape your data, okay? That's another important thing that you can do here. You can directly import data from a Microsoft Excel data sheet, and you can also create a live connection to data sets in the Power BI service. As I've already mentioned before, the Power BI service is related to cloud services, right? So you can just create a live connection immediately using the Power BI data sets. You can also import data from a SQL Server database. You can also create data by yourself by adding it using the create table option, and you can just add how many ever columns that you'd like to, right? See, I can add as many columns I'd like to. I can insert as many rows I'd like to. I can name it whatever I'd want to, and you can also make some changes. You can edit to this data and all of that. So that option is also available. You can also check out the recent sources that you've worked on. You can transform data, as I've already mentioned before. You can use the Power Query Editor to transform data. So what you can do is you can shape your data here. Here you provide Power Query Editor with some instructions for adjusting the data while loading and presenting it. Shaping really doesn't affect the original data source, only the particular view of that particular data. You'll have to remember this. Okay. So shaping basically can mean transforming the data, such as renaming columns or tables, removing rows or columns, or changing data types. So Power Query Editor captures all of these steps sequentially under Applied Steps option. See, you can manage columns, you can reduce rows, you can manage your parameters, you can do whatever you'd like to using the Power Query Editor. So each time this query really connects to the data source, the steps are carried out and the data is always shaped the way you have specified it in this option. Okay. So transform data really allows you to play with your data and specify it in a certain format. You can add new visuals, you can add text boxes, you can add more visuals. Okay, that's all for home. You can also insert a new page. You can also use this plus icon to insert, new pages. See, I've made a page too after I click the plus icon. If you want to delete anything, you can just click the cancel button and you can delete the page. That's how easy it is to work on Power BI. Okay, you can add new visuals, you can add more visuals. You can also create a decomposition tree to visualize your reports. You can embed a Power App in your report. You can add a text box, buttons, shapes, images can be imported from external sources or your computer. And moving on to the modeling part, you can really add new tables, you can add new parameters, and you can also select the language that you would like to work on. Then moving on to the view part, you can really select a theme for how you'd like to work on. You can customize your current theme. You can browse for themes. And these are some of the themes that are already available on Power BI. You can also click on page view. You can fit to width. You can pick an actual size. And we'll be talking about mobile layout a little later on in this session. So whatever visualizations you create, you can make a mobile layout out of it. So that's pretty cool. You can add grid lines if you'd want to. You can automatically align objects. You can lock objects as you'd like to, and all of that. And once you click on the mobile layout again, you'll just reappear to your report page. Okay. And you can also get some help. You can check out the Power BI blog. You can check out the community. You can check out Power BI for developers. You can also submit an idea. You can download and browse on external tools. You can check out examples using sample data that are available already on Power BI. Okay, there's some guided learnings, the training videos, any sort of help that you need, you can use the help option and you can check it out. Okay. The next important thing is the filters, visualizations, and field objects. Okay, before we move on to that, so let me just explain that this part is to build your reports. Okay, there are various parts in Power BI that help you build reports. So the report view has basically 6 main areas. The first one is your home option, the ribbon at the top, which really displays the common tasks that are associated with reports and visualizations. We talked about all of these common tasks. The second area is your canvas area, which is in the middle, where visualizations are really created and arranged. Okay, so this is the middle part. The third part is the pages tab, which is present here. We spoke about this earlier, which is at the bottom and which lets you really select or add report pages. Okay, and the fourth part is your filter part. Okay, so the filters pane is where you can filter your data visualizations. That is what it really does. The next part is your visualizations pane, where you can add, change, or customize visualizations as you'd like. And you can also apply drill through. The final and the sixth part is your fields pane, which really shows the available fields in your queries. You can drag these fields onto the canvas, the filters pane, or the visualizations pane to really create or modify visualizations. So the field part is where your data set is loaded. Okay, once you load your data set, the entire tables and columns that are present in your data set is displayed on your fields part. So that's what it really does. You can expand and collapse filters, visualizations, fields, And by selecting the arrows on tops of the panes, collapsing the panes really just provides more space onto the canvas to really build cool visualizations that you're working on. So the visualizations pane, as we've already discussed, shows really information about the visualization and also lets you modify it. All the icons that you can see here show the type of the visualizations that you can create. You can change the type of a selected visualization by just clicking on different icons, or you can also create a new visualization by selecting an icon with no existing visualization selected. The fields option, on the other hand, in the visualization pane lets you drag data fields to the legend part and other field wells in the pane. And the filter option lets you apply formatting and other controls to visualization. So this is all you have to know for the user interface part. Let's move ahead and download our data set that we will be working on today. So for this, I'm just going to go to my Google search engine and I'm going to click on Kaggle. So Kaggle is a very big platform for people to work on various data sets, and people from all over the world upload their data sets that they work on. So you can download any of theirs and work on it in your own projects. So I just click the data option on the left hand side and I'm just going to scroll down. Today we'll be working on the COVID-19 data set. So we'll just download any of the data set that is available. Here you can see once I scroll down, so there's a separate option for COVID, and I'm just going to click the novel coronavirus 2019 data set. This has been uploaded by SRK, and I'm just going to scroll down and check out all of the available data sets. So you can see that there is one COVID-19 data set. There is also confirmed cases, confirmed US, deaths US, and finally the recovered cases. I'm happy with this data set, so I'm just going to download it. Because this is in a zip format, I'm just going to click on extract all, and I'm just going to click extract. So that's done. Okay, this is great. So I'm going to quickly move back to my Power BI desktop and I'm going to click get data, and I'm just going to click text to CSV file. I'm going to click archive one, and I'm just going to upload the data set. The first data set is the COVID-19 data. Currently, this is a CSV file, and you can see that Power BI has prompted a window with all of the available data in the current data set. You have observation date, you have the state, you have the country or region, the last update, confirmed, deaths, and recovered. I'm happy with this data. I'm just going to load it into my Power BI. It'll just take some time to load all of the data. You can see in the field section, you have the data set COVID-19 data, you have the confirmed cases. So the various columns that were available, the confirmed cases, country, the deaths, the last update, the observation, the province state, recovered, and the serial number for each of them. So this data set is what we'll be working on. We'll just build some visualizations, some really simple visualizations, and we'll create dashboards. So this is just one data set that we'll be working on. Okay, so what we're going to do is we will learn how to create a few charts and understand how you can analyze the data. So we'll be creating visualizations now. So on the first page, let's create and work on bar charts. Okay, so what I'm going to do here is I'm going to select a stacked bar chart. That's the first icon that's available. And I'm just going to click on country or region. And I want to plot or view the confirmed cases of different regions. So I'm just going to track the confirmed field and I'm just going to drop it in the values add data fields here. Okay. And what it really gives me is it gives me an overview of all the countries with the confirmed cases. As you can see, US is on top. So this is 2019 data. So that is pretty old data. We are in 2021 right now. So as you can see, back then, US was on top, followed by India, Brazil, Russia, France, UK, and so on. So these are all the confirmed cases. You can also really add filters. You can just scroll down. You can add is less than some certain number. You can see that there is so many confirmed cases and the least is South Africa. So you can just add less than or greater than some certain amount, and only those countries which is greater than that number will be displayed. I'm just going to put is greater than some number. Okay. And I'm just going to click apply filter. Okay. You can see that the regions with values greater than this number will display on your bar chart. On page 2, so this is stacked bar chart that we've just worked on. In the second one, we'll create visualizations using line charts. So again, I'm just going to click a line chart and I'm going to click the country or region because that's important. So I'm just going to click on province or state here now, and we'll check out the number of deaths, and I'm just going to drag and drop that in the values field. And you can see the number of deaths that have occurred in England, and then Maharashtra, Cambodia, Rio de Janeiro, Texas, Florida, and all of that is given in your line chart. Again, you can just add some filters if you'd like to. I'm not going to add any filters as of now, and I'm going to create a new page. So if you click on the 3 dots that are available, you can export data. You can show this as a table too if you'd like to. So that's pretty nice. And you can also sort them accordingly, according to ascending order, according to descending order. All of that can be done. So that's great. So if I scroll down, you can see the number of death cases in each of the state that is present. Okay. And I'm just going to click back to report. So this will just take me back to the visualization. Okay. Now I've created a new page, that is page 3. And here what we're going to do is we are going to create a pie or donut chart. Okay. So pie charts are quite well known. However, when it comes to displaying a lot of data, it is not recommended that one uses a pie chart because it can be really difficult to identify tiny differences between each of these categories. So what we're going to do here is we are going to click a pie chart. You can see the icon that's right here. I want to check out the recovery. So I'm just going to drag and drop this values here. And I'm going to click on the province and state. Okay. So as we've already mentioned, there can be a lot of problems using pie chart because each of these tiny differences cannot be figured out in a pie chart. So what I'm going to do here is I'm just going to look for states in India. I'm just going to look for some major states: Maharashtra, Karnataka, Delhi, Tamil Nadu, Uttar Pradesh, Uttarakhand. I'm just going to mention all of the states that I can remember from India. You have Andhra Pradesh. I've just picked up a few states from India and I have represented them in this pie chart. Now you can see that it's much more simpler, and you can see that Maharashtra has the most number of recovered cases, followed by Karnataka, then Tamil Nadu, Delhi, Uttar Pradesh, and then finally Uttarakhand. So it's pretty nice to represent tiny data sets in pie charts. You can also use donut charts if you'd like to. So I'm just going to click a donut chart. A donut chart is also a very pretty visualization that you can use. Moving on, you can use KPIs, that are key performance indicators, which are really a measure of the company's performance and it evaluates its success. We can display this in Power BI using the card or gauge. You can use the gauge or you can also use the card panel. So what I'm going to do is I'm going to create another page. So I'm just going to click on the gauge option, and what I'm going to do is I am going to add the number of deaths. Okay. So you can see that this is given in a gauge format. If you want it in a card format, you can just pick the card option. So these are the KPIs that you can work on. And now if you want to delete a chart, you can simply click on it and just click delete on your keyboard. If you want to add a new page, as I've already mentioned, you can just click on the plus icon. So now we will learn how to create a dashboard. What you can do is you can just copy paste all the visualizations that we've created so far onto the same page. And this basically gives a dashboard. That's how easy it is. Okay, and I can move this. So I can just click on the visualization, copy, go back to page 1, and then paste it. I can also resize each of these visualizations as I'd like to. And that's it. That's how easy it is to create your own dashboard. This is your dashboard on page 1. And you can also obviously change colors if you'd like to. So if you even want to change colors in your visualizations, you can do that. You can just go to this format icon and you can just click data colors and you can switch colors. Okay, we'll switch to something light maybe. Okay, you also want to change the colors in your legends of your bar chart. You can do that. You can just go to, again, the format option, go to data colors. So just click on for show all. You can see that different countries can be chosen with different colors. So you can choose France of one color, and you can represent UK in another color, and Colombia in another color, and so on. You can do that. And all of the changes will be reflected in your visualization immediately. Okay. So now what we're going to do is we're going to learn how to save. Okay. Just click on save, name your file as anything you'd like to. I'm just going to name this COVID-19. I'm going to save this file. And if you want to publish your work, you can do that too by clicking the file option. You can see the publish option and you can just publish to Power BI. Okay. Here you have to enter your email address, and then once that is done, you can just publish it. So let's move ahead and check out one more use case of Power BI. So as in the case of most modern technologies, Power BI is also likely to embrace the law enforcement agencies, which are benefiting immensely with the use of big data analytics and other technological innovations. Power BI dashboards can be used very effectively to get insights into aspects such as deployment of personnel at critical locations during specific periods of the year by plotting various parameters such as the types of crimes that occur, the incidences, the crime patterns, etc. Like many of the factors and parameters can be involved in really finding the crimes that take place in a certain area. This is really helping the police and the other forces into getting a better insight into where crime can occur over a certain area and how it can be also prevented. So this is just one use case. Power BI can be used for many instances and many use cases to find and make better decisions in our daily lives and in our organization too, if you are working in any.
Let us understand what is SQL in Power BI. Well, structured query language in Power BI extracts, transforms, and manages data before visualizing it in reports and dashboards. Power BI connects to SQL databases, allowing users to fetch relevant data, optimize queries, and enhance performance. But why SQL is crucial for Power BI? SQL plays a vital role in Power BI by enabling efficient data extraction, transformation, and optimization before visualization. Since Power BI is a data-driven tool, having clean and well-structured data significantly improves performance and reporting accuracy. SQL helps query large datasets, perform complex joins and aggregations, and optimize data loads before bringing them into Power BI. Now let us see some of the key reasons. So first, here we have efficient data extraction. SQL allows you to fetch only the necessary columns and rows, reducing the data loads on Power BI. Also, using join and group by in SQL minimizes data processing inside Power BI. The next key reason is performance optimization. Here, the large data sets slow down Power BI if not optimized. So SQL pre-aggregates data, reducing the need for complex DAX calculations. Indexes and views in SQL help speed up query performance in Power BI. The next key reason is handling complex data models. So SQL simplifies many-to-many relationships and data normalization before loading into Power BI. Using CTEs, subqueries, and window functions, SQL ensures clean data for efficient Power BI modeling. The next key reason is direct query versus import mode benefits. So with direct query, SQL ensures that Power BI always fetches real-time data from the databases. In import mode, SQL pre-processes large tables, reducing Power BI's memory consumption. Alright, I hope now it's clear what is SQL in Power BI and also why it is crucial in Power BI and its key reasons. So now we will see how to import data into Power BI with the use of SQL. So first, let me connect to MySQL and then create a new database. So here I'll select new database. and create a database called Power BI DB and then click OK. And if you expand the Power BI DB and right click on it, you will get the following options. So go to New Query. We will be using a new query to create the table. So before creating the table, let me show you the dataset first. So this is my CSV file. The columns in this dataset are ID, product, region, sales and profit. So that we will create a table for this dataset now. Now here coming back to SQL, let's type create table sales data. And then I will type the column names and their data types such as ID and its data type int. And then the same way for the product and its data type as varchar 255. Then the next column region varchar, followed by sales and its data type as decimal. And finally the profit and its data type again decimal. And now let's close the bracket. Now let us select all and click execute. And you will see that the comments were successfully executed. Now we will insert the values in the columns. So we will type insert into sales data value because we have named our tables as sales data, and open the bracket and then type each column value in and close the brackets. And then let us type select star from sales data and now select the first line and execute it. Followed by let's execute the second line. And you can see that our columns and values have been executed. Let us follow the same step, select and execute it. And to import data into Power BI desktop, click on Get Data and select SQL Server. And in the Database tab, you can add this server name by right-clicking on the server and selecting Properties. Now copy the server name and paste it into Power BI and then click OK. And then click on Connect and then click OK. So the data is now displayed and you can also select and load it into Power BI. So as you can see, this is the data that we have loaded using SQL. And now to view this data set, click on Table View and this is how it is presented. Here it is. So now let us create a chart and present these values. So for that, go to Report View and let's do a small example. So I'm going to select this chart and in this I'm going to drag and drop the columns. Okay. So in the y-axis I'm going to drag and drop the product column and in the x-axis I'll be selecting profit. So that's it. It's simple, right? And I hope it's pretty much clear now. So this is how the Power BI and SQL integration simplifies the data analysis by enabling seamless connectivity and transformation. So here the users can choose between direct query for real-time access or import mode for performance optimization. Also, the strong SQL skills enhance data modeling and querying capabilities. And together, these tools empower businesses with insightful, data-driven decision making.
What is Matplotlib? Now it is very important for us to understand as to how Matplotlib works fundamentally. Now it is pretty easy and pretty basic. You have some data, then your computer will draw that data to a canvas of some sort, but it is only in the computer's memory. Now once your computer has drawn that data, you can show that data. So this is so the computer can first draw everything and then perform the more laborious task of showing it on the screen. Very basic. I know you might find it pretty lame, but it is very important for us to understand how fundamentally Matplotlib works. So you have an example in front of your screen. So again, we have that data in which we have country-wise percentage of unemployed youth. And I've done some analysis and I've shown it graphically, the percentage change in the unemployed youth country-wise between 2010 to 2011. So this is how that plot looks like. It is nothing but a bar plot. Now there are various types of plots available. We'll have a look at few of those in the next slide. So we'll move forward and see what are the various types of plots. So I've listed down 6 types of plots. First is the bar graph, then histograms, scatter plot, pie plot, hexagonal bin plot, and area plot. So we'll move forward and we'll get started with it. We'll write our first Matplotlib code. So here's the most basic code in order to generate one of the most simple graph. So let me explain to you this code. First of all, what I've done, I have imported pie plot from Matplotlib as PLT. Then I'll use this pie plot in order to plot the graph in the canvas. And then finally, I'll use this PLT, which is nothing but pie plot, in order to show what we have got. So Pretty basic, guys. So what I'll do, I'll open my PyCharm and execute this practically. So this is my PyCharm, guys. So over here, I'll first create a Python file with .py extension, and I'm going to name it as first code. Now over here, I'll first import pyplot from Matplotlib. So for that, I'll type from Matplotlib import pyplot as PLT. Now this PLT is pretty much similar to NP that we were using in Numpy array, if you can recall. So it is not mandatory to use PLT only. You can use whatever you want, but a lot of people use it as PLT, and I'll keep it that way. Now our next step is to plot our graph to the canvas. So for that, what I'll do, I'll type in plt.plot, and I'll write in here my X and Y axis values. So for X axis, I'll keep it as 1, 2, 3. Then for Y axis, I'm gonna add values such as 4, 5, and 1. So this will plot our graph in the canvas. Now final step is to show that plot. How we'll do that? I'll just type in here plt.show, and we'll execute this and see what happens. Run first code, and yep, this is how our first basic graph looks like. So with 3 lines of code, you have got this graph. So we'll move forward and we'll see how to actually add title labels to our graph. For that, I'll open my slides once more. So now, of course, there are some problems with our graph. First off, we have actually learned in school that we are supposed to put labels on each axis. And we need to also add a title to our graph. It actually doesn't make sense. Our graph doesn't make sense if there are no X and Y axis labels and a title. So you don't know what is axis, you don't know what is X axis, you don't know what is Y axis, and what is the graph about. Plus, in terms of programming, it is very unlikely that you'll be actually filling in data to the plt.plot function. Now over here, you can notice that we are actually filling in data like 1, 2, 3, 4, 5, 1. Instead, you will be passing variables into it. All right. So it should be something like plt.plot, and you can say X, Y if you have defined variables X, Y. All right. So now let us show plotting variables as well as adding some descriptive labels and a good title. Now the code is pretty much similar to the previous one, but it has few extra fields. Let me explain you that. So of course I've imported the pyplot from Matplotlib. After that, what I've done, I've defined 2 variables X and Y, and I have certain values in it like 5, 8, 10 and 12, 16, 6. You can put whatever values you want, and this can even contain a data frame, a pandas data frame that has a data set. After that, what I've done, I've defined plt.plot function in which I have X and Y. Instead of filling the data, I'm putting in variables that actually contain data. After that, I've added a title which is info, then Y label which is nothing but Y axis, and X label which is nothing but X axis. After that, I need to show my plot. So for that, I've done plt.show. And the result is there in front of your screen. We have a title, we have labels for X axis and Y axis. Now let me open my PyCharm and execute this practically. This is my PyCharm again, guys. So I'll remove till here, and obviously I need pyplot function from Matplotlib. So now I will define X and Y variable. So in X, it'll have a list of numbers, say 5, 8 and 10. And now I'll define one more variable Y, which again has a list of numbers 12, 16 and 6. 12, 16 and 6. Yep. So I'll write in here plt.plot, and instead of filling in data, I'll be passing variables. All right. And now our next step is to add title and X label as well as Y label. So in order to add title, I will write here plt.title and the title of my graph. So I can just write here info. And now I'm going to define X and Y labels. For that, I'll type in plt.y label, and I'm going to name it as Y axis. Similarly for X label, I'm going to do the same thing, X axis. All right. Now finally, I'll type in plt.show. Now go ahead and run this. So you can see that we have a graph that contains the title info, Y-axis as a Y label, as well as X-axis as the X label. Now I'll again open my slides and we'll see what next are we going to see. Now this graph is pretty much incomplete or ugly, I would say, because what if I want to change the width of this particular line? What if I want to add some grid lines? What if I want to change the color? So all those things, how will I do that? Don't worry, the next slide will actually tell you the same, how to add style to your graph. So how to add style to your graph? For that, first thing that you need to do is import the style function from Matplotlib module. After that, you need to call it style.use ggplot. So whatever plot that you want to use, I'm using ggplot right now. Then again, I've defined 4 variables x, y, x2 and y2, and all of these contains a list of numbers. Again, I'm telling you it can be a data frame as well, which contains a data set. Then what I've done, again I have used plt.plot function, but over here apart from x and y, there are many other fields. So don't get confused, I'll explain it to you, it's very easy. So this thing G actually tells me that the color of my line should be green. Then this is label. So this label is not for your x-axis or y-axis, it is for your curve, which is line 1. You can give whatever name you want. Then we have line width. I want the width of my line to be 5. So I've put in here 5. Similarly, I've done for the next plot as well. Then I've added title, which you know how to do that. Similarly, y label and x label. Now after that, I'm using this legend function in order to add a legend to my graph. Over here, you can notice that we have it present in our graph where I'm pointing with my highlighter right now. So we have line 1 and line 2. After that, what I've done, I've added grid lines to my graph, which is of the color K, which is nothing but black. So you can see it in my graph as well. We have grid lines available. And finally, plt.show. So this is my pie chart again, guys. Let me first remove all of this. And I need to import the style function. So for that, I'll type from Matplotlib import style. That's it. Style.use ggplot. Now define the variables. First will be x, add certain values to it. I'll add in 5, 8, 10. 5, 8, 10. Then y. I'm going to add a list of numbers 12, 16, 6. Now one more variable x2. Again, it will have list of numbers, which will be 6, 9, 11. Then I'm going to use y2 variable and I'll add some numbers to it, 6, 15 and 7. Alright, so now I'm going to use plt.plot function, and over here first I write x comma y. Then now given a color to it, I'm going to give it as green. Next, label line 1. Now line width, which is equal to 5. Now again for x2 and y2, I'm going to type in plt.plot x2 comma y2 comma the color, then label. So I'm going to type in line 2, then comes line width. Alright, so now our next step is to add title to our plot. So plot plt.title, and the title that I'm going to give is info again. Then x and y labels, plt.y label, y axis, then plt.x label, x axis, plt.show. Now go ahead and run this. So over here I've not added any grid lines. I can do that as well. So for that, let me first close it. Fine, so I've defined title, x label as well as y label. Now our last task is to actually add grid lines. So for that I'll type plt.grid and just write in here true, comma, give a color. I want it black, so I'll keep it that way. Finally, show your plot. So plt.show, that's all. Go ahead and run this. So you can see that this is our graph. So we have changed the default line width. We have added grid lines. We have added labels, titles, plus we can add legend as well. So let me show you how you can add a legend. So for that, I'll go back to my code once more. Just write in here plt.legend. Go ahead and run this again and you'll see that legend has been added. So here we have line 1 and line 2 as our legend, and we have changed the default line width, title, y-axis, x-axis labels, plus we have grid lines. So this is how you can customize and add style to your graph. we are going to look at how to plot various types of graphs. For example, a bar graph or a histogram, all those things. Fine. So first we'll look at how to plot a bar graph. So these are all the linear graphs that we have seen till now. Now we'll see how to plot a bar graph. So before I tell you how to plot a bar graph using Matplotlib, let us understand why we actually use a bar graph. So bar graphs are basically used to compare things between different groups. And when we are trying to measure changes over time, bar graphs are very well suited when changes are larger. So this is why we use bar graph. Now let us understand how we can do that using Matplotlib. Now since we know why we use bar graph, let me explain you the code and how you can do that using Matplotlib. So first import pyplot like we do every time. After that, instead of plt.plot, I'll use plt.bar. And I have filled in data here. You can fill in variables as well that contains data. Then I have defined a label, example1. After that, I have one more plot in which I have filled in data plus a label, and I've given a color as well. I don't want the default color. I want some change. So I've written it as green. After that, I've plotted the legend. After that comes legend and then X label and Y label that you have seen in the previous graphs as well. Then I've added a title and then finally show it. Don't worry guys, I'll execute this practically in my PyCharm now. So this is my PyCharm guys. So over here what I've done, first of all I have imported the pyplot function. Then instead of plt.plot I'm using plt.bar, and inside that I have data filled in. Instead of that I can even have variables that contains data. Then comes label in which I am using example1. Then again for one more plot I have plt.bar. Inside that I have data filled in, then label, and then in order to differentiate between both of them I'm using a color green for this particular bar graph. Then comes legend, and then after that I've defined X label as well as Y label. After that I have title and then finally show it. Now go ahead and run this and see if it works or not, and yes it does. So we have legend here, we have Y label as well as X label, and we have a title for our graph. I'll tell you, in histograms we have quantitative variables, all right? And when I talk about bar plot, they have categorical variables. So let me explain you this with an example. So suppose if I want to plot the GDP growth of every city in a particular country. So at that time I'll use a bar plot because it has a category, this particular city, like New Jersey, New York, all those things. Now when I talk about, I'll use histogram when I'm talking about quantitative variable. That means if I'm talking about age group. In that same example, if I want to calculate how much each age group is actually contributing towards the GDP growth, so at that time I'll be using histogram. So I hope this answers your question. All right, he wants me to repeat it. Fine, I'll do that. So when I talk about histogram, it actually has quantitative variables. When I talk about bar plot, it has categorical variables. Now with an example, if I explain you can take the example of GDP growth. So if I want to calculate how much GDP growth is there for every city in a country, so at that time I'll use bar plot. But if I want to calculate how much each age group is contributing towards the GDP growth of a country, then at that time I'll use a histogram. So over there we had a category in bar plot like cities, but here we have a quantitative variable that is age group. So I hope this answers your question. All right, he says yes, fine. All right, so let us move forward and focus on the code that you have in front of your screen. So let me explain you this code. So over here we have population ages. So we have defined a list in which we have multiple numbers. After that we have defined one more list or a variable, bins, in which we have multiple numbers again. Now instead of using plt.bar for bar plot, for histogram we use hist, plt.hist. Then comes population ages. Instead of data I am filling in here variables that contains data. Then bins. Then his type, I want it to be a bar type. Now when I talk about his type, I want it to be bar. And then the width should be 0.8. That's all. The rest all you can understand. It is X label, Y label, title, legend, and finally show the plot. Now I'll go ahead and execute this practically in my PyCharm. So this is my PyCharm guys, and just to save time, what I've done, I've actually copied it already. So over here you can see we have imported the Matplotlib module. Then we have a variable population ages and bins. Now instead of using plt.bar, I'm using plt.hist for histograms. Then comes the two variables, and then his type is equals to bar, and then I've defined width. Similarly, I've defined X label, Y label, and title like the previous examples. Then comes legend, and then finally show the plot. So let us go ahead and execute this and see if it works or not. Yep, it does. So we'll move forward and understand scatter plot as well. Now before we understand how to plot a scatter graph, we need to understand why we actually use scatter plots. Usually we use scatter plots in order to compare two variables, or three if you're plotting in 3 dimensions, looking for a correlation or groups. So basically you try to find out how much 2 or 3 variables related to each other. So over here, as you can see, there is one point here and there's another point here. So these two are pretty much dissimilar to each other, right? Now when I talk about these 2 points, they're pretty close to each other. So you can say that these two are pretty much similar. And basically what we are doing here, we're trying to find the relationship between the two variables, and that is actually called your correlation. Now let us understand the code. Now let me explain you the code. So first of all, we have imported the pyplot function from the Matplotlib module. Then we have two variables x and y, which contains a certain set of values. Now instead of calling plt.plot or plt.bar or plt.hist, I'm using scatter because I'm doing it for a scatter plot, right? Now inside the parentheses, I have x and y variables. These variables contain data, and I can even write the data instead of just writing the variables as well. Now I've defined a label and then color. Then rest of the things, you know, we have x label, y label, the title, then legend, and then show. That's all. Now let's go ahead and execute this practically in my PyCharm. Now this is my PyCharm, and over here I've already pasted the code. So I'll just go and run this and we'll see what happens. So this is how a scatter plot looks like. So here we have our legend, then we have the title, then we have our y-axis, then x-axis. These two are the labels for that. So let me close it and see what is the other plot that we are going to focus on. Now once scatter plot is done, we'll have a look at the area plot, or you can even call it as a stack plot. So basically these area graphs are very similar to the line graphs, okay? They can be used to track changes over time for one or more groups. Area graphs are good to use when you are tracking the changes in two or more related groups that make up one whole category. You can take an example of, say, public and private groups, okay? So before I explain you the code, let me tell you one thing, guys. The problem here is with polygons, we cannot actually have labels for our data. In order to solve that problem, all we did here was plot some empty lines, giving them the same color and the correct labels in accordance with our stack plot. We also gave them a line width of 5, as you can notice here, to make the lines a bit thicker in the legend. Now we can easily see that we are spending our day sleeping, eating, working, and playing. So this is how the code works. Now let me execute that practically in my PyCharm. So I've copied the code already just to save time again. Now this is our code. Over here I've already explained to you why are we defining these empty lines, just to add labels. Now let us go ahead and execute this and see what happens. So this is our graph, guys, and again we have legends, title to our graph, and y label as well as x label. So we'll move forward and look at various other plots. This is called a pie plot. So let me tell you about pie charts a bit. So pie charts are pretty much similar to stack plots, only they are for a certain point in time. Typically a pie chart is used to show parts to the whole and often a percentage share. You can consider the example of percentage of market share and things like that, right? Now let me tell you guys, Matplotlib handles the sizes of the slices and everything. So all we need to do is just feed it the numbers. That's what we have done here. So let me explain you the code here. So over here we use plt.pie to plot a pie chart. We have slices. We have specified slices. Now slices, which are nothing but the relevant sizes for each part. Then we specify the labels and then the color list for the corresponding slices. Next, we can optionally specify the start angle for the graph. This lets you start the line where you want. In our case, we chose a 90-degree angle for the pie chart, which means the first division will be a vertical line. Next, we can optionally add a shadow as well. And after that, we can even use explode to pull out a slice a bit. So we have explode that says 0, 0.1, 0, 0. So because of that, you can see that eating has been pulled out a bit. Now basically we have 4 total slices. So with explode, if we didn't want to pull out any slice at all, we would have just written here 0, 0, 0, 0. Now if we want to pull out the first slice a bit, we would do 0.1, 0, 0, 0. And if we want to pull out the second slice a bit, what we can do is 0, 0.1, 0, 0, like in our case. Now finally we do an auto pact. Now this auto pact overlay the percentages on the graph itself. So you can see that we have 8.3, 29.2%, 54.2%, all those things written on the graph itself. And then finally add a title and then show it. Now let me execute this practically, guys. Now just to save time, I've already written the code. So I'm just going to go ahead and execute this and we'll see if it comes or not. Yep, here is our pie chart. So we have seen multiple types of plots. We have seen pie plot, bar plot, histograms, area plot. Now what we need to understand is how to handle multiple plots. So at that time, what will you do? Let me open my slides again and we'll move forward with that. So this slide actually tells you how to deal with multiple plots. Now you can notice in the figure as well, we have two plots available. Now let me help you out with the code that is there in front of your screen. So in the beginning, we are importing a couple of modules. One is matplotlib.pyplot, which you are already familiar with. After that, there is a numpy module as well. So we have covered numpy modules in the previous sessions. If you have any doubts, you can go through it. Now after that, you might find this part confusing if you're not familiar with numpy. Now let me just tell you what it does. It will create a numpy array that will have elements between 0 till 5 in the steps of 0.1. Now similarly, T2 will also be a numpy array that will have elements ranging from 0 till 5 and in the steps of 0.02. Now after that, the code is pretty much similar to the previous examples that we have seen. But there is one new concept that is called subplot. Now let me tell you what this subplot does. It helps us to plot multiple plots, alright? So when we write subplot 211, this means that we have two plots. Horizontally, we have only one plot present and vertically we have two plots. And in that vertical position, this plot will be our first graph. Now you can notice that we have one more subplot that is 212. So vertically we have two plots, horizontally we have one, and this is the second plot. So what I'll do, I'll open my PyCharm and I'll play around with it a bit so that you'll be able to understand it better. So now this is the code, guys. First I'll go ahead and execute this and we'll see the result. So we have a graph, something which is like this, right? We have two plots which are aligned vertically. Now what I'm going to do is I'm going to just minimize this and I'm going to change the subplot value so that you'll be able to understand better how we are dealing with multiple plots. Now over here, if I make this as 2 and this one as well as 2, so let us see what we get. So we have got the same graph, but it is aligned horizontally, if you can notice. This is our another graph and this is our first graph. So you can notice the difference between both of these graphs, right? So this is why we use subplot. So we have, this was the first graph and this is our second graph. This is how it works.
What is data? Now this is a quite simple question. If I ask any of you what is data, you'll say that it's a set of numbers or some sort of documents that I've stored in my computer. Now data is actually everything. Alright, look around you, there is data everywhere. Each click on your phone generates more data than you know. Now this generated data provides insights for analysis and helps us make better business decisions. This is why data is so important. To give you a formal definition, data refers to facts and statistics collected together for reference or analysis. Alright, this is the definition of data in terms of statistics and probability. So as we know, data can be collected, it can be measured and analyzed, it can be visualized by using statistical models and graphs. Now data is divided into two major subcategories. Alright. So first we have qualitative data and quantitative data. These are the two different types of data. Under qualitative data, we have nominal and ordinal data, and under quantitative data, we have discrete and continuous data. Now let's focus on qualitative data. Now this type of data deals with characteristics and descriptors that can't be easily measured but can be observed subjectively. Now qualitative data is further divided into nominal and ordinal data. So nominal data is any sort of data that doesn't have any order or ranking. Okay. An example of nominal data is gender. Now there is no ranking in gender. There's only male, female or other, right? There is no 1, 2, 3, 4 or any sort of ordering in gender. Race is another example of nominal data. Now ordinal data is basically an ordered series of information. Okay, let's say that you went to a restaurant. Okay, your information is stored in the form of customer ID. All right, so basically you are represented with a customer ID. Now you would have rated their service as either good or average. All right, that's how ordinal data is. And similarly, they'll have a record of other customers who visit the restaurant along with their ratings. All right. So any data which has some sort of sequence or some sort of order to it is known as ordinal data. All right. So guys, this is pretty simple to understand. Now let's move on and look at quantitative data. So quantitative data basically deals with numbers and things. Okay, you can understand that by the word quantitative itself. Quantitative is basically quantity, right? So it deals with numbers, it deals with anything that you can measure objectively. All right. So there are two types of quantitative data. There is discrete and continuous data. Now, discrete data is also known as categorical data, and it can hold a finite number of possible values. Now, the number of students in a class is a finite number. All right, you can't have infinite number of students in a class. Let's say in your fifth grade, there were 100 students in your class. All right, there weren't infinite number, but there was a definite finite number of students in your class. Okay, that's discrete data. Next, we have continuous data. Now, this type of data can hold infinite number of possible values. Okay, so when you say weight of a person is an example of continuous data, what I mean to say is my weight can be 50 kgs, or it can be 50.1 kgs, or it can be 50.001 kgs, or 50.0001, or it's 50.023, and so on, right? There are infinite number of possible values. Right? So this is what I mean by continuous data. All right, this is the difference between discrete and continuous data. And also I'd like to mention a few other things over here. Now, there are a couple of types of variables as well. All right, we have a discrete variable and we have a continuous variable. Discrete variable is also known as a categorical variable. All right, it can hold values of different categories. Let's say that you have a variable called message, and there are two types of values that this variable can hold. Let's say that your message can either be a spam message or a non-spam message. Okay, that's when you call a variable as discrete or categorical variable. All right, because it can hold values that represent different categories of data. Now, continuous variables are basically variables that can store infinite number of values. So the weight of a person can be denoted as a continuous variable. All right, let's say there is a variable called weight, and it can store infinite number of possible values. That's why we'll call it a continuous variable. So guys, basically variable is anything that can store a value, right? So if you associate any sort of data with a variable, then it will become either discrete variable or continuous variable. There is also dependent and independent type of variables. Now, we won't discuss all of that in depth because that's pretty understandable. I'm sure all of you know what is independent variable and dependent variable, right? Dependent variable is any variable whose value depends on any other independent variable. So guys, that much knowledge I expect all of you to have. All right. So now let's move on and look at our next topic, which is what is statistics. Now, coming to the formal definition of statistics, statistics is an area of applied mathematics which is concerned with data collection, analysis, interpretation, and presentation. Now, usually when I speak about statistics, people think statistics is all about analysis. But statistics has other parts to it. It has data collection is also a part of statistics. Data interpretation, presentation, visualization, all of this comes into statistics. All right, you're going to use statistical methods to visualize data, to collect data, to interpret data. All right. So the area of mathematics deals with understanding how data can be used to solve complex problems. Okay. Now I'll give you a couple of examples that can be solved by using statistics. Okay, let's say that your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness? Now, even though this sounds like a biology problem, this can be solved with statistics. All right, you will have to create a test which can confirm the effectiveness of the drug. All right, this is a common problem that can be solved using statistics. Let me give you another example. You and a friend are at a baseball game, and out of the blue, he offers you a bet that neither team will hit a home run in that game. Should you take the bet? All right, here you'll just discuss the probability of whether you'll win or lose. All right, this is another problem that comes under statistics. Let's look at another example. The latest sales data has just come in, and your boss wants you to prepare a report for management on places where the company could improve its business. What should you look for and what should you not look for? Now, this problem involves a lot of data analysis. You'll have to look at the different variables that are causing your business to go down, or that you have to look at a few variables that are increasing the performance of your models and thus growing your business. All right. So this involves a lot of data analysis, and the basic idea behind data analysis is to use statistical techniques in order to figure out the relationship between different variables or different components in your business. Okay. So now let's move on and look at our next topic, which is basic terminologies in statistics. Now, before you dive deep into statistics, it is important that you understand the basic terminologies used in statistics. The two most important terminologies in statistics are population and sample. So throughout the statistics course, or throughout any problem that you're trying to solve with statistics, you will come across these two words, which is population and sample. Now, population is a collection or a set of individuals or objects or events whose properties are to be analyzed. Okay, so basically you can refer to population as a subject that you're trying to analyze. Now, a sample is just like the word suggests, it's a subset of the population. So you have to make sure that you choose the sample in such a way that it represents the entire population. All right, it shouldn't focus at one part of the population. Instead, it should represent the entire population. That's how your sample should be chosen. So a well-chosen sample will contain most of the information about a particular population parameter. Now you must be wondering, how can one choose a sample that best represents the entire population? Now, sampling is a statistical method that deals with the selection of individual observations within a population. So sampling is performed in order to infer statistical knowledge about a population. All right, if you want to understand the different statistics of a population, like the mean, the median, the mode, or the standard deviation, or the variance of a population, then you're going to perform sampling. All right, because it's not reasonable for you to study a large population and find out the mean, median, and everything else. So why is sampling performed? You might ask, what is the point of sampling? We can just study the entire population. Now, guys, think of a scenario wherein you're asked to perform a survey about the eating habits of teenagers in the US. So at present, there are over 42 million teens in the US, and this number is growing as we are speaking right now, correct? Is it possible to survey each of these 42 million individuals about their health? Is it possible? Well, it might be possible, but this will take forever to do. Now, obviously, it's not. It's not reasonable to go around knocking each door and asking for what does your teenage son eat and all of that. All right, this is not very reasonable. That's why sampling is used. It's a method wherein a sample of the population is studied in order to draw inference about the entire population. So it's basically a shortcut to studying the entire population. Instead of taking the entire population and finding out all the solutions, you're just going to take a part of the population that represents the entire population, and you're going to perform all your statistical analysis, your inferential statistics on that small sample. All right. And that sample basically represents the entire population. All right. So I'm sure I've made this clear to you all, what is sample and what is population. Now, there are two main types of sampling techniques that I'll discuss today. We have probability sampling and non-probability sampling. Now, in this video, we'll only be focusing on probability sampling techniques because non-probability sampling is not within the scope of this video. All right, we'll only discuss the probability part because we're focusing on statistics and probability, correct? Now again, under probability sampling, we have three different types. We have random sampling, systematic, and stratified sampling. All right. And just to mention the different types of non-probability samplings, we have snowball, quota, judgment, and convenience sampling. All right. Now guys, in this session, I'll only be focusing on probability. So let's move on and look at the different types of probability sampling. So what is probability sampling? It is a sampling technique in which samples from a large population are chosen by using the theory of probability. All right. So there are three types of probability sampling. All right. First, we have the random sampling. Now, in this method, each member of the population has an equal chance of being selected in the sample. All right, so each and every individual or each and every object in the population has an equal chance of being a part of the sample. That's what random sampling is all about. Okay, you're randomly going to select any individual or any object. So this way, each individual has an equal chance of being selected. Correct? Next, we have systematic sampling. Now, in systematic sampling, every nth record is chosen from the population to be a part of the sample. All right. Now, refer this image that I've shown over here. Out of these 6 groups, every second group is chosen as a sample. Okay, so every second record is chosen here. And this is how systematic sampling works. Okay, you're randomly selecting the nth record and you're going to add that to your sample. Next, we have stratified sampling. Now, in this type of technique, a stratum is used to form samples from a large population. So what is a stratum? A stratum is basically a subset of the population that shares at least one common characteristics. So let's say that your population has a mix of both male and female. So you can create 2 stratums out of this. One will have only the male subset and the other will have the female subset. All right, this is what stratum is. It is basically a subset of the population that shares at least one common characteristics. All right. In our example, it is gender. So after you've created a stratum, you're going to use random sampling on these stratums and you're going to choose a final sample. So random sampling meaning that all of the individuals in each of the stratum will have an equal chance of being selected in the sample. Correct? So guys, these were the 3 different types of sampling techniques. Now let's move on and look at our next topic, which is the different types of statistics. So after this, we'll be looking at the more advanced concepts of statistics. All right, so far we discussed the basics of statistics, which is basically what is statistics, the different sampling techniques and the terminologies in statistics. All right, now we look at the different types of statistics. So there are 2 major types of statistics, descriptive statistics and inferential statistics. In today's session, we'll be discussing both of these types of statistics in depth. All right, we'll also be looking at a demo which I'll be running in the R language in order to make you understand what exactly descriptive and inferential statistics is. So guys, we're just going to look at the basics, so don't worry if you don't have much knowledge. I'm explaining everything from the basic level. All right. So guys, descriptive statistics is a method which is used to describe and understand the features of specific data set by giving a short summary of the data. Okay, so it is mainly focused upon the characteristics of data. It also provides a graphical summary of the data. Now, in order to make you understand what descriptive statistics is, let's suppose that you want to gift all your classmates a t-shirt. So to study the average shirt size of a student in a classroom, so if you were to use descriptive statistics to study the average shirt size of students in your classroom, then what you would do is you would record the shirt size of all students in the class, and then you would find out the maximum, minimum, and average shirt size of the class. Okay. So coming to inferential statistics makes inferences and predictions about a population based on the sample of data taken from the population. Okay. So in simple words, it generalizes a large data set and it applies probability to draw a conclusion. Okay. So it allows you to infer data parameters based on a statistical model by using sample data. So if we consider the same example of finding the average shirt size of students in a class, in inferential statistics, you will take a sample set of the class, which is basically a few people from the entire class. All right. You already have had grouped the class into large, medium, and small. All right. In this method, you basically build a statistical model and expand it for the entire population in the class. So guys, that was a brief understanding of descriptive and inferential statistics. So that's the difference between descriptive and inferential. Now in the next section, we'll go in depth about descriptive statistics. All right. So let's discuss more about descriptive statistics. So like I mentioned earlier, descriptive statistics is a method that is used to describe and understand the features of a specific data set by giving short summaries about the sample and measures of the data. There are two important measures in descriptive statistics. We have measure of central tendency, which is also known as measure of center, and we have measures of variability. This is also known as measures of spread. So measures of center include mean, median, and mode. Now, what is measures of center? Measures of the center are statistical measures that represent the summary of a data set. Okay, the three main measures of center are mean, median, and mode. Coming to measures of variability or measures of spread, we have range, interquartile range, variance, and standard deviation. All right. So now let's discuss each of these measures in a little more depth, starting with the measures of center. Now, I'm sure all of you know what the mean is. Mean is basically the measure of the average of all the values in a sample. Okay, so it's basically the average of all the values in a sample. How do you measure the mean? I hope all of you know how the mean is measured. If there are 10 numbers and you want to find the mean of these 10 numbers, all you have to do is you have to add up all the 10 numbers and you have to divide it by 10. 10 here represents the number of samples in your data set. All right, since we have 10 numbers, we're going to divide this by 10. All right, this will give us the average or the mean. So to better understand the measures of central tendency, let's look at an example. Now the data set over here is basically the cars data set, and it contains a few variables. All right, it has something known as cars, it has mileage per gallon, cylinder type, displacement, horsepower, and real axle ratio. All right, all of these measures are related to cars. Okay, so what you're going to do is you're going to use descriptive analysis and you're going to analyze each of the variables in the sample data set for the mean, standard deviation, median, mode, and so on. So let's say that you want to find out the mean or the average horsepower of the cars among the population of cars. Like I mentioned earlier, what you'll do is you'll check the average of all the values. So in this case, we'll take the sum of the horsepower of each car and we'll divide that by the total number of cars. Okay, that's exactly what I've done here in the calculation part. So this 110 basically represents the horsepower for the first car. All right, similarly, I've just added up all the values of horsepower for each of the cars and I've divided it by 8. Now 8 is basically the number of cars in our data set. All right, so 103.625 is what our mean is, or the average of horsepower is. All right, now let's understand what median is with an example. Okay, so to define median, median is basically a measure of the central value of the sample set is called the median. All right, you can say that it is a middle value. So if we want to find out the center value of the mileage per gallon among the population of cars, first what we'll do is we'll arrange the MPG values in ascending or descending order and choose a middle value. All right, in this case, since we have 8 values, right, we have 8 values, which is an even entry. So whenever you have even number of data points or samples in your data set, then you're going to take the average of the two middle values. If we had 9 values over here, we can easily figure out the middle value and choose that as a median. But since there are even number of values, we're going to take the average of the two middle values. All right. So 22.8 and 23 are my two middle values, and I'm taking the mean of those two, and hence I get 22.9, which is my median. All right. Lastly, let's look at how mode is calculated. So what is mode? Now, the value that is most recurrent in the sample set is known as mode, or basically the value that occurs most often. Okay, that is known as mode. So let's say that we want to find out the most common type of cylinder among the population of cars. All we have to do is we will check the value which is repeated the most number of times. Here we can see that the cylinders come in two types. We have cylinder of type 4 and cylinder of type 6, right? So take a look at the data set. You can see that the most recurring value is 6, right? We have 1, 2, 3, 4, and 5. We have 5, 6, and we have 1, 2, 3. Yeah, we have 3, 4 type cylinders and 5, 6 type cylinders. So basically we have 3, 4 type cylinders and we have 5, 6 type cylinders. All right. So our mode is going to be 6, since 6 is more recurrent than 4. So guys, those were the measures of the center or the measures of central tendency. Now let's move on and look at the measures of the spread. All right. Now, what is the measure of spread? A measure of spread, sometimes also called as measure of dispersion, is used to describe the variability in a sample or population. Okay, you can think of it as some sort of deviation in the sample. All right, so you measure this with the help of the different measure of spreads. We have range, interquartile range, variance, and standard deviation. Now, range is pretty self-explanatory, right? It is the given measure of how spread apart the values in a data set are. The range can be calculated as shown in this formula. So you're basically going to subtract the maximum value in your data set from the minimum value in your data set. That's how you calculate the range of the data. All right. Next, we have interquartile range. So before we discuss interquartile range, let's understand what a quartile is. Alright, so quartiles basically tell us about the spread of a data set by breaking the data set into different quartiles. Okay, just like how the median breaks the data into two parts, the quartile will break it into different quartiles. So to better understand how quartile and interquartile are calculated, let's look at a small example. Now, this data set basically represents the marks of 100 students ordered from the lowest to the highest scores. Alright, so the quartiles lie in the following ranges. Now, the first quartile, which is also known as Q1, it lies between the 25th and the 26th observation. Alright, so if you look at this, I've highlighted the 25th and the 26th observation. So how you can calculate Q1 or first quartile is by taking the average of these two values. Alright, since both the values are 45, when you add them up and divide them by 2, you'll still get 45. Now, the second quartile or Q2 is between the 50th and the 51st observation. So you're going to take the average of 58 and 59 and you'll get a value of 58.5. Now, this is my second quarter. The third quartile or Q3 is between the 75th and the 76th observation. Here again, you'll take the average of the two values, which is the 75th value and the 76th value. All right, and you'll get a value of 71. All right. So guys, this is exactly how you calculate the different quartiles. Now let's look at what is interquartile range. So IQR or the interquartile range is a measure of variability based on dividing a data set into quartiles. Now the interquartile range is calculated by subtracting the Q1 from Q3. So basically Q3 minus Q1 is your IQR. So your IQR is your Q3 minus Q1. Alright. Now, this is how each of the quartiles are. Each quartile represents a quarter, which is 25%. Alright. So guys, I hope all of you are clear with interquartile range and what are quartiles. Now let's look at variance. Now, variance is basically a measure that shows how much a random variable differs from its expected value. Okay, it's basically the variance in any variable. Now, variance can be calculated by using this formula. Right here, X basically represents any data point in your data set. N is the total number of data points in your data set, and X bar is basically the mean of data points. All right, this is how you calculate variance. Variance is basically computing the squares of deviations. Okay, that's why it says S squared there. Now let's look at what is deviation. Deviation is just the difference between each element from the mean. Okay, so it can be calculated by using this simple formula where xi basically represents a data point and mu is the mean of the population. Alright, this is exactly how you calculate deviation. Now, population variance and sample variance are very specific to whether you're calculating the variance in your population dataset or in your sample dataset. That's the only difference between population and sample variance. So the formula for population variance is pretty explanatory. So xi is basically each data point, mu is the mean of the population, n is the number of samples in your dataset. All right. Now let's look at sample variance. Now, sample variance is the average of square differences from the mean. All right. Here, xi is any data point or any sample in your data set. X bar is the mean of your sample. All right. It's not the mean of your population. It's the mean of your sample. And if you notice, n here is a smaller n. It's the number of data points in your sample. And this is basically the difference between sample and population variance. I hope that is clear. Coming to standard deviation, it is the measure of dispersion of a set of data from its mean. All right, so it's basically the deviation from your mean. That's what standard deviation is. Now, to better understand how the measures of spread are calculated, let's look at a small use case. So let's say Daenerys has 20 dragons. They have the numbers 9, 2, 5, 4, and so on, as shown on the screen. What you have to do is you have to work out the standard deviation. All right, in order to calculate the standard deviation, you need to know the mean, right? So first you're going to find out the mean of your sample set. So how do you calculate the mean? You add all the numbers in your data set divided by the total number of samples in your data set. So you get a value of 7 here. Then you calculate the RHS of your standard deviation formula. All right, so from each data point, you're going to subtract the mean and you're going to square that. All right, so when you do that, you'll get the following result. You'll basically get this 425, 4, 9, 25, and so on. So finally, you'll just find the mean of these squared differences. All right, so your standard deviation will come up to 2.983 once you take the square root. So guys, this is pretty simple. It's a simple mathematic technique. All you have to do is you have to substitute the values in the formula. All right. I hope this was clear to all of you. Now let's move on and discuss the next topic, which is information gain and entropy. Now this is one of my favorite topics in statistics. It's very interesting. And this topic is mainly involved in machine learning algorithms like decision trees and random forest. All right. It's very important for you to know how information gain and entropy really work and why they're so essential in building machine learning models. We'll focus on the statistic parts of information gain and entropy. And after that, we'll discuss a use case and see how information gain and entropy is used in decision trees. So for those of you who don't know what a decision tree is, it is basically a machine learning algorithm. You don't have to know anything about this. I'll explain everything in depth, so don't worry. Now let's look at what exactly entropy and information gain is. Now guys, entropy is basically the measure of any sort of uncertainty that is present in the data. Alright, so it can be measured by using this formula. So here S is the set of all instances in the data set or all the data items in the data set. N is the different type of classes in your data set. Pi is the event probability. Now, this might seem a little confusing to you all, but when we go through the use case, you'll understand all of these terms even better. All right. Coming to information gain, as the word suggests, information gain indicates how much information a particular feature or a particular variable gives us about the final outcome. Okay, it can be measured by using this formula. So again, here h of S is the entropy of the whole data set S. Sj is the number of instances with the j value of an attribute A. S is the total number of instances in the data set. V is the set of distinct values of an attribute A. H of Sj is the entropy of subset of instances, and H of A, S is the entropy of an attribute A. Even though this seems confusing, I'll clear out the confusion. All right, let's discuss a small problem statement where we'll understand how information gain and entropy is used to study the significance of a model. So like I said, information gain and entropy are very important statistical measures that let us understand the significance of a predictive model. Okay, to get a more clear understanding, let's look at a use case. All right, now suppose we're given a problem statement. All right, the statement is that you have to predict whether a match can be played or not by studying the weather conditions. So the predictor variables here are outlook, humidity, wind. There is also a predictor variable. The target variable is basically play. All right, the target variable is the variable that you're trying to predict. Okay. Now the value of the target variable will decide whether or not a game can be played. All right, so that's why the play has two values. It has no and yes. No meaning that the weather conditions are not good and therefore you cannot play the game. Yes meaning that the weather conditions are good and suitable for you to play the game. All right, so that was a problem statement. I hope the problem statement is clear to all of you. Now to solve such a problem, we make use of something known as decision trees. So guys, think of an inverted tree and each branch of the tree denotes some decision. All right, each branch is known as the branch node, and at each branch node you're going to take a decision in such a manner that you'll get an outcome at the end of the branch. All right, now this figure here basically shows that out of 14 observations, 9 observations result in a yes, meaning that out of 14 days, the match can be played only on 9 days. All right. So here if you see on day 1, day 2, day 8, day 9 and day 11, the outlook has been sunny. All right. So basically we're trying to cluster our data set depending on the outlook. So when the outlook is sunny, this is our data set. When the outlook is overcast, this is what we have. And when the outlook is rain, this is what we have. All right. So when it is sunny, we have 2 yeses and 3 nos. Okay. When the outlook is overcast, we have all 4 as yeses, meaning that on the 4 days when the outlook was overcast, we can play the game. All right. Now, when it comes to rain, we have 3 yeses and 2 nos. All right. So if you notice here, the decision is being made by choosing the outlook variable as the root node. Okay, so the root node is basically the topmost node in a decision tree. Now what we've done here is we've created a decision tree that starts with the outlook node. All right, then you're splitting the decision tree further depending on other parameters like sunny, overcast and rain. All right, now like we know that outlook has 3 values: sunny, overcast and rain. So let me explain this in a more in-depth manner. Okay, so what you're doing here is you're making the decision tree by choosing the outlook variable at the root node. The root node is basically the topmost node in a decision tree. Now the outlook node has 3 branches coming out from it, which is sunny, overcast and rain. So basically outlook can have 3 values. Either it can be sunny, it can be overcast or it can be rainy. Okay, now these 3 values are assigned to the immediate branch nodes, and for each of these values, the possibility of play is equal to yes is calculated. So the sunny and the rain branches will give you an impure output, meaning that there is a mix of yes and no, right? There are 2 yeses here, 3 no's here. There are 3 yeses here and 2 no's over here. But when it comes to the overcast variable, it results in a 100% pure subset. All right, this shows that the overcast variable will result in a definite and certain output. This is exactly what entropy is used to measure. All right, it calculates the impurity or the uncertainty. All right, so the lesser the uncertainty or the entropy of a variable, more significant is that variable. So when it comes to overcast, there's literally no impurity in the data set. It is a 100% pure subset, right? So we want variables like these in order to build our model. All right. Now we don't always get lucky and we don't always find variables that will result in pure subsets. That's why we have the measure entropy. So the lesser the entropy of a particular variable, the more significant that variable will be. So in a decision tree, the root node is assigned the best attribute so that the decision tree can predict the most precise outcome. Meaning that on the root node, you should have the most significant variable. All right, that's why we've chosen outlook. All right, now some of you might ask me, why haven't you chosen overcast? Now guys, overcast is not a variable. It is a value of the outlook variable. All right, that's why we've chosen outlook here, because it has a 100% pure subset, which is overcast. All right, now the question in your head is, how do I decide which variable or attribute best splits the data? Now right now I know I looked at the data and I told you that here we have a 100% pure subset. But what if it's a more complex problem and you're not able to understand which variable will best split the data? So guys, when it comes to decision trees, information gain and entropy will help you understand which variable will best split the data set. All right, or which variable you have to assign to the root node, because whichever variable is assigned to the root node, it will best split the data set, and it has to be the most significant variable. All right, so how we can do this is we need to use information gain and entropy. So from the total of the 14 instances that we saw, 9 of them said yes and 5 of the instances said no, that you cannot play on that particular day. All right, so how do you calculate the entropy? So this is the formula. You just substitute the values in the formula. So when you substitute the values in the formula, you'll get a value of 0.940. All right, this is the entropy, or this is the uncertainty of the data present in our sample. Now, in order to ensure that we choose the best variable for the root node, let us look at all the possible combinations that you can use on the root node. Okay, So these are all the possible combinations. You can either have outlook, you can have windy, humidity, or temperature. Okay, these are our 4 variables, and you can have any one of these variables as your root node. But how do you select which variable best fits the root node? That's what we are going to see by using information gain and entropy. So guys, now the task at hand is to find the information gain for each of these attributes. Alright, so for outlook, for windy, for humidity, and for temperature, we're going to find out the information gain. Alright. Now a point to remember is that the variable that results in the highest information gain must be chosen because it will give us the most precise and output information. Alright, so the information gain for attribute windy, we'll calculate that first. Here we have 6 instances of true and 8 instances of false. Okay, so when you substitute all the values in the formula, you'll get a value of 0.048. So we get a value of 0.048. Now this is a very low value for information gain. Alright, so the information that you're going to get from windy attribute is pretty low. So let's calculate the information gain of attribute outlook. Alright, so from the total of 14 instances, we have 5 instances which say sunny, 4 instances which are overcast, and 5 instances which are rainy. Alright, for sunny, we have 3 yeses and 2 nos. For overcast, we have all the 4 as yes. For rainy, we have 3 yes and 2 nos. Okay, so when you calculate the information gain of the outlook variable, you'll get a value of 0.247. Now compare this to the information gain of the windy attribute. This value is actually pretty good, right? We have 0.247, which is a pretty good value for information gain. Now let's look at the information gain of attribute humidity. Now over here we have 7 instances which say high and 7 instances which say normal, right? And under the high branch node, we have 3 instances which say yes and the rest 4 instances which say no. Similarly, under the normal branch, we have 1, 2, 3, 4, 5, 6, 7 instances which say yes and 1 instance which says no. Alright, so when you calculate the information gain for the humidity variable, you're going to get a value of 0.151. Now this is also a pretty decent value, but when you compare it to the information gain of the attribute outlook, it is less. Right, now let's look at the information gain of attribute temperature. Alright, so the temperature can hold, repeat. So basically the temperature attribute can hold hot, mild, and cool. Okay, under hot we have 2 instances which says yes and 2 instances for no. Under mild we have 4 instances of yes and 2 instances of no. And under cool we have 3 instances of yes and 1 instance of no. Alright, now when you calculate the information gain for this attribute, you'll get a value of 0.029, which is again very less. So what you can summarize from here is, if we look at the information gain for each of these variables, we'll see that for outlook we have the maximum gain. Alright, we have 0.247, which is the highest information gain value. And you must always choose a variable with the highest information gain to split the data at the root node. So that's why we assign the outlook variable at the root node. Alright, so guys, I hope this use case was clear. If any of you have doubts, please keep commenting those doubts. Now let's move on and look at what exactly a confusion matrix is. Now the confusion matrix is the last topic for descriptive statistics. Alright, after this I'll be running a short demo where I'll be showing you how you can calculate mean, median, mode, and standard deviation, variance, and all of those values by using R. Okay, so let's talk about confusion matrix. Now guys, what is a confusion matrix? Now don't get confused, this is not any complex topic. Now a confusion matrix is a matrix that is often used to describe the performance of a model. Alright, and this is specifically used for classification models or a classifier. And what it does is it will calculate the accuracy, or it will calculate the performance of your classifier by comparing your actual results and your predicted results. Alright, so this is what it looks like: true positive plus true negative and all of that. Now this is a little confusing. I'll get back to what exactly true positive, true negative, and all of this stands for. For now, let's look at an example and let's try and understand what exactly confusion matrix is. So guys, I made sure that I put examples after each and every topic because it's important you understand the practical part of statistics. All right, statistics has literally nothing to do with theory. You need to understand how calculations are done in statistics. Okay, so here what I've done is now let's look at a small use case. Okay, let's consider that you're given data about 165 patients, out of which 105 patients have a disease and the remaining 50 patients don't have a disease. Okay, so what you're going to do is you'll build a classifier that predicts by using these 165 observations. You'll feed all of these 165 observations to your classifier and it will predict the output every time a new patient's detail is fed to the classifier, right? Now, out of these 165 cases, let's say that the classifier predicted yes 110 times and no 55 times. All right. So yes basically stands for yes, the person has a disease, and no stands for no, the person does not have a disease. All right. That's pretty self-explanatory. But yeah, so it predicted that 110 times the patient has a disease and 55 times that no, the patient doesn't have a disease. However, in reality, only 105 patients in the sample have the disease and 60 patients do not have the disease, right? So how do you calculate the accuracy of your model? You basically build the confusion matrix, all right? This is how the matrix looks like. N basically denotes the total number of observations that you have, which is 165 in our case. Actual denotes the actual values in the data set, and predicted denotes the predicted values by the classifier. So the actual value is no here and the predicted value is no here. So your classifier was correctly able to classify 50 cases as no. All right. Since both of these are no, so 50 it was correctly able to classify. But 10 of these cases it incorrectly classified. Meaning that your actual value here is no, but your classifier predicted it as yes. All right. That's why there's 10 over here. Similarly, it wrongly predicted that 5 patients do not have diseases, whereas they actually did have diseases, and it correctly predicted 100 patients which have the disease. All right, I know this is a little bit confusing, but if you look at these values, no, no, 50, meaning that it correctly predicted 50 values. No, yes means that it wrongly predicted yes for the values that it was supposed to predict no. All right. Now, what exactly is this true positive, true negative, and all of that? I'll tell you what exactly it is. So, true positive are the cases in which we predicted a yes and they do not actually have the disease. All right. So, it is basically this value. All right. We predicted a yes here, even though they did not have the disease. So, we have 10 true positives, right? Similarly, true negative is we predicted no and they don't have the disease, meaning that this is correct. False positive is we predicted yes, but they do not actually have the disease. All right, this is also known as type 1 error. False negative is we predicted no, but they actually do not have the disease. So guys, basically false negative and true negatives are basically correct classifications. All right. So this was confusion matrix and I hope this concept is clear. Again guys, if you have doubts, please comment your doubts in the comment section. So guys, that was descriptive statistics. Now before we go to probability, I promised you all that we'll run a small demo in R. Alright, we'll try and understand how mean median mode works in R. Okay, so let's do that first. So guys, again, what we just discussed so far was descriptive statistics. Alright. Next, we're going to discuss probability and then we'll move on to inferential statistics. Okay, inferential statistics is basically the second type of statistics. Okay, now to make things more clearer for you, let me just zoom in. So guys, it's always best to perform practical implementations in order to understand the concepts in a better way. Okay, so here we'll be executing a small demo that will show you how to calculate the mean, median, mode, variance, standard deviation, and how to study the variables by plotting a histogram. Okay, don't worry if you don't know what a histogram is. It's basically a frequency plot. There's no big science behind it. All right, this is a very simple demo, but it also forms the foundation that every machine learning algorithm is built upon. Okay, you can say that most of the machine learning algorithms, actually all the machine learning algorithms and deep learning algorithms have this basic concept behind them. Okay, you need to know how mean, median, mode, and all of that is calculated. So guys, I'm using the R language to perform this, and I'm running this on R Studio. For those of you who don't know R language, I will leave a couple of links in the description box. You can go through those videos. So what we're doing is we're randomly generating numbers and we're storing it in a variable called data. Right? So if you want to see the generated numbers, just run the line data. All right, this variable basically stores all our numbers. All right, now what we're going to do is we're going to calculate the mean. Now all you have to do in R is specify the word mean along with the data that you're calculating the mean of. And I've assigned this whole thing into a variable called mean, which will hold the mean value of this data. So now let's look at the mean. For that, I've used a function called print and mean. All right, so our mean is around 5.99. Okay, next is calculating the median. It's very simple, guys. All you have to do is use the function median, all right, and pass the data as a parameter to this function. That's all you have to do. So R provides functions for each and everything. All right, statistics is very easy when it comes to R because R is basically a statistical language. Okay, so all you have to do is just name the function, and that function is already inbuilt in your R. Okay, so your median is around 6.4. Similarly, we'll calculate the mode. All right, let's run this function. I basically created a small function for calculating the mode. So guys, this is our mode, meaning that this is the most recurrent value, right? Now we're going to calculate the variance and the standard deviation. For that, again, we have a function in R called as var. All right, all you have to do is pass the data to that function. Okay, similarly, we'll calculate the standard deviation, which is basically the square root of your variance, right? Now we'll print the standard deviation, right? This is our standard deviation value. Now finally, we'll just plot a small histogram. Histogram is nothing but it's a frequency plot. All right, it'll show you how frequently a data point is occurring. So this is the histogram that we've just created. It's quite simple in R because R has a lot of packages and a lot of inbuilt functions that support statistics. All right, it is a statistical language that is mainly used by data scientists or by data analysts and machine learning engineers because they don't have to sit and code these functions. All they have to do is they have to mention the name of the function and pass the corresponding parameters. So guys, that was the entire descriptive statistics module. And now we'll discuss about probability. Okay, so before we understand what exactly probability is, let me clear out a very common misconception. People often tend to ask me this question: what is the relationship between statistics and probability? So probability and statistics are related fields. All right, so probability is a mathematical method used for statistical analysis. Therefore, we can say that probability and statistics are interconnected branches of mathematics that deal with analyzing the relative frequency of events. So they're very interconnected fields, and probability makes use of statistics and statistics makes use of probability. All right, they're very interconnected fields. So that is the relationship between statistics and probability. Now let's understand what exactly is probability. So probability is the measure of how likely an event will occur. To be more precise, it is the ratio of desired outcome to the total outcomes. Now the probability of all outcomes always sum up to 1. Now the probability will always sum up to 1. Probability cannot go beyond 1. Okay, so either your probability can be 0 or it can be 1, or it can be in the form of decimals like 0.52 or 0.55, or it can be in the form of 0.5, 0.7, 0.9, but its value will always stay between the range 0 and 1. Okay, now the famous example of probability is rolling a dice example. So when you roll a dice, you get 6 possible outcomes, right? You get 1, 2, 3, 4, and 5, 6 phases of a dice. Now each possibility only has one outcome. So what is the probability that on rolling a dice you'll get 3? The probability is 1 by 6, right? Because there's only one phase which has the number 3 on it. Out of 6 phases, there's only one phase which has the number 3. So the probability of getting 3 when you roll a dice is 1 by 6. Similarly, if you want to find the probability of getting a number 5, again the probability is going to be 1 by 6. All right. So all of this will sum up to 1. All right. So guys, this is exactly what probability is. It's a very simple concept. We all learned it in 8th standard onwards, right? Now let's understand the different terminologies that are related to probability. Now there are three terminologies that you often come across when we talk about probability. We have something known as random experiment. Okay, it's basically an experiment or a process for which the outcomes cannot be predicted with certainty. All right, that's why you use probability. You're going to use probability in order to predict the outcome with some sort of certainty. Sample space is the entire possible set of outcomes of a random experiment. An event is one or more outcomes of an experiment. So if you consider the example of rolling a dice, now let's say that you want to find out the probability of getting a 2 when you roll a dice. Okay, so finding this probability is the random experiment. The sample space is basically your entire possibility. Okay, so 1, 2, 3, 4, 5, 6 phases are there, and out of that you need to find the probability of getting a 2, right? So all the possible outcomes will basically represent your sample space. Okay, so 1 to 6 are all your possible outcomes. This represents your sample space. Now event is one or more outcome of an experiment. So in this case my event is to get a 2 when I roll a dice, right? So my event is the probability of getting a 2 when I roll a dice. So guys, this is basically what random experiment, sample space and event really means. All right. Now let's discuss the different types of events. There are two types of events that you should know about. There is disjoint and non-disjoint events. Disjoint events are events that do not have any common outcome. For example, if you draw a single card from a deck of cards, it cannot be a king and a queen, correct? It can either be king or it can be queen. Now, non-disjoint events are events that have common outcomes. For example, a student can get 100 marks in statistics and 100 marks in probability. All right. And also the outcome of a ball delivered can be a no ball and it can be a 6. Right. So this is what non-disjoint events are. All right. These are very simple to understand. Right. Now let's move on and look at the different types of probability distribution. All right. I'll be discussing the three main probability distribution functions. I'll be talking about probability density function, normal distribution, and central limit theorem. Okay. Probability density function, also known as PDF, is concerned with the relative likelihood for a continuous random variable to take on a given value. All right. So the PDF gives the probability of a variable that lies between the range A and B. So basically what you're trying to do is you're going to try and find the probability of a continuous random variable over a specified range. Okay, now this graph denotes the PDF of a continuous variable. Now this graph is also known as the bell curve, right? It's famously called the bell curve because of its shape. And there are three important properties that you need to know about a probability density function. Now the graph of a PDF will be continuous over a range. This is because you're finding the probability that a continuous variable lies between the ranges A and B, right? The second property is that the area bounded by the curve of a density function and the x-axis is equal to 1. Basically, the area below the curve is equal to 1, all right, because it denotes probability. Again, the probability cannot range more than 1. It has to be between 0 and 1. Property number 3 is that the probability that a random variable assumes a value between A and B is equal to the area under the PDF bounded by A and B. Okay, now what this means is that the probability value is denoted by the area of the graph. All right, so whatever value that you get here, which is basically 1, is the probability that a random variable will lie between the range A and B. All right, so I hope all of you have understood the probability density function. It's basically the probability of finding the value of a continuous random variable between the range A and B. All right. Now let's look at our next distribution, which is normal distribution. Now, normal distribution, which is also known as the Gaussian distribution, is a probability distribution that denotes the symmetric property of the mean, right? Meaning that the idea behind this function is that the data near the mean occurs more frequently than the data away from the mean. So what it means to say is that the data around the mean represents the entire data set. Okay, so if you just take a sample of data around the mean, it can represent the entire data set. Now, similar to the probability density function, the normal distribution appears as a bell curve. All right. Now, when it comes to normal distribution, there are two important factors. All right. We have the mean of the population and the standard deviation. Okay, so the mean in the graph determines the location of the center of the graph, right? And the standard deviation determines the height of the graph. Okay, so if the standard deviation is large, the curve is going to look something like this. All right, it'll be short and wide. And if the standard deviation is small, the curve is tall and narrow. All right, so this was it about normal distribution. Now let's look at the central limit theory. Now the central limit theory states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. Now that's a little confusing. Okay, let me break it down for you. Now in simple terms, if we had a large population and we divided it into many samples, then the mean of all the samples from the population will be almost equal to the mean of the entire population. All right, meaning that each of the sample is normally distributed, right? So if you compare the mean of each of the sample, it will almost be equal to the mean of the population, right? So this graph basically shows a more clear understanding of the central limit theorem, right? You can see each sample here and the mean of each sample is almost along the same line, right? Okay, so this is exactly what the central limit theorem states. Now, the accuracy or the resemblance to the normal distribution depends on two main factors, right? So the first is the number of sample points that you consider, all right? And the second is the shape of the underlying population. Now, the shape obviously depends on the standard deviation and the mean of a sample, correct? So guys, central limit theorem basically states that each sample will be normally distributed in such a way that the mean of each sample will coincide with the mean of the actual population. All right, in short terms, that's what central limit theorem states. All right, and this holds true only for a large data set. Mostly for a small data set, there are more deviations when compared to a large data set. It's because of the scaling factor, right? The smallest deviation in a small data set will change the value very drastically. But in a large data set, a small deviation will not matter at all. Now let's move on and look at our next topic, which is the different types of probability. Now this is an important topic because most of your problems can be solved by understanding which type of probability should I use to solve this problem, right? So we have three important types of probability. We have marginal, joint, and conditional probability. So let's discuss each of these. Now, the probability of an event occurring unconditioned on any other event is known as marginal probability or unconditional probability. So let's say that you want to find the probability that a card drawn is a heart. All right. So if you want to find the probability that a card drawn is a heart, the probability will be 13 by 52. Since there are 52 cards in a deck and there are 13 hearts in a deck of cards, right? And there are 52 cards in a total deck. So your marginal probability will be 13 by 52. That's about marginal probability. Now let's understand what is joint probability. Now joint probability is a measure of two events happening at the same time. Okay, let's say that the two events are A and B. So the probability of event A and B occurring is the intersection of A and B. So for example, if you want to find the probability that a card is a 4 and a red, that would be joint probability, all right, because you're finding a card that is 4 and the card has to be red in color. So for the answer, this will be 2 by 52 because we have 1, 2 in hearts and we have 1, 2 in diamonds, correct? So both of these are red in color, therefore our probability is 2 by 52. And if you further down it, it is 1 by 26. Right? So this is what joint probability is all about. Moving on, let's look at what exactly conditional probability is. So if the probability of an event or an outcome is based on the occurrence of a previous event or an outcome, then you call it as a conditional probability. Okay. So the conditional probability of an event B is the probability that the event will occur given that an event A has already occurred. Right? So if A and B are dependent events, then the expression for conditional probability is given by this. Now this first term on the left hand side, which is P B of A, is basically the probability of event B occurring given that event A has already occurred. Alright. So like I said, if A and B are dependent events, then this is the expression. But if A and B are independent events, then the expression for conditional probability is like this. Right? So guys, P of A and P of B is obviously the probability of A and probability of B. Right? Now let's move on. Now, in order to understand conditional probability, joint probability, and marginal probability, let's look at a small use case. Okay. Now, basically, we're going to take a data set which examines the salary package and training undergone by candidates. Okay. Now, in this, there are 60 candidates without training and 45 candidates which have enrolled for Edureka's training. Right. Now, the task here is you have to assess the training with the salary package. Okay, let's look at this in a little more depth. So in total, we have 105 candidates, out of which 60 of them have not enrolled for Edureka's training and 45 of them have enrolled for Edureka's training. All right, this is a small survey that was conducted, and this is the rating of the package or the salary that they got. Right, so if you read through the data, you can understand. There were 5 candidates without Edureka training who got a very poor salary package. Okay, similarly, there are 30 candidates with Edureka training who got a good package, right? So guys, basically you're comparing the salary package of a person depending on whether or not they've enrolled for Edureka training, right? This is our data set. Now let's look at our problem statement. Find the probability that a candidate has undergone Edureka's training. Quite simple. Which type of probability is this? This is marginal probability, right? So the probability that a candidate has undergone Edureka's training is obviously 45 divided by 105. Since 45 is the number of candidates with Edureka training and 105 is the total number of candidates. So you get a value of approximately 0.42. Alright, that's the probability of a candidate that has undergone Edureka's training. Next question. Find the probability that a candidate has attended Edureka's training and also has good package. Now this is obviously a joint probability problem, right? So how do you calculate this? Now since our table is quite formatted, we can directly find that people who have gotten a good package along with Edureka training are 30, right? So out of 105 people, 30 people have Edureka training and a good package, right? They're specifically asking for people with Edureka training. Remember that. Right? The question is find the probability that a candidate has attended Edureka's training and also has a good package. All right, so you need to consider 2 factors, that is a candidate who's attended Edureka's training and who has a good package. So clearly that number is 30. 30 divided by total number of candidates, which is 105. Right? So here you get the answer clearly. Next, we have find the probability that a candidate has a good package given that he has not undergone training. Okay, now this is clearly conditional probability because here you're defining a condition. You're saying that you want to find the probability of a candidate who has a good package given that he's not undergone any training, right? The condition is that he's not undergone any training. All right. So the number of people who have not undergone training are 60, and out of that, 5 of them have got a good package. Right, so that's why this is 5 by 60 and not 5 by 105, because here they've clearly mentioned has a good package given that he has not undergone training. So you have to only consider people who have not undergone training, right? So only 5 people who have not undergone training have gotten a good package, right? So 5 divided by 60, you get a probability of around 0.08, which is pretty low, right? Okay. So this was all about the different types of probability. Now let's move on and look at our last topic in probability, which is Bayes theorem. Now guys, Bayes theorem is a very important concept when it comes to statistics and probability. It is majorly used in naive Bayes algorithm. Those of you who aren't aware, naive Bayes is a supervised learning classification algorithm, and it is mainly used in Gmail spam filtering, right? A lot of you might have noticed that if you open up Gmail, you'll see that you have a folder called spam, right? All of that is carried out through machine learning, and the algorithm used there is naive Bayes, right? So now let's discuss what exactly the Bayes theorem is and what it denotes. The Bayes theorem is used to show the relation between one conditional probability and its inverse. All right. Basically, it's nothing but the probability of an event occurring based on prior knowledge of conditions that might be related to the same event. Okay, so mathematically, the Bayes theorem is represented like this, right? Like shown in this equation. The left-hand term is referred to as the likelihood ratio, which measures the probability of occurrence of event B given an event A. Okay. On the left-hand side is what is known as the posterior. Right? It is referred to as posterior, which means that the probability of occurrence of A given an event B. Right? The second term is referred to as the likelihood ratio. Alright, this measures the probability of occurrence of B given an event A. Now, P of A is also known as the prior, which refers to the actual probability distribution of A, and P of B is again the probability of B, right? This is the Bayes theorem. Now, in order to better understand the Bayes theorem, let's look at a small example. Let's say that we have three bowls. We have bowl A, bowl B, and bowl C. Okay, bowl A contains 2 blue balls and 4 red balls. Bowl B contains 8 blue balls and 4 red balls. Bowl C contains 1 blue ball and 3 red balls. Now, if we draw one ball from each bowl, what is the probability to draw a blue ball from a bowl A if we know that we drew exactly a total of 2 blue balls? Right? If you didn't understand the question, please reread it. I shall pause for a second or two. Right? So I hope all of you have understood the question. Okay, now what I'm going to do is I'm going to draw a blueprint for you and tell you how exactly to solve the problem. But I want you all to give me the solution to this problem, right? I'll draw a blueprint. I'll tell you what exactly the steps are, but I want you to come up with the solution on your own, right? The formula is also given to you. Everything is given to you. All you have to do is come up with a final answer, right? Let's look at how you can solve this problem. So first of all, what we'll do is let's consider A. All right, let A be the event of picking a blue ball from bag A, and let X be the event of picking exactly 2 blue balls, right? Because these are the 2 events that we need to calculate the probability of. Now there are 2 probabilities that you need to consider here. One is the event of picking a blue ball from bag A, and the other is the event of picking exactly 2 blue balls. Okay, so these 2 are represented by A and X respectively. So what we want is the probability of occurrence of event A given X, which means that given that we're picking exactly 2 blue balls, what is the probability that we are picking a blue ball from bag A? So by the definition of conditional probability, this is exactly what our equation will look like, correct? This is basically occurrence of event A given an event X, and this is the probability of A and X, and this is the probability of X alone, correct? Now what we need to do is we need to find these 2 probabilities, which is probability of A and X occurring together and probability of X. Okay, this is the entire solution. So how do you find P, probability of X? This you can do in 3 ways. So first is white ball from A, either white from B or red from C. Now first is to find the probability of X. X basically represents the event of picking exactly 2 blue balls, right? So these are the 3 ways in which it is possible. So you'll pick 1 blue ball from bowl A and 1 from bowl B. In the second case, you can pick 1 from A and another blue ball from C. In the third case, you can pick a blue ball from bag B and a blue ball from bag C, right? These are the 3 ways in which it is possible. So you need to find the probability of each of this. Step 2 is that you need to find the probability of A and X occurring together. This is the sum of terms 1 and 2. Okay, this is because in both of these events, you're picking a ball from bag A, correct? So guys, find out this probability and let me know your answer in the comment section. All right, we'll see if you get the answer right. I gave you the entire solution to this. All you have to do is substitute the value, right? If you want a second or two, I'm going to pause on the screen so that you can go through this in a more clearer way, right? Remember that you need to calculate 2 probabilities. The first probability that you need to calculate is the event of picking a blue ball from bag A given that you're picking exactly 2 blue balls. Okay. The second probability you need to calculate is the event of picking exactly 2 blue balls. All right. These are the 2 probabilities you need to calculate. So remember that, and this is the solution. All right. So guys, make sure you mention your answers in the comment section. For now, let's move on and look at our next topic, which is the inferential statistics. So guys, we just completed the probability module, right? Now we'll discuss inferential statistics, which is the second type of statistics. We discussed descriptive statistics earlier, all right? So like I mentioned earlier, inferential statistics, also known as statistical inference, is a branch of statistics that deals with forming inferences and predictions about a population based on a sample of data taken from the population. All right. Now, the question you should ask is, how does one form inferences or predictions on a sample? The answer is you use point estimation. Okay. Now, you must be wondering, what is point estimation? Point estimation is concerned with the use of the sample data to measure a single value which serves as an approximate value or the best estimate of an unknown population parameter. That's a little confusing. Let me break it down to you. For example, in order to calculate the mean of a huge population, what we do is we first draw out the sample of the population and then we find the sample mean, right? The sample mean is then used to estimate the population mean. This is basically point estimate. You're estimating the value of one of the parameters of the population, right? Basically, the mean, you're trying to estimate the value of the mean. This is what point estimation is. There are two main terms in point estimation. There's something known as the estimator and there's something known as the estimate. Estimator is a function of the sample that is used to find out the estimate. All right. In this example, it's basically the sample mean, right? So a function that calculates the sample mean is known as the estimator, and the realized value of the estimator is the estimate, right? So I hope point estimation is clear. Now, how do you find the estimates? There are 4 common ways in which you can do this. The first one is method of moments. Here what you do is you form an equation in the sample data set and then you analyze a similar equation in the population data set as well, like the population mean, population variance, and so on. So in simple terms, what you're doing is you're taking down some known facts about the population and you're extending those ideas to the sample. All right. Once you do that, you can analyze the sample and estimate more essential or more complex values. Right. Next, we have maximum of likelihood. Now, this method basically uses a model to estimate a value. All right. Now, a maximum of likelihood is majorly based on probability. So there's a lot of probability involved in this method. Next, we have the Bayes estimator. This works by minimizing the errors or the average risk. Okay. The Bayes estimator has a lot to do with the Bayes theorem. All right. Let's not get into the depth of these estimation methods. Finally, we have the best unbiased estimators. In this method, there are several unbiased estimators that can be used to approximate a parameter. Okay. So guys, these were a couple of methods that are used to find the estimate. But the most well-known method to find the estimate is known as the interval estimation. Okay, this is one of the most important estimation methods. All right, this is where confidence interval also comes into the picture, right? Apart from interval estimation, we also have something known as margin of error. So I'll be discussing all of this in the upcoming slides. So first, let's understand what is interval estimate. Okay, an interval or range of values which are used to estimate a population parameter is known as an interval estimation. Right, that's very understandable. Basically, what they're trying to say is you're going to estimate the value of a parameter. Let's say you're trying to find the mean of a population. What you're going to do is you're going to build a range and your value will lie in that range or in that interval. All right, so this way your output is going to be more accurate because you've not predicted a point estimation. Instead, you have estimated an interval within which your value might occur, right? Okay, now this image clearly shows how point estimate and interval estimate are different. So guys, interval estimate is obviously more accurate because you're not just focusing on a particular value or a particular point in order to predict the probability. Instead, you're saying that the value might be within this range between the lower confidence limit and the upper confidence limit. All right, this just denotes the range or the interval. Okay, if you're still confused about interval estimation, let me give you a small example. If I stated that I will take 30 minutes to reach the theater, this is known as point estimation. Okay, but if I stated that I will take between 45 minutes to an hour to reach the theater, this is an example of interval estimation. All right, I hope it's clear now. Now, interval estimation gives rise to two important statistical terminologies. One is known as confidence interval and the other is known as margin of error. All right. So guys, it's important that you pay attention to both of these terminologies. Confidence interval is one of the most significant measures that are used to check how essential a machine learning model is. All right. So what is confidence interval? Confidence interval is the measure of your confidence that the interval estimated contains the population parameter or the population mean or any of those parameters, right? Now, statisticians use a confidence interval to describe the amount of uncertainty associated with the sample estimate of a population parameter. Now, guys, this is a lot of definition. Let me just make you understand confidence interval with a small example. Okay, let's say that you perform a survey and you survey a group of cat owners to see how many cans of cat food they purchase in 1 year. Okay, you test your statistics at the 99% confidence level and you get a confidence interval of 100, 200. This means that you think that the cat owners buy between 100 to 200 cans in a year. And also, since the confidence level is 99%, it shows that you're very confident that the results are correct. Okay, I hope all of you are clear with that. Right, so your confidence interval here will be 100 and 200 and your confidence level will be 99%. Right, that's the difference between confidence interval and confidence level. So within your confidence interval, your value is going to lie and your confidence level will show how confident you are about your estimation. Right, I hope that was clear. Let's look at margin of error. Now, margin of error for a given level of confidence is the greatest possible distance between the point estimate and the value of the parameter that it is estimating. You can say that it is a deviation from the actual point estimate. Right? Now, the margin of error can be calculated using this formula. Now, ZC here denotes the critical value or the confidence interval, and this is multiplied by standard deviation divided by root of the sample size. All right, n is basically the sample size. Now let's understand how you can estimate the confidence intervals. So guys, the level of confidence, which is denoted by C, is the probability that the interval estimate contains a population parameter. Let's say that you're trying to estimate the mean. All right, so the level of confidence is the probability that the interval estimate contains the population parameter. So this interval between minus ZC and ZC, or the area beneath this curve, is nothing but the probability that the interval estimate contains a population parameter. All right, it should basically contain the value that you are predicting. Right, now these are known as critical values. This is basically your lower limit and your higher limit confidence level. Also, there's something known as the z-score. Now this score can be calculated by using the standard normal table. All right, if you look it up anywhere on Google, you'll find the z-score table or the standard normal table. Okay, to understand how this is done, let's look at a small example. Okay, let's say that the level of confidence is 90%. This means that you are 90% confident that the interval contains the population mean. Okay, so the remaining 10%, which is out of 100%, the remaining 10% is equally distributed on these tail regions. Okay, so you have 0.05 here and 0.05 over here. Right, so on either side of C, you'll distribute the other leftover percentage. Now these z-scores are calculated from the table as I mentioned before. All right, 1.645 is calculated from the standard normal table. Okay, so guys, this is how you estimate the level of confidence. So to sum it up, let me tell you the steps that are involved in constructing a confidence interval. First, you'll start by identifying a sample statistic. Okay, this is the statistic that you will use to estimate a population parameter. This can be anything like the mean of the sample. Next, you will select a confidence level. Now, the confidence level describes the uncertainty of a sampling method. Right? After that, you'll find something known as the margin of error. right? We discussed margin of error earlier. So you find this based on the equation that I explained in the previous slide. Then you'll finally specify the confidence interval. All right. Now let's look at a problem statement to better understand this concept. A random sample of 32 textbook prices is taken from a local college bookstore. The mean of the sample is so, and the sample standard deviation is this. Use a 95% confident level and find the margin of error for the mean price of all textbooks in the bookstore. Okay. Now this is a very straightforward question. If you want, you can read the question again. All you have to do is you have to just substitute the values into the equation. All right. So guys, we know the formula for margin of error. You take the z-score from the table. After that, we have deviation, which is 23.44, right? And that's standard deviation. And n stands for the number of samples. Here the number of samples is 32, basically 32 textbooks. So approximately your margin of error is going to be around 8.12. This is a pretty simple question. Now that you know the idea behind confidence interval, let's move ahead to one of the most important topics in statistical inference, which is hypothesis testing, right? So basically, statisticians use hypothesis testing to formally check whether the hypothesis is accepted or rejected. Okay. Hypothesis testing is an inferential statistical technique used to determine whether there is enough evidence in a data sample to infer that a certain condition holds true for an entire population. So to understand the characteristics of a general population, we take a random sample and we analyze the properties of the sample, right? We test whether or not the identified conclusion represents the population accurately, and finally we interpret their results. Now, whether or not to accept the hypothesis depends upon the percentage value that we get from the hypothesis. Okay, so to better understand this, let's look at a small example. Before that, there are a few steps that are followed in hypothesis testing. You begin by stating the null and the alternative hypothesis. All right, I'll tell you what exactly these terms are. And then you formulate an analysis plan. All right, after that, you analyze the sample data. And finally, you can interpret the results, right? Now, to understand the entire hypothesis testing, we'll look at a good example. Okay. Now, consider 4 boys, Nick, John, Bob, and Harry. These boys were caught bunking a class and they were asked to stay back at school and clean their classroom as a punishment. Right? So, what John did is he decided that 4 of them would take turns to clean their classrooms. He came up with a plan of writing each of their names on chits and putting them in a bowl. Now, every day they had to pick up a name from the bowl and that person had to clean the class. Right? That sounds pretty fair enough. Now, it has been 3 days and everybody's name has come up except John's. Assuming that this event is completely random and free of bias, what is the probability of John not cheating? Right? What is the probability that he's not actually cheating? This can be solved by using hypothesis testing. Okay. So we'll begin by calculating the probability of John not being picked for a day. Right? So we're going to assume that the event is free of bias. So we need to find out the probability of John not cheating, right? First, we'll find the probability that John is not picked for a day, right? We get 3 out of 4, which is basically 75%. Now, 75% is fairly high. So if John is not picked for 3 days in a row, the probability will drop down to approximately 42%. Okay, so 3 days in a row meaning that is the probability drops down to 42%. Now let's consider a situation where John is not picked for 12 days in a row. The probability drops down to 3.2%. Okay, thus the probability of John cheating becomes fairly high, right? So in order for statisticians to come to a conclusion, they define what is known as the threshold value, right? Considering the above situation, if the threshold value is set to 5%, it would indicate that if the probability lies below 5%, then John is cheating his way out of detention. But if the probability is above the threshold value, then John is just lucky and his name isn't getting picked. So the probability and hypothesis testing give rise to 2 important components of hypothesis testing, which is null hypothesis and alternate hypothesis. Null hypothesis is basically approving the assumption. Alternate hypothesis is when your result disapproves the assumption. Right? Therefore, in our example, if the probability of an event occurring is less than 5%, which it is, then the event is biased. Hence, it proves the alternate hypothesis. So guys, with this, we come to the end of this session. So before I wrap up, we're going to run a quick demo, which is based on inferential statistics. Let's quickly open up R Studio. Again, I'll be running this in R language, and those of you who don't know R, it's okay. I'm going to leave a couple of links in the description, and this is pretty understandable. This is just basic math, right? Now, in this demo, what we'll be doing is we'll be using the Gapminder dataset to perform hypothesis testing. Now, guys, the Gapminder dataset contains a list of 142 countries with their respective values for life expectancy, a GDP per capita, and population every 5 years from 1952 to 2007. Okay, don't worry, I'll show you the dataset. So what we'll do is we'll begin by installing and downloading the Gapminder dataset. So this install.packages will basically install the Gapminder package, and this library Gapminder will just load the Gapminder library. All right. So we've successfully loaded our Gapminder package. Now let's view this dataset. These are the countries, all right, different countries, and you have the continents, the year, the life expectancy, the population, and the GDP per capita. Okay, for so each of these countries, we have this information, right? Now, the next step is to load the famous deployer package provided by R. We're specifically looking to use the pipe operator in this package. Okay. Now, for those of you who don't know what the pipe operator does, this is the pipe operator, right? Now, the pipe operator allows you to pipe your data from the left-hand side into the data at the right-hand side of the pipe. Okay, it's quite self-explanatory. It's a pipe which connects two data points, right? So let's install and load this package. All right. Now, our next step, what we're going to do is we're going to compare the life expectancy of two places. Okay, we're going to compare the life expectancy of Ireland and South Africa, and we're going to perform the t-test to check if the comparison follows a null hypothesis or an alternate hypothesis. Okay, so let's run the code. Okay, so now we'll apply the t-test and we'll compare the life expectancy of these two places. All right, let's run this. Notice the mean in group Ireland and South Africa. Right here is the mean. You can see that the life expectancy almost differs by a scale of 20. Now we need to check if this difference in the value of life expectancy in South Africa and Ireland is actually valid and not just by pure chance. Okay. For this reason, the t-test is carried out. So pay special attention to this p-value over here. This is also known as the probability value, right? The p-value is very important measurement when it comes to ensuring the significance of a model. A model is said to be statistically significant only when the p-value is less than the predetermined statistical significance level, which is ideally 0.05, right? So your p-value has to be much lesser than 0.05. As you can see from our output, the p-value is very, very lesser when compared to 0.05. Right, it is an extremely small value, which is a good thing. Now, in the summary of the model, notice another important parameter called the t-value. Right, I've been talking about the t-test. And what exactly is this t-value? You can see it over here. It is 10.067. Now, a larger t-value suggests that the alternate hypothesis is true and that the difference in life expectancy is not equal to 0 by pure luck. Hence, in our case, the null hypothesis is disapproved. So to conclude the demo, we'll be plotting a graph for each continent such that the graph shows how the life expectancy for each continent varies with the respective GDP per capita. Just to add a little bit data visualization, I'm performing this last step. So guys, here we can clearly see from the output that the alternate hypothesis is true. All right. And also this is calculated with a 95% confidence interval. Right? You get what I'm saying when I'm talking about 95% confidence interval, right? This is our confidence interval 15 to 22, and our confidence level is 95%. This is exactly what we discussed a couple of minutes ago. Now, just to end the demo, I'll show you a small visualization. Here, what we're doing is we're showing how the life expectancy for each continent varies with respect to the GDP per capita for that continent. Okay, so this is our plot. Okay, if you look at the illustration, you can almost see a linear variance, right? You can almost see a linear line in the life expectancy for each of the continent with respect to the GDP per capita. Right, this also shows how well the R language can be used for statistical analysis. Right, look at how pretty the graph looks, and also how well they show that there is almost a linear dependency between the GDP per capita and the life expectancy.
So first, let's have an introduction to hypothesis testing. So the first question which might arise in your mind is, what is a hypothesis? So let's understand this with an example. Like a few years ago, if you remember, Maggi noodles were banned, which is a product of a Nestle company, on the claim that it has excess amount of lead in it. So the government regulatory body, which says that there cannot be more than 2.5 ppm of the lead in any food product, has conducted a test on a sample of Maggi noodles and found that there was an excess lead in Maggi noodles. So what happened is, you can see here like the lead content. So the lead content should be less than 2.5 ppm as per the government regulatory bodies. So what happens is, suppose if like the manufacturer, like which is the Nestle, which produces 1 million packets of Maggi noodles every day, you cannot actually do a survey on that. What they did is, they did a survey on 10,000 packets of Maggi noodles, and that's how they found out that there is excess lead in Maggi noodles. So this is how it becomes a claim, by extracting a sample through a very big population, because the government regulatory body cannot do test on all the packets of Maggi noodles. So they extracted out a small sample out of a very big population, and they made a test out of it, and that's how they reached to a conclusion. That's how they claim that Maggi noodles contain excess lead. So the process of extracting out a sample from big population and conducting a test on it is called hypothesis. I hope it's clear now. We can also look at another example, like a survey being conducted on Edureka employees. The average commute time of an Edureka employee to reach office from home and then going back to the office comes out to be 35 minutes on average. But it's an average, means there are employees which are taking time as 10 minutes also, some are taking time as 50 minutes also, 1 hour also, some are taking just 30 minutes, 40 minutes also. So we found out that we conducted a survey on 100 Edureka employees, and we found out the average commute time to be 35 minutes. So this becomes a claim. This is the status quo. So this is how the hypothesis has been formulated. Now let's understand what is hypothesis testing. So if you conduct a test on this hypothesis, that's what hypothesis testing is. So hypothesis testing, if I frame it, it becomes, hypothesis testing is like used to confirm your conclusion about the population. Through hypothesis testing, you can determine whether there is enough evidence to conclude if the hypothesis about the population parameter is true or not. Now let's understand the null and alternate hypothesis. So we will understand this with an example of criminal trial. So suppose there is an accused which has done some crime, and now judge has to decide whether he has done the crime or he has not done the crime. So there are like now two hypotheses you can see. The first hypothesis is that accused is innocent, he hasn't done the crime, and the second is that the accused has done the crime and he is guilty. So you can see here like there are two opposite hypotheses here. So the first one is null hypothesis, denoted as H naught, which is a prevailing belief about the population. It states that there is no change or there is no difference in the status quo, means there is no difference in the situation, according to which the accused is innocent and he is just a member of the society and he hasn't done anything wrong. Now, second one is the alternate hypothesis, denoted as H1, which is a claim that opposes the null hypothesis, which means the accused is innocent, which brings a change in the situation, a difference in the situation. Now, if you remember the older example which I gave you of Maggi noodles, now the status quo here is, if you remember, the null hypothesis here is that the lead in the food product, means in the Maggi noodles, does not exceed the maximum limit. That is, it does not exceed the 2.5 ppm. And the alternate hypothesis will be lead in the Maggi noodles does exceed the 2.5 ppm limit. That is the maximum limit. Now, if you remember the example of Edureka employee, the survey done on Edureka employees for reaching the office and coming back from the office to their respective homes, means the average commute time, which is taken by them is 35 minutes. But suppose now the claim is after some research or survey, we found out that it's taking more than 35 minutes. So now can you please tell me which one is the null hypothesis will be in the situation? Like I will give you the option. So the first option is like employees take an average commute time of 35 minutes, and option B is employees take more than 35 minutes. So you can pause this video right now and you can answer the question in the comment section below. Now you see the outcome of the communal trial example is like the null hypothesis, accused is innocent, and alternate hypothesis is that the accused is not innocent. So if you see here, the rejection of null hypothesis will be like guilty, because that is status quo, there is no change. But if you reject the status quo, which means the accused is guilty. And the second is failure to reject the null hypothesis, which means the accused is not guilty, which means like we don't have the enough evidence to reject the null hypothesis. But remember this thing, that in any way there cannot be a situation where you accept the null hypothesis. The only situation is you don't have enough evidence to reject the null hypothesis. Now we have to understand this important concept, that is formulation of null and alternate hypothesis. So now we will understand how to formulate null and alternate hypothesis. So if your claim statement has words like at least, at most, less than, or greater than, you cannot formulate the null hypothesis just from the claim statement, because it's not necessary that the claim is about the status quo, means always about the status quo. So you can use the following rule to formulate the null and alternate hypothesis. So the null hypothesis always has the following signs like equal to, or smaller than equals to, or greater than equals to. And the alternate hypothesis always has the following signs like not equal to, or greater than, or lesser than. Keep that in mind. This is a very important thing. Now let's see an example of Flipkart. Suppose Flipkart claimed that its total valuation in December 2020 was at least $20 billion. Here, the claim contains greater than equals to sign. So the null hypothesis is the original claim. The hypothesis in this case can be formulated as like you can see here, total valuation greater than equals to $20 billion, which is null hypothesis, and total valuation is smaller than is $20 billion. You can understand the difference between the signs. I have told you the signs which are used in null hypothesis and alternate hypothesis. You can see the equal sign is there and there is no equal sign in alternate hypothesis. Similarly, in situation 2, you can like Flipkart claim that the total valuation in December 2020 was greater than $20 billion. Here the claim contains greater sign. So the null hypothesis is the complement of the original claim. So the hypothesis in this case can be formulated as, you can see like total valuation greater than $20 billion, which is alternate hypothesis, and total valuation which is smaller than equals to $20 billion is null hypothesis. You can see the difference between the signs. To summarize this, you cannot decide the status quo or formulate the null hypothesis from the claim statement. You need to take care of the signs in writing the null hypothesis. It always has to be formulated using not equals to, or greater, or smaller signs. Once you have formulated the null and alternate hypothesis, the next most important step of hypothesis testing is making the decision to either reject or fail to reject the null hypothesis. We will understand this with the critical value method. So we take here the example of archery. Now suppose there's a friend of yours named Aviral who likes to brag about his skills of archery, and he told like he has scored 70 in archery. But you doubt his claim because you have a perception that he likes to brag about. So you have this perception of Aviral that he usually brags. So you doubt his claim. So you can see like Aviral's claim here is that he scored 70. That is the status quo, means that is the null hypothesis. So for clearing your doubts, just for the confirmation purpose, you played a match with Aviral. So you played like over 5 games of archery with him, and you find that the average score of game is 20. So which is like less likely to believe actual claim of Aviral if he gets 20 as the average score, because 70 is like far away from 20. So you can like reject the null hypothesis. But suppose the average score of 5 games is like 65. In that case, you more like to believe his claim because that is near to 70. Or if it is more than like even 70, like suppose he got 80 or 90, in which case Aviral is like underestimating himself. So we can see this graph here. So you can say like the status quo is 70. Suppose like the score, we can say for the 5 games he got a little lower, like we can say around 55, 60, or say 50 we got. We can say like he scored around 50. Now we have to understand like that we can reject it or not. So there's a critical point where you will reject the Aviral's claim, or there's a critical point above which you will like accept the Aviral's claim. So we say these points as lower critical value or upper critical value. Like suppose if it is 50 or it is 55 or it is until 45, we can say, just for example purpose I'm saying, not for definitive purpose. If the score is 45 or 50 around, so we say like we can actually believe Aviral. But and if it is lower than that, we can say like he was just bragging. Or if he gets the value around like 80 or 90, which is more than 70. So if that is the value, then we'll also like accept the Aviral's claim. We can also say that he might be underestimating himself. So can see this graph, first one. In this, see like if whatever the score comes out and that score is come under lower critical value. Suppose you believe that if he gets only 60, below than that you feel like he's just bragging. So he got 50, which comes under lower critical value. So we say that Avril actually like was just bragging. And suppose you can say like he got around 80 score. So you can say, okay, you are believing in him. But if you say like, suppose he got score of around 90 or 100, which comes under upper critical value. So you feel like he is just underestimating himself. So in that case, if the research hypothesis means alternate hypothesis value comes under lower critical value, upper critical value, you reject the null hypothesis. And in the similar manner, if these values doesn't come under lower critical value or upper critical value, we say it comes under acceptance region, as you can see here. Like 50 comes under acceptance region, so we accept the Averell's claim. So in such a situation, we fail to reject the null hypothesis. So these kind of tests where we have like both a lower critical value and upper critical value, these kind of tests we say it as two-tailed tests, which are mostly used in healthcare system. Like suppose there's a medicine in which the paracetamol drug is required, but there's certain amount of quantity is required. Like paracetamol, which is used for curing pain and fever of a patient, and we require like 500 ml for curing it. But suppose drug present in the medicine is just 300 grams. It will like decrease the efficacy of the medicine, and it might not be useful for the patient. And like suppose there is a increase in the value of the drug, like suppose there is 700 gram or 1000 gram, that can like do side effects to the patient. Maybe it can like cause diarrhea or maybe cause other problems. So which is not a good thing. There is both lower critical value and upper critical value for that. So there should only be 500 grams of paracetamol, not more than that, not less than that. So that's the critical point. Now the second one is lower tail test. So lower tail test and like upper tail test both are there. You can see how their graphs are shown. So these kind of tests are usually used in manufacturing companies. Like we have taken the example of Maggi noodles, where the government regulatory authority found out that the lead content in Maggi noodles has exceeded 2.5 ppm. So there is one kind of test. Like in this, you can see like there was an upper critical value. Like if it exceeds 2.5 ppm, that comes under upper critical value. There are like three kinds of tests in it, as I've explained to you, like two tail test, lower tail test, and upper tail test. So you can see like in lower tail test, the rejection region is on the left side, as you can see on the left side of the graph. And if you see the right side of the graph, you can see the rejection region is on the right side of the distribution. That is for upper tilt. Now that you have an idea of acceptance regions, critical values, low critical value, upper critical value, and different types of tests, let's have a different example to have a better understanding of critical value method. So assume that you are the owner of multiple AC stores. You want to know about the mean demand of AC units per month per store during summer. Till now, you have been ordering 350 AC units per store per month based on the historic demand. But now the meteorological department has said that there will be intense heat waves. So you anticipate that the demand might go up. So you want to check your assumption that the average units required in 1 month will be different from 350 units per store. So in this case, you are assuming that 350 units is the average number of units that are sold every month. When you are trying to visualize it, you use a histogram and the means comes out to be 350 approximately, like you can see here. So this becomes the mean or average of population. So next you will define the null and the alternate hypothesis. You start with the null hypothesis, that is the assumption about the status quo. So you assume that H0 is true, and this implies that your population mean is still equal to 350. In this AC hypothesis problem, the assumption is that the average demand for the AC units per store in 1 month is 350 units. So your null hypothesis H0 states that the mean demand of ACs is 350 units per store every month, as you can see here in the graph. So now that your null hypothesis is clear, the next step is to state the alternative or research hypothesis. So H1 is the opposite of H0, which means like the opposite of null hypothesis. So it challenges the status quo. This is the assumption that you try to prove, and you should examine all evidence with respect to H1. In your AC sales problem, H1 is that the population mean mu is not equals to 350. You should always examine the evidences with respect to alternative hypothesis, not with respect to null hypothesis. So now you need to formulate the hypothesis. So the first step would be to, in formulating the hypothesis, is that H0 is equals to 350. So there's like no change in the status quo, and H1 is not equal to 350, which as I explained you, like status quo has changed in alternate hypothesis, which actually is just opposite of the null hypothesis. Now you need to find the critical region for it. Suppose like the sample mean is very far away from 350, suppose it's around 600. So you can easily say that it lies in the upper critical region, and you can say like you can easily reject the null hypothesis here and accept the alternate hypothesis. Like you can say that the sales is increased. And suppose if sample mean is not very far away, it's like very near to the 350, like you can say like it's around 355. If you say 355, then it's like sample mean is very close to 350. So you cannot reject the null hypothesis, but you also like can't accept cause. So further statistical evidence we will see for it, and then we will decide what we need to go for. So for that we need to do the sampling distribution of the X bar. So as you're working on samples, you will compute the standard error. The standard error can be calculated as standard deviation by square root of number of samples. So you calculate the standard error because you want to know is the value 370.16 has significant distance from the mean 350, so the null hypothesis can be rejected. Now we have the normal distribution of sample means with a mean of 350, and we have the standard error, or we can say that sample standard deviation, which is 15. So now we have to find the critical value through it. So to find the critical value, you need to first specify the probability of an error happening, and we need to like keep this in mind. The probability of an error happening should be the least. So suppose you find out the critical value to be 380. So it's like if you get the sales of more than 380, you can easily reject the null hypothesis. So we can take the significance error value, that is alpha, to be 0.05, which is normally taken as 0.05 only. So we can say through this that the percentage of error happening is 5% only. For 95% of the time, the condition will be right. Means like for 5% of the case, when you will reject the null hypothesis, when null hypothesis will be actually true. And for 95% of the cases, that will be acceptance region. So it's like we fail to reject the null hypothesis in 95% of the cases when it is actually true. So the error won't take place in 95% of the time. So here you can see like there is a lower critical region, upper critical region. There is a ZC value we have to find out for it. So as it's 5% means 0.05. So that will be like divided into half for lower critical region and for half for upper critical region. So for upper critical value, you find it by subtracting it from 1 for area under this curve, which comes out to be 0.975. Then we have to find the Z score for it. That can be found out through this table. Like if you see horizontally and vertically is 0.9750, horizontally it is 1.9 and vertically it is 0.06. So if you add, it comes out to be 1.96. So then you calculate the critical value, like upper critical value and low critical value from the value of ZC. So that you can calculate through this formula, like critical value equals to mu plus Z score into standard deviation of the sample. Okay. So you can see like upper critical value comes out to be 379.4, which is under the acceptance region, and LCV comes out to be 320.6. So as you can see, like the sample mean is less than upper critical value and greater than lower critical value. That is, it is in the acceptance region. So the final decision is that we fail to reject the null hypothesis. Means null hypothesis is true. So we can say that sales will be like equivalent to 350. So now let's understand in a standard form like the critical value methods. So after formulating the hypothesis, the steps you must follow for making a decision using the critical value methods are as follows. You can see like you have to calculate the value of Z score from the given value of alpha, mean significance level, which we have taken as 0.05. So like you can see like 0.05 is given as 5% is not specified in the problem. So then you have to calculate critical values like upper critical value and lower critical value from the value of ZC. And finally make the decision on the basis of the value of the sample mean X with respect to the critical values, means upper critical value and lower critical value. I hope this made you understand the critical value method. So apart from critical value method, there's other methods as well to reject the null hypothesis or failing to reject the null hypothesis. So we will look at one of these methods, which is p-value method. So we will now find the p-value for the same AC sales example. So you can see the p-value is the shaded region from the gray area region. So we have to find the like for 370.16 of mean, p-value will be like for like greater than the 370.16. So we need to find the p-value for the Z score 1.34. So if we look for Z table, you can see like the value will be for 0.9099. You can see how horizontally it has been plotted and how vertically it has been plotted for 1.3 and 0.04. We have find the value to be 0.9099. So now for calculating the p-value, we will subtract 0.9099 from 1. So it will come out to be 0.0901. And just because it's a two-tailed test, so we will multiply it by 2 and we get the value as 0.1802, that is 18.02%. And now, so if you see the significance level, which was 0.05, that is 5%. So you can see like p-value is higher than the significance level. So we can now easily say that we cannot reject the null hypothesis. So the final decision is that we fail to reject the null hypothesis. So after formulating the null and alternate hypothesis, the steps to follow in order to making a decision using the p-value method, like we have understood in the process, is that we have to calculate the value of the z-score for the sample mean point on the distribution. Then we need to calculate the p-value from the cumulative probability for the given z-score using the z-table. So, and the third step is to finally make a decision on the basis of the p-value, like multiply it by 2 for a two-tailed test with respect to the given value of alpha, means the significance value. So by comparing that, we have reached the final conclusion. I hope this made you understand that the p-value method as well, how we can use it for rejecting null hypothesis and for failing to reject the null hypothesis. Now let's understand the types of errors in hypothesis testing which can occur. So the first type of error which can occur in hypothesis testing, we call it as type 1 error, which occurs when the null hypothesis is actually true and we reject it. So if you remember the criminal trial example, so we need to have all amount of concrete evidences to prove that accused has actually done the crime. Suppose judgment for the crime is a death penalty. Just suppose, and if we like, if the judge doesn't get all the proper evidences and he give the judgment as a death penalty, and somehow like those evidences doesn't prove that he is accused, and suppose in reality the accused is actually innocent and he gets the death penalty, that will be a very big error, so which can actually affect the society a lot. So that's the, I mean, say, the density of type 1 error. So we need to keep that in mind, that we need to have concrete evidences to support our alternate hypothesis. So we don't have to reject null hypothesis like that. We need to have proper concrete evidences for it. So then there is a second kind of error, which is a type 2 error, which occurs when the null hypothesis is actually false, but we still fail to reject it. So like type 1 error is denoted by alpha, and the type 2 error is being denoted by beta. So in the same criminal trial example, suppose the accused has actually done the crime. He is actually a criminal, but we don't have enough evidences to prove that he has done the crime. So that will lead to type 2 error, because that person can actually, like the criminal can actually again go and do several other crimes, and which can be harmful for the society. That is also like a very grave situation. So these are, you can say, the types of error we can take place in hypothesis testing, type 1 and type 2 error. I hope you have understood this concept of errors as well. So now that you have a conceptual understanding of hypothesis testing, let's see a case study of Flipkart and how hypothesis testing can be applied in like real-time business and e-commerce business. So let's first have a business understanding and understand the problem statement as well. So in this entire demonstration, you will be looking at an important business metric used in the e-commerce industry, that is the click-through rate, popularly known as CTR. So this is a very important business metric, especially for the businesses that have a website presence or a application presence. So on this metric, we will be making claims and hypotheses and then test them using the concepts that we learned previously. Before getting into hypothesis testing part, let's understand what CTR means and how specifically we are like going to use it in this demonstration. So click-through rate is a pretty generic yet important term in the online marketing industry. In plain terms, it measures the action rate of some entity, may it be a banner ad or a homepage for some website, or we can say if there's an ad tech website. So like if people will be opening a certain course and applying for it, so those are like action rate of that course of that entity. So now let's understand how the search through rate or CTR can be defined in the search context. So in the case of online search, the CTR is the proportion of searches that was successful when you are trying to compute the search CTR. The relevant formula for it can be given as like total number of successful searches by total number of searches. So what are the successful searches? So I will give you an example for search CTR through Flipkart only. So if you search for, like, we can search for machine learning books. This is the like normal search we are doing, and these are the results. And if I go open a particular search into it, so that becomes a successful search. So now let's get introduced to the industry problem statement that we are going to solve in this entire case study. So suppose that you are a data analyst at Flipkart and you works with a product manager, and that product manager claim that the search CTR has increased from 35% to 40%. And you will be trying to test this claim using the concepts of hypothesis testing. So let's dissect the problem statement a bit further, which will help us in hypothesis formulation as well. So to summarize this problem statement, we can say that the product manager is like claiming that the average population search CTR is 40%. That means out of 100 such searches on Flipkart website, around 40 searches will like result in conversions, means in successful searches. So using this, we can like formulate the hypothesis, means null and alternate hypothesis. So according to the given claim, as the search rate is 40%, which means null hypothesis will be 0.4, and the alternate hypothesis, which means we are going to challenge the claim. So the alternate hypothesis will be H1 like P not equals to 0.4. Now we have taken this data of 14 days. It's like a sample, we can say. And in this, we can say like on day one, it has like 38% and 37% day two. But on some days, we have 44% as well, 43%, 41% as well. So for the 14 days data, we have taken for the formulation for further like backing up of our research hypothesis. So now you must be thinking we can like go ahead and conduct the hypothesis test directly on the given data. But think about it for a while. Like which data exactly are you going to test the hypothesis on? Is it the CTR of 1 day, 1 week, or multiple days? Since the data is varying a lot across all days, how do we ensure that the sample is a random representation one? Because we need to have an appropriate representative sample. Let's understand how to choose the representative sample. So do you think like we need to take the data in a manner like it should show like 40% CTR rate on every day? That's not possible, right? That's not happening. So we will of course take the data where like on some days there will be like 40% CTR rate, there will on some day 35%, there may be some day 45%, and it will vary somewhat. On weekday it will vary, on weekends it will vary, right? So according to given claim, population mean for the given search CTR is 40%, or we can say 0.4. Now the sample we have seen can show variation and may not be exactly equal to the value that is 40%. So it is only that on an average, when you compute the mean CTR for several days, that will bring the search CTR average to be like 0.4, means 40%. So now once you have understood this concept, you need to know which distribution you need to look at. So like do you need to see the population distribution or sample distribution, means some different samples. So now that we have understood that we have to focus on sample mean, we will finally compute the sample parameters for the given sample data. So we see that like we can see the CTR it's varying, and we see like for every day there are like normal searches which happen around 500 we can see for day 1, day 2, and then on some day it happens to be 600, some day it happens to be 800. So it's like that. So we can see here the clicks as well. The successful clicks means we can see successful searches, those are 190, 185. On some days it is 312, 175 as well. So we can see the total searches are like 7400, and clicks come out to be 2885. So for the 14 days, come out with the average search CTR, that is the total number of clicks out of total number of searches. So which results in 0.39 as the average search CTR. So therefore, like we can say the sample mean comes out to be 0.39 and sample size is 7400. So we can say like we have taken the sample of total searches of 7400. So that brings the sample size to 7400. So next step is we need to compute the test statistic. So now that we have the required sample parameters, we need to compute the test statistic for the given sample. For this, we need the sampling distribution standard deviation as well. So let's say you are given the population variance as 0.24. Now let's go ahead and compute the sampling distribution's standard version. Note that you are already given the population variance of 0.24. So from this and the given sample size, you need to compute the sampling distribution standard deviation. Recall that from the central limit theorem, the formula for sample distributions standard deviations comes out to be sigma by root n. So we can say that sigma square, which is population variance, is 0.24. And as we've already found out the sample size, that is n equals to 7400, thus the sampling distribution standard deviation is computed as sigma by root n, which comes out to be 0.006. So thus we have calculated the sampling distribution standard deviation given from central limit theorem comes out to be 0.006. So now let's go ahead and calculate the test statistic for the sample, which you know will be its Z score. So Z score, as you know, like can be calculated by the following formula, that is x minus mu by sigma by root n. Now for the given problem, we have the parameters as follows. We can say like sample mean is 0.39, population mean is 0.40, that is claimed by the project manager as well. And sampling distribution like standard deviation, we have got 0.006. So substituting the values we get like in the formula, that is x we have 0.39, mu is 0.40, and sigma value is 0.005, means 0.006. We can see the sigma by root n value, that is the sampling distribution standard deviation, that is 0.006, and we get this value as z value, that is 1.756. So this is the test statistic of our sample data. Next method is we have to find the critical region, and we already know like what is alternate and null hypothesis, as well as the population variance, that is 0.24. as well as the sample mean to be 0.39 and sample size to be 7,400. That is what we got from the test statistics from our sample data. Second crucial parameter that we need is the level of significance of alpha. That is like how much the results can deviate. So the level of confidence or alpha is the like maximum permissible limit to which the sample can deviate. And for the given test, we can take it as 0.05. It's like a industry thumb rule, we can say, like taking the alpha value to be 0.05. But sometimes if you have other situations and conditions that are different from them, then you can have a different like alpha value as well. But here we don't have any such conditions or situations which can affect our significance level. So we have just taken it as 0.05. So using this, we can find the critical region for the given test conditions. So for finding the critical region, you need to use the like value of alpha, means the significance level, as well as the given null hypothesis as well. Since it is a two-tailed test, so we need to have a cutoff range as well. So this cutoff range will be divided into two. So as we have 0.05 as the significance level, that will be divided into two. So that will bring us two like regions on the left side and the right side, that will be lower critical value and upper critical value. So that will be divided into 2 by alpha. So that will comes out to be 0.025. So if your value comes under 0.025 on the left side or the right side, then we can like reject the null hypothesis. But as we saw that our value is 0.39, like that comes out to even minus 1.756. That doesn't come under the critical region. So it's like become easier for us to make the final decision based on the given hypothesis. So now that you have found the critical region, you need to check where your test statistic lies and based on that make the decision. So on the basis of our evaluation of critical region and on the basis of Z score and everything, we have found that we can't reject the null hypothesis. Right? So therefore we can say that we haven't found enough statistical evidence to disprove the product manager's claim. So this is about the finding the critical region. And now other than finding the critical region, we have another approach which is the p-value approach to do the same as well. So let's go ahead and use that approach as well. So here you will be doing the same hypothesis using an alternative procedure, that is the p-value approach. So this is the most common way of finding the significance of test results in the industry. So technically, like p-value is the probability of observing values which are similar to more extreme than the observed value, given that the null hypothesis is true. This metric also enables us to determine whether the given test statistic gives us sufficient evidence to reject or fail to reject the null hypothesis. So let's go ahead and use this approach as well. So when you compute the p-value, you sort of followed an opposite route to the original critical value route. So as we know that p-value approach is more extreme approach of getting the sufficient evidence for rejecting or failing to reject the null hypothesis. So on that basis, we can get more extreme limits. So we can get it like here for 0.39 and similarly on the right side as well. On the left and right side, we have got more extreme limits. So now we can like compute the p-value. So for computing the probability corresponding to the given Z score, that is minus 1.756, we get the p-value as a 0.039. Since this is a two-tailed test, you multiply this value with 2 and obtain the p-value as 0.079. Now, since the value is greater than the given level of significance, you fail to reject the null hypothesis. To summarize, the p-value approach also gives us the same result as the critical value approach, which is that either both will reject the null hypothesis or fail to reject the null hypothesis. So with this, we come to the same conclusion as of critical value approach, that we have still don't have proper evidences, like proper sufficient evidences to reject the project manager's claims of click-through rate being increased to 40%. Now that we have learned about the basic concepts of hypothesis testing, and we have learned like how to formulate the hypothesis and then make a decision through either the critical value method or through the p-value method. So we will now learn how hypothesis testing is used in the industry and how the concepts which we have learned till now form an important foundation of useful industry concepts. So let's start. So till now we have done critical value method and p-value method, and both of them comes under z-test. But what if I tell you that we won't be able to apply them practically, like when we are working in the industry? It happens because if you know the formula, if you remember the formula, like it is because the formula for standard error is population standard deviation sigma by square root of sample size n. And in most of the cases, when we handling the situation practically, we don't have the population standard deviation. So we won't be able to calculate the standard error. So how will we calculate the hypothesis? So here comes the t-test. Before understanding t-test, first let's understand t-distribution. So if you see t-distribution's graph is actually very similar to normal distribution. Like you can see here, the normal distribution graph in blue and the t-distribution graph in red. The only difference is the distribution graph is shorter and a little flatter. So we can say like redistribution is very similar to normal distribution in many cases. For example, like it is symmetrical about its central tendency. However, it is shorter than the normal distribution and has a flatter tail, which would eventually mean that it has a larger standard deviation. And at a sample size beyond 30, the t distribution becomes approximately equal to the normal distribution. So each t distribution is distinguished by what statisticians call degree of freedom, which are related to the sample size of the data set. If your sample size is n, the degrees of freedom for the corresponding t distribution is n plus 1. For example, if your sample size is 10, you use t distribution with 10 minus 1 or 9 degrees of freedom, you can say, denoted as t9, t base 9. Okay. So smaller sample size have flatter t distributions than larger sample sizes. And as you may expect, the larger the sample size is and the larger the degree of freedom. So for example, if your sample size is 10, you use a t distribution with 10 minus 1 or say 9 degrees of freedom. So smaller sample sizes have flatter t distributions than larger sample sizes. And as you may expect, the larger the sample size is and the larger the degree of freedom, the more the t distribution looks like a standard normal distribution, or we can say the z distribution. So now the question is when t distribution is used. So the most important use of the t distribution is that you can approximate the value of the standard deviation of the population sigma from the sample standard deviation s. However, as the sample size increases more than 30, the t value tends to be equal to the z value. Thus, if you want to summarize the decision making in a flow chart, it will look like this. So if you look at how the method of making a decision changes if you are using the sample standard deviation instead of the populations. So if you recall the critical value method, the first step is like calculate the value of ZC from given value of alpha, that is significance level, take it as 5% if not specified in the problem. So to find ZC, you would use the T table instead of the Z table. The T table contains values of ZC from a degree of freedom and value of alpha, which is significance level. So ZC in this case can also be called as T statistic. So practically you would not need to refer to the Z or the table when doing hypothesis testing in the industry. Going forward, when you need to do hypothesis testing and demonstrations of Excel or we can say of R programming, you would use the term t-test since that is mostly performed in the industry. So all calculations and results of a t-test are same as the z-test whenever the sample size is greater than 30. Now the next one is two sample mean test. So two sample mean tests are divided into two types. That is a two sample mean test paired and two sample mean test unpaired. So two sample mean test paired is used when your sample observations are from the same individual or object. During this test, you are testing the same subject twice. For example, if you are testing a new drug, you would need to compare the sample before and after the drug is taken to see if the results are different. And similarly for two sample mean test unpaired, which is used when your sample observations are independent. During this test, you are not testing the same subject twice. For example, if you are testing a new drug, you would compare its effectiveness to that of the standard available drug. So you would take a sample of patients who consume the new drug and compare it to those who consume the standard drug. So we will do a test for it. We can do it in Excel. So Excel is like very heavily used in industry. So this is the data set we have. So we will be performing the t-tests, multiple kind of t-tests in Excel. So Excel is like heavily used in industry for hypothesis testing. So first we can see the one sample mean test. In one sample mean test, we have the commute time of Edureka employees. We have taken the data of 32 Edureka employees, and we can see like how much time the employees are taking for like reaching Edureka office from the respective homes and then reaching back to their home from the office. So we can say like this is the all the data for 32 employees, and this is the hypothesized mean, which is 35. That means we can say that another hypothesis, but we need to like do our research along with the statistics. We have to come and prove the alternate hypothesis, whatever claim we want to make, like whether it is 35 or it is not. That is just simple. We have previously seen in our like p-value approach and critical value method also from our basic concepts which we have learned. We have learned how to do it. So this was the one sample mean test. Now let's see the two sample mean test paired, which we just talked about. So here you can see that there's a commute time for Edureka employees given for day one and also for day two for the same employees. That's why it is being told paired, because if you see the sample size is same and also of the same person. Like there's a person A, it has a commute time of 27 on day one and a commute time of 23 on day two. Similarly for person B, the same commute time of like 43 for day one and 42 for day two. So now what we have to do is we have to check for whether the average time is equivalent to like we have taken the average commute time to be 35. So if it is coming 35 or not for the day 1 and day 2, and we will find the difference actually. The difference should be 0 actually. That then only the null hypothesis will be correct. So how we can do is, if you know like there is this option of add-ins, you can search for add-ins in Excel. It is add-ins. You open the add-ins and you will find this option of analysis toolpack. Just select this one and click OK. And when you do that, you will find data option that there is a data analysis pack which has been added. So you open this. So you can see like different types of tests and different types of statistical methods are given here for checking. So here you can see like t-test paired two sample for means is given. This one we have to select because we are checking for two sample mean test paired. So we'll go OK, and we will select the range. So it's here. So range is from here to down. This is the range, and variable 2 also range we will take. Just select here. Okay, and hypothesize mean difference should be 0, right? So we will take 0, and alpha value is 0.05, and output you can also get the results in a new sheet, but other than that you can also select the output range as well. In that way you will get in the same sheet. Output range we can select. So I will select column E and F. So that is the output range, and just click OK. So you got the results here. So you can see like that's just given as pair two sample for means, and then mean you can see like there's a little difference in mean for variable 1 and 2. And just a second. So other than that, the variance is also given, observations also, like you can cross check from here like how many samples are given in variable 1 and variable 2, so they are same. And Pearson correlation is given, and DF is also given, T stat is given. Also like if it is a one tail test or two tail test, in that way P value is also given. So you can see like even in one tail and two tail both the values are larger than 0.05 and like 0.025 as well for two tail and one test in reference to that. And so we can easily say that if comparing the values of one tail and two tail test are higher. So we fail to reject the null hypothesis, and we don't have enough evidences to reject the null hypothesis. So that is the two sample mean test paired. Now let's come to two sample mean test unpaired. In the same manner, in what the difference in this one is, you can say like this is the commute time of team 1. We can say of like this is for Bangalore, for Edureka of employees in Bangalore, and for Edureka employees in New Delhi. Like in Edureka employees in Bangalore, the commute time is 27, 43, all these things are given, but it is not related to team 2 which is in New Delhi. So it's not of the same person. So that's why we say it as unpaired, because both the values are not related to each other. So in the same manner, we can go and open the data analysis package. So there are like two things. If you are sure about the equal variances, you can select, but right now I'm not sure. So I will select the t-test two sample, assuming unequal variance. So we'll just select this, and we will select the variable range. And similarly for second one, we are selecting this variable range for second. So for variable 2, we will select the range. The mean difference will be 0 here. We want in the output range, so we will select the output range as well. So let's select this one. So that's it. So now you can see like the mean variance and everything, like there's a significant difference in mean, and you can see the variance as well and everything. And for one tail test there's a value of 0.01, for two tail test is 0.02. So you can see like there is a significant difference in that, and it's also like lower, the value of one tail test and two tail test are lower than the 0.05 and 0.025 as well. So we can say like we are able to reject the null hypothesis here. So now let's move back to the third kind of test in a t-test, and that is two sample proportion test. So two sample proportion test is used when your sample observations are categorical with two categories. Like it could be true or false, 1 or 0, yes or no, male or female, or we can say like success or failure. And there are like different other categorical examples. So for example, if you're comparing the effectiveness of true drugs, you would define the desired outcome of the drug as the success. So you would take a sample of patients who consume the new drug and record the number of success and compare it with successes in another sample who consume the standard drug. So we will also see its demonstration in Excel. So this is the data for two sample proportion test we are going to take. Here you can say like commute time for day 1 is given and commute time for day 2 is given. And then we have converted that into categorical data. So if the commute time is less than 35, it's 0. And if it is more than or equal to 35, it is 1. So it's like the commute time is given in such a manner that if it is more than 35, it is 1. And if it is less than or equal to 35, then it is 0. So the data is given. So here, but how we will gonna make the test, like execute the test here. This time we are not going to use the data analysis package. And there's one more thing called Excel stat. And for that, you can simply search for Excel stat and you will get it for 30 days. So you can get a free trial of Excel stat. Like it is a 14-day free trial. You can click here and you can get it added to your Excel. So I already have it added in my Excel. So I will just go to Excel stat here. Here, this is the place where it get added. So you just have to start the Excel stat. First time when you click, it just process, and then again you have to go to Excel stat. Then you can just go to test a hypothesis, and that you have to go to parametric tests and select the test for two proportions. So you have to select the frequency for it. Just a second. We'll just cross it. We will first select the frequency. We will first check the frequency for it. So same data for. So here you can see the frequency is 15 and the total sample size is 32. And in this one, frequency is 20 and the total sample size is 32. So we'll again go to parametric test, two proportions, and we can now give the frequency, right? So it is just 15 and this is 32 sample size. This is 20. Sample size is 32. We can also select the proportion as well, but we will be like selecting the frequencies only, not proportions. So because it's easier. So and again we can like select the range for it. So we will just select the range. And you can select in this manner. The range has been selected. Other than that, you can go to the options, and here the hypothesize difference will be 0, significance level will be that, and variance will be there. And in this we have to like select the proportion 1 minus proportion 2 is not equals to 3, that is the one null hypothesis. So we will just select OK. So now you can see we got the results. So you can see like the frequency is 1 is to 15, sample size 1 is to 32, frequency, everything is given, sample size 2 is in the same frequency and the same sample size, same minute is given. Also if you want to run again with a different frequency, that also you can run. That's not a problem. So if you want to change the alpha value, means the significance level, you can change that and again run. And you can see the difference is given. So we see that the p-value is 0.309, which is larger than 0.05. So it is the answer is also given there. The difference between the proportion is equals to 0, and the difference between the proportion is different from 0. That is the alternate hypothesis. But as the compared p-value is greater than the significance level, so we cannot reject the null hypothesis. So we got the answer here. So now let's move on to the next test. The next test is A/B testing. So A/B testing is like a direct industry application of the two sample proportion test sample. While developing an e-commerce website, there could be different opinions about the choices of various elements, such as the shape of buttons, the text on the call to action buttons, or like the colors of various UI elements, or we can say like the copy on the website, or numerous other such things. So often the choice of these elements is very subjective and is difficult to predict which option would perform better. So to resolve such conflicts, you can use A/B testing. So A/B testing provides a way for you to test two different versions of the same elements and see which one performs better. So A/B testing is like entirely based on the two sample proportion test. The two sample proportion test is used when you want to compare the proportions of two different samples. You can use various tools to conduct A/B testing like R or Optimizely, etc. So, but here we will be doing the same A/B testing in Excel. You can use various tools to conduct A/B testing like Optimizely, Excel, etc. So let's see an example of A/B testing. Like if you know, there is this media company, like gaming company, Electronic Arts. So when Electronic Arts, a successful media company, released a new version of one of its most popular games, the company wanted to get it right, which is the SimCity 5 game. So if you see the homepage for SimCity 5, a simulation game that allows players to construct and run their own cities, would undoubtedly do well in terms of sales. So Electronic Arts wanted to capitalize on its popularity. So according to HubSpot, Electronic Arts relied on A/B testing to get its slide page for SimCity 5 just right. So the desire behind this A/B testing example revolved around improving sales. So Electronic Arts wanted to maximize revenue from the game immediately upon its release, as well as through pre-sales efforts. So these days people can buy and download games immediately. The digital revolution has made those plastic encased CDs nearly obsolete, especially since companies like Electronic Arts promoted digital downloads. It's less expensive for the company as well, and more convenient for the consumer. So however, sometimes the smallest things can influence conversions. Like Electronic Arts wanted to A/B test different versions of its sales page to identify how it could increase sales exponentially. So I'm highlighting this particular A/B testing example because it shows how hypothesis and conventional wisdom can blow up in your faces. So for instances, most marketers assume that advertising incentive will result in increased sales. That's often the case, but not this time. So the original version of the pre-order page, which you can see here, has offered 20% off on a future purchase for anyone who bought SimCity 5. And you can see the option B, so which is the variation which is like created afterwards. The variation, if you see, like has eliminated the pre-order incentive. Like you can see here, the pre-order incentive is given, and here there's no pre-order incentive. So as it turns out, like the variations performed more than actually 40% better. Means option B performed 40% better than the control version, means the original version. So avid fans of SimCity 5 weren't interested in an incentive. So they just wanted to buy the game. As a result of the A/B test, half of the game sales were digital. So do you understand why it works? So the A/B test for Electronic Arts revealed important information about the game's audiences. Like many people who play a popular game like SimCity don't play any other games. They like this particular franchise, consequently the 20% off offer didn't resonate with them. If you make assumptions about your target audience, you will eventually get it wrong. So human behavior is like difficult to understand even without hard data. So you need A/B testing to generate data on which you can rely. So let's now demonstrate A/B testing also on the same Excel file. We have the data set already. So we will just go to A/B testing data. So you can see the data is given here for control group and variable group. So we can say like this is for our Edureka website only, for example. So like someone has reached our website and has opened the course, and if that person registers on the application, so that is where we give them as a 1, and who haven't registered, we give them a 0. That is how it is being labeled. That's how we have labeled the data. Whoever has registered, it's 1, and whoever has not registered but has opened the course, we have labeled it as 0. Let's now check the results for both of them. So let's go to Excel stat, and same visualizing data we can open, not the visualizing. So test a hypothesis, and we can go to parametric tests, and we can do the same test for two proportions. So first let's check the frequency of it. So you can see the total sample size is 2620 and sum is 618. So we will just select it here. We will just copy it here, 618 and 2620. So similarly, we will do the count for variable 2 also, and we got like 601 and the frequency, and the 2380 is the sample size. So we will just go to test a hypothesis, to parametric test for two proportions. We will just fill the values here, 618, and this is 2620, this is 601, this is 2380. Select the frequency, and then we will select the range as well, select this range. And other than that, we will go to options, and for this one we will select the proportion 1 minus proportion 2 is smaller than D, which is lesser than 35. That is our null hypothesis, and everything is same like 0 and significance table 5, and then we will just give OK. So results will be here soon. So yeah, as I am using the Excel stat trial version, so it is showing like to use the trial version. So yeah, so you can see here is like test for two proportions we have done, which is the A/B test, but you can see like the frequency and everything is given here. Frequencies you can see like 601 out of 2380, and so if you calculate it in percentage for the variable 1, that is for control group, there's a 23% success, and for the sample size 2, which is like variable group, for that the success rate is 25%. So we found the variance also, like continuity correction, everything is there, data is given, and like 95% confidence interval on the difference between the opportunities we have got. And you can see like the p value is 0.091, which is like the and alpha value is 0.05. So we see like p value is greater than alpha value. So the answer is like we cannot like reject the null hypothesis because like p value is greater. So that's how the A/B testing is done. So now we are like done with all the testings, and we have completed the industry demonstration as well. So we have also understood all the concepts of hypothesis testing, and we have also implemented them on like with the relevance of industry, whatever the test is being conducted in industry. Of those kind of test also we have conducted. I hope the concepts of hypothesis testing are now clear to you.
So the first topic I'll be discussing in today's session is Introduction to SQL. In today's world, data is everything, but to manage it, one has to master the art of data management. To play with the data and database, we need to know the language that is understood by these databases, and that language is SQL. SQL is the core of relational type databases. Because of its huge popularity, it is used by most companies today worldwide. After understanding the basic introduction, the first question that arises in our mind is, what is SQL? SQL is an abbreviation for Structured Query Language. It is a language used to perform actions such as update, retrieve, manipulate, and store data on a relational database. Now that we have learned what exactly SQL is, let's see some of its interesting facts. Do you know when SQL was born? Well, let me answer that question for you. SQL was developed at IBM by Donald D. Chamberlain and Raymond F. Boyce in the early 1970s. It was initially called as SQL, that is, Structured English Query Language. But later it was changed to SQL because SQL was a trademark of UK-based engineering company. SQL is said to be a powerful language. Reason for that is it uses very simple English sentences and also uses very few lines. It uses common words such as select, insert, update, and many more to perform its core functionalities. SQL is known to be a declarative language. When you write a query, you have to describe what needs to be done, and you don't have to worry regarding the flow of the query. It will be handled internally by the DBMS that you're using. Now, let's look at some of the features of SQL. So the first feature is SQL has well-defined standards. As it says, developers of SQL has clearly mentioned how exactly each and every query has to be written. There is no room for ambiguity when it comes to writing a query. The standards has to be followed. SQL is easy to learn. Yes, SQL is a language that is used to work with a database. Since SQL has a large user base as well as well-defined standards, for a beginner it is really easy to learn. Next one is, in SQL we can create multiple views. This is one of the unique and early feature that SQL came up with. View is nothing but creating a virtual table. A virtual table is a temporary table for certain use. By doing this, we can protect the integrity of the data. SQL has the ability to not only create a single view but can create multiple views. Finally, SQL queries are portable in nature. It means we can execute the SQL query in one system and execute the same query in another system without changing the format. But the condition is the environment setup of these two systems has to be same, else the SQL query won't be executed. So these were some of the features of SQL. Now let's look at the next topic, that is data and database. Firstly, let's look at what is data. So the standard definition for a data is values from different source which has been translated for some purpose. And this purpose can be anything. Source for the data can be like temperature reading, financial data, videos, blogs, text, etc. It goes on. In the end, it should make a meaningful sense. Only then we can consider it as a data. This image clearly depicts the different source of data. So we can clearly understand that the data source can be anything. Since we are clear about what data is all about, let's head to the next topic, that is, what is database? Firstly, let's look at the formal definition for a database. A database is an organized collection of data, where the data is stored and accessed electronically from a computer system. To make you understand what it means, let me use an analogy to explain the concept of database. Consider a library. Usually, the library contains a huge collection of books of different genre. Here, library is a database, and these books are the data. In the image, we can see a person performing an action on the data, and those actions can be like create, store, update, etc. When the user sends the instruction as well as the data, it will be stored inside the database after a certain process. And this entire process is bidirectional. That is, control flows on both the sides. Next, I'm going to talk about different types of databases. There are different kinds of databases that are in use today. And these databases are classified based on capabilities, features, functionality, size, and performance. So few of them are distributed database, object-oriented database, centralized database, operational database, graph database, cloud database, NoSQL database, and finally, relational database. Among these databases, the two popular types that are widely used are, first one, relational database, and second one, NoSQL database. Relational databases generally uses SQL language, and we're going to learn more about it in the coming modules. Moving on, let's look at some of the popular databases that are widely used today. So they are MongoDB, Postgres, Microsoft Access, Microsoft SQL Server, MySQL, and Oracle DB. These are the few popular databases that are used today. Each one of them has its own pros and cons. Since we have already started the topic of database, it wouldn't be fair to drop this topic abruptly. So I shall discuss a few basic database related queries. The first query is how to create a database. To explain this, let me jump into MySQL Workbench. This is the interface of MySQL Workbench. On the left side of the screen, we can see the database. In the center area, we are going to write our queries. At the bottom part, we are going to get the status of the query that has been executed. So you might wonder why I'm using MySQL Workbench for executing SQL queries. Well, SQL is a language that is used to communicate with the database, whereas MySQL Workbench is a database management system. So MySQL Workbench allows us to use SQL queries to communicate with the database. Can't we use other DBMS? Yes, we can, but the syntax of the queries may slightly vary. So let me explain you the first topic, that is how to create a database. And the syntax for this is create database are the keywords used to create a database. Followed by that, we have to specify the name of the database. Here, I'm using Edureka as a name for my DBMS. So let me select this entire statement and click on the lightning icon. So I can see at the bottom that the database with the name Edureka has been created. So let me refresh it. So we can see that the database with the name Edureka has been created. So the next topic I'll be discussing is how to delete a database. And the syntax for this is drop database are the keyword used to delete a database, and followed by that will be the database name. So let me select this entire query and click on the lightning icon. So we can see that the database with the name Edureka has been deleted. So these were the few queries related to database. The next topic that we're going to learn is table. So what is a table? A table in a database is nothing but a collection of data in a tabular way. It consists of rows and columns. The table contains data elements also known as values using a model of vertical columns and horizontal rows. The point of intersection of a row and a column is called a cell. A table can have any number of rows but should have a specified number of columns. To understand the concept of a table in a better way, let's look at the image. So the name of the table here is person. When we create a table, it has to have a name. A table without a name doesn't exist. So what is tuples? A single row of a table which contains a single record for that relation. Here there are 6 tuples. Next is attributes. Features of an entity is called attribute. An attribute has a name and a data type. Here there are 4 attributes. Those are ID, first name, last name and date of birth. So I hope you have understood the concept of table. Let's now understand the table constraints. So what are table constraints? In simple words, it is a restriction that are specified by the user while creating a table. So you may wonder why these kinds of constraints are required. The answer for that is, even though a table stores the data, that data has to be of certain format. To ensure the data integrity, we use constraints. These constraints have to be decided during the creation of a table. If we want to change the constraint, then we have to delete the table and then we have to create a new table using the new constraints. Few of the constraints that are used most of the times while creating a table are check, default, primary key, foreign key, not null, index, and unique. Since we have understood what table is, let's look at some of SQL queries related to the table. The first one is how to create a table. To understand this, let's head to the MySQL Workbench. To create a table, we need an active database. Since we had deleted the previously created database, let me create the database once again. So we can see that we have a database with the name Edureka. So now let me create the table. And the syntax for creating a table is create table is a keyword used to create a table. Followed by that, we have mentioned the table name. We need to make sure that the table name is unique. Keep in mind that in a database, there cannot be 2 tables with the same name. Inside the table, we have declared the columns along with the data type. And we have to end the query with a semicolon. So let me execute this query. So we can see that the table EMP has been created. So the next query I'm going to discuss is how to delete a table. And the syntax for this is we shall use drop table keywords to delete a table. And followed by that, we have to specify the table name. So let me select this entire query. And we can see that the table with the name EMP has been deleted. With all the basic introduction understood so far, let's now understand some SQL basic queries. Let me begin this by introducing the most basic and widely used query, that is select statement. And the syntax is select column name from the table name. We can specify the name of the columns that are present in the table. Also, note that if you want to display all the columns of a table, then use star operator. Now, let's jump into execution part. To explain the entire SQL queries, I'm using student table, and this student table has student ID, first name, last name, address, city, and marks as its columns. So the syntax for select statement is select star from student. Since we have to display all the columns, I'm using star operator. So let me select this entire query. So we can see that the entire table has been displayed. So this is one of the way in which we can use select statement. The another method is, if we want to select a particular column, then we have to specify that column name. And the syntax for that is so we can see that from the table, we have selected only first name and last name. Usually, select statement is used to select the data from the database. So the next SQL query that I'm going to discuss is where clause. Where clause is used to filter records. Where clause is used to extract only those records that fulfill the specified condition. To demonstrate where clause, let me assume this scenario. If I want the name of the students who are from the city Goa, then my where clause query will be something like this. Select first name from student where city is equal to Goa. So let me select this query and execute it. So this is the output. Now let's look into and or not statements. If we need to add 2 or more conditions in the where clause, then we can use the above mentioned operators. These keywords will add more complexity to the query. So the first operator is and operator. This operator displays a record if all the conditions separated by the and operator are true. Let's look at the syntax. Select columns from table where condition 1 and condition 2 has to be true. To understand the example, let's dive into the demo part. I want to display the details of the student who has the first name as Bharat and last name as Singh. To achieve this, I'm using AND operator. So let me execute this query. Yes, I got the output for the student name Bharat Singh. The next operator I'm going to discuss is OR operator. OR operator usually displays a record if any of the conditions separated by OR is true. And the syntax for this is select columns from table where condition 1 or condition 2 is true. To understand the example, let's dive into the demo. I want to display the details of a student who has the first name as Bhuvi or the last name as Kumar. To achieve this, I'm using OR operator. Here, any one of the condition has to be true. So this is the query to execute a scenario. So we have got the output for the student with the name Bhuvi Kumar. So let's head to the next operator, that is NOT operator. So this operator displays a record if the condition or conditions are not true. So the syntax is select columns from table where the condition is not true. Let's see how this example works. Here, I want to display the details of the student who does not have the first name as Ashok. To achieve this, I'm using NOT operator. In this, we can see the details of all the students except Ashok. So the next query I'm going to discuss is insert into. If we want to insert any record or data into a table, then we can use insert query. And the syntax for this is insert into is a keyword that is used in insert query. Followed by that, we have to specify the table name and columns. After that, we have to specify the values. Let's look at the example to clearly understand how exactly this query works. So this is the example for insert query. So we're gonna insert first name as Manoj, last name as Sharma, address as 07 MG Road, and city as Jaipur. Also the marks is 438. So let me execute this query. So we can see that the data has been inserted. To check whether the data has been inserted or not, let me use select query. So we can clearly see that Manoj Sharma details has been added to the table. Next, I'll be discussing few aggregate functions. An aggregate function is a function where the values of multiple rows are grouped together as input on certain criteria and a single value is returned. We often use aggregate functions with the group by and having clauses of the select statement. So we will be discussing group by having in the later part of the session. Some of the aggregate functions are count, sum, average, minimum, and maximum. So let's discuss each one by one. So the first one is count. This function returns the number of rows that match specified criteria. So the syntax is count of column name from table where the condition. So now let's try this example in MySQL Workbench. Using this query, I will calculate the number of student ID that is present in the table. So let me select this query. In the output, we can see that the count of the student ID is 6. The next aggregate function is average. An average function returns the average value of a numeric column. So the syntax for this is select average of column from table where condition. Let's execute this example. Here, I'm trying to find the average marks scored by all the students. So let me select this query. So the average marks scored by all the students is 480.333. The next aggregate function is sum. Usually, sum function returns the total sum of that particular column. The syntax is select sum of column from table where condition. So let me execute this example. In this example, I'm trying to find the total marks scored by all the students. So let me select this query. The total marks scored by all the students is 2882. Moving on to the next aggregate function, that is minimum. Minimum function will return the smallest value of the selected column, and the syntax is select min of column from table where condition. So let me execute this example. If I want to know the student name who has scored minimum marks, I'll use this query. So let me select this query. Ashok Sinha has scored 385 marks, and this is the minimum marks in this entire table. And the last aggregate function that we're going to discuss is max. Max function returns the largest value from the selected column, and the syntax is select max of column from table where condition. Let's execute this example. So this is the example for maximum function. So let me execute this query. So we get the output, that is Bharat Singh has scored 580 marks. So 580 marks is a maximum marks in the entire table. Next SQL query is group by. Group by is the functionality used to arrange a similar type of data into a group. For instance, if the column in a table consists of similar data or values in different rows, then we can use group by function to group the data. The syntax is select column from table where condition group by the same column. Let me execute this example. I want to count the number of students who are from different cities. If there is any student from same city, then the count will be incremented. At the end, the output will have all the city name with the count of the students from that particular city. So let me execute this query. We got the count of students from different cities. Since all the students are from different city, we can see that the count is 1 in all the cases. If the data is large, we can clearly get to know how effective this query is. Next query is having. This clause is used to place condition where we need to decide which group will be part of the final result set. The having clause was added to SQL because the where keyword could not be used with aggregate functions such as sum, count, min, max, etc. So the syntax is select column from table where condition group by the column and having condition. So let me execute this example in MySQL Workbench so that you'll get an idea about having clause. From the table, if I want to display the students who have scored more than 500, then I'll specify that condition after having keyword. So let me execute this query. So we can see that there are two students, Ashok and Bhuvi, who have scored more than 500 marks. Moving on to the next query, that is order by. Order by keyword is used to sort the result set in ascending or descending order. This keyword is used to sort the result set in ascending or descending order. The order by keyword shall sort the record in ascending order by default. If we want to sort the record in descending order, then we need to use the descending keyword. So let me explain the syntax. Select columns from table, order by columns, either by ascending or descending. Let me execute this example. In this example, we will get the count of students from different city, and we are arranging the city in descending order. So let me execute this query. We can see that the cities are arranged in descending order based on the starting alphabet. The next SQL query that we're going to learn is null values. In SQL, we use the null term to represent a missing value. A null value in a table is a value that appears to be blank. A field with a null value is a field with no value in SQL. Keep note that a null value doesn't mean that the value is equal to 0. To check the null value, we are not supposed to use the operators such as greater than, less than, equal to. These operators are not supported in SQL. We have special keywords. Those are is null and is not null. First, let's look at the is null operator. Is null operator is used to test the empty values, and the syntax for this is select columns from table where column is null. So let me execute this example. I want to display the student's name whose marks is null. So let me select this query and let me execute this. Since all the students have marks and none of them has null value, in the output we don't have any student names. The next query is not null. The is not null operator is used to test for non-empty values, and the syntax is select column from table where column is not null. So again, let me execute this example. I want to display the student names whose marks is not null. So let me execute this query. Since all the students have marks, all the student names are displayed. Let's move to the next query, that is update. Generally, the update command is used to modify rows in a table. The update command can be used to update a single field or multiple fields at the same time. Let's look at the syntax for update statement. Update table set column equal to value where condition. Let's execute this example. Here I want to change the name of the student with student ID 1. Previously, the student with student ID 1 was Ashok Sinha. Now I want to change his name to Amar Kumar. So let me execute this query. So we can see that the student name has been updated. To check the student table, let me execute this query. And we can see that the name of student ID 1 has been changed from Ashok Sinha to Amar Kumar. The next query we are going to discuss is delete. The SQL delete command is used to delete rows that are no longer required from the database tables. It deletes the whole row from the table. The syntax is delete from table where condition. So let me execute this example. If we want to delete a record from student table where the city is Mumbai, let me execute this query. So we can see that the query has been executed. To check the table, let me execute this statement. And student with the ID 1 has been deleted. Next, let's discuss in and between operators. In operator is used to specify multiple values inside the where clause. It acts as multiple OR. Let's look at the syntax. Select column from table where column in value. Let me execute this example. If we want to display the record of a student who are from certain city, then we can use in operator. In the given example, let's display the name of the students along with their IDs who are from Delhi, Goa, Pune and Bengaluru. Let me execute this query. In the output, only those students from the specified city name are displayed. The next operator is between. Between operator will select a particular value within the specified range. It is compulsory to add the beginning and the end value. Let us look at the syntax. Select column from table where column name between value 1 and value 2. Let's execute this example. If we want to display the record of students whose marks are in certain range, then we can use between operator. In the given example, let's display the name of the student along with their ID who has scored in the range of 400 and 500. So let me execute this query. In the output, only those student records who have scored in the range of 400 and 500 has been displayed. So the next topic we're going to cover is aliases in SQL. Alias is a process of giving a table or a column a temporary name so that it helps when the query is complex. It increases the readability of the query. This renaming is temporary and the table name does not change in the original database. We can alias a column or a table. So the first concept is column aliasing, and the syntax is select column name as alias name from table. So let me execute this example. In the student table, the column name student ID is bit long. when we write a nested query, we might face some trouble. In order to tackle such situation, let alias that student ID column as ID. So let me execute this query, and we can see that the column student ID has been aliased to ID. Next is table aliasing. Now let's look at the syntax for table alias. And the syntax is select column from table as alias name. So let's execute this example. We generally use as keyword in aliasing. So let me execute this query. By using the technique of table aliasing, I have displayed the names of the students from the student table. So that was the basic concept of SQL.
So let's begin with the very first topic, that is, why should you use time series analysis? So first of all, in time series analysis, you just have one variable, that is time. Now you must have seen there is a lot of algorithms present. Then why do we need one more algorithm, that is time series? So let me explain you this with an example. Now let's take an example of a supervised learning. So under supervised learning, we have linear regression or logistic. So there we have an independent variable and we have a dependent variable. So there what we do, we deduce a function, or you can say a mapping function, of how one variable is related to another. And then we can go ahead with the analysis part. But in time series analysis, you just have one variable, that is time. So for example, you own a coffee shop and it's quite a successful coffee shop in the town. So what do? You try to see how many number of cups of coffee you sell every month. For that, what you will do, you'll add up all the sales of your coffee. Now, let's say you started this coffee shop in the first month, that is the January. So what you'll do, you'll record the data month-wise and then you'll sum it up. So you will have all the data till the present month. But what if you want to know the sales the next month or the next year? Now imagine guys, you just have one variable, that is sales, and you need to predict that variable in accordance with time. So in such cases where you just have time and you need to predict the other variable, you need time series analysis. Now we know why do we need time series analysis. Let's move ahead and understand what exactly time series is. So time series is a set of observations, or you can say data points, which are taken at a specified time. Now over here at your x-axis you have the time, and on the y-axis you have the magnitude of the data. So if you try to plot time series plot on the x-axis, you will always get the time which is divided into equal intervals. So you cannot create a time series if one data point is at week level and other are different. There should be equal interval, let's say a day, a week, a month, a year, a decade, and a century. So that is the constant thing that a time series require. Now let us see the importance of time series analysis. Now first and foremost is business forecasting, because your past defines what is going to happen in future. So let's say you'll be seeing a lot of traders in the Sensex who are trying to predict what will be the price of the stock market tomorrow. So that is nothing but a business forecasting. You also see a lot of retailers who tries to know how many number of goods they are going to sell the next day. So all of this can be achieved with time series analysis. Now this is not just limited to one domain like retail or finance, but it is applicable almost everywhere. Now it is also help us to analyze the past behavior. So here you can analyze in which month did the sales went up or when was the dip. So here you can easily understand your past data. So with every dip and a peak, there is a business reason attached to it. So you can understand this with respect to time. For example, some festival is there and you're selling chocolates. So your sales will increase during a festival. So you need to think about the seasonality part also. Now don't worry guys, we'll be having a complete discussion on seasonality as well. So now coming back, it also helps you to plan the future operations. So you can analyze the past and then you can forecast your future using this algorithm, that is time series analysis. Now apart from all this, you can also evaluate current accomplishment. So this means you can determine which goals you have met in the current scenario. Let's say you have predicted, okay, I'm going to sell around 100 chocolates in a day. But did you actually do that? So all of this can be analyzed using time series analysis. Moving ahead, let us see the different components of time series. Now most of time series have trend, seasonality and irregularity associated with them, and some of them do have cyclic patterns also. But it is not compulsory that there has to be pattern present. So let us discuss each one of them in detail. Now the first is trend. So trend is nothing but a movement to relatively higher or lower values over a long period of time. So when the time series analysis shows a general pattern that is upward, we call it an uptrend. Also, if the trend exhibits a lower pattern that is down, we call it as a downtrend. And if there was no trend, we call it as a horizontal trend, or you can say a stationary trend. So now let me explain you better with an example. So there is a new township that has been constructed. Okay, and people are going to come and live over there. So what happens? A hardware guy comes up and opens up a shop there. So people who will be coming up will definitely buy stuff from there. Now once all these houses are settled up or it's been occupied, the need of hardware reduces. So the trend may go down. So let's say the sales were up in the first year and by another 1 year or maybe in 6 months it has gone down. So that is the trend, guys. So for some amount of time selling was high and then it got down. But this is not a pattern. This is something that is happening year on year. But trend is something that happens for some time and then it disappears. Then we have seasonality. So here seasonality is basically upward or downward swings. But this is quite different. It's a repeating pattern within a fixed time period. So for example, Christmas happens every year on 25th December. Let's say you're on the business of chocolates. So every year on year, chocolates are served more and more in the last week of December. Now this is because Christmas is there and you will be noticing this across the year. That is from past 2 years, 4 years, 6 years, 10 years and so on. So it's a repeating pattern within a fixed time period. While in trend that is not the case. Now let me take another example. Let's say ice cream this time. So ice cream sales will go comparatively higher in summers rather than in winter. So that is again a seasonality. Then we have irregularity, or it is also called as noise. So these are erratic in nature, or you can say unsystematic. It is also called as residual. So this happens basically for short duration and it is non-repeating. So here let me give you an example. So let's say there is a natural disaster. Let's say there is a flood in your town out of nowhere in 1 year. Now a lot of people are buying medicines and ointment for relief. But after some time when everything is settled up, the sales of those ointments have gone down. So this is something that no one could have predicted. It's going to happen erratically. You don't know how much number of sales are going to happen. So you cannot foresee about the event that the flood is happening. Okay, so this is some random variation. So this is what irregularity is. Now moving ahead, we have cyclic. So cyclic is basically repeating up and down movements. So this means you can go over more than a year. So they don't have a fixed pattern. So they can happen anytime, let's say in 2 years, then fourth year, then maybe in 6 months. So they keep on repeating and they are much harder to predict. Now moving ahead, let's discuss when not to apply time series analysis. So first of all, you cannot see time series analysis when the values are constant. So let me take the same coffee example over here. So let's say the sales of number of coffee in the previous month were 500. Then this month also the sales number is almost the same, that is 500. Now I wanted to predict the number of sales in the next month. Now in such cases where the values are constant, as in our case the number of sales were 500 in the previous month and then in this month also we have the same number. And now we want to predict it for the next month. So in such cases where the values are constant, time series cannot be applied. Similarly, if you have values in the form of functions. Let's say you have sine of x or cos of x. So for example, in this case you have x value and you can get the value by just putting it in the function. So there is no point of applying time series analysis where you can calculate the values by just using a function. Now you can apply time series to these as well. But again, there is no point of applying it if you have a formula before that or the values are just constant. So these are the cases when you should not apply time series. Moving ahead, let us see what is stationarity. So no matter what guys, how much you try to avoid the stationarity part, it will always be there in time series. So here time series requires the data to be stationary. So any kind of statistical model that you apply on time series, the data should be stationary. So let's understand what exactly it is. Now most of the models work on the assumption that time series is stationary. Now if the time series has a particular behavior over time, there is a very high probability that it will follow the same in the future. Also, the theories and formulas that are related to stationary series are more mature and easier to implement as compared to a non-stationary series. Now, there are two major reasons behind the non-stationary of a time series. So first is trend, which is basically the varying mean over time. Secondly, we have seasonality. So this is the variation of a specific time frame. So stationarity basically has a very strict criteria. First one is it should have a constant mean. Now here the mean should be constant according to the time. Secondly, we have constant variance. So again, variance should be equal at different time intervals. And thirdly, we have autocovariance that does not depend on time. So for those of you who don't know what mean is, I'll not go into the details, but I'll just explain you in a nutshell. So mean is basically the average. Then variance is just the distance from the mean. So each point's distance from the mean should be equal. And then we have autocovariance that should not depend on time, or it should be equal as well. So for example, let's say you're standing at time t, okay, and your previous time period was t minus 1 or t minus 2. Let's say there are previous two time periods. So the values at t minus 2 or t minus 1, they should not have any kind of correlation between them, which is basically dependent on your time period. So that is nothing but autocovariance. So when these three conditions are met, then we can say our series is stationary, and then we can apply time series analysis over it. Now to check the stationarity in Python, we have two popular tests. Now first is rolling statistics and the second is ADCF, or you can say augmented Dickey-Fuller test. Now in rolling statistics, we can plot the moving average, or you can say moving variance, and see if it varies with time. Now by moving average or variance, I mean that any instance t will take the average or variance of a time window. Let's say if you want to know for the last year, that is for last 12 months or anything. And also guys, this is more of a visual technique. So you cannot deploy this kind of stuff on production, but it is quite useful for the POC purpose. Then we have ADCF, or you can say augmented Dickey-Fuller test in the world of data science. So Dickey-Fuller test, which is another statistical test for checking stationarity. Now here you have the null hypothesis, which is time series is non-stationary. And once you perform this test, you'll get a result which comprises of a test statistic and some critical values for different confidence level. Now here it is said that if the test statistic is less than the critical value, we can reject the null hypothesis and say that the series is stationary. So now let me just move on to my next topic. So now we'll discuss what exactly is ARIMA model. Now ARIMA is one of the best model to work with time series data. So this is basically the combination of two models, that is AR plus MA. And it's quite powerful guys. So once you combine both of these models, you get the ARIMA model. Now your AR model stands for autoregressive part and MA model stands for moving average. So AR is a separate model, MA is a separate model, and what binds it together is the integration part, that is indicated by I. So AR is nothing but the correlation between the previous time period to the current. So what does this mean? Now let's take this into consideration that you are standing at a time period t, and there are previous time periods like t minus 1, t minus 2, t minus 3. Now if you find any correlation between t minus 3 and t, that is nothing but the autoregressive part. So as I told you earlier that there is always some kind of noise or irregularity attached in a time series. So we need to figure out that noise. In fact, we need to average that out. Now, whenever we try to average it out, the crust and drops that are present in that noise smoothen out and we can have average forecast of that noise. You can actually never predict when a next customer is going to come in and buy 100 items at once. So we try to smoothen it up by taking its average. Now, ARIMA model has three parameters. It has P, it has Q, and it has D. So P basically refers to your autoregressive lags, then Q stands for moving average, and D is the order of differentiation. So we have each parameter for each of the models. So if we take the integration by just one order, then the value of D would be 1. If we differentiate it in the order of 2, then we have the value D equals to 2. So that is how we can predict these values P, Q, and D. And each of them has a different method to it. So if you want to predict the value of P, you will be using an PACF graph, that is nothing but a partial autocorrelation graph. Then to predict Q value, we need to plot ACF plot, that is autocorrelation plot. And D, I have already told you, to make data stationary, we use some kind of differentiation. So the order differentiation defines the value D. So I guess enough of theory part. So now let's quickly jump on to the demo and let's see how you can implement all of these things. So now we'll have a look to a demo and we'll forecast the future. So here we have a problem statement where there is an airline which has the data of passengers across months. So here what you need to do, you need to build a forecast to determine how many number of passengers are going to aboard these airlines at the month level in the future. So here we have month, or you can say dates. So here we have dates from 1949 till 1960 and we have the number of passengers traveling per month. So now we have this kind of data and we need to analyze what will be the number of passengers if we have to predict it for next 10 years. So now let me just go to my Jupyter notebook and let us see how my predictions look like. So guys, this is my Jupyter notebook wherein I have the code and we'll be implementing all the things that we have discussed till now. So first of all, we'll be importing all the necessary libraries. So here we have imported Numpy. Then we have imported Pandas for data analysis part, and you can say data processing. Then we have imported Matplotlib for data visualization, creating plots and all those things. Then in order to implement Matplotlib, we have also written %matplotlib inline for Jupyter notebook. So you'll not get a particular plot open in a new window. Everything will be there in your Jupyter notebook itself. And then I have just defined the size. So now let me just run this. Next, what I've done, I have imported my air passengers data using Pandas. So we have a function of read CSV in Pandas that is represented with PD. So we have substituted this in a variable data set. And then what we have done, we have just passed those strings in a date time format. So here we have set our data month wise. So using pandas, we have a function to date time. So over here, you can specify a month, and then you can just set this as your index. So here you have index variable as month. Next, what I have done, I have imported date time. And then I have just printed the top 5 values. So now let me just run this. So this is how my data looks like. So I have month as my index, and then I have number of passengers as my second column. So this data I've already showed you in the presentation, wherein I have the data from 1949 till 1960. So I have just printed the head of it. So now let me just print the tail. So let's say I want to know the last 5 data entries. So here we have data till 1960, and we have the number of passengers. Next, what we have done, we have simply plotted a graph between them. So guys, in time series, we have date and we have another variable. So here my other variable is number of air passengers. So here we have date on my x-axis and number of passengers on my y-axis. And then we have simply plot that graph. So now let me just run this. So this is how your data look like. So here you can see the trend is going up. So let's say if you want to calculate the mean at 1951, so here your mean will lie somewhat over here. And let's say if you want to calculate the mean of this year, that is 1960. So here your mean will be somewhere here. So here you can see that you have a upward trend and the mean is not constant. So this tells me your data is not stationary. So now I have told you guys that there are two tests which basically helps you in checking the stationarity of the data. So here we have rolling statistics as well as we have ADCF. So let us go through each one of them. So here we'll be first going to the rolling statistics. So here we have rolling mean and we have rolling standard deviation. So here as you can see we have a window of 12. That is nothing but the window of 12 months. So let's say we have Jan of 1949 and you place the value of Jan 1950 with the value of 1949. So this gives you the rolling mean at yearly level. And you have to do the same with the standard deviation as well. So in Python, to calculate mean and standard deviation, you have a function dot mean and you have dot std. So this will automatically calculate mean and standard deviation. So now let me just run this. So here if you notice your first 11 rows is NaN, that is not a number. Now this is because we have calculated all the averages of these 11 and given over here. And similarly you can do the same for the next ones. Next, if you just scroll a little bit, you'll see it's a long data set and you have the same result for standard deviation as well. So it's the same procedure guys, average has been calculated and then just given out. So here you must be having a question why only 11 values are NaN. So over here we have just given a window of 12. Let's say I've given a window at daily basis or you have data at a day level. Then your window size would be 365. So here my data is at monthly levels, so the forecast will be on monthly only. Now similarly, if you have data at day level, then probably your window can be 365. So I hope you get the reason why I am giving the win as 12 and why we are calculating the mean and standard deviation. Then what we have done, we have simply plotted this rolling statistics part. So here we have the original data which is just plotted by the color blue. Then we have the mean data. So here we have just plotted the mean for what we have just calculated above and then we have given the color red to it. Similarly, we have plotted the same for standard deviation and we have given a color black to it. After that, we have just given a legend, we have given a title to it, and now let me just run this code for it. So over here, you can see we have a plot somewhat like this. So guys, blue line is my original data. And as you can see, I have my mean in red and I have a rolling standard deviation in black color. So over here, you can conclude that your mean and even your standard deviation is not constant. So here your data is not stationary. So guys, this is my rolling statistics method, which is again a visual technique. So here we have already concluded that this is not a stationary data set. Now let me perform Dickey-Fuller test as well. So to perform Dickey-Fuller test in Python, you have to import from statsmodel.tsh stat-tools import adfuller. Now this is the function which has been provided in Dickey-Fuller test. So here I have a function that is adfuller. I have passed the data set into it, which is the number of passengers, and then I have just given a lag, which is equals to AIC. Now AIC is basically Akai information criterion. Now what does this AIC mean? So AIC gives you the information about what you wanted in time series, the exact value to the actual value, and it analyzes from the difference between them. So don't just worry about this guys. For now, just think about this as a metric and see what happens when we just run this Dickey-Fuller test. So when we run this, we'll have values to test statistics. We have t-value, number of lags that has been used, and number of observations used. And then we have printed the values in a loop. So now let me just run this cell as well. So this for statement will basically print all the values. Now I have a statistic value, a p-value, number of lags used, number of observation, and we have critical value at different percentages. So here your null hypothesis says that your p-value should be always less. So here we have a very large value, that is 0.9. So this should be somewhat around 0.5. So that would be a great thing. Also, your critical value should also be more than the test statistic. So here we cannot reject the null hypothesis and we can say that data is not stationary. Then what we'll do, we'll estimate the trend. So here also with the results of Dickey-Fuller, we got to know that the data is not stationary. Then what we'll do, we'll estimate the trend. So here what we have done, we have taken a log of the index data set. So index data set is nothing but the data set which has index as time, or the data which has been set monthly wise. So here we have just taken a log, and let me just run this for you. Now if you see here, numbers on your y-axis have changed because the scale itself has changed. Here we have taken the log, but here your trends remains the same, whereas the value of y has been changed. Next, let us calculate the moving average with the same window. But keep in mind guys that this time we'll be taking up with the log time series. So again we'll be having window is equals to 12, that is nothing but the 12 months. And then we'll be just plotting the graph with the log time series. So here data is already in the logged form. So now let me just print it. So here you can conclude that mean is not stationary, but it is quite better than the previous one. But again it is not stationary because it's moving with the time, and this trend is again an upward trend. So we can say that the data is not stationary again. Next, what we'll do, we'll get the difference between the moving average and the actual number of passengers. So we have mean and the actual time series that we have. Now why are we doing this? Now the reason is that unless we perform all these transformations, we'll not get the time series as stationary. So now you must be having a question as to whether it's the standard way to make a time series stationary. No, it's not guys, because it depends on your time series as in how you can make it stationary. Like sometimes you have to take log, sometimes you might want to take a square of it, sometimes cube roots. So it all depends on data what it holds. So here we're going to log scale. So we are going to take MA and then subtract both of them. So here we have the log scale and we have the moving average. And then we have just printed the head of it, that is the top 12 values. Then what we have done, we have just removed the NaN values. So that is done by just typing drop NA, and in the brace you can write in place dot true and then just print the head of it. So now let me just run this. So here we have the month and we have the number of passengers. So here we have the numbers, which is basically the difference. Then moving ahead, I have purposely put in actual code of this ADCF test. So ADCF is the augmented Dickey-Fuller test. So above I have just applied a simple ADCF function. But this is the whole code guys. So you have to perform this whenever you have to determine whether time series is stationary or not. So here I have defined a function which is test stationary, and I have performed both the tests. I have determined rolling statistics as well as performed Dickey-Fuller test. So over here I have used the window as 12, and then I have plot rolling statistics as well I have performed the Dickey-Fuller test as well. So let me just run this, and I'll just run the function as well. So now if you see, you have the original data as blue lines, then you have standard deviation in black line, and you have rolling mean in red line. So here you can visually notice that there is no such trend, or you can say it is much better than what we used to see earlier. So here we have rolling standard deviation and we have rolling mean. Now let me see the ADCF results as well. So here if you notice, your p-value is relatively less. In early cases we used to have 0.9 something, and over here you have p-value at 0.02. Now if you notice, your critical value and your test statistics value is almost equal, which basically helps you to determine whether your data is stationary or not. So I hope by now you got the idea between the Dickey-Fuller test and the rolling statistics test as to how you can determine whether the data is stationary or not. Next, what I have done, I have calculated the weighted average of time series. Now why I have done this? Because we need to see the trend that is present inside the time series. So that is why we have calculated the weighted average of time series. So now let me just run this and you'll get to know why I'm talking about this. So as you can see here, as the time series is progressive, the average is also progressing towards the higher side. So here your trend is upward and keeps on increasing with respect to time. Moving ahead, let's see another transformation where we have a log scale and then we'll subtract the weighted average from it. So in a previous scenario, we have subtracted simple mean, but in this we'll be using weighted mean and then we'll check for stationarity. So here we have just subtracted them and then passed the variable in the test stationarity function that we have just defined it over here. So over here it will go through both of the tests and then it will display the results. So over here I'll just run this cell. So over here, you can notice that your standard deviation is quite flat. It is not moving here and there. And in fact, you can also say that this doesn't have any trend. Also, if you notice the rolling mean, it is quite better than the previous one. Now let me just see the results of ADCF test as well. So over here you have a very less value of P, that is P is equals to 0.005. So your TS is again stationary, which means that your time series is again stationary. So here you can use both this transformation to check whether your data is stationary or not. So now we know that our data is stationary. Now what we'll do, we'll shift the values into time series so that we can use it in the forecasting. So what we have done earlier, we have subtracted the value of mean from the actual value. Now what we'll do, we'll use the function called as shift to shift all of those values. So here let me just run this plot. So this is how the plot looks like. Now here we have taken a lag of 1. So here we have just shift the values by 1, or you can say difference your time series once. So guys, if you remember, I talked about the ARIMA model. So ARIMA model has 3 models in it. That is the AR model, which stands for autoregressive. Then we have MA model, that is for moving average, and I is for the integration. So ARIMA model basically takes 3 parameters. And D there stands for the integration part, or you can say how many times you have differentiated a time series. So here your value becomes 1 now. Next, what I have done, I have simply dropped the NaN values. So here, if you just run this code, you'll see that output is quite flat. So here your null hypothesis or the augmented Dickey-Fuller test, wherein we'll take the null hypothesis, is rejected, and hence we can say that your time series is stationary now. So here you can say that you again have blue as the original data, you have red as your rolling mean, and you have black as your standard deviation. So visually also we see that there is no trend present and it's quite flat. So here we can say that your time series is stationary. Now let us see the components of time series. So here you first need to import from statsmodel.tsa.seasonal import seasonal decompose. So here your seasonal decompose segregates 3 components, that is trend, seasonal and residual. So here what we have done, we have simply plotted these graphs and let us see how all these graphs looks like. So let me just run this. So this is how your output look like. This is my original data, which we saw that there was a trend. So this is my trend line. So this is going upward, in which you can say it's quite linear in nature. Along with that, we have seasonality also present in high scale. So we have a seasonality graph over here. And then we have the residuals as well. So residuals are nothing, guys, the irregularities that is present in your data. So they do not have any shape, any size, and you cannot find out what is going to happen next. So it's quite irregular in nature. Now what we're going to do, we'll check the noise if it's stationary or not. So over here we take the residual and we'll save it in a variable that is decomposed log data. And again I'll just pass it to the same function that we have just created above, which is test stationary, and inside this test stationary function we have 2 tests, that is rolling statistics and ADCF test. So now let me just run this cell, and this is how your graph looks like. So looking at the output visually, you can say that this is not stationary. That is why we have to have your moving average parameter in place so that it smoothens it out to predict what will happen next. Now we know the value of D, but how can you know the value of P and Q? That is the value of autoregressive lags and the value of moving average. So here, as I told you guys, we need to plot ACF graph and PACF graph. So in order to calculate the values of P, we need to plot PACF graph, and in order to calculate the value of Q, we need to calculate ACF graph. So ACF basically refers to your autocorrelation graph, and your PACF stands for partial autocorrelation graph. So in Python, we first need to import these 2 graphs, that is from statsmodel.tsa.stattools import ACF and PACF. Then using this function ACF and PACF, we are just passing a data set, and we have preferred a method that is OLS. So there are various methods, but we usually prefer OLS. So OLS is ordinary least square method. Then what we have done, we have simply plot ACF graph and we have plotted the PACF graph. So now let me just run this and let's determine how you can calculate P value and Q value. So guys, this is my autocorrelation graph and this is my partial autocorrelation graph. Now in order to calculate the P and Q values, you need to check that what is the value where the graph cuts off, or you can say drops to 0 for the first time. So if you look closely, it touches the confidence level over here. So here if you see, your P value is almost around 2. And similarly, if you look at this graph, you'll see that it cuts it over here, or it drops to 0 over here, and then the value of Q also becomes 2. So this is how you can calculate the value of P and Q using PACF graph and ACF graph. Next we have the value of P, we have the value of Q, and we have the value of D. So what we can do, we can simply substitute these values in the ARIMA model. So here what I've done, I first imported the model ARIMA, and then using the function ARIMA, I have the order listed over here. So I have P value as 2, I have differenced it 1, so my D value becomes 1, and my Q value is again 2. So here I have just plotted the graph and then calculated the RSS, which is the residual sum of squares. So here let me just run this graph. So here you can see the residual sum of squares is quite good, that is 1.02. So here you have plotted the values of P, Q and D as 2, 2 and 1. Now you can also play around with these P and Q parameters. Now let's say I want to change the parameters to 2, 1, 0. So if I do that, let me just run this again. So here if you see, once I have just changed the value to 210, my RSS score has been increased. So greater the RSS, the bad it is for you. Now let me again change it to 012. Now in that case also my RSS has been increased to 1.4. So here you need to take care of the RSS part. So the greater the RSS, the bad it is for you. So here we'll just revert back to 212, wherein we have the value of P as 2, Q as 2, and we have taken only one difference, so the value would be 1. Now let's take the moving average model in consideration. So here a P value is 0. Now for our model you have to do 210. Next for AR model, what you can do, you have to do 210, wherein you have the value of Q as 0. So here I have 210 and let me just run it for you. So here you can see that your RSS has again reached 1.5. Now we have seen that with respect to AR, that is your autoregressive part, your RSS is 1.5. Now if I again go to MA, wherein I have the values as 012, the RSS score is 1.4. So here we conclude that with respect to autoregressive part, we have the RSS as 1.5. With respect to moving average, we have the RSS is 1.4. And if we combine both of them and make ARIMA out of it, that is this part, that is 212, we have very less RSS. So let me just run this as well. So here when I substitute the values as 212, that is P and Q value is equals to 2 and D we have taken as 1. So here your ARIMA model gives you RSS of 1.02, which is quite good. Next, what we'll do, let's fit them in a combined model, that is ARIMA. So here we have seen that with respect to AR, we have RSS as 1.5. With respect to MA, that is moving average, we have RSS as 1.4. And when we apply the combined model, that is ARIMA, the RSS, or you can say the residual sum of square, is dropped to 1.02. So here let's do some fitting on the time series on what data we have. So here we have just converted the fitted values into a series format. And then we have just printed the head of it. So now let me just run this. So over here we have the month as well as the predictions over here. Next, what we'll do, we'll find it the cumulative sum, and then we're going to have the predictions done for the fitted values. So now to calculate the cumulative sum, we have the function called as sum, and then again we have just printed the head. So this is my result. And finally we're going to have the predictions done for the fitted values, and then we have just printed the head of it. So now let me just run this. Next, we also keep in mind that after performing these transformations, we also need the explanation of the whole data so that it comes back to the original form from where we have just started using it. So in order to know the values in that form, you need to take the exponent of it. So these are the 3 steps which are very important for data transformation. So you'll be finding cumulative sum, we'll do the predictions, and we'll also calculate the exponent of it so as to get your data in your original format. Now after that, we just plot the actual values to how our model has fitted. So now let me just run this. So you can see that the orange line is basically the model that we have fitted. And here you can see that only the magnitude is varying, whereas the shape has been properly captured by the ARIMA model. Now how we can do predictions, guys? Now there is a function in Python that is predict. Now before predicting the values, let me first see my data, that how many rows are there in my data set. So this is my data set name. So now let me just run this. So here we have the dataset from 1949. We have the number of passengers. It will go on till 1960, and we have 144 rows into one column. So here we got to know that we have 144 rows. So what if I want to predict it for next 10 years? So what will be my prediction? Now here you have to see that how many number of data points would you want. So let's say if you want to predict for 10 years, so the number of data points would be 120. That is 12 into 10. So here if you want to predict it for 10 years, you have 120. So using that plot.predict function, I can actually predict the future. So here using this function, I'll give the first index of the time series and then the number of data points you want the time series for. So I have 144 rows plus 120 because I want it for 10 years. So 144 plus 120 is equals to 264. So I'll write it over here. Now let me just comment this for now and let me just run it. So over here, if you can see, my blue is the forecasted value and this gray part is your confidence level. So now whatever happens or however you do the forecasting, this value will not exceed the confidence level. So this is how you can see that for the next 10 years, you have the prediction somewhat like this. So this is how you can do prediction. And if you don't want to see the graph, you can actually write in the data point. So here I want the prediction for 10 years. So I have just typed in the steps that is equals to 120 and you get the result in an array format. So that is how you can perform a lot of operations with this data and predict it for, let's say, 6 months, 12 months, next year, 10 years, and it's totally up to you guys. So now let me just go back to my presentation and let's see what all we are left with. So here we have just built a model wherein we have forecasted the demand for the next 10 years. So in a data set, we have the date in the monthly basis and we have the number of passengers.
So let's get started with Excel interface. So you can get started with Excel using Google Sheets or the Excel desktop app, which is included with the Microsoft Office subscription. So the version of Excel that I'm going to use in this tutorial is Excel 2016. So here, let's click on New. If we click on this blank workbook, a new workbook will appear. And below are some templates that will make your work easier. You can search for templates here as well. Okay, so now let's create a blank workbook. So now a sheet appears. Okay, this is a sheet in Excel. So a sheet refers to a single tab within a workbook where you can input and organize data. A workbook can contain multiple sheets, each identified by a tab at the bottom of the Excel window. So we can rename the sheet by double clicking. So let's rename it as sales revenue. Okay, we are going to work with sales data. So I've just renamed the sheet. So now let's explore the different sections of this workbook. So this section at the top is called the Quick Access Toolbar. So the Quick Access Toolbar in Microsoft Excel is a customizable toolbar that provides easy access to frequently used commands and tools. You can customize the toolbar according to your needs. So here you can click on this and customize the toolbar. You can click on whichever option you want to appear in the Quick Access Toolbar. So if I click on spelling, spelling appears in the toolbar. So below the Quick Access Toolbar, we can see tabs such as File, Home, Insert, Page Layout, etc. So each tab has specific functions, and when we click on a tab, a ribbon appears. Okay, so this is the ribbon bar. Ribbon refers to the top section of the Excel window that contains tabs, groups, and commands for performing various tasks and accessing different features and functionalities. So ribbon consists of different groups. Okay, so this is a clipboard group, this is a font group, and this is an alignment group. Okay, each have different functions. And at the bottom, we have a slider function to zoom the worksheet. So I've zoomed the worksheet. And now we can also see multiple rectangles in this sheet, right? So these are called cells. So a cell refers to the intersection of a row and a column within a worksheet. Each cell is identified by a unique reference called a cell address. Okay, cell address is basically the combination of column letter and the row number. For example, cell at the intersection of column B and row 3 is B3. So you can see the reference number. Cell address is B3 here. Okay. So if we select multiple cells, it is called a range. Okay. So if you click on tab, it will go to the next column. And if you click enter, it will go to the next row. So now let's add some data to the Excel sheet. So let's create a sales report. Let's create columns and name them. So I'll create a column and name it product ID. The second column is product name. The third column is units sold. And the next column is price. Okay. And then we'll add revenue. Alright. So let's add the product IDs. 5. And let's add product name. A, B, C. Okay. And let units sold be 100. So these are just random numbers that I'm applying. And let's just add price for each unit sold. Yeah. So now you can see that the column product name is not completely visible. So first let's add the spacing. So let's just, so we can adjust it like this. Okay. But there is another option. You can click on this button here. So it will select the entire sheet and click on the line that separates two columns and double click on it. So space is adjusted automatically according to the data entered. So if you want to insert a column before product name, select the column product name and right click and click on insert. Yeah, so you can see that a column appeared. In the same way, if you want to create a row, click on the row and insert. Okay, a row is created at the top. So now let's just delete whatever we created right now. So right click and delete, because we don't want the row and column that we created, right? So delete. Now let's do some calculations for the data that we have created. So here what we'll do is we need to calculate the revenue column. So we'll calculate it using units sold and price. It's nothing but the multiplication of units sold and price. So here let's use a simple formula. So formula is a mathematical expression used to perform calculations, manipulate data or automate tasks within a spreadsheet. Formulas in Excel always start with an equal sign followed by the expression that you want to evaluate. So let's put an equal sign here. Then whatever we type in the cell can be seen in this formula bar. Okay, so equal units sold into the price. Okay, and press enter. So if you want to apply the same formula to the below rows, either you can click on this plus sign, double click, or you can also drag them down. So the same formula will be applied to all the rows. So here we have used an operator to calculate revenue, right? We have used the multiplication operator. So apart from multiplication, Excel supports various operators such as addition, subtraction, division, exponentiation and concatenation. Okay, so now let's calculate the same revenue in this column using a function. So Excel provides numerous built-in functions to perform specific calculations or tasks. Examples of functions include sum, average, if, VLOOKUP, etc. So here we'll use a function called product to calculate revenue. So is equal to product. So this is the function. Number product, number 1 is the units sold, comma, the price. We'll close the bracket. So we can see that we got the same answer using the operator and sum. Alright, so now let's just delete this. So now let's calculate the grand total for the columns units sold, price and revenue. Okay, so to calculate the grand total, there are 3 ways you can calculate. So first is using an operator. So op is equal to, either you can add everything using operator plus 54 plus 2 plus 45 plus 12. Okay, this is one way to calculate the sum. Okay, next I'll teach you another way, that is using function. So to calculate sum, we have a function sum, double click and select the range of the cells and close the bracket. Okay, this is the second way to calculate sum. Apart from that, we also have auto sum. Okay, so here we have a function called auto sum, which will automatically calculate the sum of the column. Alright, Now let's just drag this the same way so that the sum of price and revenue is also added. Yeah. Now let's add a new column and name it product category. So let's click here and insert a new column. Okay. We'll name it as product category. Okay. So let's name it food, stationery. Let this be stationery. Then we have food and clothing. So these are the product categories that we have added. Now what we'll do is let's analyze sales trends by category. Let's add the name. Okay, here we'll add the product category and here the total revenue. So let's calculate the total revenue according to categories. Let's adjust the space. Okay, so first category is food. Let's paste it here. Second, we have stationery. Paste it here. Then we have clothing. So these are the three categories. So we'll calculate the total revenue. How do we do that? We'll do that using the SUMIF function. Okay, is equal to SUMIF. So the first argument is range. Okay, we'll select the range, that is the product category, comma the criteria. So food is the criteria. Okay, if product category is food, then we need to sum the revenue, right? Comma the sum range is the revenue. Alright, now let's just close the bracket. Yeah, so this is the total revenue for food. So I'm just double clicking here. Yeah, so we got the total revenue for stationery as well as clothing. So now we can see the revenue based on categories. Okay, now let's do some formatting to the data that we have created. Formatting in Excel refers to the process of changing the appearance of cells, rows, columns and other elements within a spreadsheet to improve readability and enhance the overall presentation of the data. Before you share an Excel file, either for an assignment, submission or any work-related tasks, make sure you format it. Okay, so the first thing that we'll do here is we'll add a title. Okay, add a title to this table or this sheet. Now I'm going to add a row here. Click on insert and a row is seen here. So let's add the title as sales revenue analysis. Okay. Now you can see that the title is in the first column, but I want it centered according to this table. So I'll select these cells and click on merge and center. So now we can see that the title is in the center. Now let's just style this heading. So under styles, go to cell styles and choose a heading, heading 1 or heading 2. So here I'm choosing heading 2. Yeah. So heading is styled. Next, let's style the grand total. So this is the grand total, right? So let's select these rows and go to cell styles. And there's a default style for grand total. Let's just click on that. Yeah. Now let's format the entire table. So let's copy the entire table and format as table. We can choose any of these options. I'm choosing this one. Yeah. Okay, let's do the same thing for this one also. Let's add a heading under cell styles. Let this be heading 3 and we'll add some color to these cells. Okay. Let's do one more thing, that is let's add border to the entire table. Okay, that you can do it under the font tab. Let's just do all borders. Yeah. Now we'll just adjust the column spaces again. Yeah. Now we can see that the table is well formatted. Next, let's take a look at data visualization. Now we have categorized the revenue based on each categories, product categories, right? So let's visualize the revenue according to the categories food, stationery and clothing. So first of all, let's select this data range and go to insert. So a bar chart is always suitable for visualizing categories. So here we have different charts. This is bar chart, line, pie chart, scatter plots. So here I'm choosing bar chart. So I'm choosing the first one. Okay, so this is the plot that Excel has generated. Let's zoom out a bit. Yeah. Now this is the chart. Now we'll make some changes to this chart. Okay, first of all, let's change the title. Total revenue based on product categories. Okay. Yeah. Now what is missing in this chart? Axis titles. Axis titles are very important for any chart. So make sure you add them. So this is the total revenue. Total revenue. This is the product category. Now let's also add data labels. Okay, let's just click on plus symbol here and add data labels. Yeah. Now this plot shows us that the product category food had the highest revenue, followed by stationery, and clothing had the lowest revenue. So this is how we create a simple chart in Excel and interpret from it. So now we are done with the analysis. So we just go to File and save it. Okay. And then you can go to File and also export it into PDF. Okay, and publish. So this is the PDF file of the analysis that we have done in Excel.
Alright now, so why do we need data analysis, right? With so much of information being collected through data analysis in the business world today, we must have a way to print a picture of that data so we can interpret it. Data analysis gives us a clear idea of what information means by giving us a visual context through maps or by graphs. This makes data more natural for human mind to comprehend and therefore makes it easier to identify trends, patterns, outliers with large data sets. So now coming down to what is data analysis. Well, data analytics is a science of analyzing raw data in order to make conclusions about the information. The techniques and process of data analytics have been automated into mechanical processes and algorithms that work over raw data for human consumption. Data analytics helps businesses to optimize its performance. Now let's take a look at steps that are involved in data analytics. There are 5 basic steps that go in for analyzing of a data. Alright, so let's see each of these steps in detail. Starting off with the step 1, that is asking the right questions. The first step towards any sort of data analysis is asking right questions from a given data. Identifying objective of the analysis, it becomes easier to decide on the type of data we'll be needing for drawing the conclusions. Then we have data wrangling. Data wrangling, sometimes referred to as data mugging or data pre-processing, is a process of gathering, assessing and cleaning of raw data into the form suitable for analysis. Well, data wrangling has 3 sub-steps, starting off with gathering of a data. After identifying the objective behind the analysis, the next step is to collect the necessary data required by us to draw appropriate conclusion. There are various methods by which we can collect the data. Then we have assessing of that particular data. After the data has been gathered, sorted in the support form and assigned to a variable in Python, it's time to do some high-level overview of the type of data we are dealing with. Then moving on with the same thing, we have data cleaning. Data cleaning is a process of detecting and correcting missing or irregular records from a data set. In this process, data is present in a raw form and cleaned appropriately so that an output data is void of missing and inaccurate values. Then moving on to the step 3, we have exploratory data analysis, or in short we can say it as EDA. Once the data is collected, cleaned and pre-processed, it is ready for analysis. As you manipulate data, you may find you have an exact information you need, or you may need to collect more data. During this phase, you can use data analytics tools and software which will help you understand, interpret, and derive conclusions based on the requirements. Moving ahead to the step 4, that is drawing out the conclusions. After the analysis phase is completed, the next step is to interpret our analysis and draw conclusions from it. As we interpret the data, there are three key questions which one must ask themselves. Did I analyze the answer of my original question? Was there a limitation in my analysis which could have affected my conclusion? And the third question that you can ask yourself is, was the analysis sufficient enough to help making decision making? And finally, coming down to the last step, that is communicating the particular results. Now that the data has been explored and conclusions have been drawn, it's time to communicate your finding to the concerned person or communicating to the mass employing data storyline. Now that the data has been explored and the conclusions have been drawn out, it's time to communicate your finding to the concerned party. This can be done by writing it in a storyline or writing blogs or making predictions or finding the reports. Great communication skills are the plus in this stage since your finding needs to be communicated in a proper way to the other people. So now, what are the benefits of data analysis? Well, data analysis positively affects an organization's decision-making process with interactive visual representation of a particular data. Businesses can now recognize more patterns quickly because they can interpret data in a graphical or a pictorial form. Here are some of the most specific ways that data visualization can benefit an organization. Starting off with correlations in the relationship. Without data analytics, it is challenging to identify a correlation between the relationship of an independent variable. By making sense of those independent variables, we can make better business decisions. Then we have trends over time. While this seems like an obvious use of data visualization, while this seems like an obvious use of data analytics, it is also one of the most valuable applications. It is impossible to make predictions without having necessary information from the past and the present. Trends over time tell us where we were and where we can potentially go with our particular business model. Then moving ahead to frequency. Closely related to trends over time is the frequency. By examining the rate or how often customers purchase and when they buy gives us a better feeling of how a potential new customer might act and react to different marketing and consumer acquisition strategies. Going ahead to the next one, that is examination of the market. You see, data analytics takes the information from different markets to give out an insight of an audience to focus your attention on and which ones to stay away from. We get a clear picture of opportunities within those markets by displaying the data on a various charts and graphs. Finally, coming down to risk and reward. You see, looking at the value and risk metrics required experience because without data visualization, we must interpret complete spreadsheet or numerous amount of numbers. Once the information is visualized, we can pinpoint the area that we might need to give some attention towards. Now that we know the importance of data analytics and how it is being used in a real world today, let's have a look at various tools that go in for analysis of our data. So if you are someone who thinks that we have few tools for data analytics, well, this might take you by surprise. Well, we have n number of tools that go in for performing data analysis. You see, one of the popular way to acquire data, or you can say scraping of a web, we can use something called as Beautiful Soup. And apart from that, in order to visualize our data, we have n number of tools such as Power BI, then we have Seaborn, TensorBoard, and many more. All right. So now that you have a brief intuition about what does it mean to perform analysis on a particular data set, let me now take you to my Jupyter notebook and show you how we can scrape real-time COVID data and visualize and perform analysis on that particular data set. All right, so for this, let me move to my code editor. The code editor that I'm going to use over here today is going to be a Jupyter notebook. All right, so the first thing or the first step that we discussed earlier is to acquire the data, right? So let me just quickly write it here, data collection. Okay, data collection is all about acquiring right data at a right time. And then we have data pre-processing, and then we have to perform exploratory data analysis. So I would write the short form of it, EDA. And finally, we are supposed to draw out the conclusions. So this is what we are going to do here today. In order to collect our data, I can either use like CSV file, and with this current COVID trends, I can obviously download the latest version of it from the Kaggle. What I would do is let's scrape the new data from the web. Okay, so let's see, I would be using this website called as Worldometer. Okay, so if you don't know about this Worldometer, it's a website that is available, and with this we can get the live updates of the COVID cases. Okay, so let's go here by view by country, right? And here we are presented with a table. Okay, so now what I'm going to do is I'm going to scrape this particular website and make use of this particular table that we have over here. and we are going to plot all of this data into a different forms, and we'll also use these different features, right? So we have these columns like total cases, new cases, total deaths, and all of these, and we're going to perform analysis with respect to each of these. So in order to scrape the data, what I'm going to use is I'm going to use something called as Beautiful Soup. So first off, if you don't have Beautiful Soup, you can just install it by pip install Beautiful Soup 4. I've already installed this, so I won't be installing it once again. So, but yeah, if you want to install, you just have to do that. So let's now import this from BS4, import Beautiful Soup as soup. So basically I'm just trying to annotate the entire use thing. So it would save me a lot of time. Like I don't have to write the entire Beautiful Soup. So let me just write it as soup. And let me also import date and time. So from date time, import date and date time. So now what I'm going to do is we'll straightly get down to scraping our website. So first off, let me give a comment here, web scraping. Great. So now what I'm going to do is let's write this variable like say URL, and let me take this and copy this particular URL. Great. And now what I'm going to do is I'm going to send a request. So request is basically like, let me show you what I'm doing here. So every time you deal with websites, we have two parts here. We have the client and the server. Okay, this is gonna be client and this is gonna be server. So we are the clients over here. Okay, we send a request to the server, and in return server gives us a response. So in order to give this send request, right, we have something called as the request. Like we have a module called as request, and we are gonna make use of that. So let me quickly import that. So from URL lib dot request, import request, and then we also need URL open, right? So URL open is basically used to open our website. Okay, so let me quickly get down here. Let me execute this cell. Let me quickly open our URL. So I'm going to give a variable here request, and then call the request class, and over here we're going to pass the URL. Apart from this, let's also give headers, and here is going to be user agent, and as this is a dictionary, we're going to give Mozilla 5.0. All right, so now we want to open our web page. So web page, this would be URL open, and we are going to pass the request. Okay, so if I just print out what this web page gives, they'll just give us an object, right? Okay, so as you can see here, we are getting this HTTP response. So basically this thing here, we are sending a request, and this is the response that we are getting from the server. And now we are going to parse this. So this is where we are going to use Beautiful Soup. So I'm going to give the name here as page soup, and I'm going to call our Beautiful Soup over here, and then pass our web page. And I can also give here as HTML parsing, right? So HTML dot parse. Okay, and now let me just quickly execute this. This will take some time depending on your internet speed. And apart from that, if you want to see what this page soup would look like, it's basically an entire HTML of this particular web page. Okay, so now what I'm going to do is, apart from this, let's also import date and time, because I want to show it to my user that we are updating this so and so the data on that particular time. Okay, for this I'm going to use my system data, and if you see over here, the data that goes in, right, so the data that we have over here is that, like, if I go for now, it just gives me, still most of the cases are not updated. So what I'm going to do is I'm going to take the previous day's data, and the reason why I'm going to do that is because if I take up the previous data, then it would be the complete data set, right? So that's what I'm going to do here. So in order to get previous day's data, so let me first make today. So this would give me the object of like current day, right? So date time dot now. And as I mentioned earlier, we need the previous day's data. So in order to get previous day's data, I'm going to use something like yesterday's string. You can just give any name that you feel like. I'm just giving here like a random name. And what I'm going to do here is I'm going to create a string format. And now in order to get previous date, so it will be date.today, and then we'll also have something called a string format, comma today dot day -1. So -1 would return as the previous day's time, and then today dot year. All right, and let me see what this would look like. Okay, it's gonna be day, right? So okay, so let us now execute this. So this is giving us the previous day's time. All right, so now let's quickly get down to scraping the website. Okay, we anyways have this. What I'm gonna do is, let me just rearrange this particular cell, and yeah. So now what I'm gonna do, now we have the complete HTML page that is in the form of page soup. Now I don't want the entire web page data. I just want this particular table over here. So let's kind of parse our table. So let's say table. So this would be page soup dot find all. Okay, and now we're going to pass the table. The table is nothing but the table tag here, and we'll also pass an ID. If you know the basics of HTML, then you might know that there can be one ID is something which is pretty unique, and no two data can have a same ID. So the name of the table over here is going to be main table countries yesterday. Okay, and let's kind of execute this and see how this table would look like. It's going to be underscore, right? So it's page soup dot, yeah. Okay, so as you can see here, like if I have to compare this, we are getting this only this table over here. Okay, and now and if you want to see the ID for this, you can see it's pretty much evident here. We have main table countries yesterday. And now we are still going to parse this table in order to get all the column data and the row data. So let me quickly show you how that can be done. Okay, so let's give some variable name, let's say containers, and this would be equal to table dot 0. The reason I'm putting 0 is because I'm gonna get list over here dot find all, and tr, which represents tag, and then you can say style, and as this is a dictionary, we'll give a colon here. And let's see what does this container have, and let's execute this. So as you can see here, this is basically giving me the list. So if I put list of 0, this will just give me the country name, then total, new, and all this. So this is basically this value over here. And apart from that, if I need rest of the data, so let me say 1. So you can see here we are just having the data over here. So this is the world, right? So world and all of these data, and this is present over here. It's this part. All right. So now what I'm going to do is I'll create an empty list which will hold all of this data. So all underscore data, and this would be an empty list. Okay, and then we'll have a for loop to iterate over the countries. So we are going to iterate over this container. So what I'm going to do here is for container or for country, because this is going to return as a country in containers. So country data, right? Okay, and as this is just the data, what I'm going to do is I'm going to first off save the first one, like let's say title and container 0, and I'll delete container 0. Okay, and now whatever data is there, we are going to add it to this, and temporarily we are going to add the country data to this particular list. Okay, so now I have country container. This will be equal to country dot find all. We are parsing the data here, and then we'll do td. Okay, and now what we'll do is if country container of 1 dot text is equal to China. All right, then continue. Okay, and I'll also have a for loop here for I in range 1 comma length of country container, right? So length of country container, because country container gives me the list of components that are present in that country. So what this means is, now for example, if I take country container as India, then we'll have all the values with respect to India, and all of this will be present in the form of a list. Okay, Okay, so let me put back the colon here. So let's say final feature. This will be country container of I, that is the index dot text. Okay, and now if clean, and clean is basically value that we are gonna define. So this is, we haven't defined clean yet. So if that is true, then I not equal to 1 and I not equal to length of country container minus 1, because we are gonna go like it's gonna be n minus 1, right? So yeah, then in this case what's gonna happen is, okay, let me give some space here. Yeah, so if you want me to zoom, let me zoom in a bit. Great. Okay, so now what's gonna happen is we are gonna try cleaning out our data a bit. Okay, so now it's gonna be final feature is equal to final feature dot replace. We'll be replacing comma with basically an empty space. Okay, and also if we have, sometimes we'll have plus and minus, right? So we'll also fix that up. So that is nothing but if final feature, that is, this is going to return as a string dot find, and basically this will be plus here. Okay, then we have final feature. We're just trying to replace the value here. So wherever we have the plus, we'll replace it by empty string. And similarly, we'll do this for the negative one. Okay, before that, one last thing, we'll just change it to the float value. Okay, and now as you have seen, we just done it for positive. We'll also do it for the negative ones. So that is, it's going to be elif. So find feature. So final feature dot find, and this will be minus. That is, if we have this over here, so we'll replace the minus by empty space. So let me quickly fix this up. Okay, so now we are done with this if clean. And now apart from that, sometimes we'll obviously have a missing data, right? So if final feature is equal to NA means not available. Wherever we have that over there, we'll have final feature will be 0. And if the final feature is equal to an empty space, right? So if you have this, or final feature is equal to some space like this, then we'll just replace it by -1. Great, fine. Now that we have cleaned this, now what we'll do is we'll append this data to country data, and once we come out of the for loop, we'll append the country data to all data. So we'll have country data dot append. So here we're gonna append final feature, and finally we'll also append all data, that is the country data to all data, right? So all data is a list which we did, append country data, and let's execute this. So let me zoom out. So as you can see here, it's a pretty lengthy code here, and finally we want to see what this all data would look like. So first off, let me execute this. Okay, so we have made a small typo. It's gonna be or. Okay, and let's execute this now. As I mentioned earlier, we are supposed to define clean, so we'll define clean somewhere at the top. Let's say over here, and let me execute this. I think it should be done, and let's see how our data would look like. So as you can see here, with respect to the data that we have, now we have for US, we have a couple of data. Then when we go down to India, we have a couple more data with respect to India. And whatever data you see over here is this one. It's a row. Okay. So now what we are going to do is we are going to put this in the form of a data frame. So to do that, it's pretty simple to do. We'll just create a variable here, df, which usually represents data frame, and then we need to have pandas. And so for that, let me import pandas. So import pandas as pd. Let's also import numpy. Import numpy as np. Looks great. And let me quickly create a pandas data frame here. So we have pd dot data frame, and then we have all data. Okay, and let's see how this would look like. So df dot head. Okay, so as you can see here, we have all the data present here, and wherever we had this missing data, right? So we have filled it with -1. So if you see over here, if you see the world data here, we have kind of like missing data present here. And similarly, it goes for every table. Okay. And now only thing that is left to do is giving this name for this column. Okay. Either you can scrape this entire data. You can just take out that title over here and then, create a for loop, and then, we can get this data, or else you can just write it hard coded. So as we have done this one way around, as I have done using a for loop, just to get the titles or the headers for this particular one, I'll just hard code it over here. Okay. So it will be column labels. So this will be a list. Okay. And let's see if we can just copy it from here. Let's see if it's possible to copy this. No, I think we are supposed to hard type it. So yeah, let's get that done. So first off, we have country, and then we have total cases. Then we have new cases. Then we have total deaths. Okay. And then we have new deaths. Going ahead to total recovered. All right, then we have newly recovered people, active cases. Then we have serious or critical. Then we have total cases per million. And then total deaths. Then we have total tests and tests per million. Then we have population. And finally coming down to which continent that particular country belongs to. And apart from that, if you see, we have a lot of missing data in 15, 16, and 17. So I'm gonna drop that. So let me just df.drop. And here I'm gonna pass 15, 16, and 17. This is gonna be the column labels, right? So either you can give in place is equal to true, or you can just give it as a reference variable. So over here I'm giving in place is equal to true. Or just simply you can just do df is equal to. Oh yeah, the reason why we are getting this is because we haven't defined an access. So in place is true and access has to be 1 because it has to remove all these columns, right? So it should work now. Yeah, so as you can see, we have all the data, and now all we need to do is give this column names to our data frame. So df.columns, and this would be column labels. Let's execute this and let's see how our data frame would look like. df. Okay, so as you can see here, we have the country, total cases, new cases, and population, and the continent that particular country belongs to. So if you want to see just the few, so df.head. Okay, so apart from this, there are 3 columns that I would like to add. That is nothing but percentage increase in cases, percentage increase in deaths, and increase in recoveries. So for this, what I'm going to do is basically percentage increase in cases or deaths or recoveries is nothing but, total number of cases divided by total number of new cases times 100. So let me quickly create a data frame for this. So df, and here it's going to be percentage increase cases. Okay. And here what we'll give is df new cases. This new cases is from here. So new cases, divide this by df total cases times 100. And let me copy this, and we'll do the same for the deaths and the recoveries. So let me give here unrecovered. And let me change the formula for this. New cases, new deaths by total deaths. And then we have new recovered by total number of people that have recovered. And let's execute this. Okay, maybe we might have done a small typo. Okay, so let's see where we are going wrong. Okay, so we have total number of cases over here and the new cases over here. Okay, looks like we have not typecasted this. So let me quickly get that thing done. So basically what has happened is we have all this data it's present in the string format. So before we do this, we have to convert everything into a numeric form. So it's pretty easy. We'll have to iterate it over the for loop. So it'll be like for label. So this is going to be after this. So, oh yeah. So for label in df.columns. So what's going to happen is if label, because apart from the country name and the continent name, rest everything has to be a numeric data, right? So we'll fix that. Because see, if you can see here, the country name is obviously a string and the continent is also a string. So apart from that, everything is a numeric data. So now what I'm going to do is df label. This would be equal to pandas data frame dot to numeric, and we'll give that particular data frame. And let me execute this. Okay, so this has executed. It's basically doing the same thing. It's just converting whatever data we have to numeric form. And now once we execute this, it should run quite well. So new deaths. So maybe I might have done a small typo here. So what I'm going to do is I'm just going to copy this and paste it over here. So let's execute this. Okay, so the place where we are having the error is over here. So it's going to be deaths, right? And let me execute this. Yep. So now if I just print out our data frame here, so df.head, and if I execute this, you'll see we have an extra table added, which says percentage increase in deaths, recoveries, and all of this. So this is all there is about data collection and data pre-processing. So we have completed the two parts over here. So now moving ahead to the stage 3, that is EDA, and coming down to the conclusions. So let me just give a small title here. So EDA, which stands for exploratory data analysis. Okay, so now let me give some cells. So starting off with EDA, what I'm going to do over here is we'll give a generic, very generic visualization. What I'm going to do for this is we'll see how is this plotting of these cases are, like how is the number of cases increasing, deaths as well as the recoveries. We'll have a look into that. And then we'll also see how the cases are increasing with respect to different parameters. And the parameters can be something like how cases are serious, number of active cases, and total deaths with respect to different countries and all that. So let's see which. Okay, so first off, let's take something like total number of people that have recovered, active cases. Okay, total number of active cases, and also the total number of deaths. Okay, so we have something like total recovered, total deaths, which is over here, and we are going to plot this with respect to the country. Okay, so whichever country has the highest would be first, and so on and so forth. So first off, let's take the parameters that we want. So let's say something like cases. Okay, the cases here basically takes a list, or I would say it takes a data frame, and data frame is because it takes that particular value. So we want total recovered, and then we have total number of active cases. Okay, and then we also have the total deaths. And okay, let's just put this in semicolon here, or else it will start throwing us key error. And then we'll pass here lock because we need the value for this. Okay, and now what we're going to do is we'll just create a separate data frame for this. So if I put this cases like this, I'll show you. So it's basically giving me this, right? So now what I'm going to do is I'll create a cases data frame, and this would basically be pd.dataframe. This will hold all the data here, and I want to reset the index. So let's see cases data frame. Oh yeah, we have to put this obviously in the form of okay, I've done a small typo here. So this usually happens when you press the tab, right? So yeah, so as you can see, we have put this in a form of a data frame. And now let's plot this. So before we go ahead, let me just create a columns. So df dot columns, and basically we're trying to give the name for the column. It's index and 0 there, so we'll say type, and then we'll also pass total. And now what we'll do is we'll create a percentage here, trying to add this to this data frame. So percentage, and this will be np dot round. Okay, and we have 100 times cases data frame, and here we'll take total, and then we'll divide this by the sum. Okay, so np dot sum of cases data frame, where we'll be taking total value, and then we are gonna take it till the second decimal place. Okay, and let's see how this would look like. Okay, so basically we have tried to add percentage over here, but we didn't want this. Okay, so we don't want this. We want to add this to the cases data frame. So we'll do that, cases data frame, and let us do this cases data frame here as well. So as you can see, this is the percentage increase in the cases. That is 85% of the people have been recovered of the total, and then the total number of active cases is 12%, and total deaths is going to be 2%. Okay, so now that we have got this, we'll also add one more data, that is the type. Okay, that is the virus type. We all know that is a virus type is going to be COVID, so we'll just put here COVID-19, and we'll add this the number of times we have this for I in range, so the length of cases data frame. All right, and now we'll finally get down to plotting this up. So figure, if you want to see how this would look like, so let me just show you how that is. Okay, so now what we're going to do is we're going to plot with respect to percentage and virus. Okay, so for this, let's say figure. So over here we're going to use plotty, and plotty provides certain number of various versions. Okay, so what I'm going to do is I'm going to add a new block, and here we're going to like import all the plotting related libraries. Okay, so import matplotlib dot pyplot as plt. Then we have import plotty dot graph object as go. Finally we have plotty dot express. Sorry, it's going to be import plotty. The reason I'm using plotly instead of Seaborn or Matplotlib is because plotly gives me a better visualization. Okay, express as px. Then we have import plotty dot offline as py, and we'll also import Seaborn, right? Import Seaborn as SNS. And then we also have a couple of things, that is import, this is basic dependencies, gc, and we also have something like we don't want the warnings, so import warnings. And like as we want to disable this warning, so it's going to be warnings dot filter warnings, and then here we're going to pass ignore. All right, and finally one more library that I want, that is import pandas profiling. Okay, so from import pandas profiling, from pandas profiling import profile reporter, and let's execute this. So if you don't have plotty, right, so all you can do is you can just do pip install plotty. Similarly for Seaborn, so pip install Seaborn, it's as simple as that. So now coming down here, so first off we'll create this figure. So here we have px, we obviously need a bar graph, so bar, and now what I'm going to do is I'm going to pass the data set, that is cases, that's this cases data frame. Okay, so it is, yeah, it's fine. And then what do we need on the x-axis? So x, this will be virus, and on the y, this will be percentage, and the color, this will be type. And finally, every time I hover over the data, that is hover data, let me fix that up, this will be basically total. Okay, so every time I put my cursor on top, I will be getting this particular value. Okay, and let's now show the figure. So fig.show, and let me execute this. Oh yeah, it's gonna be y, right, not u. Okay, so I have put this in a lowercase, and let's execute this, and we should get a graph now. Okay, so as you can see here, every time I hover over here, if I just remove this hover data, you will see that we won't get any data over here. So we'll just get a general percentage and whatever we are trying to show here. But now if I want something to be specific, all I can do is hover data, and I want to see the total cases. So you'll see here we have a total number of cases. Okay, so what is being represented here? So with this graph, this is basically a bar plot, which is where we have virus on this x-axis and the percentage. The virus won't change because we all know it's a COVID virus, COVID-19, and the percentage over here represents that, you know, around 85% of the people have recovered. That is the total number of recoveries. and the total number of active cases that are running now is somewhere equal to 12%, and the total deaths as of now is gonna be like 2% of total number of cases that have occurred. Okay, so this is a good sign. We have more number of recoveries, which is pretty much a very good sign, and less number of fatalities is something it's an amazing thing, because now we are not losing our lives. What I would do next is we are going to plot this against new cases, newly recovered people, and new deaths. So I won't go through entire thing. All I'm going to do here is come down here, put new deaths, new cases, and then we'll go through new recoveries, and then finally new deaths. And let me execute this. So as you can see here, this is the new deaths that we have, and this is something that we can say something happened in like past 24 hours. So the total number of cases over here, if you see, is been the total number of new cases is somewhere around 52%. Okay, and the number of people that have recovered is also 46, which is pretty good. And we can see we have very few fatalities all over the globe. This is not something related to a particular country. This is something with respect to the entire world. And now finally coming down, let's also take the column that we have added here, that is the percentage increase in cases, this one. And even this would be with respect to the virus. So here what I'm going to do is, instead of going through this entire stuff, like instead of plotting something like this, what I'll do is I will just plot a bar graph, like the one which we are kind of used to it. So let's kind of fix that up. A few things that would remain the same over here is gonna be, okay, so what we'll do is, although few things would remain the same, let's create a new data frame from the start. Okay, so we have percentage, right? So PER. So let's say percentage increase in cases. So this will be NP dot round. All right, and we want to round off the figures, so we'll have a data frame, and here we'll take increase in cases, increase in recoveries, and increase in deaths. So I will just copy it from here. So increase in cases, recoveries, and deaths, right? So let me copy this and paste it over here. So let me enclose this within a semicolon. And let me give a comma over here. Okay. And now as I want the data over here, so what I'll do is dot LOC of 0. And the decimal places that I want this thing to be is 2. Fine. And now we'll say something like data frame. Okay. So we'll put this in a form of a data frame. So PD dot data frame, and we'll just pass percentage, right? Okay, before that, let's see how this would look like. Okay, now what I want to do is I want to add the percentage of the cases. So dot columns, and the name of the column that I'm going to give here is percentage. All right, and now let's try to plot this up. So we have the same drill. We have figure, and then we'll try using a different graph. So here we go dot figure. We've created an object here, and now we'll add the value. So fig dot add. So we need a bar plot. So go dot bar. Okay, and here we are going to pass the values. So X over here will be the index value. So this is PER underscore DF dot index. And then we have Y is equal to PER underscore DF and percentage, right? And the color that we want over here, because we have 3 values. So let's say marker color. So this will be like yellow. Then we can just give some random value like blue, and then red. And let's kind of show how this figure would look like. Figure dot show. And let's execute this. Okay, so we might have done a small typo here. So let me just copy this and paste it over here. And let's execute this now. Oh yeah, the reason why we are getting this error is because we have done the same mistake. So columns, and it should work now. Okay, so as you can see here, we are getting the percentage increase in data over here. So the number of cases that have increased is by 0.57, that is 57%. And then we have 45% increase in the deaths. That's pretty bad. And the number of recoveries is around 60%. Okay, so this is good. Like although number of increase in cases is kind of high, but as long as number of people are recovering is greater than increasing in the cases, I would say it's a pretty good figure to work with. So as of now, we were working on general visualization of our data. So now what we'll do is, let's go a bit specific. Let's go have a visualization with respect to continent, right? So let me give here as with respect to continent. So CON, okay, and let me execute this. Let me add few more cells, and yeah. So now what I'm going to do is I'm going to create a data frame. Let's say continent, and this will be a data frame. So if I have to get the continent name, we obviously don't have a number of continents, okay? So what I can do here is we can just use group by clause, and with that I can just get the continents that are similar in name. So what I'm going to do here is df, which is our data frame, dot group by continent, and then we'll do sum, and then we'll just do drop all. So if you remember, somewhere over here I just added an extra data to our data frame. So what I'll do is I will just restart our kernel and run all the cells, okay? So what this would do is this will just reset the previous values that we might have done, and there's something which is expected when you are trying to work with the Jupyter notebook. So now that we have done with that, so let me quickly fix this up. Okay, and let's see how this continent df looks like. So basically what we have done here is, based on the continent, we have just got 6 rows now, right? Because everything, all the data over here is being combined as one. So now what I'm going to do is, let's kind of plot this with respect to the continent. And apart from this, I would also like to have index. That would really help me out when I'm trying to plot this. Okay, so continent df dot reset index, and let's execute this. So now we have this index over here, and now what we'll do is we'll just try to create a function which would just plot out the given data. Okay, so here if you remember, we hard coded each and every values. Same over here, we hard coded each and every lines of code and pass the data explicitly, right? So now what we'll do is, moving ahead, we'll just create one function, and based on this function, all we need to do is pass out the list of data, and with respect to that particular list of data, we will get the output. Okay, so for this we'll say def continent visualization, and here we'll just take the list, so we'll say vlist. So list here, over here, vlist over here will take list of data that you would like to visualize. So if I say total number of cases, so it would visualize the total number of cases with respect to that continent, right? And now what I'm going to do here is for label in vlist. Okay, so now once I have this, so let's say something like c underscore def, so df, so we'll say continent data frame, and here inside this we'll take the continent column, and then we'll also take the label. And now we also need the percentage, and we'll round the figure up, so np dot round, and we'll just say 100 times cdef, wherein we will take the label, and then we'll divide this by np dot sum c underscore label. Okay, this label over here represents whatever the data we want. Okay, so it can be like total deaths, total cases, or whatever it is, and we want it by up to 2 decimal places. And similar to what we did earlier, we'll also add virus column, so will be virus, and this would basically be nothing but a list wherein it says COVID-19 K for I in range. This would be equal to the length of the CDEF. And similarly, what I can do is we just have to plot the graph. So let me just copy the code from here so that we don't waste our time on typing the code. So let me just copy this from here. and paste it over here. Okay, and all we need to do is we'll just change this to C_def. And here we're going to pass with respect to continent, because we have like 6 continents, and with respect to that we will get the different colors. So now what's going to happen is this would basically take, this function will take up list of values that you would like to take. So the list of values can be like total cases, new cases, total deaths, or the new deaths. It totally depends upon that. To give you a better understanding, what I'll do is let me also add up a label here. So we'll know what we are, trying to display. So fig.update underscore layout. And over here we'll give something like title. So this will take up a text, and within this text I'll just pass out the label values. And let's kind of execute this now. So now what we'll do is we just have to pass the list of values, right? So let's create some list of values. So let's say something like we want it with respect to the cases list. Okay, so over here it'll be like total number of cases, total number of active cases, new cases, what is the severity of that particular cases, and then finally we'll also look at the total number of cases per million. So let me just do that. So cases underscore list, and this would basically be a list. And apart from that, we'll also see with respect to the deaths. Okay, and then we have number of recoveries or recovered tests. So this will be like this. So let's see, as I mentioned earlier, over here we'll be passing total number of cases, and then we'll have active cases, and then we have new cases, then number of severe or critical cases. So I can just copy this from here. Fine, and then we'll also need total number of cases per million, right? So let me copy this and put it down over here. And similarly, what I'm going to do for deaths, so let's also take up the values for deaths, that is the total deaths. So let me copy this and put it down here. Okay, after deaths, then we'll take a new list of new deaths. So over here, all of these is with respect to continent. So let me paste it down, and then let's see which one we can take. We can take deaths per million, right? So deaths per million, where is the deaths? Yeah, we have deaths per million over here. And let's also take up the recovered list. So if I see here, we can say total number of people recovered and newly recovered. So you can say, we can just copy this too and copy this. If you want, we can add percentage increase in recoveries, right? So it's totally up to you. Let me just add this here. Let's also plot percentage increase in recovered people. And now what we are going to do is, let me execute this. We'll just call this function, okay, continent visualization. And now only thing that we have left to do is pass this list value. For this, what I'm going to do is let me rerun the cells from the start, and let's see what happens. Only reason why we might be getting this is because we might be adding some new data here. So let me kind of fix that up. So the reason why we're getting this error is over here, percentage, right? So let me execute this once again. So as you can see here, we will get a list. And as a matter of fact, we'll not just get one graph, we'll get the graph over here with respect to total cases, total number of active cases, new cases, serious or critical, and total number of cases per million. So as you can see, this is for the total cases. So it's here with respect to the different continents. So let me kind of zoom out. So if you can see here, we have Africa, Asia, then we have Australia, Europe, North America, and South America. And by this, we can figure out the highest number of cases over here are in Europe. Like if you take up the total, then it's 30%. And then next comes Asia, which is 24%. And the percentage in Africa is around 3% of total cases. And in North America, it takes up 26%. And South America out to 16%. So this is a total number of cases. And let's see what happens when you take active cases, right? So if you see active cases, the active cases is highest when it comes to North America. That's especially US, right? And then the second highest can be somewhere like, second highest is, there's a competition between Asia and Europe, but as of now Europe is taking the second place, that is 25%, and then we have Asia with 22%. And then if you want to see the number of new cases that is happening, you can see Asia is being leading over here. What we can figure out with this graph is, in the early days, the number of cases were pretty high in other places or other continents, but now with the second wave out there is a rapid increase in cases, especially when it comes to Asia. So you can see it's 54%, and next we have South America, then we have Europe, and as you can see, the new cases in US or the North America has dramatically decreased. And when it comes to Australia, you can say, or when it comes to Africa, you can say it's just 1.3%. So we can say safely that there are no new cases, not many. And if you see here, we cannot see this Australia, right? So with this, we can say that there are negligible amount of new cases in Australia. And when we see here with respect to serious or critical, more serious conditions are in Europe, and then comes Asia, and then we have South America. And total number of cases, when we say per million, is highest in Europe. Okay, so 50% of it, that is 50% of the people have been affected. And then we have 16% in Asia, and then North America taking 16.62%. So Asia and North US or North America is almost, toe to toe. Okay, so now we saw how we can plot it with respect to continent, right? Let's narrow down our vision. So we'll now try plotting the content or plotting the data with respect to the country. Okay, so let me quickly give a comment here. So let me give some space, and with respect to countries, okay, let me give this as a markdown and countries. So first off, we'll create data frame here. So df is equal to df.drop. So we don't want the first one, because the first one is the world data. So if you see out this here, the 0th index over here refers to the world data. So world is obviously not a name of a country. So we'll try to drop this, and we'll take rest of the other countries, right? So let us quickly get that done. -1. And then we'll say country df. And this would be df.drop 0. Okay, so this is supposed to be in this braces, and yeah. So now if you see our country df, so you'll see now we have the world data is missing. And yeah, so over here, if you can see, we have 210 rows, that is 210 number of countries, and the columns over here is going to be 18, that is number of features, right? And now what I'm going to do is I'm just going to create a data frame and straightly get down for looking into the top 5 countries that are affected with COVID. Okay, so we'll say country, and we need columns, and except the 0th one, because 0th one over here represents the name of the country, so we'll take except that. So that is 1 to 14. And the reason I'm taking 14 is because I personally don't need this. I don't need the continent or percentage increase in this. I just need the population one. And now we'll have to create a figure object. So fig is equal to go.figure, and now we'll say c is equal to 0. So now we have to put for I in country df dot index. And now what I'm doing is if c less than lookat. So lookat is a variable that we'll define here. So this variable over here basically represents how many countries you want to see, like top 5 countries, top 3 countries. So it goes through each and every country. So fig dot add trace, and now here we'll go for like go dot bar graph, and then the name, that is the name over here is going to be country df, and we'll pass country of which index, of the ith index. Okay, and now similarly what I'm going to do is we have to give the label for that x. So this will be country, and now y, this will be country df dot loc of I, and then we have 1 to 14. So if or else, if the condition satisfies, then break. And every time this happens, I want to increase the value of C. Kind of let me zoom in. And now what we'll do is we'll update the figure, that is just giving the title. So fig.update. So we have to update the layout. So update layout. So here we'll give the title. And this would be nothing but text. And the data over here is gonna be lookup. And now all we'll do is fig.show. I think this should be fine. Okay. And now we have to just have this lookup, right? So lookup. We'll give here top 5. So okay. And let's execute this. Now the reason why we are getting this is because few of the values here are dwarfing over the other values. Okay, so as you can see here, the population value is pretty huge compared to other values. So what I'll do is, instead of just taking the numerical data, I'll convert this into the form of a log. Okay, so if I do that, what's going to happen is all the data would get normalized, and then we can see something nice. Okay, so let me first, what I'm going to do is top countries affected. Okay, so this is one thing that I've changed. And apart from that, what I would like to do is I'll also add a couple of parameters here. So here it's gonna be something like y-axis underscore type, and we'll give here as log. And yeah, I think this should do. So let me execute this. So now, as you can see, once I converted this in the form of a log, the thing is the data has been normalized. Okay, so if you know the log graph, it doesn't increase like all of a sudden. So now what can I do over here? So what am I seeing here? So all this is saying is the top 5 countries that are being affected. Okay, first off we have US. So this is US, and then we have India over here, and then we have Brazil, France, and Russia. And over here we have total number of cases. The total number of cases won't be of that help. The important thing over here to see is the new cases. So you can see here the total number of new cases are increasing in India. Okay, and the population of India is around 1.39 billion. And if I have to see, if we can see here, almost 10 million of those people have been affected here. And number of recoveries, okay, or the new recoveries, you can see over here. So if I have to compare the new cases with new recoveries, I would say, yes, we are right on track. I mean, if we say, if the total number of new cases and total number of new recoveries are almost tip to toe, or new recoveries is better, that means there's be a less stress on the medical agencies over here. Okay. And yeah, so the total number of tests that have been performed per million, you can see US and Brazil is ranking over here, or the France is ranking over here. And then the number of deaths in India is surprisingly very low. Okay, so deaths per million is 131, so which is very low, I would say. And the total deaths, although we are suffering, are quite high, but the new deaths you can see over here, it's not that much. And you can see here the highest number of deaths is there in Brazil. So this is how we can get it done. And another thing that I would like to show here, when we try to use Plotty, right, what I can do is, if I just click on USA, you will see here it's just the data it shows with respect to USA. So you can see here the total number of cases in US is this, and the population of US is this, and the total number of tests, if you can see here, like almost the entire population have been tested over here. And similarly, if I go here to India, so this is the population, and according to the data, the total tests that have been performed is this. You can say almost most of the people have been tested here. The total number of cases are high, but new cases are quite high. Okay, so we have like around 294,000 cases, but the deaths are quite low. Okay, and the recovery rate is kind of similar to the total number of new cases, so which is a good sign. And deaths per million we have pretty less, so we have 131 people dying for a million. So I mean, I do agree that even a single death is a calamity, but yeah, we are doing better with respect to other countries. Like if you look into the data for France, so you can see here deaths per a million is 1,554. And similarly, let's see for Russia. Okay, even Russia is like 728. So like if I want to see top 10 countries, you can even look at that. So now you get the top 10 countries, and if you just want to look at top 2 countries or top 3 countries, so now you'll get just top 3 countries, that is India, US and Brazil.
Now, as I told you that I'll be predicting the world's best and strongest 11 players taking part in this FIFA World Cup, and I would be using Python for the analytical implementation. So I'll start this analysis by first analyzing the world's best goalkeeper, then 4 best defenders, 3 best midfielders and 3 best attackers. So if you notice over here, I'm following a 4-3-3 lineup. Well, it's often said that 4-3-3 is the best lineup, but obviously it is not fixed. So based on my players availability, I have choose this lineup as 4-3-3. So guys, it's totally up to you. You can choose any position you want. Now, as I've said guys that I'll be using a 4-3-3 position. So here I have 4 defenders, red marked as 3 midfielders, blue marked as 3 attackers, and mustard orange for a goalkeeper. So if you notice over here, I have a question mark on all these positions. Now why? Because this exactly my problem statement is. That is, I need to find out the players who will play the best in these respective positions. So this sounds pretty interesting, right? So let's begin an analysis. So here I'll be following 5 steps wherein I'll first load my dataset and then import the required libraries. Now I'll be using FIFA dataset from Kaggle. So don't worry about the dataset guys, I'll be mentioning the link of Kaggle website in the description below. So once you have loaded the dataset and imported all the required libraries, we'll then analyze it, explore the dataset, and then we'll figure out the best goalkeeper, the best defender, best midfielders, and best attackers. So let us go through all these steps one by one. Now my very first step is to collect, or you can say load the dataset and then analyze it. So if you notice over here, I have a screenshot which displays the dataset. So over here I have the name of the player, I have the nationality, that is the country he belongs to. Then I have the national position in which the player plays at the national level. Then we have the national kit, we have club position, club kit, and we have so many others like that. So this is a dataset which is provided by Kaggle. So I'll just mention this in my description box and you can just download the dataset from there. Now I'll be using different libraries as well. So over here I'll be using Pandas for data analysis, manipulation, cleaning and all those stuff. Then I'll be using Numpy for the scientific computation part and Matplotlib and Seaborn for visualizing plots. So in this step I'll be just loading my dataset and then importing the required libraries. So let me just go to my Jupyter notebook and let us implement all these steps one by one. So guys, this is my Jupyter notebook. Now, as you can see, we need to figure out the world's best playing 11. So over here, I have first imported all my libraries, that is import pandas as PD, then Seaborn as SNS, NumPy as NP, and then I've imported Matplotlib. And then I've just written percentage Matplotlib inline, that is to visualize the plots in the Jupyter notebook itself. Then what I've done, I have just read my dataset. So the name of my dataset is full data. Now using pandas, I have read the CSV and then displayed the top 7 rows. So over here I have already discussed that the dataset contains the columns such as names, nationality, national positions, and we have so many like that. So here I have just printed 7 rows and if you notice that we have 53 columns over here. So you can just go through it, explore, do experiment with them and gain insights out of them. So here if you see you have characteristics of all the players and their score. So you can just go ahead, download this dataset and explore as much as you can. Now, analyzing this huge dataset is a tedious task as it involves quite a few pre-processing steps as well. Now, there might be a lot of redundant and unwanted columns which you may want to remove. Therefore, you can delete certain columns if needed. So, let me show you that as well. So, here what I have done, I have deleted one column that is national kit. So, I don't require the column as national kit. So, what I'll do, I'll say delete. So, I'll just write DEL. DF is the name where I have stored my dataset and then I have just mentioned the column name. Over here, I don't want the national kit column. So I've just write this and then I've just printed the head of it. So once I run this, you'll see that the national kit column no longer exists. And if you notice, I just have 5 rows and 52 columns, whereas in totality, we were having 53 columns. Similarly, you can delete as many columns as you want. You can actually do a lot of transformation. You can remove the null values, that is nothing but the cleaning of data. So you can do the analysis on your dataset as well. So I'll just leave this part on you. So you can just go ahead and analyze as much as you can. Now once you have simplified this data, you can then start with the analysis part. So to explore, or you can say analyze your data, the best thing you can do is to visualize the data in the form of plots. So what happens with that is you can easily read out your conclusions. You don't have to calculate a lot of things. You don't have to play with numbers, in fact. You can simply see that, okay, this has the highest peak, means this is the most likely outcome to be happen. So that is how you can visualize everything using Matplotlib and Seaborn libraries. So here what I have done, I have plotted a simple count plot which basically gives me the number of players representing a particular country. So over here I have count plot, and on the y-axis I have the nationality, and on the x-axis I have the count, that is the players count. So as you can see here from the graph, you can easily conclude that most of the players are from England, then from Argentina, Spain, France, Brazil, and the list goes on. Now these graphs are best used to gain statistical insights. So you can just go ahead, plot with different columns and analyze your data set. Now in this case, the graph won't add a lot of value because we would be picking the best 11 and the results may vary accordingly. So these graphs are just for analysis part. So over here, the results that we got is purely dependent on your data set. So right now I'm getting the maximum count from England and then from the Argentina. So guys, don't take it personally. It's just displaying what my data set contains. Now moving ahead with the analysis, you can try out different visualization. Let's say with the player's age, with the preferred position he plays, then the rating of it, then the club he is, and you have a lot more columns like that. So let me show you one more visualization and then we'll switch to an analysis of fetching the best playing 11 for the World Cup. So here I have again plotted a count plot wherein I have the player's age on the x-axis and the count on the y-axis. So here it is quite evident that the majority of players are between the age 20 to 29 and it has the largest peak at 25 years. So that is how you can conclude a lot of other things by just going through your dataset and taking up different columns and plotting different graphs with them. So now is the time we try and find answer to the question we put forth in the problem statement. That is, who will be the world's best playing 11? So let us begin our analysis. So as discussed earlier as well, I'll be using a 4-3-3 lineup, which means we need to find 4 best defenders, 3 best midfielders, and 3 best attackers. And we'll be having one goalkeeper as well. So let us start our quest by finding a goalkeeper first. Now over here, as you can see, I have assigned some weights to these variables. So if you notice over here, I have given the minimum weight of 0.5 to the variable A, then I've given B as 1, C as 2, and the maximum weightage 3 to the variable D. Now I'll be telling you why we have assigned these weights and when we will be using these as well. Now in order to find the best goalkeeper, what I'll be doing, I'll be analyzing the data for the 2 parameters, that is the shot stopper and the sweeper. So a shot stopper is a goalkeeper who is strong in stopping the shots taken by the opponents, whereas a sweeper is a player who is quite strong in playing with his feet and making the passes. So that is why I have taken these 2 characteristics and then assigned all the weightage to the characteristics. Now in my dataset, I have various features such as we have reactions, we have a column of composure, we have the column of speed, strength, and we have many other features like that. Now that is why I've assigned weights to it. Now in short stopper, what I'll be doing, I'll be giving weightage to all these characteristics. So let's say I'm giving the weightage of A to the speed. Now A is the minimum weightage. And similarly, if you see for sweeper, I'm giving a bit higher value to the sweeper. Now why? Because sweeper is the one who sweeps up the ball if an opponent manages to breach the defensive line. So that is why I've given B weightage to him. Similarly for jumping, I've given C weightage for short stopper and I've given lesser weightage for sweeper. Then moving ahead, I've given the D weightage, which is the maximum weightage to the reflexes. So both the characteristics, either it is short stopper or a sweeper, both must be having very good reflexes. So that is why I've given the weightage D to both of them. So that is how you can assign weights to all of them. And then what you can do, you can simply plot them and then pick the best one. So what I'll be doing, I'll be first plotting my short stopper. Now over here, what I have done, I have simply plotted a bar plot wherein I'll be passing the variable that is GK short stopper, and then using the function sort values, we have arranged them in the descending order, and then I just want the top 5 of them. Then on my x-axis, I have the name of the players, and on the y-axis, I have the short stopper score. So based on these parameters, you'll get a graph somewhat like this. Now, it is quite evident from this graph that Manuel Neuer is the best goalkeeper. As you can see, he tops this chart. Now let us plot the other parameter, that was sweeper. So I'll just copy the same code. I'll just pass in the value that is GK sweeper and then pass the same in my sort values function and then arrange them in the descending order for the first top 5. So over here again, we have the player's name on the x-axis and we have the sweeper score on the y-axis. So as you can see over here, Manuel Neuer tops the chart here as well. So based on these two parameters, we conclude that Manuel Neuer would be the best choice goalkeeper for this World Cup. So by going through the two characteristics, that was shot stopper and sweeper, we came to a conclusion that Manuel Neuer is my best choice for a goalkeeper. So let me just go back to my presentation and let's see what all we have covered. So we have seen this, we have collected the data and we have imported the required libraries. Then what we have done, we have analyzed the data, we explored the data set wherein we have plotted two count plots, one with the nationality and the other one with the age. So by plotting these two graphs, you basically find out a relationship between one variable, or you can say one column and another column, and then you can predict better results. So analysis, exploring a data set and visualizing them brings you a lot of insight. So you should definitely do that. Now, I've already told you that you can go through the data set, you will find a lot of columns, you can just pick up the ones which are relevant for you, and then you can start your analysis on that. Next, my second step was to analyze my best goalkeeper. So over here, I have plotted two graphs, one with a shot stopping score and the other with the sweeping score. So as I told you guys that a shot stopper who is quite strong in stopping the shots taken by the opponents, whereas the sweeper is the one who is strong in playing with his feet and making the passes. Now, when we plot these two graphs, we come to a conclusion that Manuel Neuer is the best goalkeeper for this FIFA World Cup, and hence we chose him. Now, next in our quest to find the world's best playing 11, it's time we choose some defenders as well. Now, in order to find the best defenders, I'll be using these attributes to fetch the best defenders. So as per my position, I am using 4-3-3. So I need to fetch 4 defenders. So here I'll be fetching 2 center backs and 2 wing backs. So in center backs, we need 2 center backs, that is one who plays from the left and the one who plays from the right. So here we have LCB and we have RCB. Just the positioning is different. Then we have wing back. So again we need 2 wing backs, one who plays on the left hand side and the other who plays on the right. And based on these parameters, I'll be predicting the 4 best defenders. So let me go back to my Jupyter notebook and let us plot each one of them and find out who are my best defenders. So as discussed guys, I have taken DF center backs, that is defender center back and defender wing backs. Now I'll be using the same characteristics for left center back and for right center back. And I'll just change the positioning. Let's say I want to know the who is my best left center back, so I'll give the position as LCB. And if I want to know the right center back, I'll give the position as RCB, that is right center back. So that is how you can sort the players by assigning the positions to them. Now, if I have to calculate the center back, I should know that they should be having a high defending capabilities. So the interception, the tackling power, the jumping, then your stamina, marking, all these things should be high. So if you see over here, I have my sliding tackle and standing tackle as D, which is the highest weightage. So that is why I've assigned the weight D to them. Similarly, I've given D to marking as well, then to heading as well. So that is how you can give weights to all of the parameters. Now for wingbacks as well, you must be having high defending capabilities. So the interception should be high, the tackling power should be high. So here also I've given the standing tackle and sliding tackle as the weightage of D. Then I've given acceleration to D. And let's say finishing to A, because a wing back is not that involved in finishing. So that is why I've given the lowest weight, that is A. So now is the time we plot the center backs. So here first we'll plot the left central back. So over here if you see, I've given the position as LCB and then it's the same code guys. I've just passed in the values of center back, and using the sort value function, I have arranged them in descending values and I need to print the only top 5 values. Then on my x-axis I have the name and on the y-axis I have the score of this. Also notice guys that I have given a position LCB, that is the club position. So if you have explored the dataset, you can actually take any other column. Let's say you also have a column of national position. So you can take up that position and then you can find out the results. But for now I have used the club position because the player plays the best in the club. So that is why I have taken club position. Now you can go ahead with the national position as well and then you can perform the analysis. So guys, this is my list based on these parameters. So you can just go ahead, analyze the dataset and you can actually do wonders with the dataset. Now, if I see the result of this particular graph, I have Sergio Ramos as my best left central back. Now, let me plot the right central back as well. So over here, I'll be giving the club position as RCB and then the whole code is the same. So let me just see the result. So my best right central back is Cesar Ekpilicueta. So now, next let's move ahead and plot the wing backs as well. So over here, let me plot the left wing back. So here I'll be giving the position as left LWB or you can say LB. So LWB stands for left wing back and or you can say left back. And then it's the same exact code. Over here, my left winger or you can say left wing back is David Alaba. Since David Alaba's team does not qualify in this World Cup 2018, So I'll be picking up Alexandro as the best left winger defender. Then it's time to plot the right wing back as well. So over here I have given the position as RWB, or you can say right back. So as per this analysis, it is evident that Kyle Walker is the best right wing back for the World Cup. So that is how we have calculated the four best defenders, that is two central backs and two wing backs. Having said that, I got a list of my four best defenders. So let me just go back to my presentation and show you them as well. So over here, I got the result as left wing back as Alexandro. Then we have central back as Sergio Ramos. Then we have right central back as Cesar Espilicueta. And we have the right wing back as Kyle Walker. So moving ahead with the world's best playing 11, it's time we choose some midfielders as well. So as per the game formation that was 4-3-3, I have to choose three midfielders. Now in order to find these, I'll be analyzing the data for these parameters. So over here I have a controller, a playmaker and a beast. Let me explain you these terms. Now a controller is the person who is orchestrating your midfield engine by either sitting back or going forward based on the dynamic need. Secondly, we have a playmaker. So a playmaker is someone who will move the ball to the attacking from defense, or you can say midfield. Then we have a beast. So a beast is a typical box to box player with loads of energy and who can basically boss the midfield. So that is how I have categorized the midfielder in terms of controller, playmaker and a beast. So let me just go back to my Jupyter notebook and let us implement and give weightage to all the characteristics. So as discussed, we have a controller, a playmaker and a beast. Now when I talk about controller, I have given the position of controller as LCM, or you can say left midfielder. The controller must be good in passing the ball, then you have dribbling. So basically the characteristics that involves the highest weightage is ball control, then you have composure, you have short pass, long pass and all those things. So if you see over here in controller, I have given D weightage to the ball control, then we have short pass, long pass, so we have given that weightage. Then we have a playmaker. So a playmaker is someone who will move the ball to the attacking from the defense or midfield. So a playmaker must be having good dribbling. The agility should be very high. Then the ball control. Then you can say short pass and long pass. Everything should be high. So over here I've given D weightage to the ball control. Then D for the dribbling. Then for the short pass, long pass, and similarly you can assign weightage to all the relevant characteristics. Then we have a beast. So a beast is basically a box to box player with lots of energy and basically who can boss the midfield. So he is the one who will be playing from the position that is RCM, or you can say RM. So he'll be becoming a right central midfielder. Now in order to find the best beast, what should be his plus point? So I want that beast to be strong in defending as well as physical. So in defending you have interception, strength, tackling power. Then in physical you have the speed, stamina, agility and all those characteristics. So I have given here D weightage to the agility. Then it must be having good stamina. So I've given D weightage again. And similarly, I have assigned the weightage for the relevant characteristics. So over here, I have just assigned the weightage of all these three, and now is the time you need to plot them. So the very first plot is to plot a controller. Now when I talk about controller, I told you that I'll be giving the position of LCM, that is the left control midfielder, or you can say LM. So over here, I have just added one column that is club position, LCM or LM, and then I have just sorted the values. So as per this analysis, I'm getting the best controller or the best left controller midfielder is Iniesta. Next, what I'll do, I'll be plotting playmaker as well. So in playmaker, I want the position as CAM, that is center attacking midfield, or LAM, that is left attacking midfield. So over here, let us see the results. So the best playmaker, or you can say the best center attacking midfielder is Mesut Ozil. So we have already come to two best midfielders. That was Iniesta and Ozil. Next we need to plot the beast. So over here I've given the position as RCM or RM and then we have just plotted it. So let me just see the results. So over here, so as per the analysis, I'm getting Kante as the best beast, or you can say the right central midfielder. So here we have completed a hunt of finding the best three midfielders. So let me just go back to the presentation and let me show you them as well. So here I have the controller, or you can say the left midfielder as Iniesta. Then I have the playmaker as Ozil, and we have the beast, or you can say the right central midfielder as Kante. So now we are done with the best goalkeeper, we are done with the best defenders, and we are done with the best midfielders. So now is the time we find some attackers as well. Now in order to find the best attacker, I'll be plotting the three graphs, which is for left wing attacker, then for right wing attacker, and one for the striker. So a left wing attacker is a player who attacks from the left flank, then a right wing is the player who attacks from the right flank, and a striker is the one who attacks from the center. So let me just go to my Jupyter notebook and let us assign weightage and then let's see the results. So over here I have three positions, that is left wing, right wing and a striker. So in order to have a best left wing, he must be having strong pace. Then he should also be good in shooting, or you can say passing. So basically the attributes that contributes him is acceleration, speed, then the finishing of it, then crossing. So all these things are the characteristics. So here I have given the acceleration D. Then I've also given the finishing as D because attackers must be having high finishing and also the shooting capabilities. Now I have allocated both these characteristics as same because a left wing and a right wing both have the same capabilities. It's just the positioning difference. Over here if you notice I have given the same weightage to each one of them. And then when I'll be going to plot, I'll be just specifying the position to left wing and to right wing. Then comes my striker. So a striker is the one who should be good in dribbling, he should be good in ball control, reactions, then the finishing also should be high, the balance should be high. So all these things are the characteristics of a striker. So here we have ball control, then we have the balance. So here we have given the weightage D. Then we have high finishing. So again the weightage D. For heading also we have given D. And we have similarly assigned weightage to all the other characteristics. So now let us go ahead and plot each one of them. So here we have the very first graph which basically plots the left wing. So here I have given the position as LW, LM or LS. So on the x-axis I have the player's name and on the y I have the score. So now let me just see the results. So it's quite evident that the best left wing is Ronaldo. And now let me just plot the right wing as well. So over here I have given the position as RW, RM and RS. So I'll go to the results. Alright, so I'm getting Messi as the best right wing attacker. So here we have the left best attacker as Ronaldo and we have the right wing as Messi. Now comes the striker. So here I have just given the position striker to ST, or you can say left striker or right striker. So let me just plot this as well. So as per analysis, we are getting Robert Lewandowski as the best striker. So that is how we have calculated the best three attackers. That was Ronaldo, Messi and Lewandowski. So on my left hand side, we have left wing as Cristiano Ronaldo. Then on the right wing, we have Messi and striker as Lewandowski. We now have the best goalkeeper, 4 best defenders, 3 best midfielders and 3 best attackers. So let me just show you the complete picture of my analysis. So these are the world's best playing 11 for the FIFA World Cup in the 4-3-3 position. So here I started from choosing the best goalkeeper that comes out to Manuel Neuer. Then we have picked up 4 best defenders. So my left wing was Alexandro, then it was Ramos, Cesar and Kyle Walker. Then we have gone ahead with analysis and then we chose the best 3 midfielders. So the midfielders that came out were Iniesta, Ozil and Kante. And finally towards the end, we have analyzed the best attackers as well. So on the left hand side we have Ronaldo, on the right hand side we have Messi and on the striking we have Lewandowski. So I hope you guys like these results.
Now let's start out by understanding what exactly is a recession. Yes? Now many economists say that we are overdue for a recession. Despite a low unemployment rate and the economy's longest expansion on record, experts and the World Bank point to trade wars and other globally financial risky situations as reasons for a dim forecast. In economics, a recession is a business cycle contraction where there is a general decline in economic activity. Recessions generally occur when there is a widespread drop in spending, which leads to an adverse demand shock. So basically, it will cause an increasing deficit and lowering interest rates all over the world. And hence, it's going to significantly affect employment, salaries, jobs across industries. Across most of the IT sector, the major cuts in salaries and jobs are more likely to happen in consumer focused sectors, including hospitality, tourism, and non essential retail. As these sectors have seen an acute fall in demand because of the lockdowns across different countries, they are expected to recover and reach pre recession revenue parity in 3 or 4 quarters of operations resumed. Now, while that is the case for most of the domains, research states that the impact of the ongoing recession on the analytics domain on a whole may not be as severe as its impact on various other sectors. The broader quantifiable impact of the recession on salaries across analytics can only be measured after a few months of the recession. By then, the impact of the recession on operations costs and demand for products and services would be felt across industries and organizations. Across the IT sector, Even if the global and domestic economies have persistently slowed down, the impact of the current demand on overall operations would still be less significant as this sector provides strategic value to its global clients and consumers. So let's move on and try and understand what the Great Recession was, what it entailed, and what did we infer from that episode. Firstly, let's take a little time to cover what happened in the Great Recession of 2007-2008. The 2007 financial contagion and the subsequent Great Recession resulted in the loss of tens of millions of jobs, out of which 7 million were in the United States alone. The map that you see in front of you shows just how much it had affected each country across the globe, the red ones being the most affected while the grayed out ones were the least. Average income started to drop and higher government borrowing started to occur. The prices of the stocks and properties also fell, taking a real hit on the GDP worldwide. But here's the catch. The financial contraction did not treat all jobs equally. Nearly 80% of job losses occurred amongst workers with a high school education or lower. The remaining losses occurred amongst workers with some collegiate or associate degrees. The recovery from the Great Recession had been equally difficult for low-skilled workers and those without college credentials, since the recession accelerated the transition to a knowledge-based digital economy that rewarded high skill and college credentials. Nearly two-thirds of the 8.4 million jobs that were created during the recovery required at least a bachelor's degree, and nearly all of the remaining jobs required some sort of collegiate or associate degree. Only about a third of the new jobs required a high school degree or lower. Signs of the demand of the digital skills appeared as early as 2011. Data-driven industries were called the next frontier for innovation, competition, and productivity, which projected not only a shortfall of 200,000 data scientists, but also a deficit of 1.5 million analytics-enabled managers, and the talent gap was significant in the minds of employers. Let's move ahead and try and understand what you could infer from this Great Recession. What did we learn from this recession? Number one, a talent gap persists that is most likely to extend into the next decade. The 2016 Education and Workforce Survey identified the relevance and the need for analytic skills as crucial. 94% of employers said that these skills are very or somewhat relevant to the current job openings of their companies. 89% cited finding qualified applicants in this field as very problematic. And note that in both cases, these skills are the second most relevant and problematic field among 6 other science, technology, engineering, and math or STEM fields, illustrating that the need for analytic skills is particularly acute even within the larger STEM shortage. The next thing that we learned is that the majority of the job openings demanded for analytics-enabled professionals. Analytics-enabled professionals, including functional analysts, basically the people who use data and analytical models to inform domain-specific functions and business decisions, and data-driven decision makers, basically people who leverage data to inform strategic and operational decisions, represent nearly 70% of all job postings. The demand for these professionals are scattered across jobs of all domains. Jobs for analytics-enabled professionals represented two-thirds or more in many sectors. And this demand is not limited to the technology or professional sectors alone, but also demonstrated in finance, health, manufacturing, and retail. The next thing that we learn, and also the most important in my opinion, is that structured talent acquisition need not necessarily work for the digital economy. As the march towards digitalization continues forward, new approaches to talent recruitment and development of incumbent employees will be needed. These approaches must be defined less by traditional career tracks such as collegiate grades and more by their set of data-driven and analytical skills which needed to build cohesive, multidisciplinary teams that can deliver business results. Companies started to invest in market-driven programs for their employees, and also sponsor scholarships that linked learning with work in colleges. When creating a new undergraduate program, colleges try to create partnerships with business that made the learning meaningful in real world ways. This often meant encouraging employees at the funding company to become involved in the program or expanded funded research to include undergraduate education. Think about moving from a transactional relationship between business and higher education to a more strategic partnership where both parties are involved in meaningful ways. Strategic investments in digital data driven technologies are not likely to live up to their potential unless companies align their people and cultures with their strategies in more systematic ways. This, in turn, modernized education, training, and development for long term employability. Which brings me to my fourth and final point, which is to expand the pathways that lead to a more analytical workforce across the domains. The key to developing new capabilities in the workforce was to offer employees the opportunity to build skills in new technology areas, followed by job rotations and on job development programs to apply and practice these new skills. Employees were also motivated by the opportunity to expand their technical expertise and recognize the value of the investment that the company makes in their careers. Later, if not sooner, people started to invest themselves into learning new technologies to build a strong repertoire. All majors required some sort of foundational knowledge of data analytics and data science process. Data visualization is a great example of such knowledge. It fuses the art and science of helping students to use data to express themselves in creative ways, and also gaining insights from the data that they have acquired. In the end, the broad adoption and effective use of data and analytics added hundreds of billions of dollars in productivity over a decade. However, closing the talent gap and ensuring diverse workforce was something which is still required to capture this value. Most importantly, data-driven skills must be broadly applied to meet the demand of the current industry. Given the demand, the basic competencies have an outsized impact on the global economy. As the world generates even greater amounts of data, data-driven talent will be needed at all levels. Next, let's see how analytics can help us during a global recession. In a recession, finding ways to do business and spend less money becomes paramount. Analytics may not be able to tell you exactly when the economy might shift. However, data analytics can certainly help an organization mitigate the impact of a recession by giving you the right information to better target the right market, save money, and increase profits. The companies that respond best to an economic recession are the ones that are most prepared for one. And the good news in this case is that there is always time to prepare. Some experts suggest that the best time for an organization to conduct a digital transformation is just before a recession hits, while others say that this transformation should be done when the slowdown in sales begin. In either of the cases, this change is necessary. Acting before a recession allows an organization to be proactive rather than reactive with its data. And since it could take time to put the necessary tools in place, depending on where your organization is with its technology, it's better to already have the tools to navigate the recession rather than wait until after the dust settles to start from scratch. Analytics help companies figure out which aspects of their businesses are most likely to thrive no matter what the global economic conditions are. It may require limited focus, but by using the data to pinpoint which products do well in certain markets, a company can direct its energies to the areas it knows will continue to sell well. If a company is able to identify through the data customers who enjoy a particular product, the enjoyment is likely to lessen even in a recession, and the organization is likely to see an increase in profit from a direct-to-customer approach. In the advent of a recession, data analytics and business intelligence help save time and money. Finding ways to do business and spend less amount of money becomes paramount. Advanced analytics tools can help organizations figure out what tasks can be automated. For example, BI tools can be used to focus on customer engagement, identifying which accounts have been communicated with and whether or not there are accounts that require attention. This will increase the customer retention of said company. You could also point to other economic efficiencies that the company can take advantage of. And even if the forecasts are wrong and a recession is further away than the experts predict, only good things can come from taking the time now to come up with a plan from when the record expansion shifts to a downturn. It never hurts to be prepared, right? And the data that might help a company survive a recession could help it thrive in the current climate state. Next, let's move on to the impact of recessions on the analytics market. Now, from an expense perspective, analytic applications for financial analysis, customer profitability, and especially corporate performance management are likely to be closely evaluated. Some analytic applications, such as those associated with campaign management, can help generate additional revenues while helping to monitor and control expenses. When the threat of a recession arises, every source of revenue must be considered. Astute business people will try to maximize the revenue potential from their existing customers while attempting to attract new ones. They will also seek ways to reduce expenses and determine which departments, programs, and initiatives are performing below expectations. After all, a penny saved is a penny earned, and a company can increase its profits by both generating new revenue as well as reducing expenses. Apart from that, some organizations, particularly those concerned with defense and homeland security, have needs that are relatively independent of economic landscape. These customers and prospects are likely to cut back on their plans for deploying additional tech, but tend to focus more on fraud attempts and security trouble. In times like these, fraud tends to become more prevalent, and analytics can be used to track and analyze these attempts, and data mining can then be used to predict common characteristics of those likely to be involved in fraudulent activities. The bottom line is that analytics is not a luxury item that an organization can defer to in hard times. Rather, it is an essential aspect that can be used to identify new revenue opportunities, prevent fraud, and identify unproductive expenditures. Hence, these requirements keep the analytics market afloat compared to other sister domains. As you can see in front of you, the post-recession, when jobs were created, in every single domain, there is a requirement of analytics-based jobs. You can see the numbers on your screen, where you can see the demand for data analytics and data science jobs by sector and by job category. We have your finance and insurance, healthcare and social assistance, information, manufacturing, professional, scientific and technical services, as well as retail trade. So currently the coronavirus or the COVID-19 outbreak is having a growing impact on the global economy. Several nations, including India, UK, South Korea and China, are under lockdown or just lifting up lockdowns, right? So these lockdowns, while effectively slowing the spread of the virus, are economically extremely harmful. The world is witnessing layoffs, furloughs, and pay cuts amidst the current financial crisis. So although a lot of tech and IT employees are feeling the heat, somehow the analytics sector is staying afloat during this phase. In fact, between February and March of 2020, job titles that included terms like data science and data analytics and machine learning were on track to increase by 11% at the time when the job postings for most occupations were falling. So let's go ahead and dig in a bit deeper, shall we? Let's look at how data analytics, big data, machine learning, and in general analytics trends work in every field. First of all, we have analytics in business. Now, analytics will help you save time and money. In a time like this, finding ways to do business and spend less money becomes paramount. Advanced analytics tools can help organizations figure out what tasks can be automated, how to retain customer engagement, and which aspects of business will thrive despite of the current economic climate. Business analytics makes extensive use of analytical modeling and numerical analysis, including explanatory and predictive modeling and a fact-based management to drive decision making. In such a case, analytics will develop new insights and help drive the business performance based on current and past recession data as well as statistical methods. According to a report in 2009, despite the recession been going on for the past year, the analytics market seemed to be booming. The reasons didn't seem to vary much. Basically, data analytics helped companies to not just identify cost savings but also grow profits. Not just that, a mid-year report found that data analytics and business intelligence software applications had the highest impact for companies over the next 2 to 5 years, pulling certain companies out of the post-recession hangover. It basically was a complete roadmap to understanding how data-driven decisions and analytics had been successfully able to insulate organizations from the effects of the economic recession. And that in itself is a great reason to why this market stays afloat despite the global recession. In biomedical research, so a lot of work is going on to try to develop a vaccine to find out whether there is any current drugs that work against the coronavirus. All of those projects require molecular modeling and analytics, and many of them are using machine learning and big data to map things we know about the virus in pharmacological databases and genomic databases. You can create models using these technologies that can eliminate false tracks and allow us to identify potential targets. So instead of trying 100 or 1,000 different things, researchers can now narrow it down to a much smaller size thanks to analytics, which will make the job much, much faster. This is going to accelerate the eventual finding of the vaccine. To make any real progress in this situation, you need to bring together people who understand computation and data, people who understand biological and biomedical implications, and people who understand statistics and population models. It's a very interdisciplinary problem, and to make any headway, the world needs data, and hence it needs big data professionals, analysts, and their academia. So the trained talent in the analytics industry obviously will stay afloat. Next, let's look at supply chain management and logistics. Now, from the shortages of personal protective equipment to a variety of grocery items to electronics and apparel, during any global recession, the global supply chain is expected to be hit in unexpected and unforeseen ways. And it seems likely that it would take months, even years, to recover sometimes. Now, bouncing back more quickly, you will obviously require supply chain managers to turn new ways of managing the supply chain using data from Internet of Things or IoT, analytics, and machine learning. These tools will become the foundation on which supply chain managers gain insight to their market and erratic supply on demand trends. Next, we have monitoring mobility and social distancing. Now, recently, the Newcastle University Urban Observatory has developed an urban data dashboard to help understand the impact of social distancing measures on people and vehicle movement within a metropolitan city in real time. The objective is to understand the dynamics of movement in a city using thousands of sensors and data sharing agreements to monitor movement around the city, from traffic to pedestrian flow to congestion, car parking occupancies, and bus GPS trackers. It also monitors energy consumption, air quality, and climate, and many other variables, all of which is acquired through sensory data. This type of data not only shows how physical distancing is changing in real time, but also provides us a detailed insight into long-term behavioral changes, all thanks to the ocean of data that is available to us and the analysts that crack it down and find patterns in them. Cities, enterprises, and national governments should collectively create a massive global network of sensors to detect viruses for future pandemics as well. This further will fuel the implementation of the smart city concept, which is very specific to each city but also catering to some global problems, despite the severe criticism it has received in the past due to data privacy issues. Next, we have controlling the pandemic situation through social media using data science and AI. Now, be it reaching to the target audience through cluster algorithms or identifying the at-risk individuals who are close to the infected individuals in terms of frequency and recency of communication through graph analysis. Data science and data analytics, along with some artificial intelligence tool, will have a big role to play by leveraging the social media platforms. Additionally, natural language processing, data mining, and predictive analytics are going to come handy in detecting fake news and analyzing people's movement in near future, including travel plans, destinations, and the number of travelers. Hence, you can say that you're using data analytics, predictive analytics, and cluster algorithms to leverage social media to combat the current pandemic. Then we have the use of cloud computing in making remote work more convenient for organizations and team members. Now, with so many people in self isolation for what could be as long as 18 months under estimates, and with a possible long term shift towards home based work for a large segment of the population, large scale deployment of the public 5G access points is likely to be curtailed. Now, the cloud capacity, especially from hyperscale vendors such as AWS, Microsoft Azure, Google Compute, Oracle Cloud, and IBM Cloud, is what is going to get us through the storm. With a remote home-based workforce, remote desktop technologies will be essential until native born-in-the-cloud applications can run core business functions. Legacy vertical industry Windows client-server apps are problematic and will need to be refactored and rewritten entirely in software as a service. This will occur using enabling technologies such as containerization and microservices because VMs and IaaS are computationally extremely expensive. Next, we have the edtech, fitness, entertainment, social media, and OTT platforms. Now, with people staying indoors, the demand for online learning, fitness, social media, and digital consumption has increased exponentially across the board. Video conferencing apps such as Zoom, Google Hangouts, Google Duo, and House Party have seen nearly 72% of increase in the time spent, while the average user count has risen by over 100% in each of these. Since users will be looking for more personalized digital content, the demand for professionals with solid skills in machine learning, deep learning, data science, and data analytics will go up tremendously. And then we finally have financial tech and financial services. Now, banking and financial services are essentially for everyone. With people working from home and maintaining social distancing, this would be a great opportunity for fintech startups. Online services that we can pay for through fintech are now practically covering every industry imaginable. Now, if I had to talk about the data analytics trends in a nutshell, I'd like to say that the crisis is in its early days and it is hard to predict where it will lead. However, according to a recent survey report by Birchworks, an International Institute for Analytics, the scenario for employees in data analytics, big data, data science, and machine learning is still very promising. Demand for data-oriented occupations and skill sets skyrocketed in the year 2019, and this year, however, it might not see the same speed, but there still will be jobs for good talent. In such a scenario like we are in right now and any other recession, data analysts and data engineers have a built-in job security relative to other positions as businesses transition their operations to rely more heavily on data-related sciences. Now, this is a long-term trend that is not likely to change due to any pandemic and is here to stay. Although momentum has started to slow down, it seems like for data analysts, it is not as bad as the other industries. When it comes to data analytics deployments, organizations should not be penny-wise and pound-foolish. They should consider expanding their business intelligence deployments rather than cutting them back. In fact, the threat of a recession might even enable organizations to gain additional leverage with some data analytics and trends in hand. Data visualization tools provide you with an easier way to create visual representations of enormous datasets. When dealing with datasets that include hundreds of thousands of millions of data points, automating the process of creating a visualization, at least in part, makes your job significantly easier. These data visualizations can then be used for a variety of purposes such as dashboards, annual reports, sales and marketing materials, investor slide decks, and virtually anywhere else information needs to be interpreted immediately. Now, what do the best data visualization tools have in common? Now, the best data visualization tools on the market have a couple things in common. First is their ease of use. There's some incredibly complicated apps available for visualizing data. Some have excellent documentations and tutorials and are designed in ways that feel intuitive to the user. Others are lacking in those areas, eliminating them from the list of best tools regardless of their other capabilities. The best tools can also handle huge sets of data. In fact, the very best can even handle multiple sets of data in a single visualization. These tools can also output an array of different charts, graphs, and map types. Most of the tools that I have enlisted here can output both images and interactive graphs. There are exceptions to the variety of output criteria though. Some data visualization tools focus on a specific type of chart or map and do it exceedingly well. Those tools also have a place among the best tools out here. Finally, there are cost considerations, of course. While a higher price tag doesn't necessarily disqualify a tool, the higher price tag has to be justified in terms of better support, better features, and overall value. Now, there are dozens, if not hundreds, of applications, tools, and scripts available to create visualizations of large data sets. Many are very basic and have a lot of overlapping features as well. But there are standouts that either have more capability for the types of visualizations they can create or significantly easier to use than other tools that are listed here. Now, when I say tools, I mean applications and software platforms, and I'm not going to be including libraries. We're going to keep that for another session. So let's go ahead with our list. At number 10, we have Infogram. Now, this is a web-based data visualization and infographics tool which permits users to create and share digital charts, infographics, and maps. It has an intuitive editor known as What You See is What You Get, which transforms your data into shareable infographics. Now, a couple of pros that stand out are that you need absolutely no coding skills to use this tool. It is available in a free version. It allows you to connect your visualizations to live and public data sources, as well as gives you a choice of over 35 types of charts and 200 different types of maps. That's impressive, isn't it? Apart from that, it is also a great platform if you want to handle complex data. However, there are a couple of pitfalls here, mostly pertaining to the free version of this tool. Firstly, the free version mandates you to include the Infogram logo in your designs, as well as lacks the rich text editing feature. Also, I feel that it lacks in a few data integration features when compared to others on this list. Now, the basic version of this tool comes free of cost, and pro versions cost around $19 a month. The business version will cost you $67, and the team version is priced at $149. For the enterprise version, you can customize it by contacting the vendor. Also, both free and licensed versions are available in this tool. At number 9, we have Sysense. Now, this provides instant insights for anyone and anywhere in your organization. It allows you to create visual dashboards and reports to state any piece of data, uncover underlying trends and patterns to make data-driven decisions. Now, certain pros of having Sysense is that it has an extremely user-friendly interface, while also providing great analysis performance on larger data sets. Along with that, it has excellent support, easy upgrades, and integrates extremely well with different data sources. This product is very flexible and allows for easy customization. Its cons include difficulty to maintain and develop analytic cubes, and also if a cube is rebuilt, it is required to become inaccessible during that period. It also does not have any inbuilt data type to support the time format and has limited type of visualization. Now, pricing is not disclosed by Sysense. However, it offers a no surprise pricing package where the cost is determined on a case-by-case basis depending upon the data size and number of users. It also has a free trial available. At number 8, we have FindReport. Now, this is an enterprise-level web programming tool written in pure Java. It combines data visualization as well as data entry and is designed based on a no-code development concept. With FindReport, users can make complex reports and cool dashboards and build a decision-making platform with simple drag and drop operations. It also is one of the connoisseurs of this sort of easy UI. Now, Find Report can be directly connected to all sorts of databases, and it is convenient and quick to customize various complex reports and dashboards. The interface is similar to that of Excel, and it provides 19 categories and over 50 styles of self-developed HTML5 charts. It also gives you these really fun 3D and dynamic effects to go with it, and the most important thing is that its personal version is completely free. However, it is only a sample and does not allow intuitive use, and will also leave you wanting to learn more about using advanced tools such as incorporating JS and Java, which in case if you do not know much about Java will be difficult for you to use. At number 7, we have Google Charts. Now this is a very powerful, easy to use and interactive data visualization tool for browsers and mobile devices. It has a rich gallery of charts and allows you to get it customized as per your needs. Now the rendering of these charts are based on the HTML5 SVG technology, and it provides you with pros such as its simplicity to learn, user friendliness, its speed and accuracy, great interactivity, 3 years of backwards compatibility, as well as cross-browser compatibility and cross-platform portability, with any additional plugins, and all of this completely free. Apart from that, it supports iPhone, iPad, and Android and can read from multiple data sources including Excel, SQL databases, CSV, Google Spreadsheets, so on and so forth. This tool is completely free but comes with its own set of pitfalls, which include a mandatory network connection while using the tool, the absence of demos on advanced features, along with a lack of sophisticated statistical processing. Working with API for complex presentations is also sometimes difficult to learn. Next, we have Grafana. Now, this is an open source visualization software that lets users create dynamic dashboards and other forms of reports. It supports mixed data sources, annotations, and customizable alert functions. It can also be extended via hundreds of available plugins, and that makes it one of the most powerful visualization tools out there. You have export functions which allow designers to share snapshots of dashboards as well as invite other users to collaborate. Grafana supports over 50 data sources via plugins. It's completely free to download, and there's a cloud-hosted version for $49 a month. There's also a very limited free hosted version. Now, if you have a downloadable version, there are support plans available, something a lot of other open source tools don't offer. But then again, it definitely is an overkill for creating simple visualization, does not offer as many visual customization options as some of its competitors, and is not the best option for creating visualization images. And the final con would be its inability to embed dashboards in websites, though it is possible for individual panels. And hence, it is not higher on our list. Having said that, Grafana is one of the best options for creating dashboards for internal use, especially if you're using mixed or larger uncategorized data sources. At number 5, we have Dundas. Now, this is a very old and popular data visualization tool, and has definitely stood the test of time, and for good reason. It offers super interactive visualizations which aid the users to understand data faster and better. Its other visualization features include rich scorecards, smart tables, numerous chart types, gauges, maps, data labels, sparkline indicators, diagrams, and relationships. This tool is grounded on responsive HTML5 web tech, which allows the users to connect, interact, and analyze their data on any device from anywhere. Apart from that, it has great ETL capabilities while allowing us to write direct SQL against data sources that we choose. It has amazing flexibility in design and comes with really good support. And let's not forget its amazing library of visualizations. The cons of Dundas are few, which is why it is so high up on our list. It does not offer predictive analysis, which most newer data visualization tools do, and it also lacks support on 3D charts. Apart from that, it follows a one-time license and subscription-based pricing model, but has a free trial available. However, Dundas BI pricing and details are based on a flexible licensing model that adapts to your needs and that of your business, which is why it is not disclosed by the vendor. At number 4, we have Adaptive Insights. Specifically being designed for business users, the adaptive discovery tool Adaptive Insights allows focusing on your analysis and decision making on what is important to you. With interactive drill down and visual storytelling, you can identify the root causes, answer questions on the fly, and spot trends to address the issues ahead of the curve. It gives you a complete perspective that you shall need to drive for financial, sales, and operational performances. It also allows you to model, plan, and forecast to make better business decisions. Some of the things we like about adaptive discovery is the ability to connect to any data source, be it ERP, CRM, or HCM. It has personalized dashboards, modular metrics, as well as shared metrics. And the information is at your fingertips from anywhere with analytics delivered completely on the cloud. While this tool equips you with out-of-the-box planning, budgeting, and forecasting processes, sometimes the responsiveness is extremely slow due to the use of Java. Initially, it is a bit difficult to learn this tool, mainly because of setting up your reports, but once you get the hang of it, you should be fine. Apart from that, it's actually pretty difficult to modify reports without creating a new one on this tool, and the overall reporting functionality, in our opinion, could be improved. Like many others on this list, you need to contact the company for pricing details. It has a subscription-based pricing model, and the price will be determined by the number of instances that you want to opt for. The tool is available in 2 editions, which is the Adaptive Discovery Professional and the Enterprise version. Now, though it is a licensed tool, it does have a free trial version available. With that, we've come to our top 3 tools. At number 3, we have Microsoft Power BI. Now, this is one of the more commonly used BI tools, which allows you to connect to a wide variety of data sources, design customized dashboards and detailed reports, and supports both mobile and web-based analytics. It has pros such as being cloud-based, giving a single view of the dashboard, its affordability, and since it's a Microsoft tool, it has a very strong brand integration with other MS tools. A lot of documentation about this tool is also freely available online, along with a big and active community helping you resolve your doubts. A wide variety of charting options for data visualizations are available with consistent upgrades and an extensive database connectivity, which hopefully will cover up for how difficult it is to learn and its inability to handle bulk data. You shall sometimes face a certain lag when you are using huge volumes of datasets. Also, the cloud version does not have all the features available in the Windows version. But the good news is that it is available in both free and pro versions and has 2 enterprise pricing plans. The first one is totally free with 1 GB data storage limit, and the second plan, which is the Pro plan, costs less than $10 per user per month, which also has its own data storage limit of 10 GB. At number 2, we have Watergraph. Now, this tool is different from the others and provides marketing agencies with an easy way of reporting marketing campaign data to their clients. This platform creates visual data that is easy to comprehend no matter who you're reporting results to. Certain features include its seamless integration with over 40 of the top digital marketing platforms such as Google Analytics, Facebook Ads, and MailChimp. It has endless customization options, and you can have your pick from virtually hundreds of different pre-made reporting widgets or create your own methods of presenting data. Now, on this tool, cross-platform data analysis is extremely simple, and it gives you a great way to compare different marketing platforms and their performance in one report. Automated report creation and delivery is also brilliant when you use this service. And when managing a variety of clients, automation features can help process and deliver data to the right clients with minimal input on your behalf. Along with this, it comes with something known as white label reports, which helps you customize the report the way you see fit. Add your own images or logo and let your branding shine through with each report you create. Watergraph is a feature-rich marketing data reporting platform for agencies to use. It makes easy work of managing multiple clients while aiding you with a plethora of integrations and automation functionality. Not just that, the watergraph pricing differs based on the features you want to use. There is no need to overpay for the features that you are never going to use. The only con that we see here is the lack of versatility. It is more of something that marketing agencies would use for marketing campaigns and less of everything else, which is why it's not on the top of our list. But then what is? Finally, at number 1, we have Tableau. Now, Tableau is a business intelligence service that aids people in visualizing as well as understanding their data. It's also one of those very widely used services in the field of business intelligence, which allows you to design interactive reports, dashboards, and worksheets to obtain business visions. It has outstanding visualization capabilities and has a great performance despite the size of data sets. It is easy to use and comes with a healthy community and forum and offers great connectivity to multiple data sources. It is mobile friendly, it has powerful computation and quick insights. But it comes at a price of $70 per user per month billed annually. You have no option for scheduling and auto-refreshing of reports, and it has restrictive visual imports. Static parameters need to be updated manually each time when the data gets modified, and a lot of users find column table formatting extremely difficult to do. However, it comes in a public version, which is an open source version which is absolutely free and has almost all the features of the paid version. And the licensed version also has a free trial available for 2 weeks. Having said that, this software allows data mixing and real-time collaboration. It doesn't force users to write custom code, and all in all is one of the simplest business intelligence tools in the desktop system, which is why it tops our list of the top 10 data visualization tools of 2020. Data visualization is a huge field with many disciplines. It's precisely because of this interdisciplinary nature that the visualization field is full of vitality and opportunities.
So let's see the top 10 skills required to become a data analyst. So at number 10, we have statistics. To become a full-fledged data analyst, a thorough grounding in statistics is essential. Being good at statistics will help you understand algorithms deeply and understand when they should be used. So brush up on applied science, linear algebra, real analysis, graph theory, and numerical analysis. Linear algebra comes into play with regression, understanding data structures, and preparing data for perspective and predictive data modeling. Now at number 9, we have programming languages. Now a data analyst needs proficiency in at least one and often several programming or scripting languages, which are used to manipulate data. It's a question that needless most data nerds have to face when it comes to picking up the analytical tool of the choice. While it's not possible to be proficient in every coding language, the wider your experience, the more value you'll provide to your employer. Once you learn the fundamentals of coding, it becomes easier to adapt to the different frameworks and syntax of the new languages. Some of the popular tools and languages are R, Python, and SAS. Now moving forward, we have advanced Microsoft Excel. Now when you think Excel, the first thing that comes to your mind might be spreadsheets. But there's a lot more analysis power under the hood. While a programming language like R or Python is better suited to handle big data sets, advanced Excel methods are still widely used for smaller lifts and lighter, quicker analysis. If you are working at a bootstrap company or startup, the first version of your database might even be in Excel. VLOOKUPs, pivot tables, power pivots, and macros are some of the very important Excel functions. Over the years, the tool has remained a mainstay for businesses in every industry, so learning it is a must. Luckily, there are an abundance of great free resources online to help you get started, as well as structured data analytics classes led by instructors. Now, one of these is Edureka. Now, next we have data warehousing and BI tools. Data analysis and data minings are a subset of business intelligence, which also incorporates data warehousing, database management systems, and OLAP, which is online analytical processing. The technologies are frequently used in customer relationship management to analyze patterns and query customer databases. Large quantities of data are searched and analyzed to discover useful patterns or relationships, which are then used to predict the future behavior. Data management and manipulation skills are critical. This comes through languages such as Hive, R, Scala, and SQL. Now, SQL takes different forms across a wide range of data platforms such as Microsoft SQL Server, MySQL, which are commonly used online. Building queries to extract the information you want is must for data analysis. Now, next we have data cleaning and visualization. Data cleansing is a valuable process that can help companies save time and increase their efficiency. Data cleansing software tools are used to remove duplicate data, fix and amend badly formatted, incorrect, and amend incomplete data for marketing lists. One can achieve in a short period of time what could take days or weeks for an administrator working manually to fix it. Being able to tell a compelling story with data is crucial to getting your point across and keeping your audience engaged. If your findings can't be easily and quickly identified, then you are going to have a difficult time getting through to the others. For this reason, data visualization can have a make or break effect when it comes to the impact of your data. Analysts use eye-catchy, high-quality charts and graphs to present their findings in clear and concise way. Tableau's visualization software is considered an industry standard analytical tool, and it is refreshingly user-friendly. So some of the popular tools are Tableau and Power BI. Now next we have the big data ecosystem. As a data analyst, you may encounter a situation where the volume of data you have exceeds the memory of your system, or you need to send data to different servers. This is where Hadoop comes in. You can use Hadoop to quickly recover the data to various points on a system. That's not all. You can use Hadoop for data exploration, data filtration, data sampling, and summarization. Although this isn't always a requirement, it is heavily preferred in many cases. Having experience with Hive Pig is also a strong selling point. A study carried out by Crowdflower on 3,490 data analyst jobs ranked Apache Hadoop as the second most important skill for a data analyst with 49% rating. Now next on our list we have machine learning. Machine learning and predictive modeling are quickly becoming two of the hottest topics in the field of data analysis. While not every analyst works with machine learning, the tool and the concepts are important to learn in order to get ahead in the field. You'll need to have your statistical programming skills down first to advance with machine learning. If you want to stand out from other data analysts, you need to know machine learning techniques such as supervised machine learning, decision tree, logistic regressions, and much more. Now, these skills will help you solve different data analytical problems that are based on predictions of major organizational outcomes. Next on our list, we have analytical problem solving. Data analyst works with large amount of data, be it facts, figures, and number crunching. As a data analyst, you will need to see through the data and analyze it to find conclusions. You should understand the techniques for cleansing, organizing, and structuring data to provide efficient and reliable results. This means defining data rules to work seamlessly with data technologies. Investigation and verification skills are required to ensure you are providing the right information for the right business problem. Interpreting data results involves determining the extent and the cause of any issues involving bad data. The more advanced in analytics you get, the more math and statistics you'll need. So, a good analytical problem-solving knowledge, both practically and theoretically, are preferred. Now coming to the third point, we have effective communication. Data visualization and presentation skills go hand in hand, but presentation doesn't always come naturally to everyone, and that's okay. Even seasoned presenters will feel their nerves at times. As with anything else, start with practice. Then practice some more until you get into your groove. Companies searching for a strong data analyst are looking for someone who can clearly and fluently translate their technical findings to a non-technical team, such as the marketing or the sales department. A data analyst must enable the business to make decisions by arming them with quantified insights, in addition to understanding the needs of their non-technical colleagues in order to wrangle the data appropriately. When communicating, pay attention to the results and the values that are embedded in the data you analyzed. Most business owners don't want to know what you analyze. They are interested in how it can impact their business positively. Next on our list, we have creative and critical thinking. Data analysts must look at the numbers, trends, and data and come to new conclusions based on their findings, questioning established business practices and brainstorming new approaches to data analysis. It is said that smart people ask hard questions, while the really smart people ask simple ones. Indeed, many of the important questions you can ask about your company are the simplest. Why do people choose our products over other competitors? Why do customers leave us when they do? Should we offer discounts to boost the sales? Using data to find answers to your questions means figuring out what to ask in the first place. That can be quite tricky. In order to be an analyst, you have to think like an analyst. Trite as this saying might be, it is still 100% true. It is the role of the analyst to uncover and synthesize connections that are not always so clear. While this ability is innate to a certain extent, there are a number of tips you can try to help improve your critical thinking skills. And finally, we have industry knowledge. Whichever industry you are working for, you should know how the industry works and what will be beneficial for the business. If a data analyst does not have business acumen and the know-how of the elements that make up a successful business model, all those technical skills cannot be channeled productively. You won't be able to discern the problems and the potential challenges that need solving for the business to sustain and grow. You won't really be able to help your organization explore new business opportunities.
Let us understand who is a data scientist and data analyst. When we talk about data scientists, the first thing that sets them apart is scientist. So a data scientist works with diverse data sets. That means experimenting with diverse data. This means working with either company's data and also data from other sources, like data located on different servers or different machines or locations. So data scientist experiments and works with data. Now, to experiment, data scientist uses machine learning, and he uses machine learning models and test models iteratively to make predictions from the data. And these predictions, they have the potential to solve business challenges and problems. Now, when a data scientist makes predictions, this also helps a data scientist to discover the patterns and the hidden opportunities from the data, to draw insights from the data. Now, moving on forward to who is a data analyst now. A data analyst would work with company-specific data. That means limited data that is already there in company's database, or it could be also acquired from a third party if need arises. And a data analyst will use statistical tools and softwares to analyze the data and not machine learning models. So this is the basic difference between the two. And data analyst will not create or do repetitive testing of the ML models, but rather would stick to statistical tools and softwares to make predictions and analyze the data. And data analysts also would create reports, build interactive dashboards to showcase the trends from the data. And data analyst utilizes the data to solve immediate problem of the business at hand. Now, after having said this, let us understand this with the help of an example. And this example is from a pharmaceutical company which is involved in end-to-end drug development services. So the role of a data scientist in a pharmaceutical company would be to conduct research using existing and novel statistical methods and using software tools and databases for integrative analysis of genomic data. Also will act as a point of contact of data requests and delivery. Now, a data scientist here in a pharmaceutical company would also be involved in supporting development and documentation of data. Now, this data has to be cleaned and transformed, so various procedures are being involved here. Data scientists would also study the feasibility and statistical analysis plans here so as to develop a strong business plan, right? The another important role is to develop and implement procedures. Now, this is vast, and this would include various skills by a data scientist. And this will include collecting, organizing, coding, creating machine learning models, and analytical databases. So this is the role of a data scientist in a pharmaceutical company. Now, moving on forward to role of a data analyst in pharmaceutical company will be involved in designing, building, and maintaining the databases. Now, since it is a pharmaceutical company, a data analyst will maintain the drug list. And it will also identify requirements, data integration. Data analyst will assist the medical team in analyzing and maintaining the formulas using MS Excel and SQL management. So the knowledge of SQL and Excel is must for a data analyst. Ensuring compliance with the benchmark tools is another yet role a data analyst plays, because compliance and benchmark is something which is being set by governing organizations within an ecosystem. So these standards have to be adhered to, and that's what data analyst does. A data analyst will also monitor and report on program outcomes by using various matrices, which we will see in the later part of the video. He will also analyze and create reports and presentations for the management to make further decisions about the business. And also, one more thing that data analyst does is that he will also work with outside vendors to assist business-related concerns. So for this, communication skills are really required, which we will also cover in the coming up slides. Now, in companies, a data scientist and data analyst, they work in team and they have their roles and responsibilities very well defined. Let us look at some of the job responsibilities that a data scientist and data analyst needs to perform based on job postings on Glassdoor. So the job responsibility of a data scientist posted by Deloitte requires here that a data scientist need to know Python to manipulate data into usable formats, pull information from APIs, and automate the repeatable task. Now, this means that strong knowledge of Python is required by a data scientist. The responsibility is that of a data scientist. Another responsibility we see is that it is machine learning and NLP techniques to apply them to unstructured data to make them more meaningful and draw insight. So for this, a data scientist would be needing machine learning tools and techniques. Another responsibility is that data science and algorithms to make predictive and prescriptive analysis. As we can see, this is the responsibility of a data scientist. Now, responsibilities of a data analyst is to extract data from primary or secondary sources. Now, this could be company's database or from a third party where the company is dealing with or has some business concern. The knowledge of programming language is again another requirement. So coding knowledge, programming knowledge is required. Again, developing and maintaining databases is yet another requirement. Performing analysis to assess quality and meaning of the data. So this means that performance reporting and matrices reporting is required here. Review reports and performance indicators. So this is yet another requirement which we have already covered in our previous pharmaceutical example. So this is also required as a data analyst in a different environment, I would say. And also to use statistical tools to identify, analyze, and interpret patterns and trends in complex data sets. All right, so this is what a data analyst does. Now, moving on forward, this is just in a nutshell consolidated responsibilities of a data scientist versus data analyst, which is again being taken from a lot of Glassdoor job postings. So all in all, if I can sum it up, I can say that a data scientist is majorly concerned or involved in building and testing machine learning models and iterate machine learning models to improve the performance. Now, for this strong foundation of machine learning algorithms and their working is required by a data scientist. And a data scientist would also work with diverse data sets, complex data sets. They will perform feature engineering. That means cleaning of the data, preparing the data so well to feed before or to give it as an input for a machine learning model so that the predictions are really accurate. And if they are not accurate, improving the performance, iterating the machine learning model over and over, and conducting various experiments with the data until a very good accuracy or an acceptable accuracy of prediction is being attained. Also, the ability to deploy, validate, and monitor machine learning models, along with coordination and collaboration with other teams like engineering teams, is also a responsibility of a data scientist. So all in all, to perform all these responsibilities, a data-driven approach is required in a data scientist in order to uncover the hidden patterns from the data. So the main thing is that a data scientist has to uncover hidden opportunities from data by using machine learning tools and data science techniques, which we will also study further. Now, for a data analyst, gathering data from databases, maintaining databases, and accessing database is the key responsibility. So for this, a knowledge of SQL is really needed, is must here, and which we will also discuss shortly. Now, statistical analysis and reporting. So any statistical tool or software for analysis of the data, reporting tools, the knowledge of reporting, that is essential for a data analyst. Performing analysis to assess quality of data is yet another responsibility. Now, a data analyst is also concerned with creating reports and dashboards and presentations for the management. So for a data analyst, the knowledge of business intelligence tools and preparing presentations and creating reports, it's again very important. Also collaborating with other stakeholders and third-party vendors. So for this, communication skills must be needed by a data analyst. So these are the responsibilities in a nutshell, which has been discussed here. Now let us understand the key differences between a data scientist versus data analyst. Now, a data scientist is concerned with a potential business problem. Now, what does this mean? This means that the problems that businesses might face in future, which is still not in sight. And this is what we have been discussing in the entire video to uncover the hidden opportunities in the data. A data scientist uncover hidden patterns from the data to unleash or uncover the potential business problem that the business might face in future. So this is forward looking. Whereas the data analyst is concerned with a current business problem, day-to-day business problems, that means that the routine business challenges. For example, in a pharmaceutical company's example, where a data analyst is involved in studying the trends and the patterns of the drug, how much the sale is being done, or for example, the prices are low or high, where the market is really potential and not. These are the potential problems, or I would say current business problems that a data analyst has to deal with. Now, another difference is that a data scientist generate questions and find answers. Now, data scientist has to work with a lot of data. So by figuring out and analyzing this data with the help of machine learning models, some questions really come up. And these questions are answered by data scientists. And these questions have the potential to make strategic decisions and really impactful decisions in the business. For example, in a pharmaceutical example, if we take, then a data scientist is involved in research of novel techniques which are not pre-existing. So he has to research new techniques for drug discovery. For any kind of a research that is involved, a data scientist would be there generating questions and finding answers. Whereas a data analyst will find answers to given questions. Now this, for example, a management gave questions to data analysts that why the trend of a particular drug is not so good and which drug is really performing well in the market, so that the subsequent decision would be to produce the drug which is doing well more in the market and create strategies so that the other drugs also perform well. So this is what this really means. Now moving on forward to a data scientist uses predictive analysis, machine learning models for making decisions. Now, this means that techniques used by data scientists, they are majorly data science techniques like machine learning, artificial intelligence, and NLP techniques. And these techniques are deployed to make predictive models, carry out forecasting, and do predictive analysis along with statistical tools to aid better decisions. Whereas a data analyst will not be concerned with machine learning, but largely will be using visualization tools like Power BI and Tableau and statistical softwares like SPSS and SAS or SAS to carry out the statistical analysis of the data. Now, moving on further, a data scientist usually conduct A or B experiments. Now, this means that a data scientist has to iteratively perform various experiments, and this will include like comparing the result of two independent tests and carrying out A or B experiments, and after comparing the results, you'd be improving them by ML algorithm. Now, this is a very time-consuming and a complex process, as many iterations are required here. And as we have discussed this in roles and responsibility of a data scientist also in our previous slides. Now, on the other hand, a data analyst do not require machine learning models iterations. But I would say it is quite simple that they do not test, retest, and compare the results of ML models, but they would design, create reports, dashboards, presentations, build interactive dashboards for the management to help in decision making. Now, moving on forward to something really very interesting, and that is, remember any stories narrated when we were children? We still remember them, right? Why? It is because the stories make the data even more impactful and compelling. The way the data scientists communicate the findings is through a story aided by visuals. A data scientist has to find out patterns from the data that can impact businesses in long run. So they have to communicate in a way that will be effective and yet meaningful. Thus, storytelling comes to their rescue. while a data analyst will not be concerned in putting efforts to explain the data in a form of a story, but rather will communicate via presentations and reports using business intelligence tools like Power BI and Tableau. Now let us understand the eligibility criteria for a data scientist and a data analyst. All in all, these are also the qualifications that companies require. Now this also depends upon the company one applies to, and these are just basic few requirements of a data scientist. Graduation in science, technology, engineering, and mathematics is required. Post-graduation and PhD is preferred because this signifies the candidates possess in-depth knowledge and dedication towards a subject and can apply these learnings to solve the business challenges because of the gained knowledge over the years. Even if you have a specialization in domains like mathematics, economics, statistics, and computers, this could be counted as one of the qualifications for a data scientist. And of course, cognitive and analytical skills are required as they help to map the candidate's problem-solving ability, pattern recognition, speed of information processing, data analysis, and others. Now moving on further to the eligibility for a data analyst. Now for a data analyst, the qualification bar is not as high as set for a data scientist, and the basic eligibility are graduation, and not necessarily in science, technology, engineering, or mathematics, but it is open to many of the backgrounds. Specialization in domains like mathematics, finance, economics, and statistics is also preferred. And now this also depends upon the company's profile. Suppose you're going in bank and you're a banking business analyst, then finance requirements require statistics and economics would be a good help. Communication and analytical skills are required, as a data scientist has to act as a connecting link between a company and the client. So third-party service providers and other stakeholders also. Thus, reporting, organization, data analysis, communication, these are really required in a data analyst. So now moving on to the key skills for a data scientist and data analyst. Now in this, there's a contrast here. Now on the left side, you can see the responsibilities, and on the right side is the skills. This is of the same company. Again, the data is taken from the Glassdoor, and now we can see, we will understand this by one, picking up one responsibility and mapping it with the another skill. So like for example, the responsibility is to write and execute Python scripts. The skill required will be strong programming skills like Python in this case. Another responsibility is machine learning and NLP techniques. Now, to bring out order to the unstructured data, the required skill in which case is data scientist ecosystem or data science ecosystem knowledge like NLP, statistical techniques, neural networks, etc. So I can say that the skills must match the responsibility. If the company requires you to learn Python, then a data scientist responsible or skills required would be strong knowledge in Python. If suppose the company would be working in R language, then the programming language skills required would be R. So usually Python is preferred, that we would see in the coming slide also. Now let's move on further to the key skills for a data scientist. Now this is again been consolidated after studying a lot of job posting responsibilities. The first skill that we came up with is programming language. Programming language is used for machine learning and analysis of the data. Now, the languages that can support analysis of large volumes of data, like Python, R, or Java. So in Python, libraries like Pandas, Numpy, Matplotlib, deep learning libraries like TensorFlow, the knowledge of the same is required. Another skill is machine learning, the ability to understand the algorithms, innate mathematics, the working of algorithms, and how to improve any algorithm in case of inaccurate prediction, that is hyperparameter tuning. A data scientist must know. NLP for structured and unstructured data processing. Now, next technology is big data. To extract information from unstructured large data that simple data processing softwares cannot handle. So big data technologies like Hadoop, Spark, Kafka is required. Now, another skill is statistics for analyzing and understanding data, for better interpretation of data. So statistics knowledge, both descriptive and inferential, is required here. And for statistics, even R and Python is preferred. And statistical softwares like SAS, SPSS, or Excel can be used. Now, data mining. Data mining is yet another skill. It is used for extraction of patterns and knowledge from large amount of data. And some data mining techniques are classification, clustering analysis, regression analysis, and so on. Now, coming to key skills for a data analyst. Now, these skills again depends on the job responsibilities mentioned by the company, but all in all, the major key skills are statistics and visualization. So knowledge of any statistical tools like SPSS or SAS, and visualization tools like Power BI and Tableau for dashboard reporting and building. Excel, a good working knowledge of Excel is required by a data analyst to analyze the data. But Excel has its own limitations because it cannot process large, huge amount of data. So for that, big data technologies are required here. So database, and since we have already discussed that a data analyst uses limited or works with limited amount of data, so Excel for few companies, for most of the cases, does well. Now, coming to databases, a very good and strong knowledge of database is required. This is required because a data analyst has to work with data, the stored data, to retrieve the data, to access data. So a language which can help to access data, to modify data is required. So good knowledge of SQL or NoSQL databases is also required now. NoSQL databases like MongoDB, Oracle, or MySQL, and others. Reporting. Now we've seen that reporting is really important for business intelligence, for project reporting, for generating graphical data reports. So softwares like Tableau, Power BI, DataPine, Pro Workflow, they're used for reporting, whereas there are other reporting tools like for a data analyst. And these data reporting tools are really very vast, and it depends upon the company which software it uses. So I can name just a few reporting tools like SAP, Jira, specific softwares from Microsoft can be used. So again, this depends upon the company, which software the company is using for reporting. Programming language. Programming language like Python or R for better analysis, manipulation, and visualization of the data. Now in Python, the knowledge of Numpy, Matplotlib, Pandas, Seaborn library is required. And if you're working with R, then dplyr or ggplot2 can be good to learn. Now moving on forward to the salary estimation. Now the salary is dependent upon location, the company, and the experience, and also the skill set one possesses. Since the skills in a data scientist is required is more, and also the qualifications, so the salary is also, but obvious, would be on a higher side. So now from an Indian perspective, if we see the salary of a data scientist at the beginner level having 1 or 2 years of experience is 6 lakhs per annum. For the senior level having 5 or 8 years of experience, it is 10 lakhs per annum. And for the expert level having 10 or 15 years of experience, this is 20 lakhs per annum. Now, coming to the salary estimate for a data analyst, at the beginner level, it is 3 lakhs per annum. For the senior level, it is 6 lakhs per annum. And at the expert level, it goes to 10 lakhs per annum. Again, these figures can vary depending upon the company, location, and also your experience. Now, the salary estimate for data scientists in terms of US dollars, at the beginner level, it is $95,000. At the senior level, it is $135,000. And at the expert level, it is $165,000 to $250,000. Now, the salary estimate for a data analyst, again, would be at a lower side. So the beginner level, it is $45,000. For the senior level, it could be $65,000. And at the expert level, it is $85,000. Now, to sum up, a data scientist may make more money, so you might be inclined and interested in that field. But keep in mind your education background, skill set, and the responsibilities that you might need to perform. A data analyst, you can always upscale yourself and enter data analyst field with different backgrounds, as it is relatively an easier profile to work. The qualifications are also not as stringent as for a data scientist. Chances are more to make your inroads as a data analyst than as a data scientist. A data-driven personality is really what the companies look for in a data scientist. Whichever field you choose must interest you. Based on the findings and information in this video, you can now very well decide which field is right for you.
So let's head over to the first part, which is the general interview questions. So the first question for today is mention the difference between data mining and data profiling. You can think of data mining as the process of sorting through large data sets to identify patterns and relationships that can help you solve business problems through data analysis. The thing over here is that data mining will help you discover relevant information that has not been identified before. Whereas data profiling is done to evaluate a dataset for its uniqueness, logic, and consistency. This basically means that you're checking your dataset to see if it's valid for your use case. The second difference is that in data mining, raw data is converted into valuable information. This can either be done through scraping data from the internet or filtering the existing dataset. But in data profiling, you cannot identify inaccurate or incorrect data values. Now let's head over to the second question. Define the term data wrangling in data analytics. By definition, data wrangling is the process of transforming and mapping data from one data form to another format. Basically, data wrangling is the process wherein raw data is cleaned, structured, and enriched with the intent of making it more valuable for data analytics. This process can turn and map out large amounts of data extracted from various sources into a more useful format. Techniques such as merging, grouping, concatenating, joining, and sorting are used to analyze data. Thereafter, it gets ready to be used with another dataset. Our third question for today is, what are the various steps involved in a data analytics project? This is one of the most basic data analyst interview questions. The various steps involved in any common analytics projects are as follows. You start with understanding the problem. Understand the business problem. Define the organizational goals and plan for a lucrative solution. After that, you will start collecting data. You'll gather the right data from various sources and other information based on your priorities. The third step is cleaning data. Over here, you'll clean the data to remove unwanted, redundant, and missing values and make it ready for analytics. After the cleaning process is done, you'll start exploring and analyzing the data. You can do this by using data visualization and business intelligence tools, data mining techniques, and predictive modeling to analyze the data. The last step is interpreting the results. You will interpret the results to find out hidden patterns, future trends, and then gain insights. Our fourth question for today is, what are the common problems that data analysts encounter during analysis? One of the biggest problems that data analysts face is handling the data, right? It starts with handling redundant data, collecting the right data at the right time, handling data purging and storage problems, keeping that data secure, and then handling compliance issues. These are some of the most common problems that data analysts face, and you should have a solution for this when you attend a data analyst interview. With that, let's head over to the fifth question, that is, list out some of the common tools that you have worked with. Now, this question can be considered as a pattern of skill set that most data analysts should have. Let's start with database systems. In database systems, you will need to know MySQL, MongoDB, Apache Cassandra, and CouchDB. These are some of the most commonly used database tools. After that, a data analyst also needs to know how to report and create dashboards, right? For that, you will need Excel, Tableau, and Power BI. A data analyst also needs to know how to code. For that, most data analysts use Python, R, and SPSS. These are the most commonly used programming languages, and you will need to have a thorough understanding of them. Finally, we have presentations and reports. For this, you can use PowerPoint and Keynote. During the interview, you can also give some examples and use cases of how you've used these tools before. This can help the interviewer understand your knowledge about these tools. The next question is, what is the significance of exploratory data analysis, abbreviated as EDA? The first thing over here is that exploratory data analysis can help you get a better understanding of your data. You can use different tools and techniques to understand how your data works internally. The second point is that you can have more confidence in your decisions. Exploratory data analysis is based on statistics, and the decisions you make will be based on that. So if your research is correct, then you have more probability of your decision being right. EDA can also help you refine feature selection during modeling. You can avoid overfitting or underfitting your model, and this analysis can help you choose the right model for your use case. EDA can also help you discover hidden trends in your data. This can help you find unique information that can help you make better decisions. And with that, we have the next question, which is explain descriptive, predictive, and prescriptive analytics. The main point about descriptive analytics is that it provides insights into the past to understand what has happened. You should understand that descriptive analytics is used to understand data and draw conclusions from it. You use techniques such as hypothesis testing to find out whether certain assumptions are true. Now, Predictive analytics is used to understand the future to answer the questions on what could happen. It uses available data to predict the future based on patterns. Prescriptive analytics, on the other hand, suggests various courses of action that answers what you should do. You can think of this as a doctor's prescription. If you have a problem, then prescriptive analytics can give you a solution to it. Now, all three of these are used in different use cases. So the second difference can be about the techniques that you use in these use cases. Descriptive analytics uses data aggregation and data mining techniques, whereas predictive analytics uses statistical models and forecasting techniques. Whereas prescriptive analytics uses simulation algorithms and optimization techniques to advise possible outcomes. Now, the next question is, what are the different types of sampling techniques used by data analysts? To understand this, let's first understand what sampling is. Sampling is a statistical method to understand a subset of data from an entire dataset to estimate the characteristics of the whole population. What this essentially means is that in sampling, you take a part of the entire dataset and you try to analyze that. And based on the results of that particular sample, you will derive conclusions for the entire dataset. Now, for the different types of sampling techniques, we have simple random sampling, systematic sampling, cluster sampling, stratified sampling, and judgmental sampling. Now we have the question, describe univariate, bivariate, and multivariate analysis. Univariate analysis is the simplest and easiest form of data analysis where the data being analyzed contains only one variable. That is why it's called uni, right? So with that, we can see what bivariate is. Bivariate analysis basically means you are comparing two variables. This can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. Now we have multivariate analysis. This kind of analysis involves the analysis of three or more variables to understand the relationship of each variable with other variables. Our 10th question and the last question for this section is, what are the best methods for data cleaning? So, the first thing is to create a data cleaning plan by understanding where the common errors are taking place. And after that, you will keep all the communications open. You should also remember that before you start working with data, you should identify and remove all the duplicates. This will lead to an easy and effective data analysis process. You should also focus on the accuracy of data. You can set cross-field validation, maintain value types of data, and implement mandatory constraints. You can also normalize the data at the entry point so that it is less chaotic. You need to ensure that all information is standardized. This will lead to fewer errors on entry. With that, we are done with the general interview questions that you face in data analyst interviews, and next we can see the interview questions on statistics. The first question over here is how you handle missing values in a dataset. Now, if you have handled data before, then you know that missing values is one of the most commonly found problems in a dataset. To handle this, the first method is list-wise deletion, where an entire record is excluded from analysis if any single value is missing. The second method is average imputation, also called as mean imputation, where you fill in the missing values with the average of that particular value. The third method is regression substitution, followed by the fourth method, which is multiple imputations. Now, the second question that we have in this section is explain the term normal distribution. Normal distribution is one of the most basic concepts in graph theory, and it refers to a continuous probability distribution that is symmetric about the mean. Some of the important points over here is that you should remember that the mean, median, and mode of a normal distribution is equal, and all three of them are located in the center of the distribution. Now let's head over to the next question, which is, what is time series analysis? By definition, time series analysis is a statistical procedure that deals with ordered sequence of values of a variable at equally spaced time intervals. Basically, time series data is this data that is collected at adjacent time periods. That is why you can see a correlation between the observations. This feature distinguishes time series data from cross-sectional data. I have added two graphs below for you to understand this concept better. The next question is, explain the difference between overfitting and underfitting. Now, this question is one of the most basic questions that you can find on building models. You say that your model is overfitting when it trains well on the training dataset, but the performance drops drastically in the testing dataset. This happens when your model learns random fluctuations and noise from your training dataset. Underfitting occurs when your model does not really train well on the training dataset and performs poorly on both training and testing dataset. This occurs when your training dataset is so small that it can't really derive any conclusions, or if you're developing a linear model with a non-linear dataset. After this, we have the question, how do you treat outliers in dataset? Now, to answer that question, the first thing that you need to understand is what is an outlier. Basically, an outlier is just a data point that is distant from other similar points. This may occur due to variability in the measurement or may indicate experimental errors. Now, for you to treat outliers, the first thing that you can do is drop outliers, where you can just delete all the records that contain outliers. And the second method is capping outliers data. The third method is assigning a new value. You can assign the mean, median, or some other appropriate value over here. The fourth thing that you can do is just try a new transformation. And with that, we come to the next question, which is, what are the different types of hypothesis testing? A hypothesis is basically just an educated guess about a specific parameter or population. And hypothesis testing can be described as the procedure used by statisticians and scientists to accept or reject a statistical hypothesis. Now, in hypothesis testing, you have two different kinds of hypotheses. The first thing is a null hypothesis, and the second one is an alternative hypothesis. Now, you can also get another question based on this concept. What is the difference between type 1 and type 2 errors? The type 1 error occurs when the null hypothesis is rejected even if it is true, whereas the type 2 error occurs when the null hypothesis is not rejected even if it is false. Now, let's end this section over here and head over to the interview questions on Python. The first question in this section is, what is the correct syntax for reshape function in Numpy? For you to use the reshape function, all you need to do is use two parameters. The first parameter is the array name, and the second parameter is the shape of that array. Now, I have attached a snippet that uses the reshape function over here. Go through it and type the output in the comment section. What are the different ways to create a data frame in Pandas? For this question, you can list down the two ways to create data frames in Pandas. The first method is by initializing a list, and the second one is initializing a dictionary. For you to create a Pandas data frame using lists, the first thing that you need to do is type pandas.dataframe and then give it two parameters, data and columns. Now, the data parameter consists of a list containing different lists. This will later be converted into your records. And the second parameter, columns, will consist of your column names. Initializing a Pandas data frame using dictionary is even simpler. All you need is a dictionary with values which you can convert into a data frame. The syntax is just pandas.dataframe, and in the parameters, you will mention the dictionary's name. For the next question we have, there are two arrays A and B. Stack the arrays A and B horizontally using the Numpy library in Python. Now, for this question, there are two ways you can approach it. The first way is the concatenate method, where you will type numpy.concatenate A and B and then mention the axis. The second method is the headstack method. This is another Numpy method where in the parameters you will provide a list with the values A, B. Next question is, how can you add a column to a Pandas data frame? Doing this is extremely simple. All you need to do is type the data frame's variable name followed by the column name. This is then assigned values from a list. So let's move on to the next question, which is, how will you print 4 random integers between 1 and 15 using Numpy? This is again a very simple question. If you refer to the snippet that I have given you over here, you can see that in the second line, I have used numpy.random.randant and I have given a few parameters. This randant function can help you generate your numbers. Now, the randant function itself has 3 parameters, right? In this method, the first value represents the start point. you won't find any numbers being generated before this point. The second value is the endpoint. You won't find any values being generated after this number. The third value that I mentioned over here is the number of integers that we want from this method. Now let's move on to the next question. Suppose there is an array that has values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How will you display the following values from the array? 1, 3, 5, 7, 9. Now if we observe the values that need to be extracted, we can see that all of those numbers are just odd numbers, right? So this question again refers to some of the basics of programming. All you need to do is create a list with the values given at the start of the question and then check for the odd numbers. You can do this by using the modulus operator. Now the next question is, suppose there is an array with the following values. Extract the value 8 using 2D indexing. To answer this question, all you need to do is start by creating your NumPy array, and over here you will pass the same values as given in the question. You can do this as follows. Now if you check your array, then you can see that the value 8 lies in the third row and the second column, right? But the indexing in Python starts from 0. So the third row becomes the second row and the second column becomes the first column. So if you type those indexes, you will definitely get your answer. And then we have the next question. How do you select specific columns from a data frame? Now this is also a basic question. You can do this with a single line of code. You will start by typing the data frame name and you will open two sets of square brackets inside one another. Once you do this, you can type the names of the columns that you want inside the inner square brackets. With that, we can come to the fourth section of this video, which is Data Analyst interview questions on SQL. The first question in this section is, what is the difference between where clause and having clause in SQL? Let's do this with a table. The first point is that where clause operates on row data, which means that when you use a where clause, you are only operating on individual rows of data. The having clause, on the other hand, operates on aggregated data. In the where clause, the filtering occurs before the groupings are made in the data. But the having clause is used to filter values from a group of data. In the where clause, you can't use aggregate functions, but having clause allows you to do that. The second question is a very common sort of question. Is the following SQL query correct? Now in the interview, the interviewer can ask any kind of SQL query. You need to make sure that you have a thorough understanding of SQL before attempting to answer these questions. So the query is as follows. Select customer ID and order date from year as order year from order where order year is greater than or equal to 2023. Now, is the SQL query correct? Pause the video over here and analyze the question. You can type your answers in the comment section down below. So, what's your answer? If you answered that the query is correct, then you are wrong. The query stated above is incorrect, as we cannot use the alias name while filtering data using the where clause. It will throw an error. The correct form of the SQL query is as follows. All you need to do is pass the order date through year, not directly. Now with that, let's see the next question, which is, what is subquery in SQL? A subquery in SQL is just a query within another query. It is also known as nested query or an inner query. Subqueries are just used to enhance the data which is queried by the main query. These queries come in two types, correlated and non-correlated. You can find more information about correlated and non-correlated subqueries in the blog that has been given in the description. Next, we have what is the difference between delete and truncate statements. The delete command can delete rows in your table. You can delete individual rows or a group of rows. Whereas the truncate statement is used to delete all the rows from the table. You can roll back to your data after using a delete statement. You can think of rollback as a save point in SQL. With rollback, you can navigate to a previous version of your data. This feature is not available with the truncate statements. The third difference is the category of commands that these two commands belong to. Delete is a DML command, whereas truncate is a DDL command. The fourth difference between these commands lie within speed. The delete command is slower than the truncate command. Let's now head over to the next question, which is, what do you understand by query optimization? Query optimization is basically a phase that deals with optimizing the efficiency of your query. With query optimization, your outputs are generated faster, a large number of queries can be executed in less time, and query optimization reduces the time and space complexity of your queries.
And with this, we have come to an end to this full course on data analytics. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.